depending on wherever you've joined us from here today. My name is Shreyas. I'll be your trainer for this particular training. I have over uh, almost 11 years now of experience in teaching Azure-based courses and Databricks, Terraform, all these Kubernetes. So I've been conducting trainings for NICIT Academy. So I welcome all of you to this particular training session on Azure Databricks. All right. So our entire discussion for today's call is going to be on the introduction of what you can expect from this course. All right. That is going to be the primary area for us to discuss today. But apart from that, we'll also be seeing a lot of other things, especially related to what is the prerequisite, what you should know already, what to keep in mind, why to learn Databricks, what is Databricks, right? What opportunity it brings for you. So all of that discussion we'll have in today's demo session. And the demo session will also continue for tomorrow and I guess day after, where we'll be covering various aspects. So you'll just have a real life experience of what it will be like sitting in the class and trying to understand the various concepts around Databricks, right? So that is what we are going to do for you. Now, before I move further, let me quickly guide you on what to expect from this course and what are the things that we are going to actually cover, right? So this is a course plan for all of you to look at. We'll be having 9:30 to 10:30 p.m. classes every day. The total duration on Databricks will be 25 hours plus. All right. I've written plus because depending on the class, depending on the students, yes, sometimes we move quick, sometimes we have to be slow, sometimes we have to be, in pace with the learning pace of the students. So therefore, at least 25 hours, it can go up until 30, 34, 35 also if required. All right. I'm not saying it will be, but if required, if we want to do more in the class, and that totally depends on the students, on you guys who are going to be a part of this class, right? The more interactive you are, the more questions you ask, the more we work on, and obviously the session duration, it definitely goes beyond. Now, apart from going around talking about Databricks and what it is, how it uses the Spark architecture or the Spark, programming, PySpark programming, how you're going to use that, what are the various features within Databricks. Apart from discussing all of that, since this course is called Azure Databricks and not Databricks in general, right? Because what I'm going to teach you in these 25 plus hours is going to be how you make use of Databricks and its capabilities within the Azure platform. Correct? Now, I'm not sure if all of you have an understanding on what Azure it is. All right, what is Azure, right? Maybe most of you are new to cloud computing, so you may not have an idea about cloud computing from scratch. Some of you may have an idea about cloud computing, but that could be relevant to AWS or GCP or some other cloud that you've been working with, right? So we'll have initially a 5-hour session, right? That means a week's time will be spent on understanding Azure. All right. And this is where we need to take a look at various services that we are going to cover in Databricks also. For example, when working with Databricks, we need to work with the Azure Data Lake Storage, right? Until and unless you understand what Azure Data Lake Storage is, how you create Azure Data Lake Storage, it will not make any sense to you why we are integrating data lake, why we are mounting data lake, all those scenarios. To understand them properly, you need to have a solid understanding of the Azure platform also. If not all the services, the required services at least. Now, coming to the required services, we need to understand a virtual machine, right? That my Databricks environment will create within my Azure subscription, which will work as the compute. We need to know what is data lake storage. We need to know what are the databases available, And then how do I connect my Databricks environment to my Azure environment? All right, because they are not unified, even though they are connected, they are managed, but Databricks is a separate environment, Azure is a separate environment. And when I want to mix the two, there has to be some proper permissions and access control that needs to be granted to my Databricks environment, right? So that it can connect to Azure and fetch data from there or work on data from there, or work with various data stores that we are going to create. So that is where our 5 hours bonus lectures on Azure will come in. I will explain you cloud computing from scratch. All right. We'll take a look at what cloud computing is. We'll take a look at what Azure is, how Azure is built, and then the core services that I want everybody to have an idea about, which is, mainly going to be the data lake storage. All right, because data lake storage also, and to an extent the data warehouse also, because in Databricks we'll cover something called as a lakehouse architecture, right? To understand the benefits of lakehouse architecture, first of all you need to understand what is data lake and what is data warehouse, and what are the benefits of both of them, and what are the shortcomings of both of those things, those services, right? Whether it's a data lake or a data warehouse. Once I understand the pros and the cons, then it'll make more sense, right, when I'm reading about the lakehouse architecture, as to why was there a need to connect the benefits or the pros of data lake with the pros of your data warehouse. All right, whatever shortcomings the data lake has, the data warehouse overcomes that. Whatever shortcomings the data warehouse has, the data lake overcomes that. And that is why Databricks introduced this lakehouse architecture, which most of the organizations today want to use. All right, so that is why we'll have to have some idea about data about Azure in general. Now in this course you'll get every day's recorded lecture. All right, so every day we'll complete the lecture at around 10:30 in the night. By early morning tomorrow or by the next day, you will have the lecture uploaded on the LMS portal that you were seeing a short while ago. All right, on that particular location you'll find day-wise recording of each class that we have, and on top of that you will also find all the PDF notes for each of the topic that we are going to cover in this course. All right, so you'll find everything in a unified place on the LMS portal, and the access for you will be available for lifetime. All right, you'll have a lifetime access to all the videos and the learning contents. At the end of the course, we'll be doing two projects. All right, two projects on Databricks, and that will also include some of the Azure based services, right? So that is where I wanted to introduce you to some of the Azure services, right? For example, when we are working with the medallion architecture that talks about creation of bronze, silver, and gold layer, right? Why do we create those layers? What type of transformations are we going to do? And then how do we use the medallion architecture and do a continuous refinement of my data and reach the gold layer? Now, what happens after the gold layer? Where do I put that data? So for that, we'll have a brief discussion on these services that you may have heard about, which is the data factory and the Synapse Analytics. All right, because when you talk about the data engineering, ecosystem, then you cannot limit yourself to a single service. I cannot say that if I know only Databricks, that makes me a good data engineer. If you know Databricks and you know the other services also, and how do they connect to each other, what benefits will Databricks offer you over the other existing services, that is also something that will make you a better data engineer. All right, now throughout this course we'll be writing a lot of code. All right, and primarily this will be Python, and to an extent we'll be using SQL. All right, so that is the only prerequisite that I have for you. You should have a basic understanding of what Python is, right? I'm not asking you to be an expert on Python. Uh, it is my guarantee to all of you that by the end of this course, you would be writing PySpark code fluently. If somebody asks you how to fetch data, how to transform data, how to add new columns, how to rename columns, how to, you know, aggregate the data, all those transformations you would know. All right. They are very easy to understand. Python is a language which is known for its readability and understandability, right? It is very easy to understand. But then again, I need all of your support, where all of you will have to practice, right? Whatever discussions that we are going to have. You need to practice that in real life. And for that, you will be needing an Azure account. And I will guide all of you as to how you can go ahead and create your own free Azure account. All right. Once you create your free Azure account, you can go there, create the Databricks environment. Now, Databricks environment in itself will offer you a free trial version within Azure account. All right. So within an Azure trial account, you can create a trial Databricks account that will give you all the benefits. Now, the Azure account that I'm talking about, all right, it'll give you around $200 of credit, right, which will be valid for 30 days, right? If you want to practice more, even after 30 days, you can go ahead and create a new free account. All right. So that is how you're going to implement the projects also. And that is how you're going to work with this sample code that will be shared with all of you. So I'll be sharing whatever code that we'll be writing in the class, whether it is related to, transformation of data, whether it is related to creation of, let's say, a delta table or doing time travel using delta table, right? Whatever code is to create a database within the Hive meta store, you will get all of this code that you can save as a Python code, and you can refer to it. It is well architectured. I have put all the comments in the code. I have all the headings, the topics, and everything. They are segregated topic wise, right? So you will find it very easy, to work with that particular code base that I'll be sharing with you. All right. On top of that, we'll be sharing the interview questions also and some sample CVs for all of you, right? With the project details added that you can add to your CV to show your experience in working with Databricks. Now, at the end of the course, obviously, you will have a good, all right, or I would say an excellent amount of idea about what Databricks is, what it offers, what all facilities are there, what all features are there, right? And I'll go through the content that we are going to cover in these 30 odd hours that we're going to cover, and these 30 hours will be spread across some 40-45 working days, depending on the number of sessions we have, right? So 45, almost 45 working days, 30 sessions is what we are going to cover. And in these sessions, right, um, as I told you, I'll be coming to the topics, the modules one by one, but you can expect us to cover end to end when it comes to Databricks. All right. There would be no topic untouched, or no particular module untouched. Uh, any question that has been asked to you related to Databricks, right, you'll be able to answer that. That is what we are aiming for. Clear? All right. So now let me introduce you to the tool or the technology that is Databricks, right? So what is Databricks in general, right? What is Databricks? Now, Databricks is a cloud-based analytics platform, all right? And it is built on top of Apache Spark. So that is also something that we'll be covering in the class, right? I'm not just going to tell you what Apache Spark is. We are going to get into the architecture of Apache Spark. What is Apache Spark? What architecture does it use? What is this distributed computing that we are talking about, right? What is the in-memory processing that it gives, which is better than the previous big data analytics platforms like Hadoop, right? What was Hadoop? What was the map reduce function within Hadoop? How is this Apache Spark better than Hadoop? And obviously, Databricks have taken Spark as the core, technology that this entire platform is built around. So we'll try to understand everything. All right. It's not going to be that we are going to only discuss about Databricks. I can open Databricks. I can go on with, Databricks, expecting that you all know what Azure is, expecting you all know what Apache Spark is, right? But that is not something that we're going to do. We are going to cover, first of all, the basics of Azure, then the architecture on which, this platform Databricks is built on, right? The open source distributed computing system, that is Apache Spark. All right. So Databricks is a fully managed service. When we say managed service, most of its tasks, when I say tasks, not the, writing the code and creating the cluster, right? When you create the cluster, you will just define the cluster. The actual creation of cluster, the allocation of resources, the getting of the compute resources and the storage resources, that will all be taken care of by Microsoft Azure. All right, that is why we say it's a managed service. Microsoft Azure is in the background managing the entire platform. So it offers very high performance, right? It offers capabilities for handling your large scale workloads. We'll also try to understand what is big data, first of all, right? The problem that we are trying to solve, right? That is the big data problem, right? What is the big data problem? The three V's of big data: the velocity, right? The volume and the variety of data. When I say variety, I'm trying to say that the data is coming in all different, formats from various sources. So that is what we are going to define with variety. The volume, the size of the data, right? And then obviously the velocity, the speed at which the data is getting generated. So therefore, we need systems that can process more and more and more data as quickly as possible. Because today, unlike 20 years ago, we are generating massive amounts of data. It's not even close, right, of the amount of data that we were generating 10 years ago and the amount of data that we are generating today. It's not even close. It's not even a competition. Let alone competition, you cannot even say it's a minutest of fraction. That is the kind of exponential growth that data has seen, or the data generation has seen, right? So Databricks will give you a collaborative workspace, right, where multiple people can work together. So when I say multiple people, I'm referring to their job roles, right? So you have essentially multiple types of job roles when it comes to managing data or working with data, right? One is your database administrator. That is one role. Then you have a data engineer. You have a data analyst, right? And you have a data scientist. So these are all different data related roles. When it comes to Databricks, it it is useful for data analysts also, it is used for data scientists also, and it is useful for data engineers also, right? So it's a collaborative environment where all of these people are going to work together, right, to write their code, to execute their code efficiently. All right. And Databricks, it integrates deeply with Azure. That is something that we are going to discover, right? So how it works, right? It works by integrating with Azure, and whatever resources Databricks will need will be provisioned by Microsoft Azure in the backend, hence the managed service. It connects very easily to various Azure services, right? The data lake storage that we talk about, that is the basic storage service in Azure. The Synapse Analytics, right? Again, which is the data warehousing solution within Azure. The Azure machine learning, that is to create ML workloads within Azure, right? So how Databricks works is, uh, it leverages the Sparks or Apache Sparks distributed processing capabilities. All right, to basically manage, right, large data sets across multiple machines. Now, what is this multiple machines that we are talking about? Right? What are these multiple machines that we're talking about? So within Spark, right? And it's a property of Spark, not Databricks. All right. When you talk about Spark, and I'm talking about Apache Spark here, right? Because nowadays, so many tools, so many technologies are coming in, right? Recently, I got to know a few weeks ago that GitHub has launched something called as GitHub Spark, right? Now, people are going to create these microservices on GitHub, right? And it's an AI assistant that is going to help you. So when I say Spark, don't get confused. I am talking about the Apache Spark. Clear? Now, when you start working with Apache Spark, right? How does it process your data? So what is this compute that we are talking about? Now, the Spark architecture is very simple, right? It's very simple, and I'll explain it to you, and you will understand it in 2 minutes, right? There is going to be a main controller, right? Or the master, and there are going to be individual workers. These are called as slaves. All right. Now, this master slave architecture basically signifies that the master will give tasks along with instructions, along with data, right? And it will give task, instructions, and data to all of these slaves. And these slaves are then going to do all the heavy lifting and the hard work, right? That is how it is defined in general. But when there are thousands of slaves, will the master go to each slave and make them do work? Or will the master get to know the status of individual slaves on his own? The master will not do that, right? It's too much work for him. Therefore, what the master does is employs somebody else to do this task. All right. And who's this somebody else? This is nothing but the cluster manager. So cluster manager are various cluster managers are available. You have Yarn, which is a Hadoop native cluster manager, which is, the full form for Yarn is your yet another resource negotiator, right? So that is Yarn. Uh, any other cluster manager that you know of, something that is used to manage nodes, right? Anyone wants to take a guess? Any cluster manager that you know of? It's very commonly, very prominently being used in software development industry today. It is something that is, a prerequisite for any software development role which is there in the market today.
Kubernetes.
Absolutely correct. Kubernetes, right? So Kubernetes is also a cluster manager. Then you have the standalone. Now, these are all different cluster managers which are available that you can use within your Spark architecture, right? The job of the cluster manager is very simple. The job of the cluster manager is to keep an eye on all of these slaves. Now, in general, they are not called as slaves. Please don't call them slaves. I just call them, to explain to you the master slave architecture that you are used to see. These are called as nodes. These are individual nodes. We call them nodes. All right. And all these nodes together is called as a cluster. All right. So a single compute, these are nothing but your virtual machines. So they will have some storage, they will have some memory, they will have some CPU. Yes. So you can think of these nodes as individual Linux machines that get created. When we create them in Databricks, you will see that individual Linux virtual machines are getting created. All right. So these nodes will have configurations like 4 cores CPU or virtual CPU and 16 GB RAM, right? So something like this you will see for each node. So this is going to be the size of each node. Now, depending on the amount of data that you have, depending on the complexity of data processing that you are doing, right? You are going to define the number of nodes, right? It could be a single node also, it could be 5 nodes also, it could be thousands of nodes also, and there is essentially no upper limit over here when it comes to nodes, right? So the cluster manager, which is by default within Apache Spark, is the standalone cluster manager, right? So standalone cluster manager is the default cluster manager that you have. The job of the cluster manager is very simple. It keeps an eye on all these individual virtual machines. It will see if any virtual machine is sitting idle. If the virtual machine is sitting idle, it will tell master that I have an idle machine. Give me another task. So what master will do is it will take the individual data and break it down into smaller pieces, many smaller pieces. So if you have, let's say, 1 TB of data, you can, break it into thousands of smaller pieces, right? And what the master will do is now it will send an individual unit of data, right? Like one, and along with the code, right? So what data processing that I have to do on this data, right? Obviously, you will be performing some transformations on the data. So what transformation is there? And the data, the small chunk of data, the master will share with the cluster manager, which will then give it to the node, and the node will start working. If any of these virtual machine fails, right, stops working, the cluster manager will inform the master, and whatever data was shared here will be shared again, and now the cluster manager will assign it to somebody else. So basically, you have a pool of various nodes, and the cluster manager will keep an eye on all of these nodes, right? And the master is where, the data gets broken down, and the data along with the processing logic has is transferred to the cluster, to the individual nodes, and these individual nodes will have individual output, right? So this will be output 1, output 2, output 3, output 4, let's say. So at the end, all of these individual outputs are combined: output 1, output 2, output 3, output 4. So you add all of them and you get the final data, right, that you had, with all of whatever processing that was required being completed. So this is a high level picture that I have given you, right? Inside this, there is a lot of complexity that we'll try to understand, right? What is Spark core? What is Spark context? What is Spark session? What are Spark APIs? What is a high level API? What is a low level API, right? What is API in general? Now, whatever Spark architecture that you see here, right? As a programmer, as a developer, you need to talk to it. Yes or no? You will require some knowledge to talk to this cluster, to talk to the master, to give master, the code along with the data and everything, right? And what transformation logic has to be given, all of that information you will give. So how will you talk? You talk through APIs, right? So we have these Spark APIs. The APIs are divided into two parts. All right. APIs are divided into two parts. One is high level and the other one is low level. Now, what is the difference between a high level Spark API and a low level Spark API? Now, and trust me, you won't get it right if you do not know it already, because we are, with the word high, we'll assume that it will be more complex. It will require more, information. But it's absolutely opposite. Low-level APIs like RDDs, resilient distributed data set. This also is something that we'll try to understand within the class. High-level APIs like PySpark, Scala, are. These are high level API. So these are different languages that you use to talk to the Spark architecture. So we will be using PySpark in general to talk to the Spark architecture. The low level APIs are very complex. All right. We call them low because we are trying to signify that they require you to go into the most interiors of the architecture and define everything on your own. All right. Whereas high level APIs will mean that you are defining the core logic and the code, and that is fine. Whatever else is required to talk to the interiors of the architecture, that my Spark will take care of. All right. So, for example, people love car, right? People love car, but there are two types of fans when it comes to loving cars. One is a technical fan, right? The other one is the feature fan. Yes or no? Some of you would be fans of a car based on its features, and some of you would love a car based on its technicalities, right? So a feature loving fan would be somebody who would want or who would describe a car like, oh, it has got a good shape, it's the looks are really beautiful, the color is really good, right? It has got ventilated seats, you know the music system is really good. So these are people who love the feature. And when it comes to the technical people, right, they'll talk about engine, they'll talk about transmission, they'll talk about how much torque is there, what is the engine capacity, what are the braking mechanisms in the car, right, which a general person would not be able to relate to, right? So technical, you can think of it like low level, right? And people who define the car from outside and still can define it, it is the high level, right? So now you understand the difference between the low level and the high level. So with low level APIs, these are very complex languages. RDDs are very difficult to work with, all right, because there you need to interact with a lot of interiors of the Spark. Whereas high level APIs, PySpark, Scala, you just define your logic, you define the data that you want to work on, and you can continue. It will manage everything in the backend. So this is the Spark architecture in general. There's more to it, but now at least you have an idea of how this works, right? Why did we come to this distributed computing? Why? So I'll explain it to you. Earlier, back in the day, we started with a monolithic system. We started with a monolithic system in the beginning, and this system was a single large machine, very large machine, right? And here we had something called as vertical scaling, right? Now, what is vertical scaling? Vertical scaling means increasing the capacity of the existing resource. You increase the capacity. That is vertical scaling. When I say horizontal scaling, there I'm saying that I had one machine. Instead of increasing its capacity, I add another machine, right? So this is horizontal scaling. And this is the difference between the monolithic computing and the distributed computing. In monolithic approach, I will have a very large single compute resource that will process my data. And in the distributed computing, I'll say I am not going to have a single large machine, but I'll have individual smaller machine. Power of unity, right? So power of unity will always be bigger than the power of a single unit, correct? So you have a lot of phrases also around that. That if multiple people come together, it's very hard to defeat them, right? And a single person, however big it is, uh, it's bound to get defeated. And that is where distributed computing defeated this monolithic computing. Because first of all, there is a limit to this vertical scaling here. You cannot scale indefinitely. If I have a machine, I can scale it. Obviously, I can increase the size. I can keep on increasing, and I can reach a specific point. But beyond that, it might not be possible. Correct. And monolithic computing also offer a single point of fault. All right. This means if there is any fault in this machine, the machine goes. Whereas in the distributed computing, if there is a fault in a single machine, the rest of the machines will still work and your data will get processed. Your data processing will not stop. So there is a very high, we call it fault tolerance in my distributed computing. So that is the benefit that we have with distributed computing. All right. Yeah. So we were talking about what is this Databricks, right? So this is what we are going to cover, how this data is processed using Apache Spark. What is the difference between Databricks and PySpark? See, PySpark is the language that you're going to use to interact with the Spark architecture. All right. Databricks is a platform that uses the Spark architecture along with other services also for our data processing needs or big data analytics needs. All right. Apart from this, Databricks will have a cluster manager, as I told you. There is notebooks that you'll be creating here, your Python notebooks, Jupyter notebooks you would have seen, right? It provides a notebook based interface for coding, where multiple team members can share their code, work together. So, it is where, you can have a shared collaboration among various teams. It has a lot of built-in security and compliance abilities also because it runs on Azure, right? So therefore, Databricks offers enterprise grade security. It gives you encryption, it gives you compliance, right? Industry regulations can be followed here. And with something like Microsoft Entra ID, that was previously known as your Azure Active Directory. I'm sure most of you would have heard about it, right? For authentication and identity management, and then various other Microsoft Purview integration and all. So that has added a lot of security, governance, and compliance onto the data that you're going to work with, in Databricks. Now, it has support for machine learning and AI based integration also, right? Uh, but our focus throughout this course will be mostly, on data engineering based workloads, right? So it integrates very well with Azure, right? It offers a unified data processing, analytics, everything under one roof. All right. So people don't have to switch between different tools. Everything is doable, everything is accessible in the single platform. All right. And Databricks also includes something called as a Delta Lake. Now, as of now, you do not, I'm sure most of you will not understand what Data Lake is. So it will be, silly to explain you what Delta Lake is because it is an upgrade of Data Lake. So, but it's a feature, it's a very strong feature. It's some storage layer, right? Delta Lake that ensures very fast query. All right. Also, it implements ACID compliance, right? Atomicity, consistency, isolation, durability. So it supports ACID transactions, which was not present in my data lake, right? That is something which Delta Lake offers me over and above my data lake, right? It offers time travel. So when I'm, within Delta Lake, you generally create tables in the Parquet format, and those tables will allow you time traveling, right? It's a very strong feature where you do transformations on the data, but at the same time, all the versions of your data are getting stored somewhere. All right. So they're storing a copy of all of your data. Now, what happens here is, let's say you transform data once, you transform data twice, you did it thrice. When I say thrice, it's a subsequent step. All right. So you did a particular transformation, you got a result. You did some other transformation, you get some other result. And then on that result, you did some other transformation. Three series of transformations you did on the data. Now, what if I want to go back to, the data that I received after the first transformation? In general, it is not possible. But with Delta Lake, this is possible. And this feature is called as time travel. So we'll see that also in the course. All right. So it's being used across various industries. Databricks, right? It's widely adopted across various industries, right? Due to obviously the ability to process very large amounts of data sets. and generate some actionable insights from those data sets. Also, it's being used in finance sector, right? Financial institutions want to deal with this vast amounts of transactional data that they're getting, and they want to implement machine learning algorithms to identify fraud detection, right? To create a fraud detection system, do real-time analysis of their data. So Databricks is a unified platform that will allow them to do machine learning, workloads also, and then um, for you to analyze the streaming data that you're getting, the real-time data that you're getting, um, try and work like a data warehousing solution for your data also. So all of that it can do, right? Similarly, in healthcare it is being used, in retail it is being used, right? So everywhere, data bricks is something which is being used. So why learn Databricks, right? Now the importance of big data processing, and obviously analytics also, in today's tech landscape is huge. All right. The modern world is sitting on big data. Big data is everything, right? I hope you understand the difference between normal data and big data. And it's very, very simple, right? If you have, just give me a second. Yeah. So if you have a pinch of sand in your hands and I ask you to count it, that is normal big data, normal data, which is, somewhat difficult, just a pinch. And the chances are that you'll be able to count the number of particles in that pinch of sand that I've given you, right? That is your normal data. Big data is if I give you the entire beach and I'm asking you to count the sand particles. That is big data, all right? Which is obviously you cannot process it. The human mind cannot process it. A simple computer may not be able to process it. Multiple computers also may not be able to process it. And you need a specific architecture and a method to process that huge amount of data that you have, right? Now, as I said, the organizations today, across industries, they're relying on these data, right? Whatever data we are generating, the organizations are relying on these data to, make decisions. They want to predict consumer behavior. They want to optimize their operations, right? They want to develop AI models. Now, AI models will also need data to learn, right? So data analysis has become critical asset in business strategy today. And therefore, every organization is using it, is making use of it, right? And with the explosion of connected devices, sensors, digital transactions, the sheer volume, velocity, variety of data generated today, right, is unprecedented. So your traditional systems, they would fail to process this data set, right? You'll get very slow insights, high costs, limited scalability. And this is where this big data processing platform like Databricks comes in. And that is why you have to learn Databricks, all right, which offers a very optimized solution for, high performance computing, real time analytics, large scale automations. All of that you can do with Databricks. All right. So Databricks, cloud-based, cloud-based data analytics platform that enables businesses to efficiently process big data, right? Uh, Benefits you already know. If you want to compare it, right, today, uh, Databricks to, let's say, Hadoop and Spark, right? How do I compare it? When you talk about Hadoop, right? How many of you heard of Hadoop? Just let me know in the chat window. As a big data processing engine, how many of you heard of Hadoop, the MapReduce method within Hadoop, MapReduce framework within Hadoop? How many of you heard of it? A few? Yes, absolutely. So you compare Hadoop with Spark and then Databricks. Hadoop used to work on disk. It used to write intermediate or intermittent data, I would say, or intermediate data, right, onto the disk storage, right? That made the entire process slow. That is what Apache Spark improved by introducing the concept of in-memory processing. I'm not going to write or read data from disk. I'm going to read and write data into the memory, which is much, much, much more faster, right? That is why when, in certain cases, and you'll find it in several places, which is actually not true, but everybody's using the same slang. And the slang is that Spark is 100 times faster than Hadoop. Now, for a particular situation in a particular use case, that may have worked. It's not something which is general, but in general, Spark is 60, 70, 80% times, or times, I would say 50, 60 times faster than Hadoop. And Databricks also uses the in-memory processing, but it is more optimized. It is much more faster today. All right. That is why people want to work with Databricks. When it comes to scalability, Hadoop required manual scaling, right? Manual resource allocation. Spark offered, some level of uh, moderate, auto scaling, but it was not available everywhere, right? It all depends on the tool where you're using Spark. Whereas in Databricks, you have dynamic scaling, auto scaling, rule-based scaling, everything is there, right? Hadoop was very complex. Writing, code in Hadoop was very complex. Uh, Apache Spark also requires writing code, right? PySpark code, Scala code, Java code, R code. But Databricks, it in some cases gives you a very low code, user-friendly solution. All right. Cloud integration of Hadoop is limited. Cloud integration of Apache Spark through various services is there. All right. Whereas Databricks is an Azure native support service. All right. Azure Databricks is an Azure-based service itself. So that is why, Databricks is building upon Spark's speed and efficiency, and also eliminating Hadoop's dependency on complex disk-based storage systems, right? So that makes big data processing more seamless and cost-effective with Databricks, right? So Databricks fits into the Azure data ecosystem, right? It connects with Data Lake, connects with Synapse, connects with Power BI, connects with Data Factory. And if I touch upon the job opportunities, all right. So the demand for data engineers and big data professionals has surged in recent years, right? There are various studies available, let's say that's going to, grow with, I think 28, 30% is what I remember of CAGR annually. And I'm talking about uh, the jobs which are available in the market, right? And the entire ecosystem also. The entire data engineering ecosystem in India is growing at around 28 to 30%, right? Now, more and more companies and organizations today want to work with their data, right? And they're looking for good data engineers. They're looking for good data analysts also, right, to analyze this data. But what data will data analyst analyze if the data has not been cleaned and transformed, right? So without data engineers, data analysts are useless, data scientists are useless. They all depend on data engineers, correct? To get a structured data for their analysis or for their training, right? So the rise of AI today, right? It requires vast amounts of structured data. The expansion of cloud computing, that also makes data storage and processing, more scalable. The need for real-time analytics everywhere in almost all industries are today wanting real-time analytics, not batch processing. They want stream processing, right? So, you know, professionals who are looking to enter the big data and analytics field can go ahead and explore several careers, right? As I said, data engineer. They'll be designing and maintaining data pipelines, ensuring efficient data flow for analytics and AI models. And skills are very simple. You need to know SQL, you need to know a bit of Python, right? And then you need to know cloud platforms such as Azure, AWS, because most of the organizations are today switching, they're migrating to cloud, right? Nobody wants to have an on-premises data center today. It's very not cost effective, right? Moving to cloud is cost effective. And then the kind of features and the services that cloud service providers are giving you today, right? that also makes it very lucrative for organization to switch to cloud, right? Uh, Apart from that, the salaries and everything, right? In India, data engineers earn somewhere around 8 lakhs to 30 lakhs, depending on the obviously experience and expertise. I cannot give you an exact number that if you're entering as a fresher, this is what you're going to get. I cannot promise you that. But the kind of skills that you have, with the kind of hands-on experience that you have, yes, obviously you'll make a great case for yourself while interviewing and while trying to get a job in field of data engineering. All right. And there is one more thing as to why you should go ahead and learn Hadoop. No, sorry, Databricks, right? Now, 60% of or 60% or above of the Fortune 500 companies today, they're using Databricks in some way. Databricks is a multi-cloud solution. If you understand Databricks, if you're able to work with Databricks, Databricks will work exactly how it works in Azure, in AWS also, in GCP also. So it does not matter what cloud the company is working with, all right, or what cloud the company has its infrastructure on. As long as you know Databricks, you can go ahead and work with a company who has, which is having all of its resources in Azure, also with a company that is having its resources on AWS. Then in that case, you just need to know more about the AWS services because you already know the capabilities of Databricks, right? How it's going to work. So you don't have to change your knowledge around Databricks. All you have to do is change your knowledge around the cloud services. And cloud services, when working with Databricks, is not a very huge part. The majority of the portion is on Databricks itself. Clear? So if you're looking to switch to data engineering on Azure, right? Uh, then obviously you're going to find increased job opportunities across industries because Azure currently is the fastest growing cloud. All right. There are several studies that suggest that almost 85% of job openings today mention Azure as a required skill, right? In data engineering, they will mention Azure or Azure specific services. All right. So data engineers are essential across multiple sectors: finance, healthcare, retail, tech companies. I've told you everything about that. And businesses, they rely on structured data to create these pipelines, to create, to get analysis and everything, right? And good data engineers are highly sought after today. So if you are demonstrating an expertise in big data processing, especially with Databricks, right, uh, you can significantly expand your job prospects, across industries. So I'll just quickly walk you through, 1 second, the what we'll cover in this course, right? And then maybe we can take a few questions. But don't worry, tomorrow is also a demo session. Day after tomorrow is also a demo session. So I would suggest everybody to sit here in those sessions at least, and we can have a discussion. Tomorrow also we can have, we can take up your questions day after tomorrow also, and today also we'll take it. All right. So what are we going to essentially cover in this course? You would, I think, already have the details, right? So it'll start with the basics of Azure. Let me write this, right? So we'll start with the basics of Azure, right? We'll move on towards, what is cloud computing, what are Azure services, what is storage, what is networking, what is security and identity management, and then we'll move on to discussion on how do you create Databricks on Azure, right? Because I need to show you how you actually go to the Azure portal and create a Databricks environment, right? That is also essential. Then we'll come up to setting up the Databricks workspace itself, right? So this is where, we'll see how you create the workspace, how you configure it, how do you set up your Azure storage and Databricks integration, right? How do you connect your Databricks to your data lake storage? Then we'll try to work with the data where, that is going to be the module 3, that is working with data, right? So this is where, we'll see reading and writing data from various sources, trying to do analysis and transformation on the data using SQL. All of that we'll do in this particular section. Then we'll move to the next module, that is module 4, where we'll talk about the advanced data architectures in Databricks. We'll see the medallion architecture in Databricks. We'll see the data lakehouse, the Delta Lake, all those things. Then we'll move towards module 5 that talks about visualization and creation of dashboards using Databricks. How does it integrate with Power BI? That also we'll see. We'll see ADLS and Databricks integration. How do you mount ADLS on top of Databricks? We'll see Hive Metastore, how you create databases, how you create tables and views within the Hive Metastore, right? We'll see how you can, stream data and do streaming data analysis using Databricks. We'll see how you can create pipelines using Delta Live tables within Databricks. And we'll see, Databricks jobs also. We'll see source control, CI/CD with Databricks. And then finally, we'll talk more about the governance part, where we'll see the access control within Databricks. And we'll have the final project discussion. So all the core capabilities of Databricks we are going to cover both theoretically and through demonstrations in the class, right? And I'll also be giving, wherever necessary, I'll be giving you practice problem statements with the data sets. Obviously, you have the data set, you have the problem statement. Now I'll leave it to you to do the implementation work. All right. So that is going to be the entire course structure. This is what we're going to cover. Tomorrow, we'll have a demo on basics of Azure. Day after tomorrow, we'll have a demo on Spark and Databricks. All right. So I want to cover both of them. Right. So day one, Azure only demonstration, and day two, of the demo, the day three it will be, right. If you count today as day one, then day three would be talking about Spark and going into the depth of Spark architecture, trying to understand how the data is processed, how the data is distributed, how the memory management is done. All of that we'll cover on day three. Is that clear to all of you? Yes or no?
Yes, do you
Yeah.
cover unit catalog here?
Yeah, I think multiple people spoke at once. I could not.
Sorry,
Yeah,
Yes,
were you
yes.
covering Unity catalog?
the recording you're asking about,
No, classes.
the
Some,
classes will, yeah, the classes will be from 9:30 to 10:30 p.m.
I'm
late night
asking
class.
about the Unity catalog. Unity catalog is important part of data governance, right? So,
Yes, Unity Catalog also will be working with the data governance and compliance part. That is also part of syllabus.
yeah, thank you.
Yeah.
I am Rishi, and I have one question actually. So,
Mhm.
okay,
Wait, wait, I'll just
yes.
mute them. Yeah.
So I was just
Mm.
wondering, like, so I heard something about the AI BI in the Databricks. Is that also the part of the course?
Uh, See, AI and BI. So BI we are going to cover to an extent. AI is not something that we are going to work with, extensively within Databricks. All right. Our focus will be mostly on data engineering solutions.
Okay, okay. Thank you, thank you.
Yeah.
Hello, Shreyas. I have two questions.
Mhm.
I want to know what is the prerequisite for this course? And the second question would be how much years of experience I can claim after completion of this course?
Yeah. So prerequisite is very simple. SQL, you should know. Uh, Somewhat data analysis using SQL, you should be able to understand, right? What is aggregates? What is, how do you do different type of joining and all? So all those things are important. Apart from that, uh, basic level of understanding to a basic to good level of understanding of Python is required. All right. If you do not know Python, we'll be sharing a Python tutorial with all of you, right? The basic Python tutorial. I have some resources available with me. So in the first week, when we are going through the basics of Azure, you can take out some 20-30 minutes a day and go through those basic Python videos, right? When it comes to PySpark, right, in general, the library that we're going to use, that we'll be trying to cover from the scratch in the class, right? And PySpark you'll learn end to end within the class itself, so you don't have to worry about it. But have some understanding of Python.
Okay, yeah, sure.
Yeah. So will be sharing. So whoever registers for the course, we'll be sharing the Python tutorial to all of them.
Okay.
I have one
And
question. Yeah,
and
go on.
how,
Yeah.
Sorry.
yeah, sorry. And there was one more question.
Yeah.
How much years of experience can we show with after completion of this course?
See, after completion of this course on Databricks, you can claim anywhere from 2 to 3 years of experience. That is the kind of depth that we are going to get into. And
Okay.
obviously, at every given point, there will be a lot of hands-on. Uh, Whatever we do in the class, you'll have to perform it on your machines, and on top of that, also with the projects, with the regular exercises, you'll have a really good hands-on experience on Databricks.
Okay, okay, sure. Thank you.
Yeah,
Hi, Shreyas. I have a question.
yeah, yeah. Hi,
So,
Om.
based on this PySpark and Databricks, can anybody switch into a data engineering role if somebody has more than 8+ year of experience?
So you're asking with 8+ years of experience and using PySpark and Databricks, can you switch into data engineering? Yes, obviously you can, right? These are uh, basically these are tools that data engineers use, right? Obviously, you'll have to build more expertise on top of it when it comes to, let's say you want to become an Azure data engineer, right? Then having understanding of Databricks is important because you'll get a lot of roles where Databricks would be a mandatory requirement. But on top of that, you also need to have some understanding of tools like Synapse, Data Factory, uh, Stream Analytics Service, all these different various tools on Azure, right? So that basic understanding I will give you within the class itself. What is Synapse? Why is it used? What all you can do? What is Data Factory? Why is it used? What all you can do, right? So you will have that level of understanding, but then again, you need to build more on top of the other services. All right. But Databricks
Mhm.
and PySpark on their own are, extremely good skills to have, right? They have nothing to do, I mean, obviously it all relates together, but then you can learn them separately also.
So, like, do you have any comprehensive course for complete data engineering which cover all the required tools and technologies?
Yeah, we are conducting, our data engineering courses where we cover everything, uh, all these services. That will start, with Azure, going on to data lakes, going on to Cosmos DB, then talking about Synapse, Data Factory, Scheme Analytics, Databricks, all those things. You can get in touch with the backend team to know more about it.
Okay, yeah.
Yeah. All right. So I think it's pretty late today, but don't worry. We have another 2 days to connect, right? So we'll have demo session tomorrow also and day after tomorrow also. And I request everybody to please be a part of demo session, right? You'll get to understand as to how we are going to, take on the concepts in the class. That'll give you a very better understanding. All right. Please do
Shreyas,
attend the yeah.
uh, yeah. Can I ask you one question? Just last
Mm-hmm.
question.
Yeah. Go ahead.
So basically, I am from a testing background, and recently I have done my master's from UK, and
Mm-hmm.
there, as a dissertation, I have done my project in, of ETL. So I
Mm-hmm.
used Talent and end-to-end project I have done from setting up the database, data warehouse till Power BI. But yeah,
Mm-hmm.
it was like a basic project.
Yeah.
And now I'm trying to move on to this course with the data engineer.
Mm-hmm.
So, what do you suggest me? Like, will it help me, or will I be able to, or what? I'm not sure.
All right, I understood your question.
Yeah.
See, uh, if you want to really get into data engineering, and since you have a background in ETL, right? You just said, so these services, they are very important. Uh, Databricks or other services also, right? They're very important. And if you want to build your career in data engineering, then these are must-know technologies for you, right? Databricks, PySpark, extensively being used, right?
Okay.
And your existing knowledge, right, that you have in ETL projects, right, whether it's a data pipelines that you created, right, data validation you would have done, you would have tested your pipeline, CI/CD integration of those pipelines also you would have done, right? So on top of that, Databricks and other Azure services also that we're going to discuss about, right, they're going to be very useful for you to, transition completely into this data engineering role.
Okay, yeah, because I was thinking like I'm new to cloud. I have never worked in cloud. So, yeah, but although I have an interest to get into this field, so mm,
All
just
right,
wanted.
you
Yeah.
get in touch with the backend team. We'll discuss
Okay.
more on this.
Okay, sure.
Yeah,
Thank you so much.
yeah,
Yeah.
yeah. Thank you. So
Sure. So
Eh,
last question from my
yeah, go
side.
ahead.
Uh,
Hmm.
Yeah, do we covered any data build tool DBT from here?
Do we cover any?
DBT, data builder tool.
Uh, Not specifically.
Okay.
Specifically here. Yeah.
Okay. You're not touching any DBT or 510, right? 510
No, no,
like
no.
Okay. Got it. Thank you.
Yeah, yeah. See, it's not a native part of Azure Databricks, right?
Puna, ki-
Yes,
All
I
right.
understood, but the market is so requesting these all tools. Yeah, thanks.
Yeah.
Shreyas, I have one question. So, how much of the Python and the SQL knowledge that you do need to get this Databricks?
See, for any data engineering role, SQL is the most essential part from what my experience is, right? SQL is a must know thing, must have skill in your skill set, uh, and when you're talking about SQL, right, I would say that it's not something which will take 1 month or 2 months for you to master it, right? Even if you sit for 5 days, 10 days, you can master SQL, right? So therefore a good understanding of SQL is something which is required. When it comes to Python, eventually, to become a great data engineer, you will have to master Python, right? But for this course, to understand, right, the concepts and the things, you should have a basic understanding of Python. All right. But yes, as I said, the sky is the limit. And if you want to reach the sky, then you have to become a master at Python eventually, right? But having that, master knowledge in Python is not something which is required for you to complete this course, right?
Got it.
Because
Okay.
PySpark will be covering end to end in general.
Okay. So while learning PySpark, we'll be able to learn Python. Is that what you're suggesting?
Uh, Not exactly. Python gives you a lot of different various features. PySpark generally, helps us to talk to the Spark architecture and work with our data transformation. So that part, I'll make sure that you understand. But rest of the Python, that you have to master yourself. Yes.
Got you. Thank you, Shreyas.
Yeah. All right. All right then. Thank you all. Please do join the session tomorrow. We'll have a discussion on Azure, and we'll try to see basic services in Azure. And day after tomorrow, we'll have a session on Spark and Databricks. All right. So we'll cover both of them.
Yeah,
So
sure.
thank you.
Sorry. Yeah,
Yeah.
what is the course cost? Any chance?
Course
You.
cost is rupees 12,000.
Yeah.
Oh, okay. Great.
Yeah.
We'll be sharing this today's class, right?
Yeah,
On video.
this video will be posted on YouTube.
Okay.
Yeah. You can
Thank
go
you.
through this video on YouTube.
Yeah,
Yeah.
and those who are interested to continue, please join the same meeting link tomorrow as well.
Sure.
Yeah.
Yeah.
Thank you.
All right. Thank you all. Thank you all.
Thank you.
I hope to see you guys tomorrow. Thank you for your time, everyone.
Yeah,
Thank you. Thank you.
thank you.
In today's session, we'll try to understand, what cloud computing is, what Azure is, and what all various services that Azure offers, right? So we'll quickly go through the various aspects of Azure as a cloud platform. So that is what we're going to cover today in this particular demo session. All right. Now, when you talk about Azure, right, we cannot directly go to Azure. First of all, we have to understand what led to the development of cloud computing, right? What made on-premise environment or private cloud, as you call it, what were the limitations there? What were the issues there, or what benefits did cloud computing or these cloud service providers, as you call them, CSPs, what benefits they offered, for organizations and entities to move to cloud, public cloud. All right. So cloud computing in general is a model, right, that allows you to create resources on the cloud. When I say on the cloud, what I'm trying to say is that you will not be creating these resources in your own environment. All right. These resources will be created somewhere else in the data center that will be managed by the CSP. All right. CSP stands for Cloud Service Provider. You have Azure, you have AWS, you have GCP. These are all different CSPs that exist. IBM, all right. Red Hat also offers cloud solutions to you. So these are all different cloud platforms. Now, what type of resources are we talking about, right? And how do we access these resources? So let's take a very small example that you want to train a machine learning model, right? And the data that you have, right? Let's say this is 2 terabytes in size, and the compute that you need to train your model, let's say you need 8 cores of CPU and 64 GB RAM, right? And you do that with a laptop in hand, which is an i5 laptop, let's say, for example, right? Which has, let's say 4 cores and 16 GB RAM. Yes. And 512 GB of SSD storage. That means I cannot do it on this machine, right? Clearly, I cannot do it on this machine. So I need another machine to do this task, right? Now I have 2 options. One, I can go ahead and create a virtual machine on the cloud, right? Where, the cloud is basically the data center, right? You can think of it like a building. And within this building, the cloud service provider will have a lot of servers which will offer the compute. There will be a lot of storage there. There will be networking installations there. There will be cooling system there. So everything that you can think of in a proper on-premise data center. When I say on-premise data center, I am referring to data centers that organizations built within their own campuses, right? So all these major organizations, if you see in India, right, Infosys, TCS, Wipro, they would have created their own data centers, right? And they would be utilizing those data centers for their compute requirements or storage requirements, right? To host their applications, right? Servers where their applications would be hosted. Now, this servers, right? If I want to create this, right, on the cloud, as I said, I can create it on a virtual machine, which will be hosted on the cloud environment, right? So the environment which is not on premise is the cloud environment that you access over the internet, right? If Azure has built a data center or AWS has built a data center, they will never let you enter the data center. All right. They'll not let you go to the servers, the racks, wherever they have stored it. They'll never let you do that. All right. So this is something which you can only access over the internet, right? So you just need a machine and you can configure your virtual machines, and within 5 minutes, right? Within 5 minutes, you'll have this resource ready. 8 core CPU, 64 GB RAM, 2 terabytes of hard disk. You can have 4 terabytes of hard disk there, right? And the best part is there is no extra payment that you have to do, right? When I say extra payment, obviously there will be some payment that you'll have to do, but that will be nominal per hour rent. All right. So I'll tell you, for a virtual machine that has, let's say 4 cores of CPU and 16 GB RAM, the cost of running this virtual machine per hour is almost 16 rupees. So for 1 hour, I'll only spend 16 rupees. All right. So that means if I want to, run it for an entire day, I'll incur a cost of around almost some 400 odd rupees, right, per day. If I want to train this model for 5 days, that is almost, very nominal fee. Compare it to a situation where you have to go ahead and buy these resources, right? Cannot do. So these resources can put anything. I gave you an example of a virtual machine there where you want to create a machine very similar to your laptop to train your AI model. But there are several resources that you can create, right? For example, the Databricks resources that we are going to work with. It's an analytics, data engineering resource, right? Azure Data Lake. If I want to store data, I can create this data lake, right? So you would have seen on Google, you get this, disk storage space available online, right? Over the internet, right? Google will not give you the physical storage device. They'll not give it to you. They'll say that we'll let you create a space, whether 100 GB, 200 GB, 1 TB, 5 TB, 10 TB, whatever space you want. We'll give it to you, but you can only access it online over the internet, right? Networking resources. If you've created any resource and you create it on the cloud, right, then Azure will not have created that data center just right next to your house. Those data centers would be far, far away from where you are situated in some situation, right? So when I create a virtual machine, I generally select a region. When I say a region, that is where the data centers are, situated. So when I create a virtual machine, I create it in the East US region. So that is situated somewhere in United States, right? Now, for me to connect to that resource sitting in United States, that resource should be a part of a network. Yes or no? If that resource is not a part of network, then I cannot talk to it, right? You need network in order to talk to each other, right? So therefore, those networking resources will also be created on the cloud. You have several other networking resources like a firewall, a VPN gateway, right? These are all various, networking solutions that you create. Then you can create compute-based resources also. Let's say I want to host a web application, right? So instead of hosting it on a server within my data center, I can go ahead and host that web application on the cloud, and the cloud will give me much more benefits, right? And a lot of features also to host that application on the cloud. A lot of features, right? That is why most of the organizations are today migrating to cloud. All right. And Azure is the fastest growing CSP in the world right now. All right. It's the fastest growing CSP. And various reasons for that, right? It's closely integrated with Microsoft, right? And it's created by Microsoft. Why not integrated? It's created by Microsoft. And Microsoft is something which is, closely integrated in our lives, right? Any organization you go to, they would be using Microsoft based products, right? So that is where Azure comes in handy. It connects to all those resources seamlessly. All right. So this is the most basic concept of cloud computing, that I want to create resources, but I will be creating them in a data center that will be owned and operated by a cloud service provider, right? And obviously, it's not something which I'll do out of my wish, right? This is not something which I wish for. It's going to give me benefits, right? That is why I'm going to go to the cloud and host my resources there. So when you talk about cloud computing, right, there are 3 different types of clouds that you talk about. The first is the private cloud. All right. Another name for private cloud is the on-premise system, all right, or on-premise environment. All right. On-premises also you would have seen somewhere. Now, these are data centers that organizations used to create back in the day. All right. A private cloud was created by the organization within their campus. All right. So if you go to a TCS campus, there would be a dedicated building that they would call a data center, right? Within that data center, they will have a lot of racks. On those racks, they would place all the servers. There would be storage devices, a lot of hardware, a lot of wires connecting all the servers together, creating a network. There would be a cooling system in place because these servers, they tend to get very hot, right? When they're running, they tend to dissipate a lot of heat, right? So to manage those levels of heat, right, they have to have a very good cooling system in place. Now these data centers were created by these organizations, in 80s 90s, around that time. And it had a lot of investment also, right? A lot of investment went into creating these data centers, right? uh, a lot of capital expenditure, right? We'll talk about capital expenditure and operational expenditure also. So organizations created these environments, these data centers within their campuses, and they were utilizing these, right? And the organization, since it is created this data center, it is operating this data center, therefore entire management, maintenance, everything related to the data center is the organization's headache now. Clear? They need to hire specialists, people who are going to take care of these data centers, who are going to work as the data center admins or administrators, who are going to manage their environment, right? Their private cloud. And these data centers were only accessible to the associates or employees of that organization. All right. It's not accessible to users who are from outside the organization. Sometimes it will not be able, you will not be able to access it over the internet also, right? So how many of you face that? To connect to your company's backbone network, you would have been asked to connect through a VPN. How many of you faced that in the past? Right? If you're sitting at home or you're in a remote location and you want to connect to this private cloud that we also call as the backbone network of your organization, right? Then you would have been asked to connect through a VPN, right? They will never give direct access over the internet. All right. And only the employees of these organizations will have access to these data centers. So this was called as a private cloud. Then something changed. All right. Around 2010, something changed. What changed? Public cloud started becoming popular. All right. How did public cloud become popular? Let's see. Let's say, for example, and just a hypothetical situation, how it happened. Microsoft, let's say, came to Bangalore. All right, and I'm only giving a hypothetical situation. They came to Bangalore and they wanted to create a data center. All right, they're very excited within their campus. They created a dedicated building, a huge data center they built. But what happened was that eventually they realized that they are not going to utilize this data center completely. They don't have that much work available or workloads available. All right. They realize that their usage of this data center will not exceed 10% of the total capacity. So what about this remaining 90% of the data center? What should we do with this? And I'll give you a similar situation. Let's say you had a piece of land and you built a house with, let's say, 4 floors, right? So ground, 1, 2, 3. These are 4 different floors. Let's say you have a family of 3 and the ground floor is more than sufficient for you to stay. Now, obviously, when you built first, second, and third floor, there would be a lot of investment that went in, right? And the thing about investment is that everybody wants a return, right? If you had a huge family who would be occupying all these floors, that would have been a return, right? That it is catering to the needs of my family. But now you've put in a lot of money and you don't even have to use it. So what do you do to, get your investment back? What do you do? Anyone?
Rent.
We rent.
Rent.
You rent it out, correct? You rent it out, at least get some money back. And that is what, Microsoft also decided. We will rent this space out, right? Where the users will pay an hourly rent, right? They will never get the ownership of this data center. They'll never have the ownership of the servers or the resources that they're using. They're strictly renting business. Right? Something similar to your house. You'll never sell your house. It is only available for rent, right? So one organization came, it took a bit of a space here, right? Let's say this is the space that organization one took. Then another organization came, it took some space. Third organization came, it took some space. Fourth organization came, it took some space. Fifth organization came and they took a large space. So like this, Microsoft started renting out these data centers to, organizations from outside. All right. And what they realized was that it was a good earning opportunity. All right. It was a good earning opportunity to give out, this space within the data center out on rent. And that is what they started doing. Right. Now, what do you call a person who stays in your house on rent? What do you call them?
Tenant.
Tenant.
Right? And that is a term that you would have seen in cloud computing also. All right. Let's say if this organization number 5 is Infosys. So this space is called as Infosys's tenant on Azure. All right. Our tenant, my organization tenant, right? Infosys is tenant, TCS is tenant, Wipro's tenant. All right. This space is called as a tenant. Now, this is how public cloud started becoming popular. And these organizations were not coming and sitting here. These organizations were outside, right? They were just accessing all of this over the internet. They were trying to create their infrastructure. Now, whatever they could create within their, data centers, they were allowed to create the same. They had the same freedom here in public cloud also, with much more features, many more features. All right. The benefits that cloud computing was giving, right? Those benefits were something that these organizations went behind. And that is why, you'll see a lot of, talk about modernization, migration. What is that? Nothing. Just organizations trying to pick up whatever they have in their on-premise environment and putting it on the cloud, right? Because the cloud will give you a lot of features and a lot of benefits, right? Many services on Azure are managed services, right? When we say managed services, it means that the backend part of that service will be managed by Azure, right? So you don't need a dedicated employee sitting there managing your resources for you. All right? You don't need that. So that is where the concept of public cloud now became popular. All right? So these were owned by the CSPs. One second, guys. Just a second. Yeah. So these were owned by the cloud service providers. Let me just change the color. Yeah. This was owned by CSPs, and they provided resources and services to multiple organizations and users, right? As an individual user also, you could go ahead and, create resources on this data center, right? You and I can go ahead and create something over here. It's not just about organizations, right? I'll have my own tenant on Azure. I do have my own tenant on Azure. All right. You can also create your tenant on Azure, right? So everybody, including the organizations, can now go to the Azure cloud and create their own resources. It's available to all. That is why it's called as public cloud. All right. That is why it is called as a public cloud. All right. And you're going to access everything over the internet. That is something which is non-negotiable. Now, take the example of Infosys. We discussed, right? Infosys built private cloud first, right? Back in the day, they had their own data centers, and creation of this data center, it required a lot of investment, right? So they cannot just throw it away, right? They cannot just throw their resources away, right? So they need to continue using their private cloud, but then for the increasing workload, they are now taking support from public cloud. All right. So organizations who already had private cloud in picture, but are now, extending their services on public cloud, what will you call such cloud where we have a combination of private and public both?
Hybrid.
What do we call it? Absolutely
Hybrid.
correct. We call it as the
Hybrid cloud.
hybrid cloud. All right. Now, one more thing is here. Let's talk about the cost, right? So when you talk about the cost with the various types of clouds, public, private, and hybrid, right? Hybrid means an organization which already had private cloud and is now using public cloud, right? So the cost is divided into three parts, right? One is called CapEx, other is called OpEx, and the third one is the rent, which is also a type of an OpEx only. Type of an OpEx, but I classify it as rent so that it's easier to understand, right? But rent is also an operational expenditure. We'll understand. CapEx means initial investment, initial capital investment. All right. So when you build your house, there is an initial cost, the cost of buying all the bricks, buying all the steel, buying the cement, buying the wiring, buying the switches, right? Flooring, roofing, everything is the initial investment, the one-time investment. All right. One-time investment is called as a capital expenditure. Operational expenditure for my house. Can anybody tell me what will be the operational expenditure for my house? This is the recurring cost that you have to pay monthly. What is the monthly
Electricity
cost?
bill,
Electricity bill, house tax,
water.
right?
Yeah.
Recurring cost, water supply cost, right? Security cost, maintenance cost if it's there. So a lot of different costs are there which are recurring every month, but they are not huge, right? They're not huge. Huge cost would be building the house. That is the initial investment, the capital expenditure, the one-time cost. And rent is when I am using a CSP based solution and I am renting the services on an hourly basis, something like this. So three different types of costs are there. Now my question to all of you is, which cloud, and think very carefully, is the most expensive, and the second one is most secure? What do you think? Give me both of these answers. Which cloud do you think is the most expensive cloud, and which cloud do you think is the most secure cloud?
Might be GCP.
No, when I say cloud, right, I'm asking between the different cloud models that you've seen: public, private, and hybrid. Among these three,
Private is more secure.
It is more most
which one
Public.
is most expensive?
Yeah.
Public
Public.
is the cheapest one.
Put your
Private
answers in the
is
chat window. I think
Private,
everybody is.
yeah.
Private is the
Private,
most expensive.
Yes.
yes,
All right, and most secure.
All
and
of
might be
them.
private.
Private and
Private is considered to be most secure. Yes, that is true, right? Because it does not give you, but availability over the internet. Anything available on the internet is considered to be unsafe, right? That is why, as an administrator, when we create resources online, right? Let's say if you're creating a virtual machine, you generally do not keep a public IP address for that virtual machine, right? Keeping a public IP address means that it should not be publicly available. We use other methods to access the virtual machine. All right, we do not make it available directly on the internet. Clear? So public cloud, yes, it is considered to be most safe. Sorry, private cloud. That is why the banking organizations, right? Most of the banks, they rely on private cloud. Defense organizations, the defense organizations, they also rely on private cloud generally. They will not put their data on public cloud. Clear? And the most expensive, you are saying private cloud, correct?
yes.
Yes,
Let's see.
infrastructure, everything they have to take care.
Yes, understood. Let's see. All right. So costs, you have capex, opex, and the rent, correct? Now, when you talk about public cloud, private cloud, and hybrid cloud, right? Let me have it like this. The costs are capex, opex, and rent. In my public cloud, do I have any capex involved? Yes or no?
Yes.
Yes or no?
Yes.
No.
Yes. That initial investment
Capex.
is required, right?
What
Okay,
is
so
capex?
capex is the
Initial.
initial investment, the one-time cost of buying all the hardwares and, let's say, constructing the data center building and everything.
No.
The initial cost, that is a
Public,
one-time cost.
Public
for public,
capex,
it is
no.
not required capex.
Yes, capex is not required. Why? Because I don't have to pay the capex. The CSP
Yeah,
will pay the capex, correct?
correct. And we're paying the
So
rent.
for
Okay.
me, from my perspective, am I putting in the capex in public cloud? No, I am not.
No.
Am I paying the OPEX? Am I paying the electricity bill and everything, the salaries and
No.
all? Operational expenditure involves paying the monthly recurring costs like salaries, electricity bills, internet bills, taxes, whatever it is. But
No.
I am not supposed to pay that. Am I going to pay the rent of the
Yes.
services that I'm
Yes.
using?
Yes,
Absolutely.
Yes.
I am responsible to pay the rent, right? Whatever services I am using in public cloud, I have to pay the hourly rent. Whatever the duration of my usage is, I have to pay the accumulated cost for it. Correct? Perfect. Coming to private
You
cloud, when I
means
set up,
here organizations, right? I have one doubt.
yeah,
When
see,
you
whoever
say
is using the
you,
public cloud, when I say you, I mean you as an individual also and you as an organization also. Anybody can create
okay.
an Azure account. All right.
Okay.
In
Yeah.
personal capacity, also you can create an Azure account, a subscription you can get and start creating resources. As an organization, also you can get a subscription and start creating resources. Whatever resources an organization can create, the same resources you can also create. All right.
Okay.
There is no filtering that is happening there. When it comes to private cloud, are we responsible to pay for the capex?
yes.
Yes.
And again, when I say we,
Yes.
it could be me if I am creating that private cloud. It could be the organization if organization has created that private cloud. So we do
Okay.
end up paying the capex. Why? Because this is my private cloud. I am going to build this from scratch. I'm going to build the building. I'm going to get all the hardwares, the servers, everything. I'm going to install the cooling system. I'm going to get the power backup. Everything is my responsibility in private cloud. Do I pay the operational expenditure?
Yes.
I do. Whoever the staff for my data center, the electricity cost, the internet cost, everything which is a recurring cost, I have to pay for it. Do I pay a rent here?
No.
No.
I don't pay a rent here. I don't pay any rent here. Coming to hybrid cloud, will I have capex?
Yes.
Yes.
Yes, because in hybrid I will also have my private cloud, so capex will be
Yeah.
there. OpEx,
Yes.
Yes.
OpEx will also be there. What about the rent?
Yes.
Yes.
The rent will also be there. So which cloud is most expensive now?
Hybrid.
Hybrid.
Hybrid. Hybrid cloud solution is the most expensive because you are using both, right? You're using private also and you're using public also. So when you're using both the offerings, then obviously you're going to pay more for it. Is this clear?
Yes. Uh,
Yes.
I have one question actually on the public and the private part, right? So
Yeah.
if me as a person or a company, like if I get the service from the, let's say, Azure, if I'm using their cloud service, right? So will that be, though I'm using a public cloud, will my cloud will be private or will that be a public?
No, see, when you're using public cloud, your space is only your space.
It is
If you
still a
remember,
private only, right?
no, it's
Yeah,
see, if it in definition, yes, it's private. It's your private property, right?
Okay.
But the resources will be created in the data center that has been created somewhere else
By
by the
somebody else.
cloud service provider. Yes. All right. And you,
Yeah, it will be secure only, right? It is not
yes,
like a
yes,
public. It is not
very
like
secure,
anybody
very
can view
secure.
it or something like
No,
that.
no.
Yeah.
So that is where the directory and the tenant picture comes in. Your tenant will belong to you. Only the people you allow access to that tenant will have access to that tenant.
Got it.
Apart from that, nobody can see what is there. Even Azure cannot see what you're storing and where you're storing.
Okay.
If I got 1 terabyte of space from Azure, right, and I'm storing my data there, Azure can never see what data I'm storing. Never.
Gotcha.
All right. So the security is very high. You have a lot of security features, right? Microsoft Defender for Cloud, Sentinel. These are all different services that have been created to secure your environment. And that is something which cloud computing is offering, right? Security. They want to, assure everybody that they're highly secure. Right.
Gotcha.
Now,
Sorry to interrupt you. I have one doubt
Mhm.
here. So nowadays, the hackers will hack that everything in the centers, right, to get the information. How these people are trust this cloud, even though if they provided the security.
I did not understand your question. Could you repeat? Your
Actually,
voice is
hackers can hack that centers and get that data, right? So
hackers.
how
Okay.
we can trust the data if, even though they provide the security? Just I'm asking about it.
See, hackers.
What type of?
That is what.
Yeah.
See, now when you talk about hackers, right, we are going into a territory where it is all, a gray area, right? There has been no report of any hacker hacking into an Azure data center as of now, or any CSP data center. So that is the level of security that they have. If you've privately hosted something in your own data centers and they're able to get inside, that is different. All right.
Okay.
So whatever
Okay.
code you have running online, see, your application could be hacked. That could happen, right? But not the data center, right? But
Okay.
then again, who knows, right? The greatest of heists have happened. So, but I'll tell you, in general, cloud environment is very secure, highly secure. All right. They will continuously, check for any security vulnerability. They have a lot of resources running, which are, looking for any sort of attacks, any sort of, anomaly, right? Even when authenticating users, now you will see that back in the day, how did authentication happen on Facebook? If I ask you 10 years ago or 15 years ago, how would you authenticate onto your Facebook account or any other social media account?
Just one
You would
password.
enter just username and password was
Password.
enough, right? That is it.
Yeah.
But you come to cloud computing today. You know what Azure is doing? They'll first ask for your username and password. Then they'll do MFA, right? Multi-factor authentication or two-factor authentication. Then they will ask for some other proof, right? After your username and password, they'll either take your biometrics, or they'll ask you to enter or open an authenticator app and then press a code or enter a code from the authenticator app, or they'll send you an SMS on your mobile phone that you have to enter. Even after 2FA has been done, now they have conditional access in place.
Yeah.
Right? So if any vulnerability is there, so in conditional access, what they say is that we are closely tracking the way you access your resources. If you access your resources every day sitting in Bangalore, and there is an attempt to log into your account from a location which is not natural, let's say somebody in US tries to log into your account, immediately the access will be blocked, right? Location flagged, right? Similarly, device flagging. If you're accessing from a compliant device, we'll give you access. If your device is not compliant, right, or connected to the organization's Entra ID, then we are not going to allow you to access the resources. So now they've added conditional access also. On top of conditional access, they have added role-based access control for security, right? So based on the role that you have, you'll only be able to access those resources, right? So now, if I look 15 years ago, I was able to access all my personal private information just by username and password, correct? And today now I have 4 or 5 different authentication and authorization methods also in place, right? So that is how the security has increased, and it will continue to increase, right? There are a lot of things that they're doing regularly to increase the security.
So
So
I was
data
just
centers.
yeah.
Mhm.
I was just curious then. So if the cloud, public cloud is so secure, why would people choose to have a private cloud?
Because they think private cloud is more
It's just
secure.
okay.
Yes, it's a psychology,
Okay.
right? Sometimes that happens. It's more of a psychology that if we are not available on the internet, if we are secluded from everywhere else, we are more secure, right? But that might not be the case every time. Sometimes people will be scared to put their belongings in the bank locker. They would feel secure having it in their home, right?
Yeah, correct. Yeah.
That is a psychology. But
Understood.
any day the bank locker is more secure than your house.
Yeah.
So generally because what banks are available to the public, right? It has public access. Your house does not have public access. So that is why they believe that it is more secure, since public access is not there. But that is not how it works, right? So there's a psychology. That is why these defense organizations, you see in India, the banks and defense organizations, they rely on private cloud. You go to US is asking Azure, the US government is asking Azure to build their data centers for them.
Yeah.
All right. So in US, we have these reserved data centers that are created by Azure, right? But used by only the US government. All right. They will use those data centers for their compute purposes. So moving on, I think, guys, can you all please mute yourselves? Yeah, thank you. There's some disturbance coming in. So these are the different cloud models, all right, that we just saw. These are your various different cloud models, we call them, right? These are your models, the public, private, and hybrid. After models, we have something called as cloud services. All right. And before we go to cloud services, let's talk about the cloud benefits first. Now, high availability. All right. So these are the benefits that cloud gives you over your private data centers. All right. And I'll give you examples also here. When you talk about high availability, right, the first cloud benefit is high availability. And this means that your application or your resources are available. What does that mean? Has anybody ever tried to book a Tatkal ticket at 10 a.m. in the morning? Yes or no? You booked a Tatkal ticket?
Yes.
Yes.
Will you call that website highly available at 10 a.m.?
No.
No,
No.
it's not available. All right. It will crash, it will do all sorts of things, but you will never be able to reach the final page, right? It does not work. So that is called, low availability. Similarly, you go to State Bank of India, most of the time they will have just one response to all your queries. The bank servers are down. Now, servers being down, does that signify, high availability or low availability? That is low availability. So whenever I am unable to access my resources, it is called as low availability. And low availability creates a very bad customer experience. All right. It's a very bad customer experience. That is why Azure offers high availability. And how does Azure offers high availability? It offers high availability through SLA. What is SLA? SLA stands for Service Level Agreement. All right. And what is the Service Level Agreement? It's a guarantee. All right. Service Level Agreement is a guarantee, and Azure guarantees you that your application will be running. Right. So how is this SLA provided? It is provided in percentage. So for various services, Azure will have all different sorts of SLA. And let's say for a virtual machine, a virtual machine's SLA could lie anywhere between 99.90 to 99.99. All right. So basically, there are three types of SLAs here. If it's a single machine, it's 99.90. If it's using an availability set, then it is 99.95. If it is using an availability zone, it is 99.99. So different architectures of creating the virtual machine, and with all different architectures, you get higher and higher availability. Now, what this 99.90 SLA or 99.95 SLA or 99.99 SLA means is that in 1 month, that is, we calculate by 30 days, in 30 days, the application would be up and running for at least 99.99% of the time. All right. So 99.99% of the time of 30 days, right, will result in 0.01% of outage. Yes or no? 0.01% of outage in total. And this is almost around 4 minutes. So I'm saying that in 30 days, the maximum duration for which your application might not be available is 4 minutes. So is that high availability or low availability? That is high availability. All right. If you calculate this, right, 30 into 24 into 60, you will get everything in minutes. Once you have everything in minutes, right, you can take out the 0.01% of it and you'll get to know. It's almost around 4 minutes. All right. So Azure offers high availability by various things. All right. It will create the architecture in a way that the application is always available. Whatever could go wrong is addressed. Right. For example, if my application is only there on one rack, it will increase the availability by hosting it on 2 racks. Right. If it is in 2 racks and this is a data center building, these racks are within the data center building. What if the building goes down? What it will do? It will replicate them in 2 data center buildings. So step by step, it can increase the availability as your requirements. All right. Then you have fault tolerance. What fault tolerance means is that you can deal with any sort of fault, right? For example, let us discuss about 2 types of faults. One is where you have a fault with electricity, right? And the other one is where you have fault with internet, right? So electrical fault, internet fault, how do I deal with that? How do you deal with electricity based fault or internet based fault? You have multiple power backups. Yes or no? Multiple. Why? Because if one of the main power fails, I have backup number 1. If backup number 1 fails, I have backup number 2, right? So I have multiple backups available. There could not be a situation where my data center will run out of electricity. It will never be. Similarly, if the fault is related to internet, what will I do? I will have connections from multiple ISPs, internet service providers. I'll not just have, connectivity from one internet service provider. I'll use Geo also, I'll use ACT also, I'll use, BSNL also, I'll use Airtel also, I'll use Vodafone India also. And trust me, when I say, and I'm taking the names of these service providers, these are the actual service providers. All right. It's not that Vodafone and Geo are only into, installing or giving you SIM cards. No. They provide high-speed internet to these data centers. That is also a service that they are involved in. Clear? So to deal with any type of fault, we have a mechanism in place in cloud, and that is the benefit of cloud, right? So that was the second benefit. The third benefit is the benefit of scalability. Now, all of you know what scalability means? Yes or no?
Yes.
Increasing or
Yes.
decreasing.
Increasing or decreasing. Now, if I ask you, do you know if there are multiple types of scaling? How many types of scalings are there?
Yeah, horizontal
Horizontal
and
scaling and vertical scaling.
Absolutely correct. You have two different types of scaling. One is horizontal scaling and the other one is vertical scaling. And when we talk about Databricks, all right, when you talk about Databricks, this will come into the play. How? Traditionally, to process the data, I had something called as a monolithic system. What was a monolithic system? It was a single large machine with high compute, very high compute. Compute is what? Compute is CPU plus RAM, right? So very high CPU and RAM. And that single machine was very big. All right, don't think that I'm talking about a machine that is having 16 cores. No, not 16 cores. I'm talking about 200, 300 cores or 100 cores of CPU. All right, that is the size I'm talking about. And this monolithic system was used to process the data. All right. Now, what we did with this system was, as and when there was a requirement, we increased the capacity. If the RAM was, let's say, 500 GB, we made it 550 GB, right? So you increase the capacity of existing resources. What type of scaling is this? What type of scaling is this? This is your vertical scaling. Why? You had a machine, you increase the capacity and made that machine even bigger. So you are increasing it vertically. Clear? Yes or no?
yes.
Coming to the distributed computing. Let me write it with a different color so you can understand there's a difference between the two. When it comes to distributed computing, on which your Hadoop also relied a bit. Apache Spark relies on this, right? And Databricks relies on Apache Spark. So distributed computing. What did distributed computing say? It said that if required, I have one machine. If I need more power, I am not going to increase the capacity of this machine. I am going to add more machine. All right. If I need more machine, I'll keep on adding more machines. All right. So instead of increasing the size of a single large machine, I keep on adding more machines. What type of scalability is this? This is horizontal scaling.
Snowflake.
Yes. And this is what is used in Spark, Databricks, Hadoop. This is what is used. Horizontal scaling. These all individual machines are called as nodes and they are together called as a cluster or your compute cluster. So that is scalability. Clear? Now, after scalability, we had elasticity. Now, what elasticity says is, and it is very similar to scalability. Elasticity and scalability go hand in hand. In both the places, we are talking about increasing the capacity of my resources. All right, in both of them. But with elasticity, it is a dynamic increase. The system's ability to increase the compute, increase the storage, or increase its resources dynamically. That is elasticity. All right. Clear? When you can do it, auto scaling is, dynamic. We call it an elastic system, right? Then you have global reach. What is global reach? Global reach is very simple. Global reach says that Azure is present everywhere in the world. Yes, and I'll show you the picture also, where you would be able to see that Azure is present in your, or let me show it to you. Let me see if I have that picture available. Yeah. So, is it visible to all of you?
Yes.
We have a lot of data centers in North America. We have, a few coming up in South America. We have a few in South Africa. We have a lot in Europe, then Middle East, India. In India, we have 3 data centers: West India, Central India, and South India. South India is present in Chennai, Central India is present in Pune, and West India is present in Mumbai. Then we have, data centers here in Japan, China, Korea, right? Southeast Asia, and then Australia and New Zealand, right? So Azure is present around the globe, and that is what global reach means. But what is the need of global reach, right? Why do I need that? Why do I need global reach in Azure?
Mm,
Anyone?
Maybe you want to get it fast. You can.
Yes, latency. Latency is one of the reason. Yes.
Cost.
Yes. Cost. How cost?
Might be region to region. The charges will be different.
Yes, that is different. See, I'm saying charges are different. Obviously, it's like petrol, right? You will buy petrol in some price over here in a particular state, and you go to the next state and the price changes. So the cost is like that. All right. But what I want to understand is, see, pricing is not going to affect global reach, right? That is on me to decide where I want to create it. Latency is one, right? If I want something near me, then I can have, right? Then I can make use of this feature where, or
To
this,
deal with the regional data,
could you repeat?
to deal with the regional data,
Regional
like
data. What is regional data?
in the sense, see, we have a one language and Spanish, they speak another. To process their particular own country's data, we will be
That could be done anywhere. It does not matter.
okay.
It does not matter. You were close, but not that.
Availability.
Availability, not really. It will be available, but latency is, yes, there. All right. Availability will be always there, but latency is something which, if I want to access the data fast, I'll have it in India rather than having it in US. Local regulations. For example, how many of you are using MasterCard? Anyone here who's using MasterCard or American Express?
Yes.
Yes. All right. So in 2000, I'll tell you a short story and we'll end the session with that. In 2019, the government of India came out with a law, and this law required organization to store, data which was related to Indian citizens. All right, somewhere in India only. So in 2019, government of India came out with a law that required organizations to store data of Indian citizens somewhere in India. You understood this?
Got you.
And this is something that MasterCard and American Express and other companies also were not following at all, right? They were storing the data of Indian citizens in US. So the government asked them to stop their operations. And that is why, if you know, I had, people I know working in American Express. I had people, in MasterCard also who were working in MasterCard. And I got to know from them that American Express and MasterCard have been banned, you know, from issuing any new cards. That is why for almost, I think, around October of 2022, starting from 2020, for 2 years, American Express did not issue a single new card in India for those 2 years. And you can search it online. It's available. Why? Because they were not compliant with local regulations. What was the local regulations? Local regulations required them to store data somewhere in India, right? So until and unless they built an infrastructure in India, right? Now they had two options, either to build their own infrastructure or they can take help from Azure and create the infrastructure there, right? So this is where, Azure came into the support or the help for all the other organizations that were storing, data outside. And now it gave them a platform to store the data of Indian citizens in India. Clear? Have you heard of GDPR? Anyone who has heard of GDPR? It's a very famous regulation. It
Yeah.
stands for
Yes.
General Data Protection Regulation, and it applies to European Union. All right. The GDPR regulation says that information related to any European citizen cannot be stored anywhere outside Europe. All right. So, like this, there will be local regulations. And if there are local regulations, then you need to have the data centers present there to store the data. Is this clear now to everybody? Does this make sense?
Yeah.
Yes.
All
So
right.
basically, all data centers will not have all the data. It's basically, every data center will have a different kind of a data, right?
Uh, I did not get it.
So, like for
What?
example, the US,
Hmm.
US,
Yeah.
we have a data center.
Hmm.
Anything related to US will be stored in the US data center. Anything in the India,
If
it
the
will be
local
in
regulation says so.
the
If
Europe.
the if the see American Express and MasterCard were keeping sensitive information, right?
Correct.
When you talk about transaction based, right, financial data of individuals from India, then they're, that becomes sensitive data. So they're not stopped from keeping general data outside, but sensitive data that they cannot.
Yeah.
All right. Similarly, you would remember a lot of Chinese applications were banned at the same time, saying that they are storing our data, somewhere outside. We'll not allow that. Correct? So, with that, we'll stop here for the day. And we again have a demo session tomorrow also. Tomorrow, we'll cover Spark architecture. All right. I'll take you through the journey of what Spark is all about, why it was created, how it is created, how it works, and what benefits it gives you over the traditional systems. And that is why, looking at those benefits, the Databricks rely on Spark as the core processing engine. All right. So we'll have a discussion on Spark tomorrow.
Yeah.
So I expect to see all
Yesterday,
of you tomorrow. Yeah.
sorry to interrupt. Yesterday
Yeah.
I
Go ahead.
didn't attend the session. Just I want to know what prerequisite we need to learn this Databricks.
See, you should know SQL and you should
Okay.
know basic Python.
Basic Python means scripting level is enough for
Yeah,
oops and
scripting level is
okay.
yes, scripting level is good level. I am talking about the basic level over here. 1 second. Yeah.
Okay.
Yeah. And you'll be able to understand everything that we do in the class. If you have some basic understanding of Python, if you don't, we'll be sharing a basic level course with you that you can complete within a week. No problem.
And I'm like, so we will talk more about the cloud when we have the start the class, right?
For the first week, yes, we'll talk about Azure Cloud, but then we'll switch toward Databricks completely, and then we'll only relate to the services, that we'll be using from Azure.
Okay.
Yeah.
Shreyesh, I have one quick question.
Mhm.
Shreyesh, are you hearing me?
Yes, I can hear you.
Yeah, I was a part of projects where we were working in EDW, data warehousing side. I worked in Informatica Power Center tool for 5 years. So you know how that tool works, like getting the data from downstream and processing, transforming the data, and loading into the tables data into
Yes.
the tables, and where our upstream will use the data for reporting side. I just want to know overview of is this one even Azure also do the same the task the what is I was working in the ETL tool, the kind of
See,
taking the data.
ETL on any platform will always remain ETL, which will include three steps: extracting the data from the source, transforming the data, and then loading it to a warehouse.
Yeah.
It'll always be that. Synapse lets you do ETL end to end. Data Factory lets you do ETL end to end. Databricks is also a service that lets you do ETL end to end.
Okay.
All right. So in Databricks
Okay.
also, we can get data from various sources. We can transform the data as we want.
Okay.
In place of data warehouse within Databricks, we have something called as a lakehouse. All right. So
Okay.
we follow a
Okay.
lakehouse architecture, not the data warehouse architecture. We can create data warehouse also. We can connect to, we can create a data warehouse in Synapse and then connect directly from my Databricks to Synapse. That also I can do. But when we talk about Databricks, we will study the lakehouse architecture, which is a mix of data lake and data warehouse, right? It takes the best of both worlds. So we'll see what that lakehouse architecture is and how you store data there.
Yeah, sure. Thank you.
All right. All right then. Thank you everyone. I'll see you guys again tomorrow, same time. Please do join the demo session. All right. Thank you all.
Thank you.
Data processing and how it evolved. All right. So today we are going to work with, or not going to work with, but to discuss, right? How was data, transformed and processed traditionally? Then what happened and how Hadoop came into the picture? What Hadoop changed? One second. It's being recorded. Yeah. What Hadoop changed into the system, right? Then what were the limitations of the Hadoop ecosystem that we had to introduce something called as an Apache Spark, right? Followed with trying to understand the architecture of Apache Spark in very clear and easy manner, right? Now, before the advent of Hadoop, right? Your traditional environments. So traditionally, what happened was before this Hadoop and the modern big data frameworks came into the picture, data was processed, largely, or data processing was largely dependent on centralized systems, all right? Single systems, relational databases, all right? These systems, were effective for structured data and to an extent, moderate volumes of data. Yeah, all right. Yeah. So as I said, traditionally, right, uh, we were processing the data in a centralized architecture. All right. When you talk about centralized architecture, what that means is that data was typically stored and processed on a single server. All right. So data was stored in a single server. Data was processed on a single server. All right. Sometimes on a single server, sometimes on a small cluster of some high-end machines, right? But this centralized approach, meant that all computation and all storage, right, uh, they were bound by the capacity of your single server. All right. So this server would have some capacity in terms of compute and storage, and that became our maximum limit when we were trying to process the data, right? Because to process the data, you need two things. One is compute power so that you can process the data. The second is the storage ability to store that massive amounts of data. Correct?
Sorry to interrupt. What is it compute means? Like exact meaning?
Compute means compute is a term used for CPU and RAM. All right, compute power means some processing power and memory. Clear?
Yeah, thank you.
In cloud computing, generally the word compute is used for CPU and RAM, right? That is why we say compute-based resources. So what are compute-based resources? Virtual machine is a compute-based resource. App service is a compute-based resource. Container is a compute-based resource, right? Why? Because all of them require some amount of CPU, some amount of RAM. All right. That is why when we create nodes in a distributed architecture, we call it as a compute cluster.
So what is this AS? What does it mean?
AS is app service.
Okay.
So within Azure, you know, right, there are many services that help you do a lot of things. App service is another such service that lets you host web applications. All right. So you know what goes into hosting of a web application? A lot of things. You'll need some compute, you'll need some storage, you'll need some custom domain features, some scalability features, some backup related features, right? So all of that is present within this single service. So if I create an app service, I can go and host my application using that app service plan. All right. Now, as I said, these systems and the processing of data was very much dependent on a single machine. And now that is where the problem in any infrastructure lies. If you rely heavily on a single machine, it's very dangerous, right? It's very dangerous because that is a single point of fault. If anything goes wrong in that single machine, your entire infrastructure crashes. All right. So these systems, these centralized systems, right? As the data volume increased, these systems or these models, became a bottleneck due to their limited compute and storage resources. All right. We used to call them the monolithic systems, right? Then we had relational database management system also, RDBMS, like Oracle, MySQL, the SQL server that we have. They were also the backbone of data processing, right? And they used they used to store data in a structured format, right? In the form of a table. Structured data is a data which is stored in a form of a table where you have predefined columns with fixed data types, and each new entry or each new data is a new row, right? So these, your relational databases, right, or the RDBMS systems, they use something called as SQL to query this data, all right, or the SQL, which is your structured query language, to manipulate the data, to retrieve the data, to process the data. Now, these RDBMS systems, they were optimized for transactional processing, correct? What is transactions? Individual operations that you used to perform. Create, update, delete. Yes. So these were all your different transactions, the CRUD operations, right? And what do you do with a database? You add new rows, you delete rows, you modify rows. So these are all individual transactions that you're doing on the database systems. And that is why these systems are also known as transactional systems. All right. And there is another name given to these systems. Can you tell me? Systems which are optimized for transactional data processing.
Online analytical process.
Absolutely correct. We call them OLTP systems. Online transactional processing systems. All right. Now these OLTP systems, they were optimized for transactional workloads. They were optimized to, having a lot of operations happening on the database at a single time, multiple operations, multiple transactions happening. And these systems were, created to efficiently handle those transactions. But what this system could not handle was analysis of data. Why? Because analysis requires compute, processing of data. All right. When I say analysis, I want to process this data also. It requires compute. And if I try to do that analysis or processing of my data in an RDBMS system, that would strain the entire database. All right, that will hog up the compute that the database has. So that is why your transactional systems, they were not optimized for analysis. All right. And these RDBMS systems, they had some limitations also in terms of scalability, right? Vertical scaling. I think we saw yesterday what vertical scaling is. To add more power to the single machine was very expensive, and it had some physical limits also. There is a limit up to which you can expand, right? Beyond that limit, you cannot. So there was a limit to the scalability here. Flexibility was also an issue. They were not well suited for unstructured and semi-structured data, right? Whereas if you look today, right, majority of your data is unstructured and semi-structured data. Do you agree with that? Majority, 80-90% of the data getting generated today is unstructured or semi-structured data, right? So the RDBMS systems cannot handle that because they are, storing the data in a structured format. So only structured data could be stored there, data present in the form of tables, right? So that was an issue. Now, also, batch processing of data in my RDBMS systems was inefficient and very slow. All right. After that, we started creating these ETL pipelines, all right, or the extract, transform, load processes were used. And they were used to move data from various sources into a data warehouse, right? And these pipelines were often built using tools like Informatica, Talent, or custom scripts in language like Perl, Python, right? And the process was very simple. You extract the data first from wherever the data is stored at, right? That becomes your source of the data. Then you transform the data, you clean it, you normalize it, you enrich the data, you apply the filters, you apply the aggregation, right? Based on your requirement. And then you load this data to a destination, right? That is the core definition of ETL. Get the data, transform it, load it, right? Loading means inserting this processed data into a data warehouse for analysis purpose, because once you transform the data, it is cleaned, it is ready for analysis. And all of this data was kept in their data warehouses, right? And we had, traditionally we had data warehouses like Teradata, IBM D2, right? They were used for analytical processing. And that is where we got introduced to a new term called OLAP systems. What is OLAP? Anyone?
Online analytical process.
Online analytical processing. Now, this was different from your OLTP systems. How? Because here you could process the data, you could analyze the data, you could do analysis on the data. And these data stores, your data warehouse specifically, they were created so that you can do the analysis of data, right? What is a data warehouse? Data warehouse is a place where you keep or clean data, and you want data analysts to come and work on that data there. It means that it was optimized for analysis, right? This is where it supports, your data warehouses will support complex queries, complex aggregations, but they were expensive, all right? And they required specialized hardwares. And scaling them, right, to handle the growing data volumes was also challenging. Now, while some parallel processing was possible back in the day using some multi-threading or distributed databases, but it was not as seamless or as fault tolerant as the modern systems that you see today, right? Failures of any sorts mostly required manual intervention, and data recovery was a big headache, right? In the early times. Then another problem with the early time was that you had file-based processing. For very large data sets, organizations would sometimes use files-based system, right? CSV files, XML files. They will keep their data over here. And these file-based systems, they processed the data, right, using custom scripts. So this approach, it lacked certain level of standardization, it was error prone, and it was difficult to maintain. right? So in conclusion, your traditional data processing was effective for its time, right? At the time where we had limited, unstructured and semi-structured data, because in the early times, most of the data that we used to store was in structured format only, right? But then it lacked scalability, it lacked flexibility, there was no fault tolerance there, right? Fault tolerance as in there is a single machine. If that machine fails, we are gone, right? And it was not meant to be for modern big data problems, right? And modern big data problems are defined by three V's. Have I told you what those three V's are? There are three V of the big data problem. These three V's are volume, variety, and velocity. This is currently the problem that data engineers have to solve. How do I manage the sheer volume of data that is getting generated today? We are generating massive amounts of data on an hourly basis, all right? On an hourly basis, let alone the day, the week. Every hour we are generating huge amounts of data. So this huge volume needs to be analyzed, because now organizations don't want to make any decision which is not based on data. Today, if you see players playing football and cricket, you will find data analysts in their team also. Have you seen that? Today in sports team also, they will have some data analysts who will try to, gather all sorts of data and then try to analyze the performance. So you think about big major corporations, how much data would they require to study their business, to study their competition, to study the market that they're working in, right? To study the consumer behavior. So a lot of data is required, and all of this data that is getting generated, it needs to be analyzed. There is something is always there in any data which is getting generated, all right? Or some importance is always there, right? So how do I manage the volume? The second is, how do I manage the variety of this data, right? It is coming in all sorts of forms, right? I'm getting structured data also, I'm getting unstructured data also, I'm getting semi-structured data also. So my solution, the big data solution that I'm trying to create, all right, or whatever solution I'm trying to create to address these three V's, it should first of all be able to handle the volume. Then it should be also able to handle the variety of data. The solution should be able to process structured data also. It should be able to process semi-structured data also, and unstructured data also. If you don't know what semi-structured, unstructured, and structured data is, structured is your tables, the relational databases, where you have rows and columns. Semi-structured is your JSON data, XML data, and your unstructured data is images, videos, right? We sometimes call it as blob data also. What is the full form of blob? What is the full form of blob? Full form of blob is binary large objects. So this data is represented in binary format, in form of ones and zeros. All right. And with this, uh, the problem that we were facing, right? That is where, or with the RDBMS, I told you, right? The scalability was a problem. RDBMS also had a very rigid schema. Yes or no? Would you agree to that? Changes to the schema would require some downtime and careful planning, right? It was difficult to adapt, or to the evolving data structures. And it was very poor. The relational databases were very poor for unstructured data. RDBMS struggled with unstructured or semi-structured data, right? Like your images, log files, sensor data, and all those things. So to, overcome, these problems, we had the rise of Hadoop, all right? And that changed the entire data processing world, right? Before Hadoop, data processing was dominated by centralized systems, the relational databases systems, and whatever issues I told you, right? It was there. Then Hadoop was born out of the need to process massive data sets, right? When we defined big data, and what is the definition of big data, right? You need to understand that. If I give you a pinch of sand, a small pinch of sand, and I put it in your palm, and I ask you to count the number of particles, I know it will be hard, but will you be able to do it? A very small pinch of sand if I give it to you. Yes or no? You might,
Yes.
right? You might eventually be able to, study, not study basically, go through it particle by particle, analyze it, and, uh, you know, uh, count the number of particles there. But when you talk about, and I give you an entire beach, can you do it? Yes or no?
No, not possible.
Not possible, right? That is big data. So therefore, Hadoop was born to process this big data, right? Which is unimaginable. You cannot imagine how you're going to process this data. Massive data sets, right? And Hadoop was created to do this efficiently, cost effectively, all right? And it was inspired by a paper that Google published, right? On something called as a Google file system and the map reduce function, framework, right? So Hadoop was developed in around, I think, 2005 was the time. It was later adopted and open sourced, right? And eventually it became a top level Apache project. All right. It introduced a new model of distributed computing. All right. This meant that instead of relying on a single powerful machine, I was now running a cluster of inexpensive servers, right? And I was distributing the computation also, and I was distributing the storage also, right? So the Hadoop's architecture is built around two fundamental components. The first thing is called as HDFS. All right. The first thing is HDFS, which stands for Hadoop Distributed File System. All right. HDFS is a distributed file system which was designed to store large files. All right. And these large files were stored across multiple machines. So HDFS results in distributed storage. I'm not going to store all of my data in a single place. I'm going to break that data into smaller chunks, and then I'm going to store it across multiple machines. It breaks files into, blocks. It calls them blocks. Each block, typically is of the size 128 MB or 256 MB. And then these blocks are distributed across the cluster. Cluster, you understand? In distributed computing, we have many machines. These machines are called as individual nodes. All these nodes are together called as cluster. So when I say I am distributing my data across the cluster, it means that if this was the data that I have, I broke it into multiple pieces, right? 1, 2, 3, 4, and 5. And first data came here, second came here, third came here, fourth came here, fifth came here. Like this, I have distributed it across the cluster, right? So within Hadoop, we had now fault tolerance. How? What did fault tolerance mean here? Fault tolerance meant that, each block was replicated. This block that I'm telling you, right? Data was divided into smaller blocks, and each of this block was replicated 3 times on different machines. 3 copies of each block was created. And that is something that you'll find in Azure everywhere. At least 3 copies of your data is created all the time. Even today, you go to Google Drive, all right, and you store your data there, all right. Have you ever heard Google coming back to you and telling you that, sorry, we have lost your data? Has it ever happened? Have you heard it, right? Have you heard ever that Google came to
No.
somebody and told them that,
No.
sorry, we stored your data in a server and in a storage device in some location, and that location caught fire, there was a disaster, there was an earthquake, there was a tsunami, whatever it was, a flood, and sorry, your data is gone now. Never gonna happen. Never.
No.
Why? Because even a small file that you upload to Google Drive is replicated into 3 copies. Always remember. You'll have a copy near to you. You'll have a copy somewhere else also. You can have, how the copies are arranged, that is internal to, Google's discretion. You don't get to decide that because you are not going to decide how many copies are getting created. But then always remember 3 copies are created. Even in Azure storage, all right, that we will see in next week, what Azure storage is, how it works. Whenever you store your data or you upload any data, the least, and whenever you upload a data, and for your storage account in general, you have to select something. There's a configuration called replication strategy, right? What does replication strategy means? Replication strategy means how your data will be replicated. So there are different ways in which your data gets replicated, and the most basic is LRS. LRS stands for, and don't worry if you do not understand it right now. I'm just giving you an example. When we talk about Azure storage, you'll have a much better understanding at that point. So whenever you create a storage account, there is something called as a replication strategy that you have to define. There are multiple strategies: LRS, ZRS, GRS, GZRS, RAGRS. All of these are different strategies. Now, when you talk about LRS, you say that 3 copies will be created, and you cannot select anything below LRS. LRS is the least. So in the least, I'm saying 3 copies will be created. So that means whenever I'm storing a single file on cloud or on Azure, 3 copies are getting created by default. So that was the benefit of the Hadoop file system. Now I had copies of my data. These copies were spread across different machines. So if any of the machines failed, guys, can you please all mute yourselves? Wait. Yeah, thank you. So as 3 copies are getting created, and they get distributed on different machines inside the compute cluster, right? So if any of the machine fails and my data on that machine was whatever data was there on that machine, right? It's not like I'll never get that data back again. I'll still have 2 other machines inside my cluster where my data will be present, right? So that introduced fault tolerance, replication across different nodes. If one node fails, data is still accessible, and it gave very high throughput. All right. This was optimized for large sequential reads rather than random access. All right. And new nodes could be added easily without any downtime. All right. I can bring these new nodes anytime I want. So that gave this HDFS a lot of popularity, the Hadoop distributed file system, where I was storing my data that needs to be processed. The second thing that Hadoop introduced, right? I told you 2 things were introduced. One was HDFS. The other was the framework that is called as the MapReduce framework. All right. So MapReduce is a programming model. All right. MapReduce is a very simple programming model, which can process large data sets in parallel. So now you are doing parallel processing of the data, and it contains 2 phases. Phase 1 is the map phase. Phase 2 is the reduce phase. Map phase says that whatever data is incoming, right, it is distributed on different machines to be processed. That is the mapping or the map phase of the MapReduce programming model. All right. So you process the input data by dividing it into multiple smaller chunks on different machines. That is the map phase. The reduce phase is once the processing is done, right? Once the processing is completed, you combine all the individual outputs together, right? To get the final outcome, and that is the reduce phase. So when you have the big data as in a small, let's say a chunk of data, and you pass this data along with the code, right? Because when you are having the data, you also need to define the logic that you have to perform, right? The transformation that you have to perform on this data, and that was defined generally through the code that you had written, right? The code will define what you need to do with the data. So this data along with the code was shared over here. 1, 2, 3, 4. Code was there, code was here also, code was here also, code was here also, right? So all these individual nodes had the code, and they had the, along with the code, they had the data. So this will produce output 1, this will produce output 2, this will produce some output 3, and this will produce output 4, right? Based on the data that was shared, the output will be performed. But this cannot be your final data. I cannot give 10 output files. I need a single output file. What I do, I'll combine them in a logical order, and I'll have my final output. So this distribution of code along with the data was the map phase. The combining of the result towards the end was the reduce phase. Is that clear to all of you? Yes or no? So now we had parallel processing in place. Tasks are distributed across different nodes and executed in parallel. Now we had fault tolerance, yes, and computation is moved to where the data resides. All right. We are not sending the data somewhere and then processing it all in a single place. No. Computation will be done on whichever node the data has been sent to. Clear? So traditional limitation of scalability, how did Hadoop address it? Hadoop enabled horizontal scaling. All right. Add as many servers as you want, increase the size of the cluster as needed, right? And the systems would grow based on our data growth, right? The scalability was a problem in traditional systems, addressed by Hadoop. Fault tolerance was a problem with traditional systems. Hadoop addressed that also. Cost was a problem, right? Traditional systems, they required very high-end servers and expensive licenses. Hadoop, ran on commodity hardware. It was open source, right? So drastically reduced the cost. And traditional RDBMS, it required structured data with predefined schema, whereas Hadoop could store and process structured, semi-structured, unstructured data. Logs, images, videos, JSON, XML, everything it was able to process. And the processing speeds were very high. All right. Traditional ETL jobs were slow and batch oriented, whereas the MapReduce enabled parallel processing, right? Significantly reducing the job completion time for very large data sets. All right. And as and when Hadoop grew, it created an ecosystem, a Hadoop ecosystem. All right. It created a rich ecosystem of various tools that emerged to address various data processing needs. Right. You have Apache Hive that would give you a SQL like interface to query your data stored in HDFS. Right. And it made Hadoop accessible for analysts who were familiar with SQL. You had Apache Pig, right? Again, a high-level scripting language for data transformation, right? And simplified the complex MapReduce jobs. So writing your MapReduce functions, right, or the code was very complex task. That is one of the shortcomings of Hadoop, that writing MapReduce code is very complex. All right. So a lot of different, I would say in the ecosystem, the Hadoop ecosystem, different tools came in. And in the real world, Hadoop had a very big impact, right? Banks were using it to detect fraud. Healthcare, providers were processing data for personalized medication and drug research. They were doing that with Hadoop. Telecom companies were monitoring network performance, predicting outages, right? Social media platforms were analyzing the user interaction and the trends. And companies like Facebook, LinkedIn, Twitter, Yahoo, they all built massive data infrastructures on Hadoop. All right. But then there were limitations as well when it came to Hadoop. A lot of limitations, right? First, batch oriented. MapReduce was not, could not support streaming analysis. Streaming data analysis means analyzing the data in real time as and when data arrives. No, we'll do batch processing. Very complex programming language, complex programming. Lot of latency, right? There was some high latency for very small and interactive queries also. All right. So there were some problems here, right? One more problem was that Hadoop was reading and writing the data to disk. There's a lot of disk input output happening with Hadoop, right? So now you tell me, if I am processing data and I'm writing the intermediate data onto a disk and then reading it for a subsequent operation, does that make my processing fast or slow?
It will be slow.
It will make it slow, right? Now, in your machines, do you know of any hardware that was introduced to avoid reading and writing data regularly from the disk? Any hardware that plays that role where you don't have to go to the disk every time and something could be temporarily stored nearby that could be accessed, quickly? Do you know of something?
Yeah, it may be cache, right? You can temporarily.
It's your
store
memory,
the-
right? It's your RAM.
Yeah.
What do we do with RAM? Why is RAM required? We put intermediate result in the RAM, right? Any application that is currently open will use my RAM and stay there, right? I don't generally work with data directly into the disk. I don't put data directly to the disk. I don't read directly from the disk. That is a very slow process. So these were the limitations of Hadoop. And that is where came in Apache Spark, the best of all. This is the evolution beyond Hadoop. All right. We all know Hadoop revolutionized big data processing by enabling, features like distributed storage, parallel computation. But, and it also allowed organization to process, massive data sets using commodity hardware, right? I did not need specialized high-end hardwares. I could use simple machines, simple small machines, right? So it made big data analytics accessible. It made big data analytics affordable. But then there are a lot of limitations also, as we discussed, and that is why Apache Spark was born in around, I think, 2010, right? They created it. They, donated it to the Apache Software Foundation in around 2013 or 14, right? And it was designed to overcome all the inefficiencies of Hadoop's MapReduce method. All right. It wanted to maintain the core strength of scalability, fault tolerance, and distributed processing, but it did not want Hadoop's MapReduce. All right. And Spark introduced a completely new computing paradigm. All right. And this was based on something called as in-memory processing. So now I don't have to write the second, let me have a glass of water. Yeah. So now I was writing data in the memory. I was processing data by storing it in the memory. I was not reading and writing data directly from the disk. And that, improved the performance for many workloads. All right. So the first thing, in-memory processing was introduced. And it was the most significant innovation at that time. All right. It could keep data in memory between operations, right? Let's say if you want to do transformation 1, followed by transformation 2, followed by transformation 3. Now, after you're done with transformation 1, you will need to put the intermediate data somewhere. So where do I keep it? Disk or memory? Now, this would mean latency. This would be fast to write also and to read also. So that is why this intermediate data in between your operations was kept in memory. That reduced the need for disk input output. So in MapReduce, each stage, writes the intermediate results into the disk, and Spark, by contrast, stores the intermediate data in a memory using something called as an RDD, which we'll talk about later on. All right. As of now, don't worry about RDD, but just know that the data is kept in the memory, that is your RAM. Now, this made Spark, and some people say, and this is something that you will find everywhere, Spark is equal to Hadoop into 100 in terms of speed. So what does this mean? It means that Spark was considered to be 100 times faster than Hadoop, but for certain workloads, it's not always true. All right, it's not always true. It is only true for a specific condition and a specific workload, a specific task that you had to perform. All right. Now, what Spark did was, it then introduced the concept of something called as an RDD also. RDD stands for Resilient Distributed Datasets. RDDs, which is, let me write it down. Sorry. Resilient Distributed Dataset. These are the foundational or the fundamental data structures in Spark. All right. They are immutable. They cannot be destroyed. They are distributed collection of data. All right. You basically create an RDD by distributing data across, multiple nodes. Right. And one more thing about Spark was the DAG execution engine. DAG stands for Directed Acyclic Graph. This means that if I want to do transformation T1, T2, T3, T4, then Spark will not blindly start going from T1 to T2 to T3 to T4. It will create something called as a DAG for this execution. That is, it will try to optimize and see how the transformations have to be done, in which order it will be most optimized. All right. So transformations on RDDs are not executed immediately. Instead, Spark will build this, DAG. It will build this graph of operations, which will optimize the execution plan before running it. Let's say if running T2 first gives me a benefit, and then T1, then T4, and then T3, then this will happen. All right. So before directly executing the data, Spark creates a DAG that is going to, first create an execution plan. So you create a plan first, then you go to execution. That is what Spark introduced. All right. And Spark gave you a unified engine, a single engine that is capable of doing everything. You want to do batch processing? Possible. You want to do stream processing? Possible. Spark streaming. You want to do machine learning? Possible. You want to do graph processing? Possible. You want to run interactive SQL queries? Doable. So it's a single place where you can do everything. All right. So you have Spark Core, which is used to, which is the foundation of the Spark platform, right? You have Spark SQL that allows querying structured data using SQL or a DataFrame API. We'll cover this obviously in depth. Spark Core, Spark SQL. We have Spark Streaming that processes real-time data streams. We have something called as MLlib, which is a machine learning library, and it includes algorithms for classification, regression, clustering. Right? If you do not know what these are all different machine learning workloads. Regression is when I want to predict something numerical, correct? All of you know what regression is? Within machine learning, we say there is something called as regression, there is classification, and there is clustering, right? So what regression does? It tries to identify a numerical value. Estimate tomorrow's temperature. It's a numerical value. Estimate this stock price 10 days from now. Numerical value. All right. Find out whether the given image is of a cat or a dog. Not regression. All right. Look at the picture. Give the name of the animal. Not regression, because here the output is not a numerical value. That is classification. If I show, or if I write down the features of a flower, and my AI model or my machine learning model has been created to identify the species of the flower based on the features, then that is classification. I can tell between different species. An incoming mail is a spam or not. It's not regression, it is classification. You classify it as a spam or not a spam. Clear? And clustering is when you try to group similar data together. All right. So Hadoop had limitations. Spark addressed those limitations. Now you had, limitation in Hadoop was high disk input output latency. Spark introduced in-memory processing, right? Hadoop was inefficient for iterative tasks. Spark solutions was, it introduced caching and DAG execution that would create a proper plan first, and it was very well, suited for iterative tasks. Hadoop had complex programming. Spark, gives us high-level APIs in Scala, Python, Java, and R. These APIs, what they mean is, if I want to talk to the Spark architecture, if I created the Spark architecture, right? And when I say Spark architecture, it consists of a few components. So when I create this Spark architecture, I should be able to contact or communicate also with that. If my task is to process data, so I should be in a place to tell Spark that, listen, this data needs to be processed and this is what I want. How do I tell that? I can tell that using any language, right? And the language here is called as API. So I can use Scala also to talk to Spark architecture. I can use Python also to talk to the architecture, to the compute. I can use Java also. I can use R also. In Hadoop, there was no real-time processing. Spark introduced Spark streaming or structured streaming within Spark. Hadoop had a rigid execution model. Spark has a flexible DAG-based execution engine. All right. So these are all the benefits of Spark, all right, that you have over the Hadoop ecosystem. Is that clear to all of you? Yes or no? Now I'll quickly give you a quick insight of what the Spark architecture is like. So you have something called as a driver program running on the driver node. So you'll have a driver. Your cluster will contain of one computer that will become the driver, and the rest will become workers. All right. So driver is the heart of the Spark application. It will run the main function, and it is responsible for converting the code that I am going to write into a DAG, right, of tasks. It is going to schedule tasks on these individual machines, right? And it is going to complete the execution and collect the final output result. So the driver maintains, the information about the Spark application state. It communicates with the cluster manager. It communicates with the executor. Then these are executors or workers. All right, you can call them workers also. You can call them executors also. You can call them slaves also. And driver could also be called as a master, right? So this follows a master slave architecture. The master will give instructions and the slaves will do it. So executors are the workers that process, right? Or executor are the processes that run on these nodes. All right. So inside this node one, I'll have executor process. Over here also I'll have an executor process. Here also I'll have an executor process. And these executor process will run tasks assigned by the driver within the computer. They will store the data in the memory, right? The executor processes will store all this data in the memory, and they will, report the task status uh, and the results back to the driver. So how does this communication happen? Does the driver talk to each of these slaves or the workers? No. They have something called as a cluster manager in between. All right. Job of the cluster manager is to manage all these workers. All these workers, whether they are in a working condition, that means they are processing data, or they are left idle, or they are not ready to start. Right? When I say not ready to start, basically they have failed. They could not be started. So cluster manager will keep an information of all the workers, and it will report that to the driver. The moment any of the executors, right, or any of the worker here or the worker node is now empty, it does not have any task, cluster manager will get this information, and cluster manager will ask driver that I need more tasks, right? I need more data, right? Because the data is going to be processed in memory. All right. Memory size is limited. If I have 10 TB of data, right, then I might send, let's say if over here in the memory, I only have 1 GB data available, 1 GB memory available for processing. So I can only process 5 GB at once in parallel. Once this is processed, then I'll have to process 5 GB more. Once this is done, then I have to process 5 GB more, right? So like that it will go. Obviously, if I want to process more data, then I'll increase the number of nodes, and I'll process, let's say if I have 100 nodes, so I can say 100 GB in a single cycle was processed. But then the driver has to, it cannot process all the data at once. If you create, 1,000 chunks of your data, it does not mean that you'll have 1,000 nodes to process that, that data. It could mean that you have a limited number of nodes, and these nodes, once they process the data, they'll send you the output, they'll get new data, they'll process it, they'll give it again, they get another data. So like that, it keeps on working. Cluster manager, there is a standalone cluster manager which is used within Spark. Standalone cluster manager is Spark's default cluster manager. And we talk more in depth of this. All right, I'm just giving you a high level picture of the architecture, right? The standalone cluster manager is there. Hadoop used something called as Yarn. Yarn is also a cluster manager that was native to Hadoop. This is called as yet another resource negotiator. Now, do you know of any other cluster manager? Does anybody know of any other cluster manager? It is widely used in programming today. It is used to manage cluster nodes. Anyone knows?
Kubernetes.
Yes, Kubernetes.
Yeah, yes,
So
someone
Kubernetes is
yesterday
also,
told.
yeah, Kubernetes also is a cluster manager.
Yeah.
All right. So you can use anyone. If you want to use Yarn, you can use that. If you want to use Kubernetes, you can use that. There is something called as Apache Mesos also. You can use this also. But by default, standalone will be there. If you do not specify anything, the standalone cluster manager will be there. All right. So with that, we'll stop here for the day. And this will end the demo sessions that we had. And from Monday onwards, we'll have regular sessions. We'll start again from the basics, right? Obviously, some of it we have already discussed, but then again, we might see some new faces who in the first class who may not have attended the first demo session or the second demo session. And we'll start with Azure basics. We'll cover first week, we'll do the Azure, and then we'll switch to completely Spark and Databricks. And then we'll see all the different capabilities of Databricks and Apache Spark in general. All right. So please, make use of this opportunity. If you've already registered, I'll see you on Monday. Those of you who've not registered, right? I encourage you to please register and be a part of this training session. From Monday onwards, only people who have registered will be the part of the training. All right. And I would like to thank all of you for being patient with me and attending this 2-day demo session that we had. I just gave you a brief introduction into what we are going to study. But as I said, this is just the tip of the iceberg, and we have a lot to cover, a lot of topics to cover, a lot of tools to discover, and we'll do that starting Monday. All right. So thank you everyone for being here, being a part of this demo session. It was really nice having all of you. You're all very interactive, and I hope to see you guys on Monday.
Shreyas, I
Thank you
think
very much.
a couple of questions we have.
Yeah.
Please
I'll take
ask
the
your
questions. Yes.
question.
Shreyas, like with this training, right? You'll be covering PySpark also?
Yes, we'll be starting with and we'll cover the basic part also, and the I would say uh, the some difficult scenarios also we'll see, but complex ones. But yes, PySpark, you will have a good understanding if you just attend this course. You can build a good understanding on PySpark.
Okay,
I'll
so
show you
you
step by step how you can
uh-huh.
read data, how you can write data, how you can transform data, right? Once reading, writing, and transformation is clear to you, then whatever we do with the data, you'll understand it very clearly.
Okay, and do you explain like on the migration part, like from on-prem to cloud?
Migration is not required here as such.
Not really.
Yeah.
Okay, okay. So what kind of jobs we can apply full total on Azure Databricks only, right?
Yes, anything that requires data engineering and Databricks has been mentioned as a required, skill. You can apply for it.
So okay, overall, how many years we can show up with this training?
We, uh, Post the training completion and post the project completion, you can easily show some 2 to 3 to 4 years of experience based on how much you practice. Obviously, the more you practice, the more years of experience you can show. The more projects you do, the better experience you could show.
Okay, so at least minimum 2 to 3 years we can
Yes,
show up.
absolutely.
Fresh, I have a quick question here. You told us right, Python and SQL. You should have some basic knowledge to learn this
Mm-hmm.
Azure.
Yes.
SQL, yeah, being ADW resource, I have hands-on experience in SQL, but Python, I can claim it as a zero. So if I
That
go
is
through
what.
some
See,
basics next
yes,
to
basics are more than sufficient. Absolutely.
yeah, because if anything asking right to like to write any scripts or something, I don't have any experience in Python.
Not required. We'll not be writing extensive scripts, but yes,
Uh,
when we work with PySpark, I'll give you a
okay.
very guided, detailed plan on, and it will be very logically created.
Okay,
So the
any
first thing that
suggestions
is,
or any link
hmm,
for the classes to understand basic level for this particular Azure course purpose? Any particular link or class
see,
educational video you can
Python you don't need to learn Azure. Python you would require, to uh, build yourself in PySpark. All right, to be able to understand how this PySpark code works, and eventually for any data engineer, Python is a must, right? Today or tomorrow you have to learn that,
Okay.
right? So you better start today.
Yeah, fine. Yeah, sure. Thank you.
Hmm, yeah.
Where can I register? The website
uh,
only, right?
Yes,
you
you can
can get
register through the website, or please reach us to the WhatsApp number. So, are you in any of our group, or can you
I'm
share
not
your number in
not
this
poss-
chat?
uh, okay,
Yeah, I will contact you. Please share your number.
okay.
you can send a direct message. Yeah.
Yeah, Supriya, I think you have some question. Can you please ask?
Yes, it's a quick question actually. What happened? Some of the banks, like they have a very sensitive data or restricted data. So, what they are doing, they are introducing their own cloud or internal cloud, something like that. So,
Hmm.
in that case, they cannot upload the data directly on any cloud like AWS, Azure, or GCP, something like that. They need lot of permissions. So they have introduced their own cloud, and can we use the same language, Databricks or PySpark, whatever, to onboard our whatever ETL tools we are using? They are not capable of processing the high, huge data. So can we use the same language to move that code on premise cloud? I mean, this tech skill set, I would.
Rephrase your question. So you said that banks have, sensitive data and they're having their own cloud. They're creating their private cloud, right? Essentially.
Correct. Yes.
And
Yes.
they have their own data, which they're, keeping and storing it on their private cloud. They're not storing anything on the public cloud.
Correct.
Right?
Yes. Yes.
Now, what is the question after that?
Yes, my question is, now currently we are using like other ETL tools like Informatica, Data 360 and something like that. But now these tools are not capable of processing huge amount of data. Like 1 GB of data process, it takes 1 hour. And now if data increases to 3 GB, 4 GB or more than that, it takes like 3 hours or something like that. So we want to increase the processing capacity. So in that case, can we use this same language like Databricks, PySpark? We want to eradicate of the.
No.
Okay.
See, it's available with public cloud, that is there, but it is also available locally.
Okay.
Right?
Okay.
The cloud integration is there, but Databricks in itself as a standalone tool also exists that you can use.
Okay. Got it.
I have one question related to the course. So you are going to cover everything related to Databricks, right? So after our course, we no need to go for any other courses.
Not in terms of Databricks.
Yeah.
You'll have a complete understanding of data engineering workloads on Databricks.
Okay.
Yeah. Hi, Shreyas.
Yeah.
Do you have offline classes available or only online classes?
Only online classes.
Only online. Okay, fine.
Yes.
And we are getting recorded session for each class, right? After, like, if
Yes.
suppose if
After
I
every
miss.
class. Yes. Every class, the recorded lecture will be uploaded.
Okay, uploaded to YouTube, uploaded to your website.
The
From there
LMS
we can
portal.
access.
Yes, the website, LMS portal. So you'll have a lifetime access to that LMS portal. Yeah.
Thank you.
So overall, it is for 25 days, right, Shreyas, if I'm not wrong?
No, we mentioned 25, but see, that is an estimate. But generally, it will take around 30, 34, 35 also. It can go. See, it depends on what kind of classes we are having. When I say what kind of classes, basically, the more interactive you are, the more classes you will have eventually, right? If you're regularly asking questions, if you're regularly involved, we'll spend more time on addressing, doubts and queries. So the duration increases eventually. But then, as I said, 25 plus is what we mentioned. 25 plus is going to be Databricks dedicated and 5-hour bonus for Azure. So 30 plus you can expect as it is from now itself.
So Shreyas, this 25 days included the project also?
Project will be given towards the end. The project documents will be shared with you towards the end. 2 projects will be shared that you can implement in your free Azure account.
No, but you will not help us to implement that project.
I'll be sharing the guided documents. If in case you have any problem, you can always connect with me and we can resolve those issues. If there is any implementation related problems that you're facing.
Okay, thanks.
Are we going to get certificate on this?
Certificate from our side, it's not available. But if you want, so you can apply for the Databricks certification, which is available.
No, institute certificates are not valid.
Databricks here will have their own certificate.
But if you want, we can give you the certificate. I mean, course completion certificate.
Okay.
So Shreyas, I did earlier also one program with NIC. So with Chandra sir. So Chandra gave us a few questions related to the certification. So do you have questions also for the certification of
Yes, I will be
Databricks?
sharing the exam terms with you, but that will be for the Databricks certifications. Yes.
Okay, thanks.
See, standalone Azure Databricks certificate does not exist, but Databricks certificate exists. All right then. Thank you all. I hope to see all of you on Monday. Thanks a lot, guys.
Okay, so most of you already are from data background, so that will be really quick for us to understand. So data types and DBMS we will understand about from the beginning. So for the people who are, not from data background, they can have like definition or, understanding of the data, what exactly the data is called in, in general terms, not for specifically for the Databricks. So in introduction, let me just here. Okay. So like everyone is familiar with the data is like measurable quantities, anything which is like observation facts are called the data. And raw data information is like most important constituent that is applied in analysis and decision making process and formation development strategies and numerous disciplines we can use the data. Okay, and as we all are familiar with relational database management system, it is having integrity and having like user defined integrity relations with the multiple tables structures and all those things. So it is helping to maintain the consistency among the data. Okay. And as we know about the tables, we will understand that how this is divided into rows and columns, and this is like, structured data. And we'll understand more about this. So here we have tables, how we are putting the tables, how we are keeping the columns, fields, attributes, keys, and records. So I hope everyone is familiar with this concept that databases are having this structure. Okay. And SQL statements. So most of us are anyways familiar with the SQL or structure query language. So we can insert the record, we can search the record, we can update the record or delete the databases recorded using these statements like select, update, delete, insert into, and create, alter, etc. So these are some of the common commands we may use to manage our structured data. Okay. And now let's go further. So features of DBMS. So as we have seen in the previous slide, that we maintain the record in rows and columns. So it maintains the consistency among the data, and data is totally structured. But nowadays, data structure is little bit changing, and data type is also changing. So for analytical purpose, we require some tool, some sort of tool which can understand structured, non-structured, or semi-structured data. So we'll talk about this kind of data which are available nowadays and which has to be, worked upon, and should be, we should have some sort of tool which can, consolidate these kind of data together and create some meaningful insights. So this is where Databricks come in. Okay, so most popular databases as of 2022, like Oracle is 31% market share, MySQL is there, SQL Server is there, Microsoft Access. So largely the structured data is being maintained in these databases, and these databases are required to be analyzed For that, we have several tools, but there are, data now gathered from IoT devices or social media or any other source, which are mostly unstructured or semi-structured data. So that also has to be, combined with this data, which we are able to fetch from here, and has to, we have to have some sort of tool which we can work with and combine this data and create some insights for the business so they can make some meaningful decision. Okay, so data is mostly divided into three categories. And structured data, first is the structured data, which we are familiar, that which is being maintained in the tables and rows. And this kind of data is easy to deal with, and this kind of data nowadays in the business world is 20% only. So if you see, the structured data quantity is getting less and less, so it is around 20% only nowadays. Earlier, during the 90s and that time, it was almost 100%, which is like, to analyze, we could manage it with the any tool available, or ETL process we could use, and we can easily manipulate this data and make some insight out of it. But nowadays we have this data, which is the unstructured one or semi-structured one, which is increasing in the quantity and almost keeping it 80% of the data which has to be analyzed. So this is really challenging with the traditional tools of ETL process, and these are like huge amount of data, which requires some sort of a specialized tool which can work with the multiple nodes or multiple resources, compute resources. But definitely without this data, if you use only this 20% data and produce some meaningful insight, it's really very difficult to make some insight which is really making any sense on that business. All right, so now let's go and see what is the structured. I think structured data, everyone understands that we are producing this structured data basically for business applications, or from the business applications, like we are using financial transactions or inventory or CRM or HR system, which are like in the tabular format, and these are having the relations or correlated tables, which can and data size is very less. So if you see the data footprint from the relational or the structured data is very less compared to other data. Okay, and now we'll understand about what is the unstructured data, because we keep talking about structured and unstructured. So unstructured data is formed by different file formats. So that are in form of log files. For example, we may have log file, we may have sounds, images, and other raw data. So any data which is not having or following any structure or tabular format is called unstructured data. Okay, so this form of data poses a major challenge to organizations because it is difficult to extract, because these are like data which are not following any pattern. So it is really difficult to extract this data and make some sense out of it. So this is called unstructured data. And managing such data means that storage space will hugely occupied. So one of the requirement by having this kind of data, and if we require to analyze this kind of data, is the storage space. We have to have sufficient storage space to keep this data somewhere and start analyzing, because structured data is already lying in the database system or data warehouse, where we can fetch the data and do the manipulation. But here we have data which is scattered across, or maybe multiple sources we may have, and we have to have some sort of storage space where we can keep this data and keep analyzing it. Okay, it cannot be described by data model or schema, so it doesn't follow any schema or data model. Therefore, it is difficult to analyze. Most databases can be managed, analyzed, and researched. Okay, so it is not so easy to analyze this kind of data and make some insight. Unstructured data includes information in textual. It can be maybe log files or some text file which are not having a regular pattern. It can be a collection of images, audios, videos, or any format it could be. And it is like qualitative data. We call it qualitative data because it is not a quantitative one. So structured data, we call it quantitative because we can maybe count it, we can measure it, So any quantitative analysis we can do on that, but these are the data which are mostly called qualitative because it cannot be measured. Okay. It is typically saved in NoSQL databases. As we know, in the database system, we have SQL database where we can run the structured query language. And by having the structured query language, we can uh, get some output using the query. But here we may be using the NoSQL databases or non-relational data store. So it could be the possibility where maybe unstructured data we are keeping as an object in NoSQL databases, or we may have a repo or data store where we are keeping all the files which we are collecting. Some of the human generated unstructured data are like text files, emails, social media posts. So these data types are some of the example which are unstructured, like mobile communication data and business applications. So these are some of the example which we may consider unstructured, and these are various or a few example having this data type. The machine generated unstructured data is like satellite images, for example, or data captured by scientific instruments or sensors. IoT devices nowadays very common in the market. So these are also generating some meaningful data which has to be analyzed, and a decision has to be around them, or video surveillance, etc. So these are some of the example of unstructured data. So same thing, text, email, images, audio files, video files, log files. It could be sensor data or social media, which doesn't follow any specific structure in common sense. Okay, so here we can see like uses of unstructured data. We may have social media, we may be using Twitter, Facebook, Instagram. So these all data are being produced by different platform, and they do not follow a standard format. So they are having their own form. So tweets are different, Facebook posts are different, Instagram posts are different. Their comments maybe, or maybe similar type of unstructured data. And uh, unstructured data and convert this social media data to structured data to understand consumer sentiments, trends. So what output we can get from these data is like we can make the sense of consumer sentiments or any trend which is being around, and the brand perception. So some of the output we can produce from these data are this kind of. Then image recognition. Image data is unstructured data applied in body identification, for example, facial identification or something like that, object recognition, and computer aided services or medical imaging, any sophisticated methods or pattern recognition logic work in the pixel level by analyzing bits to solve problems as simple face recognition or as complex as object identification. So there are some of the use like face recognition we can go for, or if these are some security installation where maybe any object identification is required, or in medical terms we may use it for disease diagnosis like x-rays or any sort of imaging technology. If we are using in medical instrument like MRI and all those things, we may analyze it by this pattern. So using ML or AI, we may diagnose this or disease. Further, for text mining, we can use unstructured data. So structured, semi-structured, and unstructured text from documents, emails, or web pages is extracted to identify key pieces of information. So sometimes text data is also important, which is like not having or not following any structure, but can give some sort of clue or some sort of idea about the brand and all those things. And categorize a text as positive, or we may create some logic around, and where we can identify positive or negative or neutral sort of categories of the topics which is being written in the text. And then these simple natural processing methodology, NLP methodologies, are used in identification of patterns. So we can identify the patterns around, and identification of keywords we can use for from this data, and content summaries. Okay, so we can do the data mining using text files. Or now uses of unstructured data like sensor data, where we can use like real-time information from both sensors or IoT devices. Nowadays, very common IoT devices which are producing a lot of data nowadays, and industrial equipment maybe. So some manufacturing plants or some plants, some sort of plants, industrial plants, their equipments also nowadays producing a lot of data which is being generated, and these data are really important for the business nowadays. So subsequently, processed for the performance bottlenecks. So these are like, these data which is being produced from the machines or different devices can be used to, if we are facing any performance related issue, if we have any bottleneck with the specific equipment or, device which is producing the data, maybe some error logs or something we can see, or if any warning or any issue frequently generated on the plant having any specific machine or device, we can use their data to analyze the process. Or any other issue, through the analysis we can make some sense out of it, and information gathered from the sensors in terms of time series help in understanding the state of environment, the condition of operational tools, and overall process of manufacturing. So mostly in the manufacturing, we are using some sort of, or many sensors which are producing the data, but these are really important data because these may indicate our efficiency or equipments which we are using in the plant, that how these plants or how these equipments working together, how efficient is our production procedure. Maybe some equipment is producing the warning or some sort of fatigue sign where it requires the maintenance or something. So operational data are equally important nowadays to make a business decision. Okay. Now, next type of data, which is the unstructured data, is video surveillance. So here we may have example like a raw video data is applied in video monitors for security, observing behavior patterns, okay, and identifying the incident. So if incident related, we have frequent incidents or sort of some sort of, then we may use the video surveillance data and make correlate these incident with each other, or maybe we can use this data and we can combine with other collected data and make some insight out of it. So facial recognition or algorithm perform video analytics on video feeds and are capable of detecting motion, identifying objects or threats, notifying security agents. So these data can be helpful for notifying security agents for any suspicious activity happening around the plant, or so now, structured data versus unstructured data. So how these are being arranged, or what is the difference mainly we can talk about here. So here, this can be displayed in rows and columns, and it cannot be displayed in row and columns. So like not like a relational database, these are like file formats. Then this could be the example, like this may have the data types which are like numbers, dates, strings, this sort of data. But here we will have the images, audio, video, and word processing. So these data types, as you may have noticed, that these are totally different and require some sort of tool which work with these both kind of data. Now, the third is estimated, almost 20% of the, enterprise data as per Gartner. And now it is getting less, because earlier it was having more share, but now it is estimated that 80% of enterprise data is unstructured one. So this quantity is really getting big. Earlier it was huge, but now it is getting the more and more share, and it is more useful to make any decision. And definitely there is huge weightage of to make a decision uh, in the business using the unstructured data. And it definitely requires, because it is managed in rows and column, a tabular format. It is not having any high demand of storage compared to unstructured one. But unstructured one could be like videos or images or some sort of data which is being produced frequently, like log files, or so that requires a lot of storage, and easier to manage and protect with the legacy solution. So we can use like DBMS to manage this. Securing these data is really easy compared to this one, because it is more difficult to manage and protect. With the legacy solution, we require some sort of a new solution which can manage this kind of data. So difference between structured data and unstructured data, we have detailed, comparison here. Like format, we have seen like tables and databases, we are managing structured one, but unstructured one, there is no format at all. Okay. And in schema, it follows the predefined schema, but there is no fixed schema. It's like flexible. In storage comparison, if we see, easy to store in databases or spreadsheets. But here, unstructured data is difficult to manage and require a specialized, storage solution. So as we go with this course, we will be looking at the storage solution, which is like Azure platform. We will be understanding about this, that how Azure stores this kind of data. Then the retrieval of the data is simple and straightforward, because we can use the SQL query or some sort of tool, and we can, easily, extract this data. But here it often requires advanced search algorithm and this to extract the data here. For analysis purpose, it well suited for, quantitative analysis. So with the help of queries, we can analyze this data easily. But here we require a specialized technique like natural language processing, etc. For processing, is easily processed during the traditional method or using the traditional method, but it requires advanced processing technique. Complexity point of view, low complexity compared to the unstructured one. It is because having a structure in place, but it is having high complexity due to lack of structure. So this is one of the challenge here. And the size perspective, we know this is very small size compared to this one, which is having the large due to multimedia content. Okay. Insights extraction, if we see, straightforward to extract insights, but here we require sophisticated analysis methods where Databricks and this kind of tools are coming in place. Now, next is database management. We can use traditional DBMS system for this, and we can manage this data, but it requires maybe no SQL or any specialized DBMS. Searchability point of view, it is highly searchable using the SQL queries, but it is less searchable, often relies on metadata. Okay. And these are some of the examples, maybe structured data like CSV files, spreadsheets, or databases could be the example here, like text documents, email, images, and videos. Okay, now something which is falling in the between means it is having not rigid schema or pattern, but it is having some sort of structure. So this kind of data is called semi-structured data. Okay, so semi-structured data is a type of data that is not purely structured, but also not completely unstructured. So something which is in between, not structured and not fully unstructured. It contains some level of organization or structure. Okay, so little bit of organization or structure, but doesn't conform to rigid schema. Okay, so this is what we call the semi-structured data. Okay, or data model. So and may contain elements that are not easily categorized. So the challenge here is that we cannot categorize or classify these data in a standard format, but some sort of structure it maintains. Okay. Now in the semi-structured data is typically characterized by the use of metadata or tags. We may use metadata or tags to identify or characterize this data that provide additional information about the data elements. Okay, semi-structured data is data that doesn't conform to a data model but has some structure. It lacks a fixed or rigid schema. It is the data that doesn't reside in a relational database, but that have some organizational properties that make it easier to analyze. Okay, so this is what the categorization of semi-structured data. Now the characteristics of semi-structured data, we can see data doesn't conform to data model but has some structure. Second characteristic is data cannot be stored in the form of rows and columns. Okay, so we cannot have standard like row format and column format like tabular structure in databases. Semi-structured data contains tags. Okay, it maintains some sort of tag and elements. Okay, so it's called metadata. So combination of tags and elements called metadata, which is used to group data and describe how data is stored. Okay, so by using tags and element, we can describe this data and make some sense out of it. So similar entities are grouped together and organized in hierarchy. Okay, this is one of the characteristic here. Entities in the same group may or may not have the same attributes. It may have different attributes in entities, but entities are like identity for this data which we can refer to, and they may have different attributes. Each entity may have different attributes, but like something which is the entity will give you like row kind of feeling here, or the properties. Doesn't contain sufficient metadata, which makes automation or the management of data difficult. So because it is not having it is not always basically having the metadata which is like maintain or can be used for automation of the data. So this is a like one of difficulty here. size and type of the same attributes in group may differ. Okay. And then due to the lack of well-defined structure, it cannot used by computer programs easily, because computer programs cannot make sense out of these data, and someone has to intervene and make some sort of a relation between them. Now the sources of semi-structured data, like as we discussed, maybe it could be emails, it could be some sort of XML files, or markup language, or binary executables, maybe TCP/IP packets or zipped files, integration of data from like different sources or web pages. So these are some of the sources where we may have semi-structured data from. All right, so let's move forward. And these are some of the example, like XML. If you see the XML format, looks like this, where we can have like keys or entities, and with different entities you can create or produce the data. So like student list is there, and with each ID of the student, data starts and having maybe the same attribute or maybe the different attribute. Okay, so like data maintain some sort of format in form of entities, but are having the list of attributes which can differ. Second, semi structured data most commonly used is JSON, which is being used in most of the even IoT devices also produce the JSON files, or some sort of equipments also produce the JSON file, which are like having similar format like XML, but having different pattern here. So here also you can see like beginning of JSON file, it is like array, and then colon. With the colon you can have key and value pair, and so like each key is having a value in front of it, and these are separated by comma from here. So these we can call attributes. Okay, and this is like entire object. So this curly braces, this one is having like an object or a row you can call or something. So this confront like this. Here you can see like we have entity here. The same way this can be called as entity, and this again separated by the comma, where we may have the next similar entity. But the attributes again doesn't fall to rigid format. The next entity may have a common thing like employee ID, but may have some more attributes or less attribute depending on the that employee attributes or available properties. Okay. Now we have seen the structure and non-structured data and semi-structured data as well. So we understand about the data types, or all the data types which we may have to analyze, or we require to analyze in using the Databricks or any tool. So this is like showing that little bit structured here, like rows and columns, or specific schema. But unstructured one is not having any schema, but having the semi-structured one is having sort of entities. So let's say if this is a each column represent one entity, each entity may have some difference in attributes, but at least some sort of formation is there. So this is called semi-structured one, mostly XML and JSON format. Now let's see what we call, or what do we understand by the big data. So big data essentially is a set or collection of data. So big data is just a new terminology because it's like huge. So that's why it is used. But again, it is the set of or collection of data only. It's nothing more, but the size is so large. That's it. So it's a collection of data, so large or complex data, okay, that it cannot be processed through normal data processing methodologies. So we cannot use a simple methodology to, simply analyze these data. And the size of data is so large. And now let's see what the size it is talking about. So these data sets normally lies, or lie in between terabytes. So as you know, lot of data is being produced every year, it is like increasing. So we started with the terabytes, but now it is, increasing all the time. So terabyte unit of data storage, which is equal to 10 to power 12 bytes, and petabytes. So now we are going towards the petabytes, where the lot of data is being produced, and this is becoming like big data, which is 1,000 of times of this one. So even more. Big data analysis can be or can help uncover patterns and shifts. So big data analysis now is becoming more and more common, because we know that there is a lot of contribution of unstructured and semi-structured data, or data is being produced more frequently with the not having a proper structure in place. So pattern and shift, as well as identify potential correlations, and especially those that concern human activity and relationships. So big data analysis is becoming more and more requirement nowadays. And some of the like parameters, or some of the properties, when we have big data we define. So first, it talks about huge amount of data. Okay, so this is what we refer to big data. And it is having, then second, when we call big data, is not having a single format. So it is having different formats of data from various different sources. So multiple sources, huge volume, veracity means inconsistencies, uncertainty in data is veracity. And then the velocity of data means like sensors and these sort of data or IoT devices. These are producing huge data, or data at a huge speed. So very high speed accumulation of data. This is one sort of thing which we can call like big data. So these are like, you can consider like properties why we call it big data. And when the value perspective, extract a useful data. So when we have these data with the high velocity, veracity, volume, and variety, but these data are important to collect and make a business decision. That's why it is called big data. Now we'll talk about some of the tools which are being used to analyze this kind of data, or in the market, which are available. So let's talk about let's say Hadoop, for example. So Apache Hadoop is an open source framework. So we'll talk about Hadoop. So let me go here. So Apache Hadoop is an open source framework that allows user to store and process large amount of data in parallel. Okay, so as we know, Hadoop is storing here and processing large amount of data. So this is one of the drawback here with the Hadoop as well. So it requires to store the data. But nowadays, data is like being produced frequently with the high speed, or different datas, which require a lot of storage. So this is one of the disadvantage with Hadoop, that it does require the data to store first. So basically, it will be it will be taking it from the source, and it will store it somewhere. So there is like storage requirement, and then it can only analyze. Okay, so it can act on that data. Okay, then process large amount of data in parallel. How it works, Hadoop uses distributed storage, okay, and parallel processing. So this is like when we talk about Hadoop, it takes distributed storage and parallel processing to break down large workloads into smaller ones. So this is what the strategy Hadoop adopts and work towards to analyze this data. Smaller ones that can be run simultaneously. So in parallel, it will work. It clusters multiple computers to analyze data. So a Databricks will also be doing the same, and it will be also having a cluster and multiple computers or compute resource, which will be working together to analyze the data instead of using a single large computer. Okay, what it can do, so Hadoop can store and process structured, semi-structured, and unstructured data. It can handle virtually limitless concurrent tasks or jobs. So this is like Hadoop's capability here we are talking. And what it's used for, Hadoop is used in many industries like including finance, healthcare, security, and law enforcement. Okay. So now let's see how it's built. So Hadoop is built on Java basically, but other programming languages also support it, including C and Python and C++. So this is like the platform is built on Java, but it does support C, Python, and C++. And where it can be installed. So Hadoop can be installed on cloud servers. Okay. Linux operating system agent or Unix OS agent or Windows OS agent. So it can be installed on maybe cloud servers, or maybe we can use it with if we have on-premise setup, which is now getting less and less. So it supports basically Linux, Unix or Windows. Some components of Hadoop includes, so Hadoop is having something called Yarn, a framework for job scheduling, and Yarn is being used for scheduling the job and cluster resource management. Okay, so it's like it will be managing your compute power, which tool is called Yarn. And then Hadoop map reduce is there, a system that stores data on multiple sources. Okay. So basically, it will store the data on multiple sources for parallel processing of large amount of data. Okay, so that tool is called MapReduce in Hadoop. Okay. The next key tool in Hadoop is HDFS, a distributed file system that stores data in blocks. Okay, so it is a distributed file system and that stores the data in blocks, which are then often distributed across the cluster and replicated for safety. Okay, so it will offer the replication as well. In case of failure, it can have second copy available, and it is going to distribute to the cluster or among the clusters. So across the cluster, it will be used, and like in small chunks, it will be analyzed. So if we talk about Hadoop architecture, it will look like this, where we can see that MapReduce, HDFS, Yarn, and Hadoop Common, they are working together. And like it is also having the almost same architecture like we are using in Databricks, but the storage is different. So here you can see we have a master node, which is like controller, or it's going to manage our resources. And here we have master and slave setup, where the slave is like the node which are actually processing this data with the help of map and MapReduce. So processing will be happening on the slave, and the master is like controller to the slave, which is going to manage the resources. Okay, now let's talk about another available tool, which is Snowflake. Okay. So Snowflake is a cloud-based data warehouse platform. Okay. That provides a single platform for data storage. Again, this platform provides like a single platform where you can store your data, integration, analytics, and more. So like here it is providing storage, integration, and analytics together. It's designed to help organizations manage and analyze large amounts of data efficiently. Okay. So this is one more tool which can help us to analyze the data. And here are some, some of the feature of Snowflake. So first feature is scalability. Okay. Snowflake can scale on demand to meet varying workloads. Decoupled architecture. So Snowflake's architecture is designed with three decoupled layers. So it is having three layers. First is storage layer, second is compute layer, and third is cloud services. Okay. Then it does support SQL. So Snowflake supports the most common standardized SQL version, enabling all common operations. Okay. Next feature is data flow platform. So Snowflake's data cloud is self-managed service that provide data storage. Okay, it's having its own, self-managed data cloud, and it provides the data storage, processing, and analytics solution. Okay. Now, a fifth feature is the multi-cloud strategy. Snowflake is available on AWS, Azure, and Google Cloud Platform, and supports a multi-cloud strategy. Okay, so it can work with the multi-cloud. Snowflake is built on Amazon Web Services, AWS basically, and Microsoft Azure infrastructure. Okay. So these are some of the features which are available with the Snowflake. And if we talk about the architecture, in VPC or virtual network, we can see this is like VPC, and in VPC we have like cloud services, one component, second component is query processing, and third component is database storage. Okay, so these three components work together on Snowflake. So this is like architecture diagram. Okay, let me see where we stand right now. Okay, now let's talk about Databricks here. So Databricks is again a unified open analytics platform for building, deploying, and sharing, and maintaining the enterprise grade data, analytics, and AI solution at scale. So it is like defined in this way that it manage or maintain the enterprise grade data, analytics, and AI solution at scale. The Databricks data intelligence platform integrates with the cloud storage and security in your cloud account. Okay, so it more talks about the integration rather than the having its own solution of storage and all those things. Okay, and manage and deploy cloud infrastructure on your behalf. Okay, so this is what briefly about the Databricks. And what Databricks is used for. Databricks provides tools that help you connect your sources. Okay, so we are not fetching it from the sources, we are connecting with the sources. So more like integration of data to one platform to process, store, share, analyze, model, and monetize data sets. Okay, so from the sources we can choose multiple sources, we can combine them, we can maybe use different sort of sources, structured, unstructured, and we can process that, we can store that, we can share that data, and we can analyze and we can model this data. Okay, with the solutions from BI to generative AI. Okay, The Databricks Workspace provides a unified interface basically, okay, and tools for most data tasks, okay, including here. So we can see what Workspace provides here: data processing, scheduling, and management. Okay, so Workspace help us to perform like data processing here, scheduling, and the management of data, uh, basically like ETL process, and generating dashboards. So we can also create dashboards. We have feature in Databricks to create the dashboards. We can create the visualizations in the Databricks, where we can have the data visualized, means we can create some charts or output of the data. We can in notebooks we can run the data and we can create some meaningful insight. We can generate some charts together, and maybe we can use this chart in the dashboard, so we can develop some dashboards from this data. And these visualizations and dashboard will be updated as our data is being processed and new data which is being analyzed. So as we process the data together, we will have more and more updated dashboards and visualization. Further, it will help. So basically, the Databricks workspace will manage the security, governance, high availability, and disaster recovery as well. So let me see. So security aspect is being managed by workspace. Governance is also being managed by the workspace. High availability means making sure that it is fail safe, means if any failure occurs, still the resource is working, and it will make sure here. And DR part as well. So if anything happens with the recovery or our main site, we should have another site where we can recover the process from there. Data discovery, annotation, and exploration also it will support. And ML, we can use the ML modeling here, tracking, and model serving. And also for generative AI solutions also taken care into the workspace. Okay, now let's go to the next slide, and we can have a brief comparison between Databricks and Snowflake. So let's talk about this. Okay, so in Databricks and Snowflake, if we simply compare, so service model here is platform as service in Databricks case, but in Snowflake it is a software as service. So the difference, if you see here, is like if we talk about platform as service, so platform provides more control in your hand. Software as service is like subscription, okay, where you have less control on that one. And in platform you have like you can manage the configuration, you can manage more aspect of it. So subscription example, for example, Microsoft 365 is an example of subscription where you can use the service but you cannot control that service. Okay. Or platform as service, like you can have like example where you are managing the platform, for example, application service. So you have control to configure this application. Okay. So this is one of the example in AWS or Azure if we talk about. So a platform as service will give you more configuration rights compared to the software as service. So this is one of difference here. Major cloud platform support. So it supports Azure, it supports AWS, it supports the Google Cloud. In the Databricks case, here also it supports all the platform which Databricks supports. So it's like same. Again, the migration to platform, it is complex because it is a data lake. Okay, so because of the data lake where we store the data, migration is little bit difficult. Here it is easy because designed to based on the data warehousing. Okay, so that's the difference here. Scalability, it is having auto scaling. It is also having auto scaling up to 128 nodes. So there is some sort of limitation here. It will have auto scaling, but there is no limitation, so it can have more advantage. Vendor lock-in, there is no vendor lock-in here, but here we have vendor lock-in because this is like subscription. So in that we may have the vendor lock-in. User friendliness here, learning curve, but here easy to adopt. So as we are learning here, we can have more friendliness here. But this is easy because it's like software as service, and you can easily adopt it. Data structures, it supports all data types basically, including raw data or audio, video, logs, text, etc. So everything it supports. It supports only semi-structured data, means JSON, XML, and all those things, and structured data. So unstructured data is not supported on the Snowflake. Okay. Now, service perspective, if we see, it is a big data science we can use, data analytics we can use it for, or ML purpose also we can use. So these sort of services are possible on this one. But here we have to have database management and data warehouse only. Data science and ML built in an unified tool for any type of development, here only available via third-party integrations. So this is dependency, and cost is like pay by uses, and here also pay by uses. Query interface, you can get SQL, Spark, DataFrame, and Colas, and here only SQL is supported. Then query optimization, vectorization and cost-based optimization is there, and here also the same one. Provisioning of different type of nodes, yes, we can do, but here we cannot use the different kind of nodes. Okay, and there is no IPO, so this is like commercials, we don't need here, so it's okay. So this is like brief comparison between Snowflakes and Databricks, and I think for today, I think we talked, in detail about the data types, different tools which are being used in big analytics. We understood about the big analytics as well. So I think we have covered a lot of things today, and I think we will continue tomorrow. So if you have any question, maybe we can take and we can wrap this session.
Kamal, one question. Like provisioning of different types of nodes is yes for Databricks and no for Snowflake. So what is that?
Yeah. Yeah, so here we can have, like node sizes, when we're talking about multiple node setup. So we may use, because this is like software as service, in software as service, we have, like subscription where we have less control on the nodes and all those things. But here we have, like we are using with the AWS or Azure. So we can choose our own, sizes that let's say how much RAM we are looking for, or what core number of cores and all those things. So here we have more choices basically compared to the Snowflake. Yeah.
Got it. Okay. Thank you.
All right. So I'll stop the sharing now, and I think today we have talked many things we have understood about the data and data types, big data and tools and all those things. So it was more like theoretical. I know it is little bit boring for you guys, but yeah, I know this is like the core, theoretical part. And hopefully from tomorrow onwards, we'll start working with the Azure, and we'll talk about the Azure services, what services are being used. So we'll talk about like Azure account and all those things. So a cloud perspective we'll talk about because then only we are going to have subscription on the Azure, and we will be using Azure services along with the Databricks. So we will build up our understanding around the Azure. So that will be helpful when we work with the Databricks. Okay. All right. Thank you everyone for today's session. And we can conclude today's session if you All agree? All right. All right. So thank you and see you tomorrow. Bye-bye. Let's see, Azure. Okay, simply we can go to azure.microsoft.com and we can try Azure for free. And the process will start from here and it will provide you $200 as well for 30 days. And then once 30 days passed, you can upgrade it to pay as you go. And it will cost you for the resources which you will be using. So let's see if it is happening here. It's in private mode. I can try in Chrome as well. Incognito. Azure.microsoft.com. Looks like site has some issue. That's why on both the browser, it is having no response. Let me reload. Yeah, finally. So it will ask you the email, phone, or Skype ID, and you can do it with that. Apart from that, you can sign up with the GitHub account as well. So both the choices you have. Simply you need to provide this and there will be a process, simple process to sign up. Like you can easily create a, account and it will give you the trial one. You choose the trial account and in trial it will provide you $200. Okay. So I can maybe show you here. Azure free trial subscription. Yeah, so depending on your country, I think so this is only about the currency, not about the amount here. I was hoping that it should provide this one. Yeah, but you can not become inactive 30 days. Okay, after 30 days, it will get inactivated if you are not using. You just need to provide or change this account to pay as you go. That's it. I think not much information is provided here. Yeah. This is what the sentence I was. We offer eligible customers USD $200 as your credits to be used within the first 30 days of sign up and 12 months of select free services. That's another benefit. So this you can take the opportunity easily. You can sign it up and you will have Azure free account. Okay. And same way, we can use for Databricks as well. So Databricks also we can sign up and it will be 15 days free use. Okay, so $200 is really more than enough, to be used, is in a 30 days. So easily you can, go for this. It's really easy process. You can take your time and you can do that. So finally, once you have a successful sign up, you will have account like this. So this is like my recent activities. I will clear this and it will look like this. So empty one. Okay, some of the services you will see from here. I mean, recent visited services. Simply, interface is really very easy in Azure. So you have this menu here. You can open this menu and you can see all the services, like everything. Okay, so if you go to all services here, so services in Azure are, arranged in categories. So categories you can see like AI and machine learning related services clubbed together. So in this category, you will see all the services available related to this. Analytics related services like Azure Databricks and analysis services, data lake, data factory, everything you will see. Like these are for data processing. So these are the tools related to this. Another like data exploration related tools, real-time analytics related tools. So all these are nicely categorized here. Then you can see that, compute related services also clubbed together, and you can see all the, services which are offered as infrastructure as service. Okay. And if you see here, these are the services which are being, used as platform as service. And these are serverless or microservices. And these are high performing, computing services. And these are the services which can work with the hybrid environment. Means if you have on-premise setup and you have cloud setup, then you can use this service. Okay, so in short, like infrastructure service where you can manage the configuration of your service is called infrastructure as service. Like virtual machine is one of the example, like images and all those things. So these are like infrastructure service and platform as service. Like most of the services which are runs as a platform, like storage service and all those things, these are being offered as a platform as service here. And serverless, which doesn't require any resource, these are like subscription kind of services which triggers, then only it will cost. If it is not going to trigger, then it's not going to cost. So this, then we have containers related services, containerization, Kubernetes and all those things. So these are arranged here. We may use database services because we are dealing with the data here. So these are the database services or data related services altogether. Then we have DevOps related services here clubbed together, and some general services, it's like interfaces mostly, which you can see. For identity, we have Microsoft Entra Connect and Microsoft Entra ID related services, which will help us to manage the identity. Entra ID is basically earlier known as Active Directory. You may have heard the name Active Directory, which is being used with the Office 365 account as well. So the same service you can see here. Okay. Rest of the things means there are a lot of services, we cannot go through them, but yeah, all the services self-explanatory. You can see like monitoring services, networking services, security services. So nicely categorized here under the all services and the categories. Okay, from here, so now let's say on high level, we would like to understand that how Azure resources are arranged. So at least we can make some sense out of it. So Azure account generally is having, a subscription approach. You can have in one account, you may have multiple subscriptions. And depending on your organization setup, you may have, multiple subscriptions allowed under the, so that is called Azure scope. I think I'll find an image. Azure scope. I may use some free images from the internet just to understand the setup of this. Yeah, I believe this image should give. I'm using the public resources, means the public images. So you can easily, find them, study more, understand if you want to, build your understanding towards it. Just give me a moment. So I'll put this image into PowerPoint and explain you guys. So okay, so here basically when we sign up, when you will use your email account and you will be creating your account. So this symbol represent your Azure account. So once you create your account, you have the account, and under your account you will have this symbol represents the management group. Okay, so this is, you assume it is a logical container where you can, contain your resources. So this by default it will create a management group which is called root management group. Okay, so it will create a root management group for you. So on top level, we have our Azure account where we signed it up, and it's a single entity. Under that, we will have a root management group that is also only one entity. You cannot have two root management group. Under the root management group, you may have multiple, this is like optional. You may have, management groups. Okay, so you may have maybe one layer of management group, or you can, have up to 6 layers. So this will look something like this, that you have root 1. Under root, you may have, let's say, management group 1, management group 2, something like this you can have. Under that, again, you can have 2.1 or something like this. So this can go up to 6th level. Okay. If we include the top one, it can go up to 7th level, means including the top one. So this is like optional. You can create the hierarchy if you are willing to have, or your organization is having complex setup and very large organization having multiple subscriptions, etc. So this is fully optional. You may have, subscription directly. So once you are creating your account as your account, using free trial account, sign up. So you will be getting a root management group, and under that you will get your subscription. So let's say, for example, it will be, directly having a subscription underneath this, and subscription is represented by this key symbol. This is basically a subscription. Okay, so this is your subscription. By default, you will get your free trial subscription. So it will be it will have a trial a symbol or trial written there. So that will be your trial account. Under that, under the subscription, before you reach to your resource or you create your resource, you will have to create something which is mandatory, is called or represented by this symbol, is called resource group. Okay, so this is nothing, this is just a logical container. Okay, so this is mandatory. So you must have subscription, you must have a resource group, and then only you can create maybe virtual machine, firewall, database, anything, any resource you are creating is going to be under your resource group. Okay, so these are like resource groups. These are subscriptions. Subscriptions will always have resource group, and there cannot be, multiple hierarchy here. Only subscription can have one layer of the resource group. There cannot be another layer of resource group under this. So it's like single layer. Only the management group can have multiple layer here. Rest all have only single layer. Okay. So this is like, entire setup of Azure or scoping of the Azure. And why we may have multiple subscription, just to understand it a little bit further. Let me just add once. We'll go to next slide. So hypothetically, let's say if you have, account created, means Azure account, and you have management groups, for example, or root management group, I'll say. Under that, you may have different subscriptions, or you may have even, further management groups, but I'm just cutting it short. So subscriptions, for example, let's say you have different department. Let's say you have a sales department, you have service department, for example. Okay, so you can create this subscription for them, and they can have their own billing setup. So basically, each subscription is associated with its billing. So they may use different credit card, but one subscription can have one payment method. That's why we may have, or it will support multiple subscription. Another reason, maybe you have, let's say, if this is not the setup, maybe you may have the setup where one office is in UK and another office in US, for example. In that case, you will be, you having multiple subscription, one subscription for UK office and another for US office, so they can have their own taxation, their own billing, their own account owner, etc. So they can manage their resources, they can have their own setup. So this could be the another, reason where you can have. And if you are having like root management group, under that the management group, you may have the situation where under your root management group, you may have, let's say, multiple regions. So for example, if let's say talk about US and India, you may have, management groups. You can create management groups like this. And under US, for example, if you have one office in Texas and another office in New York, and they are different region, so they may manage their own billing and all those things. So you can have their subscription arranged on that level. Okay, in India also you may have some different states, and where you can have your own subscriptions. So this could be the possibilities. That's why this can afford up to this complexity. Okay, any questions so far? Any doubt? Are you getting the point? Okay, looks good. So, okay, I'll continue from here. Okay, I can see. All right, so let's continue. I'll go to my Azure account and I'll show on the Azure account how these things are arranged. So I'll close this. Okay, now you can see that how we can reach out to, or subscription, how we can see the account and all those things. So I can show here, I can go to and type here. This search box is basically a universal search. Okay, so here basically you can see almost everything. I close the presentation. Okay, so here let me go to home screen so it will not confuse. Okay, so we are on home screen, and this search box is available always. So clear recent search, and it will look like this. So here you can go and you can type, let's say, if we want to see on the account level information, we will type tenant, and we can see the tenant property from here. So when we sign up, this is like the information which we have provided. So this is the tenant, which is having a default directory. Default directory is basically the Azure Active Directory you can call, or enter ID you can call. This is enter ID is used for authentication purposes, where you can create your own accounts and you can use these accounts. So I'll show you what exactly is the default directory. But before, so this we are looking at the on tenant level, means on the before the root management. So if I go to my management groups, I just type here management groups, and this symbol will be shown here as service. And here you can see like setup, how we were talking about root management group and all those things. So here you can see I have tenant root group. This is my root management group. Okay, and it is always single, means there cannot be a two root management group or something. So underneath you have a subscription. So when you sign up, you will get a free trial subscription, and it will have its own ID. So that is going to be under your root management group. Apart from that, you can create your own management groups. It's like I created one example, and this can this can go up to 7 level, including the tenant root group. So here, let's say I created just for understanding, like sales department. Under sales department, we may have further layers, like sales management group India, USA, or something like this. And under that also we can have more further management group, and under that we can create our subscription. So this can go up to that level. And easy adding subscription, also very easy. From here you can add more and more subscriptions, put their billing information, and these are ready to go. Okay, under the management groups, we have subscriptions. So either we can click on subscription and go directly, or we can type here subscriptions. And we will have this key symbol where we can list down all the subscriptions we have under this account. And we'll see the list of, subscriptions we have and their related cost, because this is under tenant root group and this is active, and it will have its own cost. So let's say I do have multiple subscriptions. They may have different use or different region, so they will have different billing. So that's why it will show the cost related to that subscription. So when I click on the subscription, I'll see all the details related to this subscription. So basically it's like individual account you can see. So you will get your subscription, which will be the free subscription in your case, and going to have $200. So whatever you are spending, it will give you the spending forecast and all those things here, nicely arranged. So you can see like your billing period also it will show once you change your account to pay as you go, because once your 30 days passed, you will have to upgrade it to pay as you go, where whenever you buy the service, it will cost. If you are not buying any service, then it is not going to cost. And definitely you can cancel your subscription as well. But again, you will not get the $200. It's the one time only. All right. So here you will see your reports and all the things you can see from here, that, how you are spending and all those things. Now, yeah, so as I informed that subscription is having its own billing, invoices, and payment methods and all those things. So this will be displayed here. You can manage the cost and all those things related to your subscription. From this left menu, you will see your invoices, if you are associated or your company is associated with the Microsoft partner. In that case, you can fill up the partner information as well. Okay. So this is how your subscription. Now we'll go to next level, which is the resource group, the final level. Under that, we can have a resource. So we have up to the subscription level we understood. Now let's go home and type here resource group or resource group. And just to make it simplify, when we call resource group, what are the resource group? Basically, it defines itself that group of resources, simple. And this is logical, so nothing physical which we can, verify or location related. So I have so many resource group created here, and resource groups are having a location. Means these are logical one, but their metadata are residing on this particular location. So some of the resource group I created like demo RG, DevOps, so whatever name we would like to provide, we can simply create a resource group, and it's going to be a group of resources which are put together on the same or just for segregation you can call. So here in my case, let's say how to create a resource group. So you have resource groups. Under that you have a plus create button. You can simply click on create, and you can simply provide the name of your resource group. So here, let's say I provide demo resource group, or I'll provide something which is unique. I do have already one created as demo. So let's say demo 2, I'll just give a simple name. Or it's better to some companies follow naming convention, so you can provide RG resource group to identify this resource. And you can select your region, so it will keep the data or metadata in that region. So okay, where you would like to arrange all the resources. So basically, let's say if I would like to manage all my data or all my resources which I am going to create under this resource group in a specific region. So these are like data center of Microsoft around the world. I can choose one of them. So let's say if I choose South India, for example. So I can choose the data center of the Azure in South India. Let's say if my office is there, and if I am a data analyst or the person who is working with Azure and Databricks, and I need to create my resources where my developers can easily access. So less hops I can choose for, means I can choose the closest region which is near to my office. So let's say my office is in India, South India. In that case, I can choose the South India data center. If I have the office in, let's say, central part of India, then I can choose maybe central India. Or the same way, one more data center which we have in West India. So there are 3 locations available in throughout India. The same way, US also divided into the same way. Let's say East US. So you can see East US. We have another location, East US 2. So sometime resources not available on East US, you can try in East US 2 as well. Similarly, we have, West US, West UK. So like this. And there also, I think there is South Central US. And you can see some more locations. I think northern part also having north central US. So these are divided, in this way. So you can create anywhere you wish to have. So I'll choose, let's say, for this South India, and I'll say next. And if I would like to identify it further with the tags, I can create tags, or tags are, Tags are just a keyword we can associate with this. Let's say, for example, if this resource group I am creating, and I am creating this resource group for managing the Databricks for sales department, for example. So I can, these are like key value pair. I can say which department I am creating it for. So let's say department, and I can put the value like this is going to be for sales. So key value pair, we can have multiple key value pair. Let's say I just want to see that or inform the people who are going to handle the billing and all those things, like evaluate the cost, etc. I would like to mention here the name of owner, for example, who is the owner of this resource group. So let's say Kamal is the owner of this resource group. Or I may further, provide up to 64 level. I think up to 64 tags it supports. So you have plenty of tags which you can associate with your resource group, and same way you can associate it with the resources. These are just to identify that whom this resource belongs to. And let's say if maybe department, owner, location, let's say if you have you would like to if you have, let's say, multiple location in this specific region, so you can mention here maybe the location, whatever you are independent to choose. So you can just type something like this. So you can put anything and it will accept. Next, so it will validate. So you are creating a resource group. In resource group, you put whatever the information, it will give you a validation success or failure message, depending on your data input. And then it will provide you the information which you have filled up. Maybe you can go to previous tab and correct it, and then you can click on create. So it has created a resource group. Let's see where it has created. I think this is the one. It's going to be in South India, and this is falling under these subscriptions. So one resource group can be associated with one subscription only. It cannot be associated with the multiple subscription. It is always be associated with the single subscription. So hierarchy is like you have on top level your tenant account, or the account when you create the Azure subscription or Azure account. Under Azure account, you will have a root management group, under which you have this subscription, which is subscription 1, under which you have a resource group. And it is sometime when you are managing for multiple client, you can create your resource group with that client. So you can associate all the resources related to that client in a resource group. So these are the advantage of having a resource group. Okay. All right. So when we click on the resource group, so how we are going to reach here? We may go to search box on the top and click on resource group. So whatever the services we are visiting, it is giving us here. So and Azure recent services which we have visited, and here also it will show you. So this interface is very useful. And here you can see, let's say, resource, or maybe you can type here, go to resource groups. Once you click on your resource group, it will show what you are into. Means, are you under a resource or resource group? You can see, and you can identify it by this symbol as well. Once you have the resource group, maybe you can create a resource. Okay, so we'll understand what exactly the resource is. So here you can have, so I will explain you about the identity and access management as well. So let's understand identity and access management. Before that, I'll just show you how to create a resource. Okay, so we created the resource group. Up to resource group, we understood the concept, and now we are creating a resource, which actual resource which is going to deliver something. Let's say it's a storage account, virtual machine, or anything we can create from here. So let's say, for example, we create something which is very simple to create. Once we go here, we have several, resources or resource type. We can go to marketplace and create. So if you see here, like categories, let's go categories. So under IT and management tools, we have 5,660 type of services available. Under compute category, we have 4,430 type of resources available. Under development tool, 3,172. So there are several type of services available. Each service which we are creating going to cost us. So that keep in mind, nothing is free. Up to the resource group, it's free. Means up to your subscription, up to your resource group, everything you can assume as a free, because these are like containers only. But when you create a resource, every resource is having its own cost. So depending on the type of resource and all those things. So there are several resources, but these are mostly third-party resources, not the Azure resources. Okay, so in this huge number, let's say 2,195. So how you will choose that, which resource we should go for? Databases 1,393 type of different services available in the databases. So there are several resources, but let's say we will create a simple one, which is going to be our let's say virtual network. Let's understand. So simplest one I'll choose. So let's say if we create a network security group. Okay, resource name is network security group. Once I put into the filter, I'll see that once I type the network security group, I have several services available under this category. It is showing 1 to 20 of 392 results it found under network security group. Okay, so you see some of the services provided by Microsoft directly, some of the third-party services. So these are also different providers having, like, it's like marketplace scenario here, where you can have any service which you are looking for. And every service is having its own cost. So like hourly cost here is 2.81 rupees per hour. So some of the services are very expensive. Some of the services may be little bit less expensive or even free. So depending on service, but what we simply can do here is we can filter it to Azure services only. So I'll just put this check mark, and now I am seeing one of three results, network security group. So I just limited it to three, which are being provided by Microsoft directly. So here you can see I have three services. First is network security group, application security group, and virtual machine application version. So I am talking here because I have written network security group. It's easy to create, that's why I have chosen it. And it's a free as well. So I'll click on that, and it will take me to the next screen where I can create the network security group instance in this resource group. On the breadcrumb, it will show which resource group you are into. And I'll simply click on create button. And here I can provide the instance name, means I'm creating a network security group, but what name I would like to keep of that network security group. So I can choose here the name of this network security group. So I'll keep a short name, let's say NSG1. Okay. So region here, I would prefer that, because we created a demo resource group into the South India. So it is always good to keep all the resources related to this resource group into the same location. So South India. And it will not deny, maybe you can create a resource in maybe Europe or US and a resource group in India as well. But only the thing is, technically, it is actually the metadata is being stored in, let's say, wherever you are creating the resource group, and wherever you are creating the resource actually going to reside on that specific location. So it's little bit, bad idea, because your resources are in different continent, and your resource group, or which is the logical container, in different continent. If, let's say, if anything happens to that location, let's say if there is any calamity, anything, then it's additional dependency. So it's always recommended that you should put your resources in the same region where your resource group is. Okay. Now I click on next, and here also it will ask for tags. So like the previously we put some tags. These are available, like department, which department, this resource which we are creating, like network security group we are creating, where it's going to, for what it is going to be. So we can simply choose this, and we can click on review and create. And again, it will pass the validation, like we have gone through the resource group same way. And then we can click on create, and it will create the resource group. So this is the deployment of this resource or network security group which we are creating. Okay, so it was very easy. It is almost deployed, and we can see here in deployment detail that our network security group, which is again having a symbol here, is created. And operational detail also you can view from here. So your operational detail you can see from here, that your how it is being deployed. If you have any failure or any glitch, you can maybe contact Microsoft support and provide this tracking ID, service request ID, and all those things. Okay, so this is successful with the green tick. So let's see how we will reach to this. So I'll click on home, for example, and I can go to my resource groups, and I will go to my resource group where I am, here. And if I go under this, I will see my network security group created under this. Okay, and it is having its own location. And so this is the basically resource which we have created under this resource group. Now, what we'll understand, that the scoping we have understand that how the account is arranged, subscriptions are arranged, management groups, resource group, and up to the resource we have understood all those things. Now, next thing is that how we will provide the identity and access management to these resources. Before that, there is another concept which is called Entra ID. So we'll talk about that. So let's go to and understand about this quickly. So earlier, the Entra ID was, known as Azure Active Directory. So some places they use short naming, which is AAD, I think, yes, Azure Active Directory. And now they totally changed this concept and changed it to Microsoft Entra ID. So it is directory service, means the user and group management. So here briefly we will understand what exactly it is. So because Microsoft Azure is associated with the Entra ID, and Entra ID is used to manage users and groups. Okay, so we have one default directory. We may have multiple directories as well in one tenant. We may have multiple directories also we can create, but one subscription can associate with one directory. Okay, so this is our default directory, this is our tenant ID. Sorry. And this is the primary domain which we are on. So Microsoft will provide domain, whatever your subdomain name, and dot on microsoft.com. So it's like free. You can put your own domain as well. So here, number of users, number of groups you have created, applications and devices. So basically these four aspect it is are being managed by the Entra ID. So Entra ID briefly manages your user accounts. So in the people who are using, or the companies which are using Azure for the cloud management, certainly or definitely they are going to use the Office 365 suite to manage their email accounts, uh, Teams meetings. So it's like end-to-end Microsoft solutions, and they are using SharePoints and all those services. So in this case, you can see that all the user accounts are being managed on centrally on one location, which is the Microsoft Entra ID. And Microsoft Entra ID, works with the Azure as well as on Office 365. So you can assume or you can understand this just by a slide. Let me see. So you have Entra ID, Entra ID. This is just to manage your users. So basically it is taking care of authentication by your users. Okay, then you have Azure, which is just for your resource management, and these both are associated. You may have Microsoft 365 suite, which is again a bunch of applications or software as service from Microsoft, and which again it provides like SharePoint, for example. It provides your mailing services, exchange services. It provides Teams. So several tools under this. So all the authentication, either you are authenticating on the SharePoint, if you are authenticating on your email account, if you are authenticating on Teams or any service, it's going to be authenticated on the Entra ID. So once your user is created on Entra ID, Entra ID will provide all the authentication services for any of this, even your on-premise, let's say, if you have an application and if it is registered on Entra ID, it will authenticate you for that application using the Entra ID. So Entra ID will take care of authentication part, and so this is how your entire setup works. And when we work with the Databricks, let's say, okay, so Databricks is going to work along with the Azure, and authentication will be taken care by the Entra ID. Okay, so Entra ID works with in this way. So all the authentication related, requests are going to go to Entra ID for user perspective. So basically, the four aspects are being managed by Entra ID. Number one is users. Number two is groups. Groups are basically group of users, number of users. Number three is application. Okay, so we can register application to Entra ID and it can manage here. So this is how the Databricks work. Databricks is an application which is listed on Entra ID, and Entra ID knows this application use my authentication and it authenticates. And the fourth is devices. Basically, these are Microsoft joint devices. Okay, so these devices are, let's say this may be laptops, computers, which are being authenticated or Entra ID or authenticated by the Entra ID user, not the individual user or account which is not available on the Entra ID. Okay, so these four aspects are being handled by Entra ID. Okay, I think it should be clear now. So we are talking here about our default directory, which is the Entra ID account, and Entra ID is having, so here simple view is given in the Azure. Further, if you have Entra ID access, because you are creating your own account, so you can go to your Entra admin center as well. So let me open another tab here, and I can simply type entra.microsoft.com. So this is like another, or this is the basically primary access to your Entra ID. And this got new symbol. And you can see it's almost identical, but yeah, it's having the complete services of Entra ID. Most of the organizations, they have, and it is called Microsoft Entra Admin Center. Most of the organizations, they have Entra ID admin or different administrator. Usually, these are the administrator who is taking care of licensing, taking care of Office 365 account, softwares, access, all those. So identity and access management. So this is like key component of identity and access management in Microsoft environment. And here you, if you go to under identity, you will go to users, you will find all users here. So here you can create your user account and provide the related access. So here let's see, in my case I have this many user account created. It's really easy to create the user account. It's you just have to click on new user and create a new user. Okay. And you just need to provide the principal name, because this is your domain, so it will uh, show your domains. If you have your custom domain, also a publicly available domain, you can choose that one, so just for authentication. So we'll use the principal name, and it should be unique among these. So when we go to all users, it should not be the same name which is already being used. So these are like principal name. It should be unique among these. So let's say I created VM admin 1, VM admin 2. I will just try to create one just to show you guys that how you can create, and VM admin 3, for example. And it will derive the mail nickname. If I have the exchange service along with this account, so it will create a mailbox for this user. Okay, so mail nickname also like VM admin 3 at this domain name. Okay, then I provide the display name of this. So let's say VM admin 3, I'll provide whatever the name I can provide here, and it will automatically be generating a password. If you don't want it auto generate, you can simply type your password. And it will have some complexity requirement. Okay, and definitely once this user is going to sign in for first time, it is going to ask the user to reset the password. So this is just temporary. Then you have choice to enable this account, or keep it disabled. Means it will create the account, but it will not enable. So next, and then you can fill up this information. These are optional. And here also you can provide like you can add this user to multiple roles or groups or administrative unit, which we are not adding. We'll understand in a while that how we can add this, and we are creating. So it created a user for us. Now that user is enabled, and that will be listed here. It may take time, I think. Yes, it is here. Okay. So this user, we can, or the user can access the Microsoft Azure, Office 365 applications, and all those things. This is how we simply create the user. And now we'll understand about the group. Okay, so I am on Enter ID admin center right now. The same interface I can see in the Azure when I am on the Enter ID from this search box. But this now this is I think going to be obsolete, or is going to be stopped in future. That's why they have separated it recently to Entra admin center. Earlier it was managed with the Azure only, and now they are developing this interface separate for Entra ID, so they can separate as per the role in the organization. So I think we are not going to see this interface in future, but it's identical, and it will reflect all the users here as well. So these all users, you see VM admin also here, almost identical, but with the less options, and it is recommended now that you go to Microsoft Entra ID and create or manage your users. Okay, so next thing, I'll again go back to Entra ID admin center, and I'll show about the group. So group of users, basically we can, same way we created users, we can create a group as well. So I have created some groups here. Groups are really easy to create. I'll make a little bit less. Yeah, okay. So we can simply click on new group, and I can say it's going to be a security group. And that security group security group is basically the group of people who are having, all security or roles assigned to this group. Microsoft 365 group is the group which is just for the collaboration, means they will get a group email address, and maybe someone can send that email to this group email, and this is for different purpose. So always we will be using a security group here. And then the name of group we can provide here. So name of group is going to be, let's say, if I haven't used some group name, maybe I can say, okay, demo to users group. Okay, so I can provide some name which can make sense what this group belongs to, and whatever name I think easily provide, and it will support, I think, 128 characters or something. Further, I can provide the description here. Let's say this group is to manage demo to users. Okay, so like this I can do. Here I can create someone owner of this group, so he can, like in WhatsApp group we have one owner, so same way we can have here the owner who will be like in charge to add and remove the members from that group and all those things. And we can select here the member as well. So let's create one empty group, and then we'll see how we can add members here. So yeah, we will have to refresh this. Yes, a group is created here. Once we click on this group, we can see from here the members. If someone is member of this group, we can add that member from here. We can pick basically the user account. So these are these are all the resources, but we will just choose the users. And let's say if we want to add like this newly created user, the member of this group, or anyone else, let's say this one. So we can pick the accounts and we can select. Okay, so let's refresh here, and it will reflect that this group is having this many members, and we can assign someone as owner as well of that group. So he or she can take care of this group, and they can provide maybe, so let's say this is going to be the owner. So refresh and this owner. So this is how basically the group is having. And roles and administrators. So Here under this, you can add some roles here. We don't have licensing, so it's really nothing showing here. And we can assign the licenses from here as well. Okay, so like in this group, you can manage all the licenses. Once you assign the license to group or any role to the group, it is going to be applied to the members of that group. Okay, so you don't have to manage the permission for individual, members, and you simply have to manage the permission for that group, and all the members of that group, maybe 10 members or 50 members, whatever the number of member of that group, will have that privilege assigned. So this is like a group concept in this one. Same way we have devices, and these are like number of devices in your organization, and you can see the list of devices from here. So like what device ID and all those, so who is accessing which device, which user is being using, you can. So this is not related to our task. And here we have the enterprise applications and app registration. So let's go to app registrations first. View all applications. So you'll see all the applications which are, currently registered on Enter ID, and some of them are expired as well. So this is like lease where, you have, application registered on Enter ID, and this application will be authenticated using the Enter ID account. Okay, so that's why this is here. These are like enterprise applications which are, inbuilt applications in the organization, or organization is using some specific application, which are again authenticated using the Enter ID. Okay, so these are like application. So these are like 4 aspect of Enter ID. Okay. All right, I think we have covered lot many things I'll share, and we have understood about the core concept of Azure, which is required us to manage our Databricks related activities, and at least if we talk to the Azure administrator, we understand each other's language. One more thing I just want to tell you is that in next session we are just left with the identity and access management for the resource, which we'll cover, and then we can start with the Databricks, I think. So in Azure, we have covered lot many things today, which are related to, or Azure perspective we'll have to keep in mind. So like a resource group, subscription, resource, what is the resource, what is the Enter ID, what is the authentication part, and all those things, how it is being managed, so all right, thank you, bye bye. All right, so we are talking here about creating a Azure Databricks account. And here to create the workspace, we have these methods or these possible options to create this one. And these are the requirement where we should have Azure subscription, but it should not be a free trial subscription. So we can, opt for free trial subscription, and then we can upgrade it to pay as you go. Don't worry, it will not charge you anything. Means still it will remain the free, but if you create the resource, it will cost you. Simple. So it's not going to cost you hugely even. Let's say if you are using the resource for 1 hour, it is going to cost you for an hour only. Okay. So as you will just be paying as you go, and it's really very a competitive price. It's not going to be a heavy price just for small labs. Okay. All right, so these are the requirement where you should not have a spending limit, request quota increase in case if you need it. So all those things are there, and then we can simply create our Databricks workspace. Okay, so we'll have to go to Azure portal and create a resource. Under analytics, you have to choose Azure Databricks. Under Azure Databricks service, provide the value of Databricks workspace. Basically, like these are the properties we will have to provide, like workspace name, subscription, resource group, location, and pricing tier. These are the only parameter we have to provide. So subscription, as we understood in the scope, I think we already discussed that what is the subscription management group and all those things. So this is going to be your Azure subscription. Okay. And the resource group is like logical container where you are going to create your resource. Okay. So resource is basically Azure Databricks account. Okay. So we will specify this one here. And the location. So as we know that Microsoft is having, data centers around the world, and we can choose the location which is close to our data and ourselves. So we can choose any region like India or US, UK, whatever, wherever our data resides. So it can easily deal with the data. And the pricing tier, then we have different pricing tier we can go for. So we can go for standard, premium, or trial. So in your case, you will go with the trial because it will provide you 14 days free trial. Okay, then maybe you can upgrade it to standard. Okay, and then finally we will review and create this service. All right, so this is the simple process creating Azure Databricks account on the Azure. So here we are on Azure portal. To go to Azure portal, we have to go to portal.azure.com, and on this one we can start with this. So when we come to the home page, it should look like this, or you may be landing to dashboard. So maybe one of the page you would be viewing here. Simply, there are several options to create the resource. Either you can go to search box here and type Databricks, and it will show you the Databricks here. Okay. Second option, you can go to this plus sign and create your own Databricks account. Okay, so you can search Databricks and it will filter it for us in marketplace. And you can select Azure services, not this one, I think. Yeah, Azure Databricks here, this one. You can choose this one. This is the second option we have. And the third option, that in the marketplace, in the create resource, I think you can go for analytics should be there. They keep changing the name. So sometimes integration, security, develop, computer, IT should be here. Yeah. Under this category, you can filter it out and you can see Azure Databricks. So these are some of the method to create any resource. But to create any resource, you should have a resource group. So either to find the resource group, you can see we don't have any resource group created right now. That's why it is showing empty. Okay, resource group is just you can assume as a container inside the subscription. So you have Azure subscription. Under the Azure subscription, you need to create a container which will keep your resources. Okay. So let's create one resource group. We can give any name. Just click on plus create button. And you can type, let's say this is going to be your Databricks, resource group. So any name we can provide. We have freedom of doing that. And I'll just provide the name like this is Octo. It will not accept the space. October Databricks batch or something like that. Anything you can provide basically. And then you need to choose the location, physical location of this resource group. So let's say I would choose Central India, maybe. Yeah. So Central India, we have 3 data center in India point of view. So Central India, we have South India, I think. Yeah, South India. Then we have West India. Only 3 data centers we have. So I could go for either Central India, West India, or South India. So West India, I think, would be Gujarat or somewhere. So I think we can choose this one as well. All right. So then next, it will ask you, would you like to put any tag? Tag is just label to stick on. So it is not mandatory. You can go next. And finally, it will validate that whatever information we provided for this resource group, it will show it here. So what I think I should put here, like OctDB wedge, and just to identify that this is the resource group, I'll go to previous and dash put RG resource group, or I can put it in front as well. It's not mandatory, just to identify that this is resource group. Okay, I'll say review and create directly from here. And validation passed, and click on create. So it has created our resource group. It's quick and easy, only the metadata stuff, because this is logical container. There is nothing in it right now. So if I click on this, I would, go into this resource group. Okay. So if I click on home, I will see this in the recent list. And if I remove it from here, for example, now I have first choice, I can go from here, or I can go from here and search for resource group, and I can view it here. So there are these 2-3 methods by which I can go into a resource group. Now next is to create the resource inside the resource group. How we can create the resource inside of our resource group. So first we need to go into the resource group and click on create. This is the one method. You can, simply create anything inside of it. Second method is you can simply create a resource from here and choose the resource group while creation. So let's say you click on create a resource, and then you choose the resource here, and while you are creating, it will ask you. So let's say Databricks. So Azure Databricks, it will show Microsoft, provided by Microsoft services, and we'll click on this card, and it will show that what exactly you are creating, and we'll click on create. And here we can choose the resource group. Okay, so we'll go here and we'll pick our resource group. And if it is not there, you want to create a new resource group. Also, you can create a new resource group from here by just providing the name, and it will pick that one. Okay. So we are on creation of Azure Databricks workspace, and here you will see that we have instance detail we have to provide. So we provided our subscription. If we have multiple subscription, we can choose the subscription from here. Then inside the subscription, we need to choose the resource group. Then about the instance, whatever we are creating, let's say we are creating Databricks, virtual machine, anything we are creating, we need to provide the information about whatever we are creating, right? So here we are creating Databricks. So we need to provide Databricks workspace name. Okay. So I'll just provide the name, whatever you can keep, basically DB Databricks workspace. I'll say -2. Okay. So this is going to be the name of workspace. We can have multiple workspace on same account. Then in region, it will choose the region which we have selected for a resource group. The same region, it will automatically be picking it up. But if we wish, we can change it as well. Okay, so let's say if I want to change it to somewhere else, and the resource group will reside in West India, but I want it created in, let's say, Central India or somewhere. It is doable, but not recommended, because your resource group metadata will reside somewhere else, and your actual resource will reside somewhere else. So that is not a good scenario. So it is having more chances of failure. Then the pricing tier, you can choose premium, trial, 14 days premium. Okay, so you can get some free DBUs, Databricks units for making or just charging us. And this is the standard. So you can go with this Apache Spark secure with the Microsoft Entra ID. The premium will go with the role-based access control. Okay, so these are like different tiers. Okay, and we'll go with the standard one here. Okay, because in my case I'm going in the standard one. In your case you will go with the trial one. So 14 days more than enough to try with this. I don't think it will allow me because I have already finished that one, but we can try. I mean, let's see. But I'm sure it is not going to give me the trial one. So maybe it will, stop somewhere, maybe throw error, or maybe it will convert to paid one. So I have already used it, I think. Yeah, so let's go with this for at the moment. Maybe anyways, I will delete this and create another one. So manage the resource group name. Basically, it will create another resource group which will be managing the resources, or automatically we created the resources for this item. So for this workspace, it's going to create more resources. So I'll give some name to this one, like the above one we have. So let's say RG Oct Databricks batch, and this is going to be managed resource group. Okay, managed, for example. Let's say anything we can give. So this is going to create a managed resource group. Next, under networking, deploy Azure Databricks workspace with the secure cluster connectivity, no public IP. Yes, whatever default, we'll go with that. Deploy Azure Databricks workspace in your own virtual network. If we wish, then we will have to select the virtual network. We can go with that, but we'll just keep it no. Next, encryption. So encryption, anyways, these all are disabled for us. So we cannot pick anything because we are on the standard. Maybe on the premium, we will be able to use these options. Next. Security and compliance also disabled for us, so we won't be able to pick these thing here. And the current pricing tier doesn't support advanced security and compliance add-ons. So these are like for premium, account, which we can pick, and it will be enabled, and then we can use these advanced features. Click on next, and it will ask you if you wish to put any tags on that. So this is going to be tags here, and finally we'll click on review and create. Okay, so here it will validate that if we are able to provide all the information which is validated, and it's not going to throw any error while deployment of this resource. Okay, so we are creating the workspace here. We'll click on create. And now deployment is underway. So it is deploying our Databricks workspace on Azure. It may take maybe few minutes. So it will show the deployment progress here. But if we click on the notification here, we'll see more detail. So meanwhile, what we can do is we can just open a new tab. So we can open multiple tabs of Azure, and one, the deployment is going on. Let's see, second one will open. And in second one, if we go to the resource groups, you'll see that it has created another resource group here. And first one we have already created. So second one is like managed resource group, where it's going to create the resources. So if I click on the first one, let's see. See, it has created a resource or Azure Databricks service in West India. And if I click back to resource groups and go to managed resource group, it is creating the supporting resources for Databricks Workspace. So it has created a storage account. If you see, it is a storage account. This is the data lake account for us. Then it has created a network security group, which is going to manage the networking component of this. Then it has created a virtual network, and it has created a managed identity. Managed identity is like ID for connecting with the resources. Authentication purposes it's used. Meanwhile, let's go. Our deployment is succeeded. Okay, so we successfully created our Databricks workspace. Okay, deployment details, we can see it was okay. I can close the notification, and I can simply go to the resource from here as well. So we created the Databricks account and on Azure, and if I go to home, for example, from here I can maybe from recent list I can go. Second option, I can go to resource groups, maybe from the search as well. Go to my resource group here and click on the workspace itself. And it will show me the status, like if it is active or disabled. I can go by the URL as well, and I can launch the workspace, and I can upgrade to premium one as well. So click on launch workspace.
Kamal, one quick question, okay?
Yes, please.
So, can you go back to subscription and say that the hierarchy, like subscription is the one which we created first, and then
Okay, so Azure subscription, you're talking about the Azure hierarchy, right?
resource.
So
I just want to say one thing, okay? So, subscription is on the top level. Under
right,
subscription, we have to create a resource group.
correct.
Under resource group, we will have a workspace.
Yes,
Can I create multiple workspaces under one resource group?
yes, you can create. Should
Okay,
not be.
so one resource group will be there under subscription.
Mm-hmm.
After that, we have created workspace. Under
Mm-hmm.
workspace, we created a resource called Databricks. Is that right?
No, it's little bit different. So let me explain you. Yes, I clarify your doubts. Let me just give me a moment. I'll open a blank space. So let's understand the hierarchy here in Azure, how it is being managed. So let me find appropriate image so I can show you. Okay, so basically, I think it's not too blur, right? I'm not. Okay, no problem. So basically, when we talk about the Azure account, our account is organized in this way. So if we see that how our account is organized, we have basically above that a root management group. Root management group. So this symbol denotes management group, this symbol, and every one of us in our account is having the root management group. Under the root management group, basically this root management group lies under our what you call tenant, or you can call it account as well. So when we create Azure account using our email address, that is called Azure tenant or account. For that tenant, we have, when we create this, it automatically creates a root management group for us. Okay, so management group is also a container. So assume subscription also a container, management group container, resource group container. So these everything is like container hierarchy. So here we have root management group. We may have another management group created under this. So that is totally possible. We can have, multiple level of, management group. So in this case,
So you are saying one management group. So any Azure, like, okay, when we go for the enrollment of Azure, right? So
right.
we will have one management group. Under one management group, we will have multiple subscriptions. We
Yes,
can't.
yes,
Okay.
So because we sign up with the trial one, so we have this key denotes the subscription. So we have a subscription called trial subscription. Okay, so this subscription is there. We may have another subscription. Let's say if we have, we want paid subscription, so we can create one more subscription. So it's totally fine. We can create multiple like this.
Got it.
Okay. And then also, just for your understanding, since we are on this page, that under management group, let's say this represent a management group, something like this. Under we can have another management group created. This is totally possible, and that can go up to 7 level, including the root management group. So you can have the possible scenario where you can keep creating the management group under the root management group, but root management is going to be one only. You can have up to 6 level underneath this one, the management groups. So after that, under these, you can have subscriptions. So subscription can be directly under the management group. It can be under another management group. So subscription 2, for example, it can be another level, or up to 6 level, 6 levels we can create and there. And under the subscription only and only we can have resource group, not under the management group. So resource group, this symbol denotes this, and this resource group can be created under the subscription. So there should be one subscription to support this resource group. Okay. Under the resource group only and only under the resource group, we can create any resource. So you are saying that workspace,
Under
right?
resource group, we can create multiple resources.
Exactly.
Okay.
And like Azure Databricks or Databricks basically is a resource for Azure. Means it's just associated with the resource group. That's it. So to manage the Databricks, we can go to the management of that console, and then we manage it. But for Azure, it is like storage account, virtual machine. Same way, it is the same resource. That's it. Okay, and I'll show you here. Just give me a moment. So if I go to my home and if I type here tenant properties. So this is my core account, basically. This is my account. So this is my Azure account I'm going into. And when I go to management group, so I can see this symbol, management group, and you can see under my tenant root group, this is like key everything falls into this. And above that is the tenant itself, is tenant account where we have gone to. So a tenant, under the tenant account, we have one root management group. Under the root management group, we may have one subscription. In your case, you will see the trial subscription. I have one paid subscription. So this subscription, it is showing here. But if let's say I want to create another subscription, I can simply create another subscription here. So it will create. So if I click on add subscription, I can add another subscription here, and that will be, easily doable. Or I can create a new subscription. For example, under the management group ID, I can create a new subscription as well. So I have created, another management group. Underneath this management group, I have created one management group called sales department, for example. Under that, I have another level of management group. So I think I should be able to expand it. So here you can see I have created another level. So this is the level 1, this is level 2, this is level 3, and underneath I can create maybe a child group, or I can create a subscription underneath. So wherever I want, I can have another level of management group or subscription directly. Under the subscription, then we'll talk about the resource group. So when I click on the subscription, for example, so now I'm talking about this subscription. And why we have the subscription. Basically, subscription is basically like container where it can calculate my cost. Okay, so I can see the cost by resource. So let's say if I have one subscription, it will keep all the associated cost here on one place. And let's say if I have subscription 2 as well, it will have different, billing cycle. It is having a different credit card we may use. So subscription is like isolation of, payment or billing stuff. So that's what the use of subscription in Azure. So you can separate your billing. And why it is important? Maybe let's say you are, working in some department which is dealing with the data, and you have associated cost with your, let's say your developers are working or analysts are working. In that case, you have different cost. And maybe you have a software development department. So their billing is different. Their, location of resources different. The developers are residing maybe on different locations. So they may have different billing cycle and no payment, etc. So this is how we can separate it. So that's the logic here. Okay. Now we talk about the resource group. So resource group falls under one subscription. So when I go to, let's say, resource groups here, it will show me that this resource group belongs to that subscription. And this is the physical location of this resource group. So resource group is like metadata container. So if I go to this resource group, inside the resource group, this is just a resource like virtual machine or anything it could be. So here we have created a Databricks resource. For Azure, it is just a resource. So if we see the relation between these three, so Databricks is like, third-party resource, we can say, which they have named it Azure Databricks, because when Databricks is working with the AWS, it will identify itself as a AWS resource. Okay, so this is how the collaboration between this all happening with the Azure and GCP and AWS. So here it is a resource. Like if it would be a virtual machine, then it would act as a resource in Azure as a virtual machine, and we can log in into virtual machine and do our stuff. Same way, we can go into the Databricks account and we can do whatever for that resource, and it doesn't, interfere with the Azure part. Azure part is just providing the resource. It's just a provider, nothing else. Okay. All right. So I think we covered a lot of thing here about this one. Let me see. Okay, so here when we launch the workspace, basically we are going into the Databricks from here. So it's like gateway. It's just a resource, and we are going when we launch the workspace. Yeah, we already launched, I think, and I'll again do this. Okay, and it will ask you for authentication. And now it is signing into the Databricks. So basically this URL is totally changed to Databricks. Okay, so we are out of basically Azure, console or, workspace, and we are into the Databricks now. So if you see here in the URL, azuredatabricks.net, and this is like identification of my account association with this. Okay, and yeah, so this URL represent that I am associated with this Azure, and this is the URL. So this is like the workspace for the Databricks, and now we are working in the Databricks. You can see the logo is changed here, and up to here it was like Azure. We were working on Azure, but here we are working on the Databricks. So yeah, this is the Databricks workspace here, and we are out of this. So these resources now, the question comes like, what is inside here? So these are like component related to Databricks. So it requires a storage account, so where it will keep the data, it will fetch the data and bring in and put it here. So that's what this Azure storage account is being used. So if you see the storage account, it automatically created and provided some numbers in the name, so it can identify, and it has created containers in it. So containers are like folders where it is going to keep the data related to Azure Databricks. Okay, so if I think I click on any container, it won't allow me to open. Yeah, so it fails. Why? Because these permissions of this container is being managed by Databricks Unity catalog. So it is having its own governing system. So it will not allow Azure user to go into and tamper with the data or change anything, because then Databricks will get corrupt or something, because it won't be able to find the system related data or something. So that's why it doesn't allow. So manage from the Azure, it will automatically be managing from itself. Okay, so like these are the services in storage account, and storage account is being managed by Databricks. So these are like supporting service, you can assume. And again, if you go to like virtual network and these things are being managed for Databricks. So you can see the address space, like this one, connected devices, if you have any, even subnets, you can see. So all networking components related to Databricks are being managed here. So we don't have to basically do anything here on the network component or any other component. We don't have to, work on this. So like this is the security group, and this will take care of the security part. So maybe I think we can go and view this, but we should not be able to change it because the permissions are being managed by Databricks. So like Databricks control plane, SSH port is open. So you can go to Databricks control plane by using SSH connectivity through this IP, the worker proxy and worker to worker. So these are like networking information related to Databricks, and these are like inbound rule related to Databricks. Again, on outbound security rules, you have these rules created, which are like default rules. No specific outbound rule is created here. Okay, and then maybe network interface or subnets with which these rules are associated. So these are the subnet with which these rules are associated. So this is like internal working of Azure Databricks and the components. Okay. All right. So I think we have covered a lot many things here about the Azure and Databricks. And now we'll talk about, let's see, so we have covered creation of the account. This we have covered using this one. Okay. Now we'll talk about, let's say, one concept which I want to talk maybe or take it. Yeah, calculator. Yeah, I just wanted to highlight this. So there is a very nice tool from Azure, which is called pricing calculator. Okay, so this is really very helpful. You can go to any resource type here. You can pick like analytics or anything you can pick, and you can, create a pricing for this. So let me just delete this Databricks I already created, but I'll show from the beginning. So in this pricing calculator, this is like without logging in, you can go to azure.microsoft.com and then pricing, I think. So this link is, publicly available. Without login, you can go here and see the pricing of, any resource. So I think it should fall under, yeah. So Databricks will fall under analytics, and these are like analytical tools available in Azure. So this many tools available in Azure, having different pricing. So if we click on Azure Databricks, it will open estimate for this one. I think it should be loading or loaded. Yes, loaded. So when I scroll down, it will aid my estimate. So I can see only one resource selected, Azure Databricks. And I can see here all purpose, this, this is basically coming from this, drop downs. So if I go and I say, okay, I created a resource in India, for example, issued India. I created Invest India, and I am going to use with the all purpose compute power. I'm going to use the standard tier, and I will use for general purpose and any instance. So instance I can pick from here, that I will be using 4 virtual CPUs, 16 GB of RAM, 100 GB temporary storage. It's going to be 0.75 Databricks unit. Means it's going to cost me $0.246 per hour. Okay, so if I'm going to use this, resource, it's going to cost me this much per hour. Okay, and if monthly estimate, if I see, it's going to be costing me $400 around. And with this, so I will be using, let's say, one virtual machine. It's going to cost me for 730 hours. So let's say if I am going to practice it for, let's say, 2 hours a day. So let's say if I'm going to practice it for 30 days, so it's going to be 60 hours. Okay. So now you see the pricing changing here. So let's say if I, practice for 60 hours, or maybe let's say 1 hour basis, then it's going to cost me something like this, I think it's not updating, looks like. One. Yeah. Okay, so this is going to have some fixed cost, looks like. Yeah, it should reflect different pricing. This is what I believe. But upfront cost is 0. But yeah, maybe minimum is 200 hours or $200 or something. But yeah, it's going to cost me in this way. Okay. Okay, and then I can reserve it. This is under the pay as you go plan, but in your case, it's going to be free only. But if I reserve it, let's say for 1 year or 3 years something, then I'm going to have a huge discount on this. Okay, this is how the pricing calculator works. And next is I just want to talk about Azure Databricks pricing here. So component perspective, it's going to have, I think here also we can maybe get some pricing information. Yeah. I'll start from top so you will not get confused. So we are exploring the pricing here for standard Central India. It's going to be United States dollar. per hour basis. So these are the feature when we talk about, standard tier pricing. For all purpose compute, we are going to have these features available. For job compute and for job light compute, these are the features which are going to be available. So this like compute power with different categories we can use. And here for premium tier features, so these are like features related to premium tier with the job compute, all purpose compute, and job light compute. And with the delta live tables, these are the feature with the advanced level. And here pay as you go, and here you will see like standard tier pricing. For all purpose compute, it's going to be almost $0.4 or dbu per hour, okay, or dbu hour basically. So $0.4 is going to cost basically, okay. If we are going with the premium tier, then it's going to cost 0.55, so little bit higher end, it's going to be. So different pricing for different uses, okay. But don't worry, practicing with the practicing, I think it's not going to cost you anything, because you have 14 days trial. You should create your account maybe with the trial one. But yes, in Azure, you should have pay as you go, upgrade. So pay as you go, you will have to do it on Azure, and then only it should be allowing you to create your free trial for Databricks. Okay. All right, so we have covered this also. Great. Now let's see. I just want to talk about data lake. Okay, so one concept in Azure Databricks is Azure Lakehouse. Yes.
One
Yes.
question. Come on. So
Yes.
as a developer, right? So are we going to set up the way like what you mentioned, right? A subscription, resource group, and workspace, then resource, right? The data bricks is the last part. So are we going to build this entire process? Why I'm saying right is as a informatica developer, I'm working on a informatica, right? As a developer, so I don't do all the setup on the server level configurations and everything. So are you saying the same thing, like the this is all about the configuration setup, and
No.
later the developer will be working on it, or developer has to do this entire process?
No. Developer has not to do this entire process, because your Azure admin will do this.
Right. So you are saying these are the steps we need to build to practice
Yeah, I mean, just to practice from your end. Yeah.
practice purpose. Like you are building everything like from the scratch.
Right. Right.
Everything your account and subscription, resource group, and then workspace, and then resource. So what we will be doing, we will be working. For example, if I am working on Databricks, I'll just get my resource group name and workspace name.
Right.
The
So let's say, for example, if you are working as Databricks consultant, or the person who is dealing with the Databricks,
Mhm.
you will be provided this URL from your Azure administrator. Simple.
Okay, that's great, right?
Yeah.
So okay, got it. I
So,
understand. Yeah, thank you.
so
Yeah.
what your Azure administrator will do is, you will means your company will say, okay, we have a workspace, please provide so and so guy. So what he will do, he will go here, he'll launch this workspace, he will find this URL, he will just give you this URL. So this is the URL, and he will say, okay, please your Azure account, login. That's it.
That's great. Okay, I
Yeah.
understand. Yeah, thank you.
Yeah. But in, I mean, let's say if you, get into a job where, someone is, let's say if you have to deal with the Azure a little bit, not in entirety, like setting up everything, but at least you should understand how it is working with the Azure. Like what is the resource group, like basic understanding, not detailed one, like basic understanding. You have like two resource, groups created for this. One is, if you on subscription level, if you don't understand anything, it's fine. But on the resource group level, at least you understand that, okay, when you are dealing with the Azure administrator, he is going to talk about your what to do with this, your Databricks account, or here we have this one, and here like you have this network security related stuff and storage account. So this is just for the information. You are not going to touch anything on this. You are going to work on this workspace only. But just to practice this one, how you can set up, you have to have a resource group. You have to have a resource created inside the resource group. That's it. Once you create, you will fall into this, workspace. And from here, you will be working.
Got it. Like you are saying, the person should know about like how exactly the subscription, how the resource group got, like on what resource group you are
Yes.
working. So that is how the
Basically,
person should
yes.
know about it. But it's not like you are
Yes.
not going to create all these steps. Okay,
Yes.
that's
Exactly. Exactly.
okay.
So let's say if I am a system administrator, I should know that how to log in into virtual machine. That's more than enough for me. I should not know that, okay, how to create a virtual machine or anything, but at least let's say I'm a Linux administrator. So I should know that how to operate with the Linux virtual machine. That's more than enough for me. But just for basic understanding, because the cloud is like part of everyone's life nowadays. So basic understanding is good to have. Okay. So that's what the objective. And when you are setting up your own, here, let's say you are practicing on the Databricks, then you have to have basic understanding to create this. So at least I would request every one of you to create this one, as we have seen today. It's easy to create. It's not difficult one. You just need to create one resource group. Whatever name maybe you can, put some name here, and you can start, you choose closest to your area, because you will be practicing on that, and create a, Databricks account. And if it is, if let's say having any problem, it's easy to delete as well. So let's say if I want to delete, let's say for example, I have created this. So it is not going to cost, or it's not going to, let's say, a month I have to keep. I can keep deleting and creating every day. Okay, that is also fine, means totally doable. So let's say, but if you are getting a free account, don't delete it, because anyway it's not going to cost you. But in my case, let's say if I just want to delete this, I close the workspace. I'll simply go to my resource group. So first resource group, this one, and this is the second resource group. I'll just go to resource group, and I will say, I just want to delete my resource group itself. So it will delete whatever inside of this resource group as well. Okay. So let's say if I delete this, I select the resource group name, and I hit delete. So it's deleting the entire resource group. Let's say if it fails or pass, because sometimes it will fail. So it will ask you to delete the dependencies. So it's really easy to create and easy to delete on the Azure. And one thing to keep in mind, that let's say if we are creating a resource and we are not having a setting to shut it down automatically, then it is going to cost you. So that will also I show you, because you will be, at least to practice, you will be managing, because Azure Databricks is free, but Azure resources will cost you. Like for example, if you are creating a virtual virtual machine to run your compute power, so that will be costing you. Okay, and that will not be a huge cost, but that will be certainly a little bit of cost. Here I think I can maybe go to pricing, and if I delete this estimate, if I go to compute virtual machine, yeah, edit, and here I can see, let's say for Central India or West India, WEST, West, where is India? Israel, India. So let's say West India. If it is going to be Linux based standard with maybe 16 GB minimum, right? So where is 16 GB? Almost 2 core, 4 core, it was 8 GB. Yeah, this one. Okay. So it's going to cost me 0.4, means $0.50 an hour almost. So if I keep running this without use, it's going to cost me. Okay, so that I have to be careful. So when I finish my lab, I should be, removing these resources which I'm not using. But in your case, you can keep it. I mean, if you turn it off, it will not cost you. Okay. So when I turn off, because it will be creating a compute power when you launch your workspace and will be using. Tomorrow we'll see, look into it, how it works. You shut down, it will not cost. It will cost you zero. But if you don't shut down, it will cost you some amount of money. Okay, it may take little while to delete this, but if it is failing, then I will show you another way to delete this. Just give me a moment here. Yeah, deleted, success. So let's go to resource group. Now you see your resource is deleted. Okay, means your Databricks workspace is deleted. Now you cannot log into your Databricks. I think what was the link? I removed it, but if I would try now, it's gone. It's not there. Okay, so it's gone. Now if I go to my second resource group, where is? Oh, okay, that's great. So what it did basically, it removed both the resource groups. I don't have, I deleted one resource group, but the second resource group was depending on the first one. So it deleted both the resource group. No resource group to display. Means I don't have any resource group. So I have no resource and resource group, and I can see it from going here and typing all resources. So basically, if I go here, I can see I have no resource inside. So in this situation where I have no resource and resource group, the Azure account is not costing me anything. If I keep it for 1 year also, it will cost me zero, because this is just empty account, nothing having in it. So I'm not using any resource. I'm not using any resource group, anything. So Azure will not charge me anything for this. Okay. So that's just explanation of Azure part. I think we have understood lot many things about Azure, and this is how you can save your cost. So at the end, you have to make sure that your virtual machine should not be running, and the settings when you are using for lab, you use the virtual machine, and it will automatically be, we can set it up, maybe turn off after 10 minutes or something. So it will automatically be turning it off, and it will not be costing us, and if in the storage account, if there is nothing, means let's say 1 or 2 files or something, it is going to cost you negligible, maybe $1 a year or something, so it's very minimal cost. Okay. All right, so I think we have discussed many things here, and tomorrow we'll discuss about the Lakehouse, means the storage part of the Databricks, and then we'll talk about the creation of notebook and all those things. So all right, okay, thank you everyone. All right, so today I was trying actually to create the Databricks account, but for some reason it failed. So it could happen. I hope you guys also were able to create your free trial account like we have practiced yesterday. So sometime it can fail also, and it can have some issues. So I show you here. For example, I try to create an account here, and it was in failed state. But now it looked like it has recovered, but I'm not sure about the resources which are created here. Let me see. 3 resources. I think one resource is missing. Some component is not being created, but we can try. So in the resource group, NICIT, I created one Databricks service. And when I go here, it is like failed. So the deployment was not complete on the Azure basically. So you can face this issue as well sometimes on depending on the reason, your account and all those things. So it could have, failure as well. Anyways, so we cannot use this workspace because it will not work anyways. So in that case, we simply have to go to our resource group and delete the resource group. It will delete all the dependencies and this Databricks workspace. So you just need to select your resource group, put it here and hit on delete, and it should clean it up. Maybe I will have to use another Azure account because on my Azure account, it was a failure of the deployment. So maybe you can see here in the deployment history, I believe it will show us the history of failures. Deployment, yeah, deployments. So it will show the history here. However, it is showing actual deployment successful. Today is 22. Let's refresh it. Yeah, let's see the last one. We can see the deployment history here. So it was talking about the resource group, not the resources. So you see that last deployment was about the resource group and all those things, but not about the resource. So, it can happen that it will not work sometimes. So let me see. You can even redeploy or try attempting new deployment as well. So that's fully possible. Okay, so we are removing our deployment from here, but I have sometime created one account in community edition. So you can also try. This is totally free, but it will have the limited options available. So you can use your private email address and create your own Databricks account on the community edition. So let me see, Azure, or you can simply call Databricks Community Edition. And you can sign in for this, and it will not charge you anything. Databricks, I think here somewhere we can find the detail also, but it is not for commercial use, so it is free of cost. It's totally free actually. Okay, so community edition, you can sign up, and there is documentation also available from Databricks. Okay, and you can use with which you will be using, maybe Azure, AWS, GCP, and all those you can select. And it will have the basic, login and all those things. All right, so today we'll talk about something on the theoretical part. The reason is our Databricks account is not ready. So tomorrow I will keep it ready with the Azure. So it should be working. All right, so today's concept we will cover is Apache Spark. So we'll understand about this concept with the Databricks, how it works, and what are the features we can use. So question is, what is Apache Spark? So Apache Spark is a distributed processing system. that help you to analyze large amount of data. Okay, and just give me a moment. I will just set up my screen. Okay, so it's a distributed processing system. So distributed means it can distribute the workload. Okay, and to analyze your large amount of data, like big data, you can call. It's a fast open source engine that's used for machine learning, AI, and big data applications. Okay, now let's see the feature of Apache Spark. It have the capability of processing in memory. Means it doesn't require a disk basically. So it will not be processing the data on the disk. If it is processing like Hadoop is processing in the disk, so it does use the storage actually to process the data. But in Apache Spark, the advantage why people move to Apache Spark is it process the data on in memory. The Spark keeps the data in memory for faster processing speeds, because if it is processing on the disk, it is going to take input output limitation is there. So in Mbps it will go, but in memory it is quite fast. Then the second feature in Apache Spark is built-in modules. So it has some built-in modules which are really helpful. So Spark has modules for SQL, streaming, ML, and graph processing. So these modules are helpful to process the data. Then next advantage here or the feature is that the programming languages. Spark has native buildings for Java, Scala, Python, and R. Okay, next is code reuse. So you can, it supports code reuse across multiple workloads. Scalability point of view, Spark is designed to scale for big data. And the flexibility, Spark is more flexible than Hadoop, which is primarily used for disk-heavy operations. Because if we have disk-heavy operations, we can, use the in-memory processing, and that is really making it fast. Okay. Now, what is the PySpark? Because when we learn about Spark or hear about the Spark, the next topic comes is what is the PySpark. So PySpark, like this symbol denotes here, the combination of Python. So this is the Python logo and this is the Spark. If we combine them together, it becomes PySpark. So PySpark is a Python API for Apache Spark that allows user to perform data processing and analytics using Python. Okay, so the Apache Spark is written in Scala programming language. PySpark has been released in October in order to support the collaboration of Apache Spark and Python. Okay, so this is like you can call APIs, Python APIs, which are being used with the Apache Spark. Okay, in addition, PySpark helps you interface with the resilient distributed dataset, RDDs, okay, and RDD in Spark and Python programming language. So this is one of use here. This has been achieved by taking advantage of py4j library. So they have created one library which will be helping to combine these both the features together. And py4j is popular library which is integrated with PySpark and allows Python to dynamically interface with the JVM objects. Okay. And what is the resilient distributed dataset? RDD is the fundamental data structure in Apache Spark. Okay. So this is you can see it is a data structure which is being used in the Apache Spark that allows for parallel processing, and it RDD helps us to process the data in parallel of data distributed across multiple nodes. So like when we call multiple nodes is talking about cluster. CULSTER. Okay, cluster, and RDD are fault tolerant and can recover from bugs and data loss. So this is the one of advantage of this data structure used by Apache Spark. Okay, then the features of PySpark. So PySpark supports many of Apache Spark features, including MLlib and DataFrames and Spark SQL. So these are the features which are supported by PySpark. In data processing, PySpark can perform real-time, large-scale data processing in distributed environment. Okay. And the next is data types. PySpark supports a variety of data formats, different sources, different format, including Python, R, Scala, and Java. So data structure, if we talk about data structure, PySpark uses data structure called DataFrame, which organizes data into two-dimensional format similar to a spreadsheet, like columns and rows. So it manages the data or organized data in a spreadsheet format. All right, so next is libraries. So we have understood that it uses this library, py4j library, allows the Python to interact with the JVM objects. Ease of use, if you see, PySpark combines the performance of Apache Spark because it's in-memory processing with the ease of using Python. Okay, applications, PySpark is used in many data engineering, data science, and ML applications. So these are the features or the uses of PySpark. Now let's understand what is the Databricks. So a Databricks is a unified open analytics platform for building, deploying, and sharing and maintaining enterprise-grade data. Okay. Then analytics and AI solutions. So it is used to manage or deploy enterprise-grade data, analytics, and AI solutions. The Databricks data intelligence platform integrates with the cloud storage and security in your cloud account. So regardless of your cloud account means you can work with the your cloud storage. If you are working with the Azure, you will be using the storage service. If you are working with the AWS, I think S3 you will be using. So like whatever the storage service available in your cloud platform, you can use with the Databricks. And security also is used with your cloud account and manage and deploy cloud infrastructure on your behalf. So basically it will be taken care by Databricks or it will be used by Databricks on your cloud account. So it will authorize the Databricks by tokens, and Databricks will be managing your storage and compute power from your cloud account. So what is Databricks used for? Databricks provide tools that help you connect with your sources of data to one platform to process, store, share, analyze, model, and monetize your data sets with solutions from business intelligence to generative AI. Okay, these are like core uses of Databricks, why we are using Databricks or why industry is using the Databricks. The Databricks workspace provide a unified interface and tools for most data tasks, including data processing, scheduling, and management, in particularly like ETL process, generating dashboards and visualization. We can generate dashboards out of these notebooks, which we'll be using. And we can also create visualization from the queries which we are using in the notebook. Okay, and next is managing security, governance, high availability, and disaster recovery. So here, these are some of the tools or features And then we can use data discovery, annotation, and exploration for that purpose. Then machine learning, modeling, tracking, and model serving, and generative AI solutions. So these are some of the common use for Databricks. Now let's understand the Databricks high-level architecture. Okay. So basically, Databricks is like prepared with the two planes, which is one is the control plane. Most of the like data analytics solutions have this architecture, so it's like pretty common. Like control plane is like control plane includes the backend services that Azure Databricks manage in your Azure Databricks account, the web application in the control plane, and the compute plane is where the actual data processing is happening. So compute plane is where your data is processed. There are two type of compute planes depending on compute that you are using. So first is serverless compute. The serverless compute resources run in serverless compute plane in your Azure Databricks. For classic Azure Databricks compute, the compute resource are in your Azure subscription. So like serverless compute is basically not running on the Azure one, but rather in the Azure Databricks, plane, like workspace we are creating. This is running there. But when we are talking about the classic one is basically you are creating a virtual computer in your Azure subscription. Okay. What is called classic compute plane, and this refers to the network in your Azure subscription and its resources. Okay. Now, if we understand about high-level architecture of Databricks here in this diagram, we can understand this like how the workspace system data, Databricks file system, and Unity catalog workspace work together. So here you can see in this diagram that when you create a Databricks account along with your cloud or Azure in our case, so how it is organized. So you can see your compute power is being provided from your Azure account, so the classic compute power, and your storage account is also created on the Azure. So this is like your cloud provider, either Azure or AWS or whatever else. So these resources are created on your cloud environment. And on your Databricks account, actually, you have control plane where it will be managing your Databricks web application. It will perform the compute orchestration. It will manage the permission using the Unity catalog. Unity catalog is like, it's like taking the control of, your cloud account and managing the permission for you. Queries and code will be performed here on the Databricks account. So these are like, these are the stuff which is happening on the control plane. And when you're talking about serverless compute plane, means the compute which is happening on without actual the virtual servers. So it's like service which is again happening on your Databricks. So this red dotted box represent that whatever happening on your Databricks account, and the blue one or the purple one is basically your cloud account. Okay. And your data resources like your databases or your on-premise data which is available maybe on the cloud or physical one will be dealing with your Databricks account. Then definitely the authentication and this thing in especially in Azure or Microsoft environment is taken care by Entra ID. So this is like on high level you can understand the Databricks architecture. Next thing is about the control plane. If we see what are the we have in database subscription. So Databricks cluster manager, basically a role or a service which is dealing with the Azure resource manager. So this part represent Azure, and this part is like Databricks. Okay. So here, if you see, we have Databricks user interface. We have Databricks cluster manager, which is the in charge of managing or creating, spinning off the virtual machines and all those things. With the help of definitely Azure Resource Manager. Azure Resource Manager is like core component which takes care of deployment of resources, and that will be instructing the Azure to create or remove the virtual machines from the cluster. Then we have a Databricks file system in Databricks control plane, which is the file system which is now about to deprecate, and I think it is deprecated and still it's being used, available in Databricks, but in future it will be deprecated. So Databricks file system is used to manage and it is having some Python libraries with this, which we will be using with the notebooks. And then definitely the cluster, which is being used with the Azure. Now, next is Azure Active Directory, which is used to authenticate. So it is like the previous one, it is the same diagram, but having like components in it. So in data plane, if you see in the customer subscription with Azure, what we are getting Databricks workspace created, as we have seen that when we create a Databricks in Azure, it show us the workspace created there. But actually it is, working on this, control plane. But this is like the representation here in the Azure. And we will be using Azure Blob Storage for storing the information which is being used by the Databricks. So permissions of the blob storage, virtual machines, workspace is taken care by Databricks basically. Next, in the cluster, so when we create the compute resource on the Azure or even AWS or any cloud platform, we have basically cluster modes available. So we can have single node cluster or multiple node cluster, and it can have access modes depending on the use. So it can be used for single user, shared, or no isolation shared. So a single or multi-node cluster is basically a multi-node cluster have one driver node. So when we talk about the cluster, we have one driver node, or you can call it like master node, and one more worker nodes. We can combine this role to one compute as well. Okay, so I think that is called the single node. They provide the ability to horizontally scale the cluster depending on your workload. Okay, these are the default type of clusters used for Spark job and are suitable for large workloads. So this automatically takes care of cluster expansion or scaling, and it can horizontally scale, means it will keep adding the nodes. So virtual machine 1 is running, and if there is more workload, then it will add another virtual machine. If there is one more requirement, so it will this is called horizontal scaling. Okay, now single node clusters have only one node basically, which is the driver node, and has no worker node. So basically it is playing both the roles here. When you run a job, the driver node act as both driver and worker node. Okay, is there are no worker nodes, single node clusters are not horizontally scalable. Basically, it is limited to one virtual machine, and it cannot be expanded or have multiple virtual machines. Okay, now we talk about access mode. So how many access modes are available? Let's see. Single user means single user access mode permits only one user to access. Okay, so when we create notebooks, we have notebooks, and we have access to that notebook, and it will be accessed by the one user who will create the notebook basically. Okay, the cluster and the cluster and supports for languages. So Python, SQL, Scala, and R is supported, and the notebook we will see as well. In the shared access mode, we have shared access, or it will allow multiple users to access the same notebook. So when we create the notebook, if it is shared one, multiple users can work on that notebook, or access that notebook, run that notebook, etc. It is only available in premium workspace and supports Python and SQL. Okay, so shared one will support Python and SQL. No isolation shared. Shared access with no isolation allows more than one user to access and collaborate. So this is a little bit advanced. The multiple users can work together on the same notebook. Okay, it is available in both standard and premium workspaces. Okay, supporting 4 languages. It supports Python, SQL, Scala, and R. And here, if you see for shared one, it support Python and SQL only. So these are like limitation here. So you have to keep in mind. The key distinction between the shared access and no isolation is that it doesn't provide process isolation. Okay. So this is only the difference we have between shared and no isolation. Okay. Now let's talk about Databricks runtime. So let's understand what is the Databricks runtime here. Databricks runtime is integrated and optimized runtime environment provided by Databricks. Okay, it includes Delta Lake. There is we will talk about this concept in coming video slides. So we have something called Delta Lake, pre-installed Java, and we have Scala, Python, R libraries, GPU support. So these are like called Databricks runtime, and which is integrated and optimized runtime environment basically. Okay, so it is provided by Databricks, and Delta Lake is like big concept. When we talk about Delta Lake, we will be talking about data Lakehouse. This is one concept, lake house. Okay, so this is relatively new concept in the Databricks. We'll talk about this. Let's understand in the cluster point of view, when we are creating the compute power, what are the feature available in that. So we can see first one is auto termination. So when we are creating the cluster or cluster resource, when we are using, it has a auto termination feature available. So I'll quickly show you as well. I think if I have here. So when we go to compute, here we should have somewhere. Let me see if I can edit it. So this is my free account basically, and it should also have auto termination feature somewhere. So basically, it will automatically turning off. So right now it is not running because it is terminated. So when I run, and after 10 minutes, if I'm not using it, it will be automatically turning off. So this is like when we are using this feature, it will automatically turn off your computer. So virtual machine or virtual resource will not cost you basically. So this is what the auto feature is here. I'll simply, okay. So this is what the auto termination here. Auto termination is useful feature that helps avoid unnecessary cost, because when your compute resource is running without use, it is even costing on the Azure platform. It automatically terminates the cluster after X minute, let's say 10 to 1000 minutes or something you can define. With the default value of 120 minutes, the auto termination range is starting from 10 minutes minimum to 1000 minutes. Auto scaling. So auto scaling in Azure Databricks automatically adjusts the number of workers and disk space to meet uh, the needs of your workload. So as you have like more and more processing requirement, when you are, let's say, running some data of terabytes or petabytes, then maybe it will automatically be increasing the number of virtual machines which will be performing or working parallel to, cater that demand. Databricks runtime versioning. So Databricks releases runtime version regularly, encompasses the long-term support LTS feature and major version. So it keep updating, and when we choose the runtime, it show us with the LTS. So this is the runtime updates or versions from Databricks. Databricks unit, or what is this is what the concept when we are being charged on Databricks. So Databricks unit is DBU. It is called DBU is a unit of measurement for processing power on Databricks Lakehouse platform. So this is like processing power on the Lakehouse platform, which we will understand in coming slides. So the Lakehouse basically provides us the ETL process. Okay, so the whatever processing is being consumed here by the Lakehouse is charged in DBUs. It's used to calculate total amount of compute resource such as CPU, memory, and input-output used to run the workload on Databricks. So basically, the Databricks platform will charge us on the DBUs, and this is like unit. I think we have seen it yesterday as well on the calculator, I believe. Let me see. Azure, or I will say Databricks calculator. DBUs, I believe. Yeah, Azure Databricks pricing. On this, you will see like we have compute power. We can select from drop down, and still it is loading in the background, looks like. Yeah. Okay, so here you can see with the premium tier, still drop down is not working, and pricing, it is going to show in per hour basis. And these are like features available, which we have seen yesterday as well. And these are DBUs per hour. So like $0.4 DBU per hour. Okay. So like premium tier, we have different DBUs for different job compute or compute power. So commonly used is all-purpose compute, which is around $0.4 to $0.55 per hour. Okay. And this is on pay-as-you-go account, means when you have basically when you create the Azure account, you will start with the free trial, and then you will have to update it to pay-as-you-go. And these are the reviews for different purpose. But if you reserve your instance for 1 year or something, you will get some Databricks commit units, and the prices are here. So $12,000 around 4% discount you will get on this. So this is like commitment from the organization, like 3-year commitment, pre-purchase plan. So these are like huge amount here. Okay. So let's go back. I'll minimize this. So when we talk about DBUs, DBU is a unit of measurement for processing power on Databricks Lakehouse platform. It's used to calculate the total amount of compute resources such as CPU, memory, and I/O used to run the workload. Now let's see what are the policy on the cluster. So when we create the cluster, what are the policies here, and what are the type of cluster or size of cluster available? So we have like memory optimized cluster available, compute optimized custom cluster, storage optimized, general purpose, and GPU accelerated. So generally we use the general purpose cluster types. So these are like for common use when we run the notebooks or experiment with something. But let's say if we have, huge demand of memory one, then we can go for this one. But this will be happening on your actually, organization's account only, where let's say they have large amount of data set where they want to, process in memory, then the memory optimize or compute optimize. If this is living, let's say having a lot of computational power needed, then maybe you can go for this storage or GPU related also you can go. As long as cluster policy is, concerned or having, policy related to cluster, is the first one is unrestricted, means compute is scalable, and the flexible compute option that allows you to provision and manage clusters without any predefined limits. Okay, so this is like one cluster policy where if you are not having huge amount of data and it's not going to overrun with your cost, then maybe you can use this where you don't have any predefined limits. But there is another one cluster policy, which is the like personal compute, which is the default policy in Azure Databricks that allow users to create single machine, basically compute resources with their own use. So this is for individual use only. Power use compute also available, which is power user compute policy in Azure Databricks allow user to create large multi-node resources for single user workloads. So user is single, but the compute is available in multi-node. Okay, so this is called power user compute. Okay, that require more compute resource than the personal compute. So this is like upgradation of this one. Then shared compute. So Azure Databricks shared compute is a cost-effective option for running Databricks workloads. It provides a pool of shared resources that can be used by multiple user or application. So shared compute is where you have multi-user environment, and the same compute power, maybe let's say if we have this cluster of 2 computers or compute power, and let's say we have 3 users, so let's say if this user is using this compute power, and this user can use the same compute power, and so it can be scheduled separately, so they can use the same compute power, means each of the user can make run their queries and all those things, but it is managing it is being used by these all people or scheduled different times or something like this. So shared resources, you can see. Next is Databricks Workspace. So now we are talking about the workspace of Databricks. What are the component of Databricks? So the workspace is an environment basically for accessing all your Databricks assets. It organizes objects like notebook, libraries, dashboards, experiments into folders and provide access to data objects and computational resources. So this is called the workspace, which having notebook, folder, library, and ML flow. So what is the notebook? Notebook is a web-based interface to documents that contain runnable commands. So notebook is nothing but a document where you can write your commands and run your commands. So you can write your command and run your commands. You can visualize your charts, or it can prepare based on the result on the commands. You can view the charts, and you can write like narrative text and all those things. So this is the use of notebook. Then what is in the folder? It's used to maintain grouping and hierarchy. So we can create folder and organize our notebooks or data and all those things. Then next is the library, a package of code available to the notebook or job running on your cluster. So if either we are running a job or we are running a notebook, it might require some library. It's like plugin sort of thing where you can use the libraries along with your notebook. Databricks runtime include many libraries, and you can add your own as well. So these libraries will work with your notebook. Then next object is ML flow. And ML flow is the collection of ML flow runs for training a machine learning model. Okay, so this is called ML flow here. Next is Azure Databricks Workspace assets. So we have understood or largely talked about clusters, what we have in the cluster. So it will provide the unified platform, various use cases like running the production ETL pipeline, streaming analytics, ad hoc analytics, machine learning. A cluster is type of Databricks compute resource. So we have gone through this. Notebook also we have understood. Notebook is web-based interface to documents containing a series of runnable cells. There are multiple commands you can run on one notebook that operates on files and tables, visualizations and narrative text. Also, commands can be run in sequence one by one, referring to the output of one or more previously run commands. So you have cells basically in notebook. So let's say if we are running one command here, then the result is we are using here, and we are running the second command, then we are using the third cell, and so it's like cell by cell, and we can run command by command. Now, next concept is jobs. Jobs are one mechanism for running code in Databricks. The other mechanism is notebooks. So basically, job is like you can schedule the job, you can combine the multiple notebooks in the job and run together. And then the libraries we have talked about. So this is like third-party libraries, locally built-in code available to use by notebook basically. And you can use this with your notebook and cluster. So this is called libraries. And then next is the data. Data, you can import data into distributed file system mounted into Databricks Workspace and work with it in Databricks notebooks. Okay. So let's say if we are uploading a CSV file or any data we are bringing into the data plane of or Databricks Workspace, we can use along with the notebook and cluster and process this data. You can also use a wide variety of Apache Spark data sources to access the data. So either we can use Apache Spark data sources, or we can upload the data into DBFS, for example, and we can use this. Next is files. In Databricks runtime 11.3 LTS long-term support and above, you can create and use arbitrary files in Databricks Workspace. Files can be any type of file, like common example, like py file, md file, csv file, txt file, log files. So these sort of files you can create in Databricks, and which will be called files in the Databricks Workspace. Next is next type of asset basically in the Databricks is like Git folders. You can also have Git folders and Gits. You can use the code here. So Git folders, Databricks folder, those content are co-versioned together by syncing them to a remote Git repository. Okay. And using Databricks Git folders, you can develop notebooks in Databricks and use a remote Git repository for collaboration and version control. So basically, the idea is like if multiple developers working together, they can use the Git repository as a distributed version control system, and they can develop the code and upload to the remote Git repository and share it with each other. Okay. And they can collaborate, maybe they can change the code, they can maintain the version history of the their code or notebooks and all those things. Next is models. So model refers to model registered in ML flow, model registry basically. So this is they call ML flow model registry model. Model registry is a centralized model store that enables you to manage the full life cycle of ML flow models. It provides chronological model lineage, and model versioning, stage transitions, and model version annotations and descriptions. So we'll talk about this when we go to So we are talking about Git folder, models, experiment, queries, dashboard, and alerts. These are some of the component in the Databricks workspace. So as we progresses with the this course, we will be going through this and talking in more detail. So we'll look into it, like queries are SQL statements, dashboards. We can create the visualizations combined in the dashboard. Also, we can have alerts and notification with the query and thresholds. Okay, and next is Databricks file system, or this is anyways going to be deprecated in future, but it is still being used. So we'll talk about this in briefly. Let me just see. All right, so should have pen tool. Okay, Databricks file system, or DBFS, is the distributed file system mounted into Databricks or Azure Databricks workspace and available on Azure Databricks clusters. DBFS is an abstraction on top of scalable object storage. So basically, it's like database or what you call Databricks file system, which works with the your data. So it's like it is like a file system which is working with your meta store, and it's like middleman in the between of this both. And when we have the DBFS we use, we can use the location where we can keep our data file and data sets and the results which we are generating using on this. So we'll go through this on the notebook and it will make more sense. So here we'll talk about this. These are some Databricks utilities which we can use with the DBFS. And these are utilities which are basically the Python utilities. And this is where that's why when we started this course, we said we don't have to learn entire Python. We just need to learn the DB utilities or utilities being used by the Python, and that will help us to understand the the process, entire process. All right, so most of this thing we have already covered here. So the core concept, I think we have covered in the slides. Now, one concept which is left is a data lakehouse. So let's talk about what is the data lakehouse. Okay. So we have heard like data warehouse. Maybe this term is very common. You guys are from the data background, so you can understand data warehouse, and probably you may have heard the data lakes as well. But this is something new, the lake house. Basically, this term is created using these both together. So the combination of these both is basically the lake house, or data lake house. All right, so let's go here and understand the data warehouse. Data warehouse, basically, we have data available and we can use this data for ETL process, and it lands into data warehouse. And from this data warehouse, we can create some outputs. And what are the pros of using data warehouse? That we can use it in the BI analytics, and the data is structured and clean data. Basically this is structured, like we in the I think first session we talked about structured, and unstructured, and also semi-structured, I think. Okay, so these three type of data we discuss about. So data is structured means it is arranged in rows and columns, so it's easy to analyze. And here structured data is clean, basically because it is having the acid properties where you have integrity and all those things. And it is having a predefined schema. So in this case, we can use data warehouse and data warehouse can easily produce the result. What are the negative points of data warehouse? What are the cons? There is no support for semi or unstructured data. So we cannot deal with the data which is not structured in this case. So data warehouse case, we are not able to produce anything meaningful out of this or ETL process if we are having a data which is unstructured or semi-structured. This is useful when we have the structured data only. Inflexible schemas. So if we are dealing with the inflexible schemas, we cannot work with this process of data warehouse, and we can struggle with the volume and velocity upticks. So when we have large amount of data, this process really gets very slow to analyze, and it does take a lot of time to perform. Long processing time compared to other processes. So this is time consuming to analyze the data. Okay. Next is data lake. So we covered data warehouse. Now next concept is data lake. Data lake is flexible data storage basically, and it supports the streaming data as well. It is efficient basically in the cloud. So you can simply create a storage account. So when we talk about Azure storage account, or maybe S3 in AWS, so we can use them as a data lake. Okay, and we can use to store, let's say, structured, semi-structured, or unstructured data. It could be audio files, videos, pictures, or anything. So binaries, we can use all this kind of data with the data lake. It supports for AI and ML as well. So the same data, we can use it for AI and ML. Now, what are the cons here? There is no transactional support. So these data are unstructured, so we cannot have the support of transactions, or we cannot have ACID properties here. And then poor data reliability, we cannot have reliable because there is no fixed schema with them. And slow analysis performance and data governance concerns. So managing the security or accessibility of data is difficult. Data warehouses is still needed. So for structured data or the data which is having the schema for ETL process, we require data warehouses. Even we do have data lakes, but if we are processing structured and unstructured data, then we require data warehouses. Okay, so what are the challenges here? The challenge is like complex technology stack. So a combination of data lakes and warehouses. We have, work with the both. We have, so one end for, unstructured and semi-structured data, we will be using data lakes. For structured, we will be using data warehouses. And then both the data we cannot combine. So these are working in silos. There is high cost and complexity because two different solutions we will be going with. And then the emergence of data lake houses. So this is to meet this challenge, the data lake house is introduced basically. Okay, because we were having these challenges because we were using data warehouses, we were using data lakes for unstructured and semi-structured. We were using the warehouses for structured one. So to meet this complexity or challenges, they introduced something called Lakehouse, and it combines the benefit of lakes or data lakes and warehouses together. And it supports the diverse data types and workloads, means it supports all kind of data, which is structured, semi-structured, and unstructured. Features like transaction support and governance also here. So let's see. The business required two disparate incompatible data platforms. So this was the challenge when we were using data lake. So data lake was being used separately, and data warehouse is used separately. and these both or two solutions are going in parallel. Okay, and these are disjoint, so these are not connected, having different silos. And here this data is used for data streaming and data science and ML purpose, and the data with having table structure, access control list, and all those things are used with the SQL analytics and business intelligence. So these are like disconnected model. Okay, now the solution is data lakehouse. This is what they come up with. Okay, so with the basically Databricks, we are using data lakehouse. Okay, let me just, okay. So data lakehouse is a data management system that combines the benefit of data lake and data warehouse. So this is what the advantage here we have. A data lakehouse provides scalable storage and processing capabilities for modern organizations that want to avoid isolated systems. So basically, we are combining these both the system data lake and data warehouse together in data lakehouse. System for processing different workloads, so we can process any of these workload, maybe the structured, non-structured, semi-structured, and also it can be used with the ML, BI, and these processes. Data lakehouse can help establish single source of truth, eliminate a redundant cost because it's combined both the solution in one, and ensure data is fresh or freshness of data. Now, if we talk about data lakehouse, often use data design patterns, incrementally improves, enriches, and refine data as move through the layers of staging and transformation. So from here, we'll talk maybe in detail, or this is like, Databricks solution in terms of data, how it is performed. So we may have different data sources, maybe structured pictures or semi-structured codes, binaries, any kind of object. By default, it will be changing it to data table, and data table can further be transformed to another type of data tables. And then finally, it will be useful for the results, and we can produce some outputs from that. Okay, so this is like, and the Unity catalog basically is like governance. So it will take care of your security stuff here. Okay, so Unity catalog is going to take care of security, and this is how the data is being transformed, and multiple data sources being used. So this is like simple diagram, and this is the diagram for data lakehouse. Okay, where you combine the data warehouse and data lakehouse together, and you reach to this scenario here, which is called delta lake. Okay, so basically, if you see in this diagram here, you can see that your data warehouse and your what do you call, unstructured data or data lake is combined in delta lake basically. So this is like additional layer which you are preparing between data, and then you can perform your ETL process. You can combine all of your outputs together and make some insights. So this is what we are doing here with the help of delta lake. And delta lake you assume is additional layer in lakehouse system. Okay, so lakehouse is the combination of warehouse plus data lake. All right, so that's it for today. Bye bye, take care. Okay, so yesterday we faced the issue with the connecting or creating the workspace or Databricks. It didn't work, but yesterday I tried again and I figured out the problem. Anyway, we knew the problem was related to quota or processing quota with the Azure. So I'll show you that what was exact the issue. You may also face this issue in future. So depending on the subscription you have, you may have this issue. So for that, you will have to go to the subscription in Azure, and you will have to select your subscription. Under subscription, you will go to settings, and under settings, you will find this location, which is uses plus quotas. Okay, and where you are planning to take your workspace, or you want to create your resource, in that region you will have to go and check for the quota. So here it shows Australia Central right now, but we are looking for some location in India. So I'll uncheck this. I'll type South India, and I'll tick for this. I'll search for this location. And now my region is here. So I can see the total regional virtual CPUs my account supposed to create is up to 10 core only. So above 10 core, if I go, it will not allow me to create the resource. So this is like my maximum limitation for this region. In this region, I am supposed to create this much only. Some region I have exhausted my quota, so maybe I can, ask them to adjust it or change it for us, and we can request new quota. Okay. So this is like limitation, or a feature in Azure, which may hold you to or throw error always when you create your resource or Databricks account. Okay, so you may also encounter this issue, so you have to be careful. All right, so this once you increase the quota or you request the quota, maybe they will take 24 hours to increase your limit, and then you can create your virtual CPUs, because in compute power, the CPUs will be or the processing will be handled by Azure. Okay, so this is what it was causing the issue yesterday, and after having a look into it, I was able to create this account. So I created a resource group. I'll go to resource group in Azure, and I created a resource group named Databricks. And in that resource, I created a Databricks workspace. So it's a same like service we have. Once we click on this, we can launch it. From here, we can launch the Databricks. I have already launched this one here. So it is open in the next tab. Okay, so it will open in a new tab only. So this is how we can reach it up to here. Okay, so now we are on this workspace. This is a premium account, means having full feature. Definitely it will be costing, but yeah, it's a premium account because I already exhausted my free tier here. So I don't have any free one, but if you are, subscribing to this, you will get 14 days free tier where you will be able to use all the features. Okay, so once we are in Databricks or Azure Databricks, we can say. So in this, we have the workspace. So I'll just show here, maybe. Let me just go. Okay, so in workspace, you will be able to just hold on. I cannot see so okay, little bit screen issue. No problem. So yeah. So we will understand about the interface here. So when we create the workspace or Databricks account, here we will see the home page, or this is our workspace like. So it is like each user who logs in will get this workspace. So with your email account, you will get your workspace. Okay, because I used with my subscription email and Microsoft email, which is provided when I created the Azure account. That's why it's long email, so it's like default one. So here, when you join any organization, you will get your workspace with your email account. Okay. And once we have this, we click on this. So this is our home page. And in workspace, you will find that you have your common workspace, or the workspace which is shared with everyone. So your organization may have shared workspace, and you will see all the shared resources here. So let's say you have common notebooks or any document or anything which will be displayed here. Okay. Also, if you have GitHub repos, you can see the repos from here. So your GitHub repos, you can view it from here. Then this is the users, means this is your personal workspace. Here you can view your own workspace from here. So this is your personal workspace. Basically, this is the same thing. If you click on this, it will take you to this one only. So this is the same thing. And this is a repo, legacy one, and the trash and favorite. So this is like orientation of your workspace. In the workspace, you would be able to create, a new notebook. So we'll understand about the notebook in detail. Let's see, for example, if I want to create a notebook here, I can go to my workspace, and I can create, or click on this create one. And by create, I can maybe organize my resources or objects in folder, Git folder, query, alert, dashboard, notebook, ML flow, experiment, files. I can manage all those things. So let's say if I am creating a notebook, I can simply click on the notebook and it will create a notebook. So we'll understand about the notebook first, and then we will talk about this. So let me see if. So notebook is basically a document which is composed of cells and these things. So we'll simply create a notebook and see. Okay, so this is like your notebook. This is the title of your notebook, and this is the like default language of your notebook. So you can change your title as well. Let's say not book -1. So like this, you can change the title of your notebook, and here it will give you the 4 options: Python, SQL, Scala, and R. So by default, whatever the default setting you have, it will pick your language of your notebook, and you can simply switching in between, you can change your default language of the notebook. So that's also doable. Now about notebook cells. So notebook is constructed or made up of cells here. So this is called a cell basically. This is a cell. We can add more cells like this. So cell 1, cell 2, cell 3. You have multiple cells like this. Each if one notebook contain multiple cells. So when you go to, let's say, your workspace, and you will see on your home page your notebook which is you have created. So from here you may be able to clone it, rename it, move to trash, all those things you can do with your notebook. Once you click on the notebook, it will open your notebook, and it will show you whatever the last modification you have done. So all the modification, it will show. Let's say we created 3 cells, so 3 cells are displayed here. You don't have to manually save it. Each time you create something, it will automatically be saving it for you. Okay, and notebook contains a collection of 2 type of cells. So this is like code cell, you can see, but we can have another type of cell as well, which is called markdown cell. So if I click on this text, so when I hover over, I can see on the top of the notebook, on top of the each cell, I can see a button which is like code and text. So everywhere I will see this choice. Okay, so let's say if I would like to have a text written here between these two cells. So for example, if I write on top, let's say I include markdown cell. So markdown code I can write, like say I can include image, header, bullet list. So this is the cell which is not writing the code basically. It's just text or sort of detail what is written below or something like this. So you can say, let's say I'm putting requirements here. So it is basically displaying it here on preview. I can hide this preview or show this preview here. So let's say if I am making it header 1, okay, so it will change the preview style. It will show like this. When I hide this, it will not show, but it will, when you change the cell, it will show like this. So this is like H1, that's why it is showing large. You can simply change it. So requirements, okay. Let's say if H2 I want to make, I can make it to H2 and it will show something like this. Okay, I think it's additionally adding this one. So I can simply select this, let's say heading 3 or heading 2, something like this, and it will show you like this. So this is the markdown one, where you can have multiple markdown one. Let's say this cell we are going to write about requirements. This cell maybe we are going to let's say query it. Okay, so you can simply type this and mention it. So you can organize your code with this one, and this may be here you would like to fetch the result or something. Okay, so this is how you can organize your cells. Okay, so this is the two type of cells, and if we look into the top bar or icons here, we can it's like we can create new notebook, we can import a notebook, we can add a dashboard to notebook, and we can clone it, rename it, export it, move it. So all these common tasks related to file we can do. And here, like we have in a Word document, as we manage the same thing, almost identical thing. We can perform any activity like cut cells, copy cell, paste cell, delete cell. So shortcuts also, I think, same. We can use this, and we can insert the cell above, cell below, where our cursor is. So basically, this cell is active. So whatever action we are taking here is going to be performed above this. We can move cell down, select all cell. We can format the cells and format notebook and all those things we can do. So these are some like common here. Then we can play around with the view menu here, where we can change the layout. So right now this layout is centered one. I can make it full width as well. So like it's consuming all the space on the side as well. So let's say if I go to centered layout, it is little bit less, having little bit of a space here. So that is the center one. Then we have cell layout. So each cell we may have layout. So standard right now it is the standard layout. If we just want to see the result, we can make it to the result one. So you will see that cells are not having anything except whatever the results we are going to have, it will show the results only. And then we have side by side, means one side it will show the query. If we have written something, it will show one end, and another end it will show the result. So side by side view also, like this, we have like requirement written here and code written here, like markdown you can see. So side by side, it will show the query and result. Okay. So this is the cell layout here. We'll keep it standard for time being. Next thing is we can see here the workspace theme. We can change because this is system default theme right now. We can change it to light one. So let's say light one will be like white, fully normal one. Second is like dark theme. We can intentionally make it dark. And whatever system preferred, we can simply change it to system preferred as well. So this is the like system one. So it is taking from system. So next is, okay, so this is what we have here. And here we see all the codes which we have written here. We can run everything together, or we have another choice where we can run it individually. So let's say if I just want to run one cell, so I can just click on this play button and I can run one cell and I can see the result for one cell. Even I can run it for the selected text, means wherever text is selected. Run all above means all the cells above this. So let's say if we are on the third or second cell here and we click here, so we will be running the first cell and second cell. Okay, so like this we can have multiple cells we can run together, and run all below also option available. So we want to run below cells, then also we can perform it. So these are some run related options on the cell. Next here, it will show you all the edit history from here, and this is also run and debug, run all, select above, below, all these clear cell outputs. We can perform these run activities. And here, if we see, we can see that whatever edit we are going through, it is maintain the history. So we can see multiple version when we have done what. So it will like keep a record of this. And I think we can restore it as well, and we can save the latest version or previous version, we can restore to, etc. We can do all the changes, we can see and view it here. All right, so this is like version history here. Next is run all, we have covered, and next one is connect here. So basically when we create a new account, we will we have the compute resource, which is like a resource available on Azure. We can run that resource. So I have created a cluster here. So if I go to, maybe I can go from here as well. So let's say if I click on this one, so it will start my cluster basically. So from here it will start costing me, right? So when I start my cluster, means it is going to start my virtual machine, which is going to run the code. Okay, so this may take time, but this resource I can find from here. So my notebook will be running on this resource. If I go to compute, in compute I can see that my resource is starting, and I created this personal compute. Okay, so when it is restart, or when it starts basically, my notebook will be able to run. Without compute resource, it will not be running. And if I go to my Azure, and if I go to my subscription here, and if I go to my uses quotas, now you see I have some resource in South India, which is having the green bar. Means I'm consuming some resource here, and my limit is changing. So you see 40% means 4 core of my this virtual CPU. is used. So if I have multi-node environment, maybe I have, let's say, multiple resource if I want, then I will have to increase, definitely I will have to increase the quota. Let's say if I have 4 core of, maybe more than 10, if it is going, then I will have to request it more. Otherwise, it will not allow to create more. So when our compute resource was not working, then this was available to use. But when we started our computer resource, it started, consuming the, limit. So this is what it's showing, that your, limit is now 40% utilized. I hope, yeah, now still it is starting. So our compute resource is starting. Meanwhile, it is starting, we can go to our compute resource and see that what the consumption or what is the configuration of our compute resource. So in configuration, you can see we have one driver which will be acting as master and driver both. Okay, and here this will use 14 GB of memory and 4 cores are being utilized. So out of these 10 cores, we are consuming here 4 cores. Okay, so 4 cores are being consumed. That's why 40% utilization. Okay. And this is the policies which we have used to create this resource. We have used personal compute. We have different choices here. So we may have, shared one and all those things. So also we can add from here. So let's say if I create another compute resource, I'll just open this one. So I can have like different policy I can use. I can use maybe unrestricted, means a lot of workers. So this is going to be, let's say, 2 to 8 workers and the driver. So it's going to consume 32 to 128 GB memory, 8 to 32 cores, and one driver it's going to consume 16 GB of memory and 4 cores. So this much resource I can allocate here, and it can be for a single user or it can be for multiple, means shared user. So here a single user means it can be used by one user. Shared means everyone can share it, and no isolation. Shared means all languages we can have. So I can, if in single user, I can choose my user who is going to use it. Share, definitely everyone is going to use it. Okay, so single I'll just keep. I'm not going to create it. I'm just showing you the screen. So here it will show that which runtime you would like to use. So certainly we should not go for the beta version. We should go for LTS, long-term support only. So we can, whatever the latest LTS available, we should go for that. Use photon acceleration. So this is one of the feature available in this cluster, so which we can use. We'll discuss about this more. And here, like we can see, like I can have 2 worker node and a number of maximum workers. I can minimum and maximum workers I can add or make it, and accordingly it will change. So here you will see the dbu per hour, means the cost per hour is going to change depending on the resource requirement we are going to have. And the driver type which we are going to have, maybe we may have different configuration also for driver and worker, which we can make it. Okay, we can enable it auto scaling. If we are disabling it, it is not going to auto scale. So if you see here in this area, when I disable this, I am stick to one fixed number of worker node. Okay, but if I enable it, it will vary between 2 to 8. So whatever number we can change it. Next here option is spot instances, means if we would like, we are looking for a discounted instance of the resource or compute power from Azure. So Azure has some scheme called spot instance, means you can claim for discounted one, or let's say if they have some free resource, they will allocate it for you with the less price basically. If you have reserved in instance or instance which is available, generally we can go for this for testing purpose. But if we have discounted, we may have some price concession. So this is what here. And yeah, driver we have, okay, and here terminate after. So in termination here, what we can do is basically, let's say we are running our instance of a cluster, and we would like to stop it after some time. So let's say if I'm running my notebook right now, and after I finish running my notebook, I want to terminate it because it will be costing me while it is running, right? So I should automatically be stopping it. So you can define this number could be between 10 to 43 200 minutes. So minimum is 10. So when you run this notebook, you require 10 minutes to stop it. Okay, so like I just ran the notebook, I just ran the cluster. So uh, automatically it will be stopping after 10 minutes if I'm not using it. Okay. Let me see. Okay, so let's go ahead, and next thing is, yeah, tags. We can provide some key value tags like in Azure we have. So tags are like same thing. And we may have some advanced options. We can look into logging, Spark, init script, and all those things. We don't have to generally touch this. Okay. So this is about, creating a compute power. I will just cancel it and let's see what compute power we have. So our compute power is ready. Now you can see the green dot, my cluster is running. Okay. And this is like 14 GB active memory, 4 cores, and this is going to be the cost here. So we may have multiple clusters, maybe for same user or maybe shared, and we can use this cluster to run our notebook. Okay, so right now it is running. So if I go to my workspace, I go to my notebook. In my notebook, I will see the green dot here and which cluster is available to run. So I may have multiple choice here. I can change the cluster, and depending on my requirement, I can run it for this. Next button is schedule. I think, yeah, schedule one. So we can schedule this notebook to run on a specific time and this thing. So if I want this notebook to run every day or every hour or every week, I can schedule it as a job. So it will become a job for me, or it will be automated for us that it will be running on a specific time. Okay, so every day, hour, week is available. We can, and automatically it will trigger the cluster, which it's supposed to use. So the cluster will invoke, cluster will start, notebook task, whatever task we have mentioned are going to run. And that after 10 minutes, if we put the logic here for 10 minutes, then automatically after 10 minutes, the cluster will stop. Okay, so this process we can automate here. And if we wish to have a notification on that, so let's say I would like to receive an email when if the cluster fails to start, or maybe some error occurs, then I want to receive a notification, then I can mention the email here and check the failure. Let's say if I want to add another notification, maybe for a different reason, let's say for success or start, then also I can mention this like this. I can keep adding. Okay, so multiple notifications I can configure. So these are like notifications, and if I want to define any key value parameters, so I can mention it here, add the parameter as well. So same way like notification. So we are not creating it, we are just viewing it. So we'll cancel it. Okay. Let's click somewhere. Okay. So now you can share your notebook with someone you want to share. So all these users are available. Basically, the users with whom you want to share will be coming from the enter ID. So let's say if I want to, I think I have one user called database, or I think I have DB admin. Why data? Let me see what's the user I have. So I will go to Azure and I'll type here enter ID. I'll open the enter ID. This is the directory to manage our users. So I'll go here, go to users. And I have a user called database admin. We'll try to search it there, and we have some of other users. So I'll go to Databricks. Yeah, I go to database admin. It should have given me the option here, but for some reason it's not coming. Email, new user, copy link, and manage. Permissions are configured here, but I am not sure. Right now it is showing. So let me reopen it maybe. Share, and again we can type data base admin. So I think we'll have to look into it, because yesterday I tried and it was working, but today it's not working for some reason. So we'll have to check. But these users, these will be coming from the enter ID only, where we have seen from the enter ID we can create this, and we can have this in the organizations. So we can pick this user and we can add this user, share this notebook with this user. Okay, so this is about share, and here on this side we have like comments. We can write the comment about our code. Okay, so whatever the code we are writing, let's say if I am writing something here, I can write the comment on this code. So I think there is also this button. I can create comment from here as well, and I can write the comment, okay, related to this code. So for example, if I have another code here, I can simply select this, click on the create comment, and I can write. If it is shared, then multiple users will be able to write this comment, and they should be able to edit it, delete it, and make change. So you can see what is happening with the code. Maybe you are working with the shared environment, so you can deal with this information which is available, and the comment is this. Then next is let me just go open comments, ML flow. So here, I think this is the ML flow. You can run your experiment and these things. So on notebook, no runs yet. So ML flow, when we talk about an ML flow, we'll go through this. Then here it will show your version history. So as you are, progressing, you are making some changes, it will show you the changes here. Okay, in this version history. And this is about the variable in Python language. If you are having any variable associated with this, notebook, you will be able to view it here automatically. And then you will see the Python libraries which are associated with this notebook. Okay. And lastly, you have some environment related information, what environment we are running in, and little bit of serverless compute only. So this will apply to serverless compute only. Okay, so we understood about creating cells. Let me just go through what we have here. Okay, now next thing is, let's close this. So in cell, we can have basically title written here, or basically if we start from here, these are the actions we can take with this cell. So let's say I want to copy this cell or cut this cell, add this cell above, or add a cell above or below, move it up, down, format Python, add a title. So basically, if I click on add a title, I can write a title with this cell. So this is, let's say I'm writing a cell, for example, cell 1 dash title. So I can add a title to each cell which I have created individually. So it will display it here. Further, yeah, here we have title. So on this menu, I can add or hide a title. So let's say if I hide a title, it will not display the title here. Title can be for internal reference as well. Okay, we can collapse cell. So if we collapse the cell, it should not show you the code. You can, hide the code as well, like this. Okay, and you can hide the title, you can expand the cell, and you can expand the code as well. So code. Okay. Next is you can clear the output. Once your cell is running, you will get the output below that cell. So you can, hide the result or clear the output as well. Copy link to the cell. Basically, it will provide you the cell link in the clipboard. And if I go to my notepad, it will be like this. So it is my ID here dot Databricks Azure Databricks.net. So this is my link. In that hash and notebook, under notebook, this is the notebook which we are talking here, and this is the command, and this is particular cell. So this is like cell address you can see over the internet. Okay, so it's like entire URL of this cell. Okay, so you can share directly this URL, and that user is having permission on this notebook, they can directly jump to this cell and look into the code and all those things. Okay, I think we have covered everything. We can export the cell, we can delete the cell, and all those things we can also perform here. And yeah, this next button is like a focus mode. So if I want to work on this particular cell and it is having multiple lines, in that case, I can, make it big, and it's like full screen mode. So if I do have multiple lines, I can, have this cell in full view mode. And if I make it small again, it will show something like boxed ones. Okay, and that's why sometime I need to collapse the cell, so it will show like this. So now it is collapsed mode. If I go for expand cell, it will show consume the space here, and even I can hide the code. So only this will show the title of the cell and some buttons, but it will like hide this. Okay, so collapse cell, show code, and it will start showing the code. And also you would notice, I think where it was, I will also have to look into it. Let me see. Yeah, so this one is basically assistance, toggle assistance. So you can click on this and it will assist you for the code. So let's say you want to see command history or command or any object or any assistance you want, like say DB utils, for example, generate, and it will say that, okay, remove this code and put this one. Okay, if I accept it, it will help me to write my code basically. Okay, I think there is FS function and these things we look into. So we can, this one is like handy assistance. It will provide if you forget the command or you want a help on the command, something like this. And this is like the, your language which is being used with the this cell. but you can simply change this language as well by using the percentage, let's say SQL, I think, and it will change the language. So if you see, if I write percentage SQL, it is changing the language to SQL. And maybe in the next cell, let's say if I delete this, for example, and next cell, for example, using the Python, first cell using SQL, another cell using some another thing. So all the languages we can use. So let's say if I just want to change it to Python. So the default is Python. So that's why it's jumping to Python. If it is not, then I can say Python, I think, and it will change to Python. Okay. So this is how we can change it. All right. So next is so we have delete cell button also available. We can simply delete this cell and it will be removed from here. So if I click on delete, it will simply delete the title cell or whatever cell we have. Language selector we have seen already. So this is like language selector. Yeah, cell focus we have seen. Let me see what else we have related to cell. Delete cell we have seen. Moving cell is easy. So let's say if I put the title here, for example, this is like cell 1. I just put the title. And let's say if this is the cell 2, and this is, for example, cell 3. Okay, so we have 3 cells here, and we can simply drag and drop these cells like this and move. So sequence we can change anytime. Okay, we can simply, drag and drop wherever we want to keep whatever cell, we can do that. So it's on the notebook, it's easy to drag and drop and cut and paste cell. So you can easily cut and paste cell as well. I think this is little bit large. So yeah, let's say if I want to copy this cell, okay, and I think paste, I'm not sure how it's going to work in edit. I think it's going to paste the cell, something like this. So Control V. So it will paste the cell like this, or you can do this. So same like Word file, we can, easily, and Control X, Control V, and all those things will work. Okay, so yeah, code, anywhere if we are writing any code, for example, let me make it be a little bit big. So let's say if we have code line 1, code line 2, code line 3, for example, then we will be, simply selecting it, any line of code, and we can, create a comment around it. So we can, simply select that line and, we can put the comment for that line of code and it will highlight. So when we click on this comment, it highlights that line. So it will, let's say, if I am here and if I click on this name, so I put this specific comment for this line of code. Or maybe I can put, let's say, select this one and put the comment. So this is like comment for line 3. I can add comments. So when someone goes there, it will highlight this line of code. So each comment I can delete these comments as well. Edit these comments, delete these comments. This is like comment 1, basically. Okay, it's cell to a dashboard. We can also add a cell to dashboard. That is also doable. So if I select my this cell, I should be able to add this to my dashboard where it is.
Kamal, I have a question. So
Yes.
what I just want to ask one question. So
yes,
what exactly you are going to do here in notebook? So
see, notebook is like work area where you are going to write the line of codes. So all the code which we are going to, write in the Databricks is going to be on the notebook only. So notebook is like place where you can, let's say if I want to import some libraries, then I want to query some data, okay, and then I want to, fetch, organize the result, okay, then I want to create the graph. So these are like steps you can understand by cells are like, acting as a steps, and notebook is like, you can have, different kind of data set. You would like to run different kind of queries on that. So these are like query files. You can largely you can assume as a query files. Okay, so notebook is the only place where you are going to work and schedule your job around. So this is like core thing for the Databricks. Is that making sense?
So,
Okay.
okay, I can fetch the data
Mm-hmm.
and I can see what I understand, right? Like
Mm-hmm.
Informatica is a ETL tool, right? I'm a
Mm-hmm.
background of Informatica. So
Okay.
Informatica is extracting the data and do the transformation and loads the data into somewhere. It's
Okay.
just like a GUI
Right.
concept, right?
Right.
So Databricks, like we
Mm-hmm.
have a notebook
Mm-hmm.
and we have a different kind of like fetching the data, doing the
Right.
transformation,
Right.
and do the scheduling in one
Yes.
place. Is
Mm-hmm.
that right?
Yes, correct.
So, so in one notebook, we can do all these steps.
Yes, all these steps you can do. Even you can visualize the data. So let me just show you something. Yeah, let me just open one thing. I think yeah, Databricks notebook. I'll just So here, see what we can do here. Introduction to Databricks notebooks. So let me go here. Notebook are a common tool in data science and ML for developing code and presenting the result. So we are developing the code here and presenting the results as well. In Azure Databricks, notebook are the primary tool for creating data science and ML workflows and collaborating with the colleagues. So basically like comments, all those things, with the colleagues we are performing on the notebook itself. Databricks notebooks provide real-time, co-authoring in multiple languages, automatic versioning, and built-in data visualization. So we have built-in data visualization as well in the notebooks. Okay. With Azure Databricks notebook, what you can do? Basically, you can develop the code using Python, SQL, Scala, and R. Customize your environment with the libraries. So you can fetch in different libraries in notebook. You can create regularly scheduled jobs. So basically, like we have seen that we can schedule a notebook itself. So let's say if I have to fetch the data in the evening and create some output of it, I can do using the notebook, right? So every evening this job will be performed. It will fetch the data. It will manipulate whatever transformation we are looking for, and it will do so. And we can have multiple notebooks for each type of job. Okay. Browse and access tables and volumes. So we can browse and access tables and volume, export result and notebooks in HTML and IPY, NB format. Use a Git-based repository to store your notebooks in. So we can also, store our notebook in GitHub or, Git-based repository. So it's like, we are developing the notebook, refining it, we are placing it somewhere, we are maintaining the version control, all those things we can do. Build and share the dashboard. So we can use the notebook. So let's say we have 5 to 10 notebooks, which are bringing this different aspect of different data, maybe from social media, from, databases, different data warehouses. So we are combining this into a dashboard, and that dashboard can show you the visualizations. Okay, so that also we can do. Open or run a Delta Live tables pipeline, so we can have sort of pipelines created with the Delta Live where we can do like use advanced editing capabilities. Also, we can do exploratory data analysis. So these are some of the aspect of Databricks notebook. So Databricks notebook is basically the place where developer is going to work heavily. Okay, so this is like single place. We will be writing the code. We will be fetching transforming all the information and running our code. So and it will support, it supports multiple languages. We can bring in the libraries and all those things. So this is like use of notebook. Okay. Let's see in notebook here. So basically what we need with the notebook is, so here you can see our, cluster is terminated because we passed the 10 minute and we didn't use it. So it automatically stopped. So this is a good feature in the compute where you can, stop and it will not cost you continuously. Okay, and now next thing, so I explained about the compute also. And compute, we can create the compute. What are the limitations? I showed you on the Azure as well, that how we can, have a compute, and compute can have some limitation, how we can extend it. So from here, we can start our cluster manually, or we can start a cluster from the notebook as well. So last time we started from notebook. Maybe we can start from here as well. We can clone the same cluster if we want, one more created for different. So cluster, you can assume that, let's say we have 10 notebooks in our environment, and some of the notebook are being used by one of our colleague. We can maybe use some particular cluster for that. So the costing point of view, we can have, charges divided that for particular job, or maybe we may have multiple clients scenario. So if we are using the notebooks for different, different client, different sources, and we can create the multiple clusters, because when cluster will cost you only when it is running. If it is not running, it is not going to cost you anyways. So you can have multiple clusters, and whenever the notebook is invoked, it will be using a particular cluster to run that notebook. And this is how you can separate the resource requirement. Okay. All right. So, and also you can edit the permission of your, cluster here. So let's see, I can manage this, cluster because I am owner. Someone maybe, can restart, or, these are like permission you can attach. So these are like permission we can grant to the clusters from here. Okay. And cluster, I showed you like how to create the cluster, what are the parameters, what are the, type of cluster we can create. So we can choose the cluster. There are different, shared one is like common cluster, which can be used among multiple users. And there is power user compute also. So it's like configurations, different configuration for your cluster. Okay, next thing, so we understood about notebook. Notebook largely we have covered, but notebook, if our notebook is in our, home, then it is not shared with other users. So when other user log in to their account, they will not be able to view my notebook. Okay. To make it visible to other users, I should have this notebook in the shared one. This shared folder is like common playground for everyone. And you can have, let's say, this shared location, so it will be visible to whoever log into this workspace. So I can even create a folder in it to manage this. So let's say folder or client folder. For example, if we have multiple client, maybe we would like to arrange the notebook for client wise. So let's say client one notebooks we are going to keep here. So it's like folder, normal way we can assume as a folder. So yeah, client one notebooks. Same way we can have another folder for client two. Okay, so this is how we can organize our notebooks. So in shared one, it will be visible to everyone whoever using our Databricks account. Okay. And user one are like personal. So you can basically the idea is that you can create your own notebook, and when notebook is acceptable, shareable, then you can maybe drag and drop it to, let's say, okay, I develop this for this one, I can drag and drop it. Now it is visible to my colleagues. So my notebook is visible to my colleagues. Same way I can create multiple notebooks for different purposes. Let's say I'm creating a marketing dashboard and I have several notebooks created and one dashboard created, something like this. So I can put them or organize them in a folder. Okay. So this is how we can, have multiple notebooks. We can even create a notebook directly. So let's say this is a notebook one, and let's say another notebook. So by default, it will give you an untitled. So you can have like notebook two, for example, and you can set the default language for your notebook. So whenever your cell is created, that is going to pick the default language from here. Okay. So let's see what happened. So if I go to my workspace again, shared, client one. So you can see I have two notebooks. Okay. So different notebook for different purpose, and default language for notebook I can change from the top. So it's going to pick whatever language I choose. So we have Python, so it is picking it the Python one, but we can change it to whatever language. All right, so this is all about notebook workspace. I'll take if you have any question related to it, and then we will next session we'll run some commands, see how we can perform the activities on the notebook, and it will be more meaningful because today we are able to have this conceptual but it was practical, so you understood the layout and all those things. I hope you guys already maybe you using community edition or your own trial one, so you can explore this area, notebook and compute maybe you can create one and check how it works. And if I mean you are not certain or sure, you can delete it and recreate it again also. So you can practice on this. You can run your compute. You can see in your notebook that how it shows. So let's say you can create some scenario here like clients or folders, and then you can maybe go to your notebook and see how the things are arranged. So once you are familiar with the interface, it will be easy. So here you will be able to see like your cluster, which cluster is being used with this notebook, and if it is active or terminated, and all those, how schedule, how sharing, all those things are working. So I hope notebook area is almost clear, and some more things are here. So we will discuss that how it shows the table of content on all those things. So we can discuss it in next session. We'll understand it more. But largely this is how the notebook, and notebook is like core thing, because anything you are performing on Databricks, you will be going through the notebook only. There is no other way that other than notebook you can deal with the data. So mostly you will be spending your time, if you are Databricks engineer and working with the Databricks, notebook is like core concept and core thing. And largely these are like interface related, whatever options available we have explored, and this is how you will be working in your day-to-day life. All right, so that's it for today. If any question, anything you would like to ask, or if you are facing creating your your account, any problem if you're facing, or if you haven't started, maybe you would like to see it again or something, you can tell me. So, how many of you have already created the account? I mean, Azure at least. I believe Azure is easy to sign up. So should have, signed up for Azure. If not, please do it so you can at least, have understanding of Azure as well, and at least basic conceptual, ideas, because interview point of view, you will have to prepare, even you are not managing the Azure. But when you say I'm working with this technology, I'm familiar with that, then at least, on high level, you should have understanding of these things like resource group, important here to understand how the resource group will be, managing the resources related to your Databricks. So what are the resources will be used, like managed identity, storage account, and all those things, virtual network. So these are like some of the resources you will have to at least have, fundamental understanding of these, and then the workspace and all those things. So I hope you have created this, and if not, what you can do, if you are not sure about the costing part and this thing, you can create and delete it as well. So uh, I have deleted it multiple times. So finally, I created one, and I will keep it available. Thanks for joining, and we'll conclude this session. Bye bye. So today's topic is, we have already covered the compute, we have covered the workspace part. Today we are going to discuss about the catalog part. Okay. So what are catalogs in Azure Databricks? We'll understand about that, and then we will practically view that how catalogs are being arranged in Databricks. So a catalog is the primary unit of data organization in Azure Databricks. Unity catalog. So basically, Unity catalog is like governance system. Okay, data governance model. This article gives an overview of catalog. So let's understand in the Unity catalog how this is arranged. Catalogs are the first layer in Unity catalog, 3-level namespace. So when we refer to any document, any table or anything, we will first have to type the catalog name, then the name of a schema, and then the table. Okay, so they contain schemas, which in turn can contain table, view, volume, and model. So inside the schema, we may have these 4 type of items, okay, and even functions. Catalogs are registered in Unity catalog meta store. So we may have, when we create the account, we have one meta store, but we can create more meta store as well. So meta store is like the top level storage, hierarchy. So if you see in this diagram, here on the top level, we have one meta store. Meta store is having the catalog inside. Inside the catalog, we have schemas, and under the schema, we may have table, view, volume, and function. So these 4 type of objects we have inside this. So this is how it is arranged. And how should I organize my data into the catalog? So what is the reason we need catalog, and how we can organize? So when you design your data governance model, you should give careful thought to the catalogs that you create as the highest level in your organization's data governance model. Each catalog should represent a logical unit of data isolation and a logical category of data access. So why we are creating the catalogs, like same in the DBMS system, database management system, we are creating the databases to isolate the data from each other, right? So same way we have catalogs to isolate isolate data from each other, and these are considered as logical units. So it allows an efficient hierarchy of grants to flow down to schemas. So basically, we can manage the permission on catalog level, then we can manage the permission on schema level, and then we can manage the permission on data object, which could be, let's say, table or volume and these things. So we can manage the permission on these hierarchy. Catalogs, therefore, often mirror organizational units or software development lifecycle scopes. So if we have, let's say, a particular catalog, maybe this can represent a organization's unit if we are dealing with multiple data sets or multiple source of data. In that case, we can organize these data into the catalogs. You might choose, for example, to have catalog for production data. In case like this is one of the example that you may create a catalog which will take care of production data and a catalog for development data. So you can separate, or logically you can separate these both kind of datas using the catalog. Or catalog for non-customer data and one for sensitive customer data. So these are some of the example where we can use the catalog to segregate this data or separate this data from each other. Next is data isolation using catalogs, how we can obtain the data isolation. Each catalog typically has its own managed storage location. So it basically creates its own container inside the Azure account. If we are using Azure account and along with the Databricks, but it will be managed by Unity, catalog in the Databricks. The permissions, etc., is being managed by that. To store managed tables and volumes, providing physical data isolation at the catalog level. Okay, so this is how basically data is arranged. You can also choose to store data at the meta store level. Meta store is the topmost level. Okay, so for example, this is like meta store. You can create the multiple meta store. So one segregation you can do on the catalog level. Let's say if you want to separate the data and their access, maybe you can create different catalog of one for production, one for let's say non-production, and then you may have one client uh, whose data is stored in one meta store, and maybe another client you may create another meta store. So like this you can also arrange. Okay, providing a default storage location for catalogs that don't have a managed storage location of their own. So default storage location can be used to host multiple data stores. You can add storage at the schema level for more granular data isolation. So even you can add storage for schema level, a separate storage, so it will isolate the data from each other. Because Azure Databricks account has one meta store per region. So the meta store is basically created for regional basis. Let's say I created my account in South India data center. So it has created the meta store for South India region. But if I want one more region, then I can create another meta store where I can host it in maybe Central India or something like that. So depending on the requirement, we can choose it. Catalogs are inherently isolated by region. So these are separate by if they are hosted in different region. So these are isolated from each other. So we'll talk about the object and physical separation of storage as well. Now let's talk about catalog level, privileges. I think before that, maybe we can, let me see what I have open. Yeah, so before we move ahead, I think we will just talk about this topic. So let's understand, because again and again we are hearing about the Unity catalog. So let's understand what is this. So the first we talked about the catalog. Okay, so catalog is like this hierarchy, and Unity catalog is like governing system over that. Okay, so let's see what exactly it is, how it is being defined. So overview of Unity catalog. Unity catalog provides centralized access control. So it's like access control system, you can assume. It is used for auditing, lineage, and data discovery capabilities across Azure Databricks workspace. So earlier they used to manage without Unity catalog. Then later on they unified it and started managing with the Unity catalog. So what is the difference in the diagram we can see? Databricks Workspace used to have its own user management, meta store, and compute power. So it was the architecture without Unity catalog. So each workspace was having its own meta store, compute, and user management. So user management here different and here different. But after having the Unity catalog, user management is centralized and meta store is also centralized. And let's say if we are working in multiple workspace, their compute are separate, but their management, user management, meta store management is unified. So this is what the Unity catalog is doing. So what are the key features? We'll look into it. Just give me a moment. Okay, so key feature of Unity catalog includes define once, secure everywhere. So because this is centralized location, we can define one place and single place to administer all the policies and all those things for all the workspaces. So it unifies that. Standard compliant security model. So a Unity catalog also security model is based on the standard NC SQL and allows administrator to grant permissions in their existing data lake using familiar syntax at the level of catalogs, schema, or maybe we can call it database, tables, views. So it is compliant with the SQL and SQL compliant, we can say, and it provides permissions on the catalog level, schema level, table level, view level, etc. Next is built-in auditing and lineage. So Unity catalog automatically captures user level audit logs that record access to your data. Okay, so it's like for auditing purpose, that who is accessing our data, who has the access of our data, and all those logs are being collected. So this is one of the job of Unity catalog. Unity catalog also capture lineage data and that tracks how data assets are created and used across all languages. So like keeping all the record related to data, related to user activity, etc. In data discovery, Unity catalog lets you take and document data assets and provides a search interface to help data consumer find their data. So basically this is data discovery. Then next is system tables. So this is public preview feature. This is like new feature. So whenever we see preview, basically this is new feature. Unity catalog lets you easily access and query data accounts, operational data, including audit logs, billable uses, and lineage. So these are like some of the key feature of Unity catalog. And sometimes these are important to remember for interview purposes. Otherwise on practical, on hands-on, it is not that much used. So the Unity catalog object model, we have already seen this. So this is the same. Now let's understand the concept of a meta store, which is on the top level. Okay, so the meta store is the top level container. Basically, you can assume that this is a container for storing the data for metadata in Unity catalog. So basically, it will keep all the metadata on the top level. Here, it registers the metadata about data and AI assets and the permissions that govern access to them. So managing the permission, metadata of AI assets and data assets are being held on the top level on Unity catalog, which is called the meta store. For workspace to use Unity catalog, it must have a Unity catalog meta store attached. So when we are working with the workspace, okay, so workspace will have its own meta store attached, And this is how, so data is being fetched from here to the notebooks, and that is being referred to this meta store, and we can fetch this data from maybe different table, views, volumes, or functions. So this is how we can access, and it should be associated with the workspace. You should have one meta store for each region. Okay, so because regionally these are separately created, so for each region we have to have a meta store in which you have workspace. Typically, a meta store is created automatically when you create a Azure Databricks workspace in a region for the first time. For some older accounts, an account admin must create a meta store and assign it. So earlier it was manual process, but now it is fully automated. Okay. So before we move ahead, I think we'll just talked enough theoretical part. So I'll just go through here. Let me, I think this I'll keep here, no problem.
I have one question, Kamal.
Yes, please.
So I have like 5 workspaces. Can I store it in different regions or one region?
Yes, in the different region, you can create the meta store and you can store the data appropriately or accordingly. Okay, so this is basically the workspace here. When we see, like, I have 2 workspace. Actually, I deleted this, but it's not gone from the Databricks. It's gone from the Azure part. I cannot see this workspace, but still it shows here. And it was created in Central India, if you see, and this is created in South India. So this is how the data is being managed. So when we create the account, we create or choose the location for that account, and that location is the default location for workspace as well as the data which we are storing. Okay, so let's understand about the catalog. So we'll go to, I think I opened somewhere catalog. So I have opened basically multiple tabs, but you can simply, right click and open it in new tab. So this is how I am doing. So in catalog, if I log into my, account, and if I choose my workspace here, which is the single most usually. So here we can see on this pane catalog. So this is about the storage here. And when we create our workspace, by default, it creates, catalog for us, or meta store and then catalog. So this is like catalog. If I click on this, I can see that about this catalog, this is the owner. So owner is like, service principal. It's like ID. And then it is having schemas in it. So it has 2 schemas, if you see. One schema is like default, second is like information schema. It's like being used by system. So here, if I expand it, I can see these schemas. And when I click on the schema, I can see, let's click on the schema like this. So I can see here, like, I can keep under the schema, I can keep tables, I can keep volumes, I can keep models, and I can keep functions. So these like 4 kind of, database objects we can say, or data objects we can say, which we can keep here. So let's expand it. So for example, underscore 1000. Okay, so this is the overview of my table, and I hope my internet is stable. It gives me warning here. All right, so about this table, we can see the name, sorry, name of owner, data source. So it becomes a data table basically, and popularity means the usage, etc. We can see the composition of the columns basically here. We can see, I will make it little small. So yeah, like data types and all those things, like what columns we do have in this. So we can see like this. And here we can see sample of data. I think, yeah, sample data is not available without active SQL warehouse. So when we run it, it will show. We have to start the compute power. And this is the detail about this table, which is stored. So this is actually the storage location. If we, let's say, if we can make it collapse it, maybe, yeah. So here you can see this is Azure Databricks, a file system where Unity catalog and the storage is the top level location. Under this, these are the IDs, and under catalogs, this is like catalog ID, and then under tables, this is the ID for this table. So this is like full address of this. These are some of the properties here, and when it was created and all those things. Okay, so then next tab here, permissions are managed related to this table. So I can grant the permissions here. I can apply, modify, select, and these permissions, these are, we can apply the tag by using this. We can modify, so add, delete, modify data. So these we can manage the permission. And here we will be using the user account, so where we would like to provide the permission. Okay, so this is on the table level. Basically we are talking about here this table only. So same way we have volumes, and under volume we can create multiple volumes. So like I have created one volume here, volume 1. So in this volume we can have some CSV files or files stored. So these are like tables, and volumes we have seen. So like this we may have more objects created. Okay, so this is like overview here. Let's go back to here. Okay, so I think we covered this. Yeah, now we'll talk about the catalog level privileges. So let's understand how the permissions are being arranged around these catalogs. Okay. So because grants on any Unity catalog object are inherited by children, so when we grant the permission on catalog level, it will be inherited to the child objects here. Owning catalog or having broad privileges on catalog is very powerful. For example, catalog owners have all the privileges on the catalog and the objects in the catalog. So because it's owner, so it's like full power or full permissions, and they can grant access to any object in the catalog. Users with the select option on a catalog can read any table in the catalog. Okay, so this is like read only permission when we choose the select. So I'll quickly jump to the another one here. So this is my catalog. If I go to permissions, okay, and if I grant here, I have like use catalog permission. I have like select, it should be execute is there, use schema is there, create models and all those things. So it is having like this. So select permission is there. Okay, so these are different permissions. So this is what we are talking. Let's jump back what was there. So select is like read only on the any table in the catalog we can do. And the users with the create table on catalog can create a table in any schema in the catalog. So if we have create table, if we are giving, then the user can create a table anywhere in any schema on this entire what do you call so here we can have connect to this, and all the schema we can use. Okay,
Kamal, one question.
yeah.
These catalog level permissions will be given by the admin, or the individual owner can do that? No, right?
Individual owner can do, because owner has the right to provide the permissions, because that's the owner of that
So
object.
we can create our own tables and we can provide the permissions to user, or
Yeah, you can create your own table, but if you are having, create table schema, then you are allowed to create the table only, not to allow the, permissions. So you should be the owner of catalog level.
that's what, like as a developer, like the person will have a catalog level access to
Yes.
create, like to give permissions to individuals
Yes,
within the
yes,
team. Okay.
yes. Okay. So like select permission will allow you, so when you provide the select, then they will be able to select or conduct the select statement on the table level. So they will be able to read the data from there. If we provide, let's say, create table permission, means they will be able to create the table in the anywhere in any schema in the catalog. Okay. So these are like permission on the catalog level. That's why this is saying that these are permissions which are available in the catalog level. If we go and we talk about schema level, there are different privileges. If we talk about the object level, then these are a little bit different. So this is how it is arranged. So these 3 layers of privileges. Okay, to enforce the principal list privilege where user have the minimum access, they need to perform their required tasks. Typically, you can grant them access only to the specific objects or level in the hierarchy that the user requires. So we may have different objects, maybe some user, let's say, working with the marketing data, and they should not be working with the, let's say, operational data or something like that. So we can separate these in different schemas, and we can provide the permission on the schema level. So this is how we can separate or segregate the permissions. But catalog level privileges let the catalog owner manage what lower level object owners can grant. Okay, so here basically catalog, on catalog level privileges, the catalog owner is like decision maker, that he or she should allow further down the line someone to manage the permission or no. So maybe he can grant or give them the access that they can allow someone else to have permission. So object owner they can become. Even if a user is granted access to low level data object like table, for example, that user cannot access that table unless they also have permission or they have the use catalog privilege on the catalog level. So this is like one thing, that when we are talking about the catalog level privilege, at least they should have use catalog privilege. If it is not there and we are directly giving them the access to the table level, it is not going to work. This is what it says, that on catalog level, you have to have a permission use catalog. I think we have seen it here. So when we go to catalog level, we go to permissions, and if we click on grant, then this permission is needed to do anything on this catalog basically. So then later on you can provide the permission on maybe table level or something. So when we say that use catalog, it covers everything. Okay, and then you are allowed to give the permission. But if, let's say, whatever the permission configured related to that user on, and let's say any table or any volume or anything else, and if we just remove this, simply it will remove all the permissions, because ultimately the user will not be able to use anything on this catalog. This is how it is being arranged here. Okay, so I think ownership and this we may understand more about it, but yeah, let's understand on the catalog type. So what type of catalogs are available? We'll understand about this. When you create a catalog, you are given 2 options. Basically, we have 2 options when we are creating a catalog. The standard catalog, first type of catalog, the typical catalog used is the primary unit to organize your data objects in Unity catalog. This is the catalog type that is discussed in this article. So basically, this catalog is basically created with the account, and this is like the data which is being managed inside of or by using the storage for Databricks account. So it's like we are ingesting the data into Databricks, and then we are using this data. Okay. So I think other tools, Hadoop, and they have this kind of solutions where you have to ingest the data first, and then only you can analyze it. So these are some of the limitation with the other system, where if they are not able to ingest it, they cannot directly work with the data. But in Databricks, we have another concept which is called foreign catalog. Okay. So a Unity catalog object that is used only in Lakehouse Federation scenarios. A foreign catalog mirrors a database in an external data system, enabling you to perform read-only queries. So basically, we are not ingesting here, the data or data sets, etc. We are, performing let's say, having the permission to perform read-only queries on whatever database system we do have. So this is called foreign catalog, and on the data system in your Azure Databricks workspace. Okay. So we can understand about the Lakehouse Federation. So I think I have opened it somewhere. Yeah. So let's understand what is the Lakehouse Federation. Okay. Lakehouse Federation Query Federation platform. So this is a query federation platform that enables you to use Azure Databricks to run queries against multiple external data sources. So we can federate with the external data sources, and we can run the query on that. So this is what the use of this Lakehouse Federation. Okay. It also describes how to set up Lakehouse Federation connections and create foreign catalogs in your Unity catalog meta store. So here in this article, we understand that how we can do this, how we can connect with the, or federation connection we can create. So let's understand what is the Lakehouse Federation. Lakehouse Federation is a query federation platform for Azure Databricks. The term query federation describes a collection of features that enable users and systems to run queries against multiple data sources without needing to migrate old data to unified system. So let's say we are using maybe 3 to 4 different sources. We don't have to migrate everything to a Unity catalog or the Azure Databricks and then manipulate it or maybe use it. But here we can, without migrating it, we can use the read-only access with this data system, and we can query it there itself. Azure Databricks uses Unity Catalog to manage query federation. You configure read-only connections to popular database solutions using drivers that are included on the Pro SQL warehouses, serverless SQL warehouses, and Databricks runtime clusters. Okay, so basically we can deal with the popular database systems. We will see ahead as well. Unity Catalog's data governance and data lineage tool ensure that data access is managed and audited for all federated queries made by the user in Azure Databricks workspace. So still we have connection with the external data here, but the logs and all those things will be managed here because the platform is being used and user is running on the same platform, using the same platform. The data is residing outside of the platform, but still all the logs are being maintained. So why to use Lakehouse Federation? We may use it for multiple purposes. Maybe the data Lakehouse emphasizes on central storage of data to reduce data redundancy and isolation. Your organization might have numerous data systems in production, and you might want to query data in connected systems for number of reasons. So what could be the reason? Maybe we want to create some ad hoc basis reporting. Another reason may be that a proof of concept work, or the exploratory phase of new ETL pipeline or reports supporting workloads during incremental migration. So this could be the reason where we would like to federate with the Lakehouse. In each of these scenario, query federation gets you insights faster because you can, query the data in place. So we are not migrating data, we are querying the data in place and avoid complex and time-consuming ETL processing. So like extract, transform, and load is not required here. We can use the existing resources. Let's say if we have DBMS that is running on some platform, we can use the platform, query the data there, and we can use the result in Databricks. Lakehouse federation is meant for use case when you don't want to ingest data. So we are avoiding to ingest huge amount of data on our Databricks environment. You want your queries to take advantage of compute. So here, what is the advantage? That we are using the existing compute power of what the DBMS we are using. So external database system, we are running the query on them itself. You want the advantage of Unity catalog interfaces and data governance. So data governance we are managing in the Unity catalog. So we are not configuring or we're not providing the access to our users, the data engineers, to database systems. Rather, we are just managing their permissions using the governance system available in Databricks. So includes a fine-grained access control and data lineage and search. So these are some of the use cases. Overview of Lakehouse federation setup. So to make the data set available for read-only query using Lakehouse federation, you create the following. What we need to do to now federation, we understood what is the federation and all those things. But what is required to do this? So we'll require a connection, a secureable object in Unity catalog that specify a path and credentials for accessing external database system. So first we have to have a connection in place. Okay. Next is a foreign catalog, a secureable object in Unity catalog that mirrors a database in an external data system. Okay. Enabling you to perform read-only queries. So these are the two requirements we have to do this Lakehouse federation. And what are the supported data sources we may have here? Is like for Lakehouse federation supports the connection to following database types. So we may use MySQL, Postgres, Amazon Redshift, Salesforce, Snowflake, and Microsoft SQL, Azure Synapse, Google BigQuery, and Databricks. So these are some of the connections we can use. So now for connection requirement, what we need, we have to have a workspace enabled for Unity catalog, which is by default nowadays it's enabled. So the older system it's talking about when the Unity catalog was not there. Then
One
the
question.
compute, yeah.
So is Databricks can connect to on-prem applications or on-prem systems?
No, on-prem it will not connect. For that, we will have to ingest to the cloud solution, and from there we can, use it.
So if the data is in Oracle on-prem system, so we have to ingest the data into cloud system first, and then from there we have to pick it up.
Right.
Okay, thank you. Yep.
So what are the compute requirements we can have? Here is the network connectivity from your compute resources or target database system. So and the next is, let's say, but if you have public connectivity on-prem also, you can, ingest this data. Means you can use the federation. So as long as you can reach to your database system, you can, establish the federation. So you don't have to ingest in that case. Next is, let's say, Azure Databricks compute must use Databricks runtime. So this should have, this is one of the requirement when we create Databricks, it should use this one. So it should not be the older one, because in that the Unity catalog was not there. And you should have, shared or single user access mode. Then SQL warehouses must be pro or serverless and must have this or above. So this is like version requirement for compute. Permissions, what are the permissions required to create a connection? You must be a Metastore admin or user with the create connection privilege on the Unity catalog meta store attached to the workspace. So this is like basic requirements here to create the foreign catalog. So this is about the connection. Then the second step we are going to take is to create foreign catalog. You must have the create catalog permission on the meta store, and either owner of the connection have the foreign catalog privilege on the connection. So these are like some permission related requirement. Create a connection. So how we'll create connection? A connection is specified path to external database system. To create connection, you can use Catalog Explorer, the create connection SQL command. So these are the two ways. First is Catalog Explorer. Second is create connection SQL command. Also you can use in Azure Databricks Notebook. So Notebook also we can use to connect with the external system, or Databricks SQL query editor also we can. So there are three methods. First is Catalog Explorer, which is like more common. Second is on the notebook level. If you would like to connect with the external system, that's on notebook level. Third is the SQL query editor. Okay, so these are the three methods we have. So let's see, Catalog Explorer. So we'll understand what is the, how it is being handled. So just give me a moment. Okay, so in your Azure Databricks workspace, you will find something like catalog, which we have seen. At the top of catalog pane, click on this plus sign here and add a connection. Okay, what alternatively we can do is we can go to external data and we can go to the connection. Then connection name we have to provide, type of the connection we have to provide, so which source we are connecting with, and then enter the connection properties such as like host information, path, and access credentials. Then these are optional that we can test the connection, and then we can, if we wish to add any comment, and we'll just click on create, and this will create the connection. Okay, so let's try this possibility here. Let's go. So as it suggests that we are on our data store or meta store, and here we can see that we have add data. So this plus sign we have to connect, and we have to go here and add a connection. And here we just need to provide any friendly name of that connection, so we can identify where it is connecting to. And then in the connection type, we can select the source where we are reaching out. Because let's say if we are going to SQL Server, then it will ask that what authentication or what type of authentication you are going to use here. So I will use, let's say, username and password. In that case, I just need to provide the host name. So we can provide the host name here, the port number where it's listening, username, password, and if any comment. And I think this is optional. Yeah, and so this is advanced option. Trust server certificate is available, then you can choose this one, and then you can simply create the connection and test the connection. So it's easy process to establish a connection with the external database system. Okay, next is we'll just go back. Okay, so let's see what else we have to do. And next is like, so another option is by SQL, run the following command. So in this, we can create a connection, and then we can provide the name of connection, type of connection, where we are connecting to. So this is we can do on the notebook. Basically, we'll provide the host name here and the port and user and password. So it will create a connection for us. Okay. We recommend that you use Azure Databricks secret instead of plain text string. So this is like recommendation that you should not put your username and password in plain string. So for sensitive data, it recommend that you can use the secret one. And if you use the secret, how it will be, how this command will look like. So when you use this one, this will remain same. So under options, we will have user, which we will bring from some secret here, and we will provide the name of secret scope. and the secret key user. So this is like key value pair. We will understand about secret in future sessions. So here basically we can store our secrets and then we can just pass the key. So this is like secret key we are passing, and it will automatically be putting the secret here. So let's say like for example, name is equal to Kamal. It means the name is the key and value is the Kamal. So when I put here name, it will automatically put my name here, or same way the password, for example. So we have secret, user secret they have created. So user secret and password secret, they will simply mention the name, where it is, which scope it is being saved, and what is the keyword or key to fetch this information. Okay, so this is like this. And then next step is that we will be creating a foreign catalog. Okay, so to create the foreign catalog mirrors the database in the external data system, so that you can query and manage access to data in that database using Azure Databricks and Unity catalog. To create a foreign catalog, you use a connection. So that's why we have created a connection here to data source that has already been defined. To create a foreign catalog, can use catalog explorer. So this is like first method we can use. The second method is create foreign catalog in SQL command in Azure Databricks notebook, or the third one is SQL query editor. So these three methods, the same way which we have used in the previous one, the same way it is here. Foreign catalog metadata is synced into Unity catalog on each interaction with the catalog. So whenever there is interaction with the catalog, it is going to synchronize with the Unity catalog. For the data type mapping between Unity catalog and data source, check data type mapping section for each data source documentation. So we'll have to look into detail here. Permissions required. What are the permission to have this or create this? So create catalog permission should be there, and it should be on the on the meta store, and either ownership of the connection. So create foreign catalog privilege on the connection you should have. Now let's go to catalog explorer and explore. So I think it's identical process. With the plus sign, we'll just go and add a catalog. And we can also go to quick access and go to catalogs button and click the create catalog button. So this is two method. Follow the instruction creating catalog here. So I think I should have opened it. Create meta store, create catalog is not there. So I'll just quickly open this. Okay, so create catalog. All right, so it will show both the ways, I think, standard, foreign, shared. For standard one, it is like for standard catalogs, you can go like this. Okay, so I think we'll jump to that and we'll do it. So here, basically, we have plus sign. So we go here and we should have create or add catalog, simple. So we added a connection. And now we are adding the catalog. So let's see how it looks like. So we'll provide a friendly name here, or a catalog is first layer of Unity catalog 3 levels. So this is like little bit of information here. So this is the first catalog name we will provide. And here we'll choose the type, which type of catalog we are creating. If we are going for standard one, means it will contain tables, views, functions, and other objects. Data is stored on the cloud storage. So this is like data will reside with the Databricks. Here, foreign catalog, which we are looking into, is going to mount a query foreign data such as MySQL, Postgres, SQL Server, and all those things. So this is what we are looking for. And the shared one also mount and query data shared with your organization via Delta Share. So this is the third option we will explore in future. So let's click on the foreign catalog. And here it will ask, when we select the foreign, it will ask for the connection. So the connection which we have created, we'll pick it from here, and that's it. We'll just hit the create button. Okay, and this is like privilege. It appears that you don't have any connection. So right now it is giving us the warning because we don't have any connection. Maybe we can create it from here as well. So this is like entire process to add a new federation or federated catalog or external catalog. Okay, so let's go back where we left. I think so. We understood about this Lakehouse Federation. Okay, so yeah, that's it. Not much here. Let me go back. So Lakehouse Federation we understood. We understood about Unity catalog. I think we haven't missed anything. Yes. Object hierarchy, metastore, levels we talked about. Yeah, we didn't go beyond this, I think. Yeah. So metastores we understood, and create Unity catalog metastore. So we'll understand about that how we can create the metastore itself. So right now we have one metastore here. So we cannot see metastore here, but I think we can see metastore when we go here on our workspace. We can click on manage account. And it will ask the authentication. Workspaces, I think. So this is going to list down the workspaces. I don't know. I'll go to catalog. Yeah, so this is the meta store basically. Yeah. Meta store is a top level container. So we are using, when we created this account with our Databricks, it created a meta store with this. So it identifies the meta store name by meta store Azure South India. So this is the reason here when it created on all those details. So this is like our console for account, where it keeps the key information or configurable information which is on the high level side. So like meta store and all those things. So we go back. So yeah, create Unity catalog meta store. Let's understand about the object, and then we'll go for that maybe. Lakehouse catalog meta store, or let's see meta store. Okay, so meta store is a top level container. I think we have covered. I'm not sure. Let's see. Yeah, some of the information we have covered, but yeah, some of repeated information also available in document, so it create confusion. So a meta store is a top level container, the topmost level container, basically above the catalog. And a Unity catalog meta store register metadata about the secureable objects like table, volume, and all those things. So all the metadata is governed or stored there. Meta store exposes 3 level of namespace. So under meta store, we are getting catalog, schema, and table. So this is 3 layer, another layer by which data can be organized. You must have one meta store for each region in. So this one we have covered already. Yeah. To create meta store, what we'll do? We'll go to our Azure account. So basically we went to Azure account. I just showed you. This was the Azure account. And we can create a storage location if we wish a separate storage location for the meta store. That is also doable. So that is like optional step you can take. And you can create managed identity. If you are creating your storage, then you have to create another managed identity, which is going to be very rare because this is like complex scenario. If you have to deal with the multiple meta store. So generally with the account we have one meta store and it's more than enough. But if let's say if there is a requirement to separately manage the meta store, in that case, you will have to create this. In Azure Databricks, create meta store, attach the storage location. So this is like the steps. Okay, so first step is like you can create a meta store. Then if you have separate storage location, you attach it with the storage location. And then the third step is that assign the workspace to meta store. So before you begin, you should familiarize yourself. Okay, these are the concept. You should also confirm that you meet the following requirements. To set up, you must be a Azure Databricks account admin. So this is one of the requirement here. And the first Azure Databricks account already have these, all those things. So this is talking about that. Then next is the workspace that you attach to the meta store must be on the Azure Databricks premium plan. So this is one of the requirement here. If you want to set up meta store level root storage, so let's say if you are creating root storage for the meta store, you must have permission to create the following Azure tenant. So because you are creating a storage account in the Azure, so you should have permission to create Azure data lake storage. Okay, so you can create the storage account if you are willing. So this is optional. And then a new resource hold the system assigned managed identity, because everything is being managed by identity here. So when we are talking about the storage account, I'll just show you here in Azure, I think. So this is our storage account, like default one where we are keeping all the data. So Databricks is creating this storage account when we created the Databricks, service on the Azure. And this like storage account where it is keeping all the information. So if I go to my containers here under data storage, this everything is being created by the Databricks. We haven't created anything, and they are keeping the storage. So this unity dash catalog dash storage is the location where Databricks is keeping actual data. So whatever we are ingesting in, we are fetching in, or let's say CSVs or anything, we are putting it. It is using the Azure account, and it will be costing on the Azure, not on the Databricks part. So Databricks is service which is, creating these all objects, like jobs will be listed here, logs will be maintained here, metadata is going to be maintained here, root data, root metadata is going to be maintained here. So like these, all these things are arranged. And if we are creating a new storage account and creating a container and managing for the meta store, in that case, it is going to have another, account. So this is what it's talking about. We'll go back. So this is the storage account is talking. So first step is like create a storage container for a meta store level managed storage. So this is optional if we want to have another container. Otherwise, we can use the same container. That's why it is, optional step. So you can use the storage account, and then you can create a container onto it. And then you have to, make a note of URI. Okay. So of that container, basically the URI of this container is that your container name at your storage account name dot. So this is like full address of your container which you are creating. I think it should also have, maybe it will show, I'm not sure. But if I go to this container, let's go container here. Or maybe I can go to storage account. I am not able to see. In the overview, I should be able to see. No, I think we will not be finding it here. Links like virtual machine we find. But I think if I click, it will not allow me. It looks like it will not allow me. But I should be able to see the properties, I believe. So like this, the address URI is going to be for the container. Also, let's see, where is our container? Yeah, this is our container. So we are going to have the address, or we can see the address, but we cannot open it. The reason it is being managed by this one. So this is like URI where our access of the container is going to be. Okay, so here like container name we will be putting, then the storage account name. Okay, so storage account name, I can show you the storage account name. This one is the storage account name basically. Okay, so this is the storage account name, and then your container name you are going to put, and then DFS for what do you call, Lakehouse storage 2. So this is the DFS. Then code, this is like static one, and then the meta store name you are going to put here. Okay, so this is like optional steps. Then you can create a managed identity to access the managed storage location. Okay, so you have to, I mean, this is also optional step when you are creating the storage account then. Then the third step is that create meta store and attach to the workspace. So this is like, you can simply create a meta store and attach to the workspace. Each Azure Databricks region requires its own Unity catalog meta store, and you can create meta store for each region in which your organization operates. So basically we are understanding or going through this documentation to understand the concept. Probably you would not require to create the separate, meta store and these things. But for let's say if you are preparing for interview, or if you are being asked in the interview about this concept, then at least you should have understanding on this, that how the data is being managed on these storage accounts. Okay, then you can simply log in and you can go to catalog and create a meta store. So the same place, I think we can click on catalog and we can create meta store. So log into your workspace. Yeah, so basically it's asking on the console. So we should be going to console, and how we will go. So I showed you how we can go to the console. It's simply you go here and go to manage account. It will open in new tab, and then you will go to catalog, and here you will create the meta store. So create meta store button is there, and then you will provide region, path. So these are like, create your meta store. And then second step is to assign to workspace. So you'll provide the name, which region you want to create it for. You can choose a region from here. Then the path, which we, optional, if we are creating a storage account, then here also it is guiding through. So container name, then all those things. So you will provide this. And then the access connector ID. So this is going to be your access connector ID, which the location specifies with this one. If you are keeping it empty, it's not going to. And then the manage the identity. So this is like the simple process you have to create a meta store. But I think it's rare to, you will have opportunity to create a meta store itself. Catalogs are more than enough anyways. Thank you everyone for joining. Today we are going to talk about the creating the catalog. Yesterday we have seen that how we can add a meta store, which is going to be rare. But at least for knowledge perspective, we should know that how this storage is attached to each other, and what are the objects we have. So the next one we have is the catalog, which we can see here. Meta store we will not be able to see here. Meta store we will have to go into the workspace, and there we can see that which meta store is there. So if we go here and click on, so basically if we click on the workspace, we click on manage account. It will ask, so it will take us to this screen. And here, if we click on the catalog, so basically this is the top level meta store we have in this workspace. So this is the top level meta store. Under the meta store, we have all these objects. So this is called catalog. Okay, so let's understand what it is and then how the objects are arranged in it. So creating catalog, or I'll just simply show you the diagram. I think It's not here. It was some different place. Looks like not here. Yeah, I think we'll come across the diagram somewhere, but not in this article. Yeah, it looks like not here. But anyway, so in catalog, we'll see that how we can create the catalog, and catalog we can visualize or we can see it here. Okay, so this is called catalog. So this is the default catalog basically. When we created this workspace, we are having this catalog automatically created for us. Okay, and if we wish to have additional catalog, we can add the catalog from here. So we can add a catalog, and we have seen yesterday as well that we can have 3 type of catalog. First is the standard, second is foreign, and the third is shared one. So this is like you can attach a catalog with the connection from outside, and this is the internal catalog. Okay, so we can create the catalog like same one. So we can organize our data in schemas, and we have more schema created, like one is information schema, which is associated with each catalog. So if I go to even system catalog, I can see information schema is there, and one schema for the system. So this is how it is arranged. So let's go here and learn how we can create one. So these are like requirements. Definitely once since we are account owner and we have the workspace permission, we will have all these requirement meeting anyways. But if we want it granular level, then we can configure these requirements. So creating a catalog, really very easy process. Here you just simply have to go to catalog, and under catalog you have to create or click on the create catalog button. In that we will have 3 choices as we have seen. So standard one or standard catalog is a secureable object that organize data and AI assets. Okay, and it is managed by Unity Catalog. So Unity Catalog is like governing, or access control sort of thing, which manages all the permission for our catalog. Okay, for all use cases except the Lakehouse Federation, which is like for foreign catalog. So except this, the catalogs created from data sharing share. So this data sharing is like one model, which is like one layer of the data storage. So you can assume as a layer. Okay, and foreign catalog, we have seen yesterday that how we can connect the external data system. So we'll have to create a connection, and then we can create a foreign catalog as well. Okay, and the shared one is the which is having the data, and we can share it with you as a data sharing share. So this concept we will study in further session. So that time we'll talk about the share and all those things. Okay, depending on the catalog type, specify the following options. So let's say if we are going for standard, catalog, we can have the option to, create, manage, storage as well. Okay, see, so we can do that. But here to create this one, simply we have to create. So if we see the interface is really very easy. We'll just simply create one and see. So I'll just, collapse everything except these two. Create and add catalog. We'll go with the standard catalog. So I'll say, okay, catalog 2, for example. I'll go for standard. If you want the location, so location will choose the default location. If you want any subpath, and here Unity catalog will take care of all the permissions we need. So we'll hit create, and catalog is created. It's really very simple process. We can view the catalog, configure the catalog. So we can go here and configure from here itself. And we can see which workspace is going to work with. So step 1, we can choose which workspace we want it to work with. So if we want it to work with all the workspaces, we will keep it selected. Then the permission we can configure for the users. Maybe we can, remove some permission or add some permission, etc. And then the metadata related information. So if we would like to put any tags with this catalog, we will go with that, and this catalog is configured. Okay, so again, you can see like this catalog is created, and it is having two schemas in it. Okay, so by default you can have two schemas. In default schema, we are going to keep the content, basically like views, table, or whatever we do have inside, volumes and etc. And the information schema is like system schema, you can say. Okay, so this is about catalog and creation of catalog. Okay, so we can arrange, yesterday we have, gone to the theoretical part, that why we have to create the catalog and all those things. So basically we want to separate or isolate the data from each other. That's why we are creating the catalog. And if we wish to create it using the, SQL statement in the notebook, that is also possible. We can type like create catalog. If not exist, then catalog name will provide. We'll provide the location path and the comment, if any. And simply we can create the catalog from here as well. Either way, it will work. All right. So this is about the creation of catalog. Now I will talk about a little bit before we begin, because now we are starting to work with the notebooks. Before we notebook is like central part, so everything on Databricks we are going to do is going to do with the notebook. So actual work we will be performing on the notebook, and coming sessions mostly we will be working with the notebook, because conceptual part we have covered lot many things, where we require like knowledge how to manage the storage account, how storage account is connected with this, how we can have the external data connected with this. So mostly we will be working with the notebooks now on. So before that, we need to understand that how Apache Spark is working with the Databricks. So this concept is really important, and it's really nice documentation. So it will provide us that how these both are working together, what is the relation between them. So let's go and we'll see this. So Apache Spark is like heart of Azure Databricks platform, and is the technology powering compute clusters and SQL warehouse. So basically, SQL warehouse and compute clusters, any query, anything we are performing, basically we are going to perform in these both. And the powering, or the Apache Spark powers these both the stuff. Okay, Azure Databricks is an optimized platform for Apache Spark. So there is little bit of optimization Databricks have perform on Apache Spark, providing an efficient and simple platform for running Apache Spark workloads. Okay, so let's understand what is the Apache Spark first, so it will be helpful for us to make more sense. So I'll take you to another article. So overview of Apache Spark. So let's understand about the Apache Spark, what it does. So here let's see Apache Spark, like history, little bit of history also we can understand. So according to Databricks definition, Apache Spark is a lightning fast unified analytics engine for big data and ML, machine learning. So if we want to understand, or for definition perspective, Apache Spark is defined in this single line, that this is a lightning fast unified analytics engine for big data and ML. And now if we see about the history, it was originally developed by UC Berkeley in 2009. Databricks is one of the major contributor. Why Databricks have optimized and all those things? Because this is like the major contributor. I think 60-70% contribution from Databricks. Apache Spark is one of the largest open source project for data processing. So we are using Apache Spark for data processing purpose. It is fast and in-memory data processing engine. So one of the advantage having the Apache Spark is that this works in the in-memory data processing. So in memory means it is going to work with the RAM, not with the storage. So most of the data processing, or especially if we see the ETL processes which are being handled by the DBMS, are relatively slow because these ETL processes are working in with the storage, not with the memory. So that's why the performance is a little bit slow compared to the big data analytics systems. And Apache Spark uses the in-memory data for processing. Okay, so which becomes very fast to analyze. And little bit about the history of this, I think, and we'll go to the feature. So let's quickly see what are the feature it provides. So Apache Spark can use to perform batch processing. So whenever we do have batch processing, it has the capability to do that. Apache Spark can also use to perform stream processing. So we can have stream processing, means almost real-time processing also we can have using the Apache Spark. It can be used for interactive processing as well, means having the processing while you're working with that. And previously we were using Apache Impala for this purpose, or these are the tools we were using, basically for interactive processing. Now the Apache Spark is also useful to perform graph processing. Spark can process the data in real time and batch mode. Both the modes are available. Okay. So these are core feature of Apache Spark. Just for our understanding, before we understand about the relation of Apache Spark and Databricks. What is the relation, we'll see. Here, I think we have already read about this point, that Apache Spark in Databricks perspective work with the compute cluster and SQL warehouse where actual processing is happening, right? Azure Databricks is an optimized platform for Apache Spark. So this is like optimized one. It's using Apache Spark, but little bit more features are included, like Photon and all those things. So we'll see, look into it. What is the relationship of Apache Spark and Databricks? As we understood that Databricks is heavily, have contributed in Apache Spark. So Databricks company was founded by original creator of Apache Spark. So basically Databricks came into the place by the people who have, created Apache Spark. So this is like relation between these both. Is an open source software project. Apache Spark has, committers from many top companies, including the Databricks. Okay. So this is what the relation. Definitely, if they are the founder, they have more insight of Apache Spark and all those things, so they can use it more efficient way. Databricks continues to develop and release feature to Apache Spark. Still, it is contributing to the Apache Spark. So this is what the insight relation these both are having. So still, they are active participant in Apache Spark, and they are maybe, having new feature launched or anything is happening, they know about Apache Spark and they can use along with the Databricks. The Databricks runtime includes additional optimizations. So what are the additional optimizations we can see with the Databricks here of the Apache Spark, and the proprietary features which they are building top of the Apache Spark is these are extending the Apache Spark, including Photon. So one feature which is like definitely they are using the core feature of Apache Spark, but they have some optimization on top of this, which is available in Databricks, which is called Photon. So they have created this. All right. So, how does Apache Spark work on Azure Databricks? So, when you deploy a compute cluster or SQL warehouse on Azure Databricks, Apache Spark is configured and deployed to virtual machines. Okay. So, Apache Spark, whenever we are running any compute or anything, any resource, we are turning it on. So, if we go, I can show you here, for example, let's go to compute. So when I start running this, so along with this cluster computer which is running here, we will have Apache Spark, running on top of this computer. So this is what the relation we are talking here. Okay, so yeah, we are here. Okay. So this is what is saying that when you deploy a compute cluster or SQL warehouse, Apache Spark is going to work with this on the Databricks. Apache Spark is configured and deployed on this virtual machine. You don't need to configure or initialize the Spark, context or Spark session, is these are managed for you by Databricks. So Databricks internally taking care of, deployment of Apache Spark, and it's like automated process. So we don't have to do anything. It is, once your cluster is running, it is up and running along with the Databricks. Okay, can I use Azure Databricks without using Apache Spark? So here a little bit of explanation they have given that Azure Databricks support a variety of workloads and include open source libraries in Databricks runtime. And Databricks SQL uses Apache Spark under the hood. So basically it's saying that it is always going to use whenever we have SQL statement running, definitely that is going to use the Apache Spark under the hood. But end users, use standard SQL syntax to create query and database objects. So on top, we are, creating, or writing standard SQL statements, but under the hood, it is going to work with the Apache Spark. Okay. So this is what the basically relation. So means it is not detachable, right? Okay, also Databricks runtime for machine learning is optimized for ML workloads, and many data scientists use primary open source libraries like TensorFlow, or these libraries also you can use with the Databricks. This is what it's saying. And the scheduled workload or against compute resource you can deploy, you can manage with the Databricks. So basically Apache Spark is, tightly, coupled with the Databricks. Why to use Apache Spark on Databricks is that it provides a secure collaborative environment for developing and deploying enterprise solutions that scale with your business. So this is what one of the use which we are going to have. Okay, and Databricks employees, include many of the world's most knowledgeable Apache Spark maintainers, because these are insiders, these are, original creator of Apache Spark. So still, Apache Spark maintainers who are running actually Apache Spark, are associated with the Databricks. The company continuously develops and release new optimizations. Further, the Databricks, why it is, gaining the popularity is that it is, optimizing continuously. It is contributing on Apache Spark, and it's improving its own platform. So they are having the optimizations which are available with the Databricks only. Okay, to ensure that users can access fastest environment for running Apache Spark. Okay, so they are building like both the end, basically they are improving, like they are improving on the Databricks end as well, and Apache Spark as well. So both the sides they are improving, optimizing the system so it can be, be faster to process the data. Okay, so this is like how we can start with the Apache Spark. So now we'll start working with the actual notebook. So let me see if anything useful for us here. So these are like setting related I have opened. So now what we'll do is we will quickly go through the document, and actually we will load and transform data using Apache Spark DataFrame. So we will understand about the DataFrame concept as well. So let's begin with this. Okay, in this tutorial, basically we'll talk about Apache Spark Python, or PySpark we can call, and DataFrame APIs. Okay. In this article, basically we have Scala and all those things, but these are identical. Python is more popular, so we'll continue with the Python. Okay. Okay, so here if you see, we have details available with the Python. We have details available with the Scala, R, and yeah. So these three are we have available. So let's continue with this. So let's understand what is the data frame, right? So data frame is like a data frame is two-dimensional labeled data structure. So a data frame is like in memory data structure, you can say, with columns and potentially different types of columns. You can think of data frame like a spreadsheet, or like SQL table or dictionary, whatever you would like to call. So basically this is like table structure. Okay, so you can think of data frame like a spreadsheet, SQL table, or dictionary of series of objects. Apache Spark data frames provide a rich set of functions like select columns, filter, join, aggregate. So these like we do in SQL statement, where we can filter, or we can join multiple tables, we can aggregate, combine the result together. So these all features are available in data frame that allows you to solve common data analysis problem efficiently. Okay, so this is about the data frame. Apache Spark data frame are an abstraction built on top of a resilient distributed data set. Okay, RDDs, it is called RDD. Spark data frame and Spark SQL uses unified planning and optimization engine, allowing you to get nearly identical performance across all supported language on Azure Databricks like Python, SQL, Scala, and R. Okay, and what are the requirements to run the data frame? Let's see. To complete the following tutorial, basically what we are going to do is we are going to define. So these are like steps we are going to take. We are going to define variables and copy public data. So we'll find a source which is publicly available into the Unity catalog volume. So we will bring this data into a Unity catalog volume. And then what we'll do is next step, we'll create a data frame with Python. Then we'll load the data into data frame from a CSV file. So the CSV file which we are creating from this public source, we are going to load this data into the data frame, and then view and interact with the data frame, and then save the data frame and run SQL queries on PySpark. So these are like steps we are going to follow in this tutorial, and we will do it hands-on, so don't worry guys. Okay. So this is like theoretical part where what we need. So to complete this entire exercise, we will require, these are the permissions or requirement related. So to use example in this tutorial, your workspace must have Unity catalog enabled, which nowadays it's like whenever we have the account, it is anyways by default enabled. But previously it was not there. That's why it is always mentioning it here. The examples in this tutorial use a Unity catalog volume. So we are going to store the data or CSV file in volume. The sample data which we are going to fetch from public URL. To use these examples, create a volume and use that volume catalog. Okay. Schema and volume name and set volume. So these are like a requisite. You must have the following permissions. If we are having minimum, a zero trust policy where we want to give a minimum, permissions, these are the permission you should have. So read volume, write volume, or all privileges we can go with. Then use schema and all privileges, and use catalog and all privileges. So on different level, on catalog level this, on schema level this, and like this. Okay. So step one, we will define the variable and load CSV file. Okay. So what we need to do is we have to, so basically we are going to use this public URL to fetch the data, okay, into your Unity, catalog volume. So, and what it contains the baby names data or something like this. Open a new notebook. We'll open a notebook by clicking the plus icon. And then what we'll do is copy and paste the following code. So we have code written here. What we'll do here is we'll use this code and we'll create this one. So in Python we have this code available. So let's copy this, go to our environment and go to workspace. If I will go to my workspace, if I go to user, okay, I can create here a notebook. Okay. Okay, I created a notebook. I'll just rename it to baby names notebook. Okay, so we are creating this notebook here, and the code which we have copied, the first code, I will paste it here. So this is the code. Now I will switch back to this one, right? So I'll just bring it near to this so we can easily work with this. So basically this is the Python code we are going to put into here, and what this code is having, it is having catalog name, schema name, volume name with the catalog, schema and volume name for the Unity catalog volume. Replace the table name with the table name of your choice. So table name we can put our own, and you will load baby name data into the table later on this tutorial. So this is like variables we are creating. So we are putting the catalog name, schema name, volume name, and this is the URL, public URL from where we are, we will bringing in the data here in this volume. And we are going to put the, file name like rows.csv, and then we can put the table name here of our choice. And here what is happening is that in path volume, these all are variables in Python. Okay, so path volume is equal to, we are going to say volumes, and then we are putting the catalog name, then schema name, and the volume. So basically we are providing the path for the data which we are storing in this volume. Okay, so the volume belongs to this volume, volume name, whatever we put in this variable, it will come here. The schema we are putting here, so that is schema, and it will be creating the path for us. And then the catalog name, we are going to put it here, so this is the catalog name. Okay, and the path for table will become that catalog, so catalog name and the schema. Okay, so path of the table we are going to put like this, and we are going to simply print this both path. Okay, and then comment you can see show complete path. So this is going to be the complete path, and this is going to be the complete path of the volume. Okay, so let's go here and see. So I'll simply come here and I'll put the catalog name and all those things. So what I will do is I'll open my catalog in another tab, so it will be easy to work with. So one tab I have opened my notebook. Another tab I am going to open my volumes. Let it load. Okay. So either we can go with the default one. So if I go here and if I see I have volume created, volume 1 in this one. Okay. So I can use this volume, and maybe I can put that file into this, or I can go to the catalog which we have newly created. So catalog 2, default, and we may create a volume here. So both the ways, it can go with. So let's pick this one, default one. So what is our catalog name? DB, let me see. Okay, DBWS_9. So this is going to be the name here. DBWS_9. I think I can easily pick it from. I should have. Okay, if I click on here, yeah, I can easily, copy from here. Or there is copy button as well. So copy. And I will go to here and replace with the catalog name. So this is going to be our catalog. So we are putting it here. Okay. Then the schema name, let's go back. Schema is the default schema we are going to use. So we can copy this schema name from here. And we'll put it here. So this is our schema name. And this is putting both, basically this one already selected. So we'll just remove this part and the default schema. And then we'll go for next step and we'll expand the schema. Inside we should have volumes. So under volumes, we have one volume called volume 1. So I'll simply take this because maybe it will be taking entire path. So here we are going to define or put the volume name. Okay. And this is our download URL, which is the correctly defined because this is used in that article. And then the file name, which we are going to have rows.csv file name, which is being used here. So, okay. So if you see file name is already here. So this is the same. Then the table name we can put of our choice. So let's say if I say this is going to be what you should put, table 1, I think is the okay, table 1 we can put. So this is going to be table 1. Okay, so we have put all the requirement here, and simply to run this here we should have have connected with the cluster. If we are not connected with the cluster, it's not going to work. So if I see here, I have cluster, which is like the cluster with one driver. I can start and attach. Okay. So right now it is not started, so it's not going to perform the work. Alternatively, what I can do is I can maybe open another tab. So I can go to compute, right click, and open this in another tab. Okay, and I can go to, so basically it will show me the compute resources. And we have cluster here, personal compute. We'll just start this manually from here. So both the way it will work. So I'll simply confirm this, and now it will be starting. Meanwhile it is starting, we can go to our Azure portal and go to our subscription. Basically, yeah, I'll open the subscription. And if I go to my uses quotas in subscription, if I select, I deselect it all, South India. So in this data center, my, resources running, I'll just filter it and I put here compute, this one, and I'll put that whatever, only show the item with uses. Right now, nothing is being used. You can see here. Now it is started using, see. So now you can see that I have quota of 20, compute cluster related, information, or I can use these resources. So here I have this quota. Basically, it is increased on the request. I requested Microsoft to increase these numbers, though. So they have requested the number. Earlier, it was showing me the failure because this quota was limited to 10. I believe it was only 5 or 10, something like this. So it was not allowing me to perform this task. Now, since we are starting our cluster, so it is changing it here. And sometime you may, face the error where your cluster will fail and say you don't have enough resources. Maybe you can coordinate with your Azure admin and ask him to increase the quota here. So this is just for your information how it is being arranged. Okay, so meanwhile it is going, let's see what else is happening. Yeah, so it's going to use these resources. We'll go to our compute tab and we can see our cluster is starting. It is not yet started. This sign has to, go away. Then we will consider or we will assume that it's started. We may have to wait a while to, let it start. It may take some time, maybe a minute or two to, just wake up this cluster and start. Meanwhile, if you have any doubt, anything, if you are having any concern, we can take some questions while it is starting. All right, so still it's going on, and once it is started, we will be able to view it here. So it's like running sign, still not started, and I think we'll see in the drop down as well here. So entirely, basically, we are, in Databricks, we will be working on the notebooks. So create multiple notebooks, um, maybe schedule it. So one of the advantage of having Databricks is that you don't have to do it manually. You can put it on automation. So you can create the job out of these notebooks, and these notebooks will run whenever you say. Let's say if I say that I want to run this notebook on daily basis, so it will fetch the data of whatever the source we have. The updated data will come in, and then let's say if you are having a dashboard or anything where you would like to have updated data, so you will not have to work manually to run or perform the ETL process. It will do its own, and once you schedule, it is always there. So that's one of the advantage having this Databricks. Yes, so my active resources, now I can see here that I can use the cluster, and my cluster is up and running. So it is connecting, and now it will show that which cluster I'm connected to. Okay, and now what I can do is I can simply go here and run the cell, and either I click on the play button. So here in this cell we have declared or variables. So what we have done, we have defined the variables and load CSV file, right? So I'll copy this title, and it's not mandatory task anyways, but I'm just putting to identify that what this cell is doing. So you can write like this, and you can run this here. So you basically what it's doing is it's just giving this output of the table path of the table. Okay, and the print the path of the volume. So this is the path of the volume, and this is the path table. Okay, so these both output we get. Let's see what next we are going to do. So we have defined our variables and load the CSV file in the first step, which we have done using the Python. We may have used the Scala, and this is the code of Scala. This is the code of R, and we simply also we can press shift and enter to run the cell. So this is like shortcut if you would like to run this cell by command. And basically it's going to copy and paste the following code into your new empty notebook cell. Okay, so this we want next step here. So let me see, we are on number 1, number 2 is done, number 3, this is done, copy and paste the following code into new empty notebook cell. So basically on step number 4, we are is talking about this next step, that it's saying that, okay, use the DB utils and FS command or CP command, where your CP command is basically to copy the data from some path. So we are saying that this is going to be our download URL and path volume and path of the file. We are going to copy this into next cell. So let's copy this and open your notebook here, go here, and you can simply go down and create. So you can collapse this cell, for example, like this. It will create some screen, space, and you can simply click on plus code and put your, command here. Okay, and we can run this command. Okay, so this is how it's going to be. So if let's say if I go here, my download URL, this is the variable which we are calling here, and it has to be in the curly braces with the F sign here. So it's going to take as a string, and then you see the path volume we are taking from here, and the file name we are going to take from here. Okay, so these variables we are basically pointing that from this URL take and copy this data with the help of DB utils, which is like command utility, and this is file system. So we are performing the copy command from here. So we are taking the data from this URL and putting it on this location. Okay, so let's see what is going to happen. Copy and paste. Okay, Unity catalog and run this command. So now next we are running this cell and then move to next cell. Okay, so let's go here and run this cell. So I'll simply minimize this and say run. And again, when I'm not using this notebook for 10 minutes, my cluster will stop. So we have put the condition on this cluster that it should automatically stop if I'm not using this resource. So it will not cost me. It has returned the true, means it has successfully copied the data from here to here. So let's verify if the data is copied or not. So I'll go here in the catalog, in the volume, and if I refresh, I think from here. So you can see in the volume 1, I have one, rows.csv table created. So this table is basically, created, or this file is being fetched in this volume from the source, So this file we successfully, downloaded from the public source available. Okay, and you can see it's happened just now. So it's like this. Okay, so this is how we were able to bring in the data from the external source and put in our volume inside of our account. All right, so let's go here and see what else we can do. Now what we will try to do is we will create a data frame out of this file. So in this step, we'll create a data frame named df1 with the test data which we have, and then display its content. Okay, so the idea is that we are going to create a data frame and going to display in this step. So step 1, we were, I think, what was the step 1 total? Define variable and load CSV. Okay, so I think there he put define variable, and load CSV part is conducted by the second cell. So we'll take this title from here. So here we define the variable, here we load the CSV. Okay, so these are like steps which we are following. Okay, next is, okay, so let's go down. Now we are going to create a data frame. Okay, so we'll take this title and create new cell here, and we'll just put the title here. So just to identify what is happening where. Okay, So we are creating data frame. Let's go and see the code. Here we'll copy paste this into empty cell, and this code creates a data frame with the test data and then display the contents and the schema of the data frame. Okay, let's go. So basically, data, we are going to create some data here, like array or JSON array, and then we are going to create some columns here. And then we are going to define a data frame. So df1 stands for data frame, and this is spark dot create data frame command with the help of this data, which is here. And schema is going to be year, which is int. So the first column. The second column, first underscore name, which is going to be string. So first underscore name. Then the second column, which is like country, and that is going to be string again. Then the sex of here, so string again, and then the count, which is the int. Okay, so these columns we are going to create here in this data frame. And then with the display command, we are going to show this data frame or output of this data frame. So display is basically a method, specific to Databricks. It's like a command of a Databricks notebook, and we can use it to show the data frame properly. If we would not have used this display, I think maybe we can try it out. So it won't show the result nicely. So it's little bit improvement. I'll simply paste it here. Okay, so I hope you understand that what we are planning to do here. And we are having in this data frame one data as well. So we just put the data here, one line of data. We define the columns, and then we told to create a data frame out of it using create data frame command. We use this data and we define the schema for this. Okay. Okay, so let's run this here and see what is happening here. Let's see. So Spark job is running, and you can see that with the help of display command, we were able to show this data. And if I remove the data, let me remove this one. I think there is one more command was there. I think display does show, here does show. Yeah, so this is the command. I think it will not show nicely, but let's see. So it will show like this, So this is like, data is not nicely formatted, but this is what the df show command, have. And when we type display, it, represents nicely. Display and df, and we just do this. I think, yeah, okay. So again, we run this, and this is little bit nice layout. Okay, so far I think should be easy to understand. Should not have any issue with this. Okay, so here we created the data frame. Let's go back. And Scala and are also available same way. Now next step we are going to do is the load data into data frame from CSV file. Okay, so in step 2, what we have done is we created a data frame, but we didn't load it. Basically, we created a manual data frame here in this case. Okay, so we are not fetching any data, from outside. So here if you see, we are just, created a simple, column structure, and we, put this data in this data frame. So it's like manual creation, no external data involved. But here what we are going to do is we are going to load the data into a data frame from the CSV file, which we have, fetched. So I'll just copy this title. I'll put it here. And I'll open or create new cell where I'm going to put this title. Okay, so load data into data frame from CSV file. So let's go back. what we need to do, so this step create a data frame name df_csv from CSV file that you have previously loaded into the Unity catalog volume. Okay, and the copy and paste. So basically what we are going to use here is spark.read CSV. Okay, so here the data frame we are creating from this command. So we are using spark.read.csv. By this command, we will be able to read this CSV file. And then we are providing the path of the volume and slash file name. Okay, so that CSV file rows.csv, I believe. So this is the entire path of that file name. So it will go to storage and read this file. And then we are going to say, okay, headers are going to be true, schema is true, info schema is true. And the separator in this is the comma. So this is comma separated file. So this is what we are going to define here. Let's copy, and then the display command will show the data which we have, fetched. So let's go here and just paste it here. Okay, I hope the command is very clear. I will just quickly run this. Now, this data is basically coming from the CSV file which we have, downloaded. Okay, so that all data is coming from here. Okay, and in the previous example, we have seen that we have created a data frame manually, having its own rows and all those things. So here, here in this case, I think, in this case, we were just putting the data manually and defining the data frame. But in this case, I'll just minimize this. We are loading the data from CSV, and we just using this command spark.read.csv and providing the path of CSV file which is available in our volume, and saying that it is having header, it is having the schema, and it is having the separator comma, because some files are tape separated as well. So we are able to display this data from that CSV file. Okay, the next one, step 4, view and interact with your data frame. So here we will understand that how we can view and interact with data frame. So we can print the data frame schema, let's say, for example. So we'll type this step because one cell is there. So we'll just understand about the printing of data frame schema. I'll go here and I'll just minimize this. So I'll create another, cell. And the beautiful thing is that the variables we have defined here are available throughout other cells. Okay, and we can run all the cells together as well. So if we go for run all, it will run entire notebook together. So that is also possible. We can run cell by cell. So let's say if we want to tweak in any cell, we can, just change that cell and work with. Okay, so let's print the schema. How to display the schema of Apache Spark data frame. Apache Spark uses the term schema to refer the name and data types of the column. So let's do this. It should be easy. So we are going to see the schema or print schema. By print schema, we are going to see the data frame underscore CSV. So this is one data frame. This is the previous one, which is manually, which we have created. So both the schemas we are going to look into. I'll simply click on this and see here. So if I run this cell, I can see that these are the schema available in this data frame. So the first one, df_csv, I can see here that year is integer value, and the first name is string, country is string, sex is string, and the count is integer. And the second one, I can see year is integer and first underscore name is there, which is the string. So if you notice carefully, this is first space name, and in the second schema we have first underscore name, so little bit different, so first one we have created with this column type or column name is different than the first and second, so there is difference. Okay, and then so this is how we will be able to print the schema in the data frame, or we can visualize. So basically the idea is when we want to perform any join or anything, we want to compare schemas, so we can do these things on the cell on this notebook. So I'll prefer you guys that you at least start using the notebook. If you have community edition or Azure or whatever, you can start working with the data frame. So little bit idea you will start developing it. Better to have Azure account and premium sort of subscription, which will not be costing you a lot. Basically, you can easily maybe manage with the maybe 50 to 100 rupees a day per hour basis. So it's really easy, you can work with. So it's worth, because practically if you don't spending if you are not spending time practically on the Databricks, then theoretically whatever understanding you have, you can maybe do this, but practically it's important to have more knowledge with this. So if any question, anything you would like to ask, we can take the question. So anyone having any question, I'll just give you time. So please go ahead. I hope you guys are getting the documentation, and so I'm providing the documentation also, which we are following, and these are publicly available as well, so you can follow them. And if there is any update, why I'm using the public documentation is, or the documentation which is the official documentation, the reason is tomorrow if there is change introduced with the Databricks, because this is evolving platform. If I provide you a rigid document, maybe in future you have, let's say, a new term added, or some document update is happening, then you will find that difficult, that what I explained you is different than the new interface or any update is there. So it's always I recommend that use the official documentation which is publicly available, because it is evolving process. Some of the instructor, like they provide the rigid document, but it doesn't help really. So nowadays it's products are evolving very fast, so I recommend that you have to have a fluid document which is updating continuously basis. And basically here Microsoft manages everything. Microsoft keep updating this document. So let's say if any article or new concept is being added to this document, it will be updated automatically. It on frequently it is like having contributors, and article is keep updating itself, and it's publicly available, free of cost, so you should definitely be going for this and use this documentation. Even on normal level practice also, you should use the documentation which is available publicly and official documentation. Further, with the Databricks point of view, Databricks maintain documentation with the platform. So if I open, let's say, Databricks documentation, if I go with the Databricks official documentation, which is having again categorized as the cloud platform which we are working with. So if we are working with the Azure, it will point to the Microsoft. If we are working with the AWS, then they have different documentation location. So let's open this, for example. So this documentation is related to AWS, Amazon Web Platform. There are sometimes difference which are important. That's why I'm not going with the Databricks documentation here when we are working with the Microsoft platform. it's better to switch to Microsoft, and Microsoft takes care of all the documentation from here. So it will totally switch and it will go to learn.microsoft.com. Okay, so it's better to use this resource, because this is the official documentation related to Azure and Databricks. Okay, because we are learning Azure Databricks. So little bit of difference, maybe almost identical concept point of view, but still there is variations, and storage account is different, cluster is different, resources being managed differently. So you will find a difference here in this 3 of 3 provider documentation. All right, so that's it for today's session. Thank you everyone for joining. Okay, so it will take a while, maybe 1 or 2 minutes to start. And meanwhile, what we'll do is we'll start creating a notebook. Okay, so before that, what I will do is I'll create some more tabs out of it. So let's say in one tab, we'll right click on this and open in new tab. So we'll open our catalog. Yeah, so it's loading our catalogs. And we have 3 catalogs here. One is system, and this one we created manually, and this one is the default one. So when we have the workspace created, we get a default catalog created, same as the workspace name. So if we go to our Azure account, you'll see the same workspace name. So this is our default catalog. Still our compute resource is starting. Okay, so here what we'll do is, I think we should have some tables here. We have one table here called organizations 1000. This is like sample data. Also, we have, catalog in 2 categories or 3 categories basically. So this is the legacy one, but here in the shared one, this is shared among all the users. So all the users will have access to this, and my organization catalogs are having the access to our user who is logged in right now. And shared one, we will have to start the SQL warehouse. So let the compute resource started. We are just waiting compute resource to start, and then we can either go to compute, go to SQL warehouses and start our SQL warehouse. It will allow us to run the SQL commands. Okay, so I think it may take maybe a 2 minute or 2 more to start with. Meanwhile, we'll explore our catalog. So in catalog, we have tables, we have volumes. Volumes are basically uploaded files, CSV files, or any file which we can keep as a volume. Tables are one which are having the data delta table format. So these are like tables here, and these the volumes which are like files which are uploaded. Okay, so let's go and open the workspace in new tab. One more tab will open, and maybe we'll arrange it on top of this. And we are on the home page of our workspace where we can create the notebooks. Okay, so we have some notebook here in workspace. We have shared workspace, which is like this is the shared one. We may have folders in it, so we can create multiple folders. And if we are going to home, this is our personal workspace, which is not being shared with the other members. Okay, if we go to create button here, we can create a notebook from here. So in notebook, we have cell and we can provide the name of notebook. Let's say demo, for example, I believe today is test 29 October or something like this. So anything we can provide like naming of this one. Okay, so this is the default language of our notebook. So by default, it will keep the sales language like this, but still we can change our language by just typing the percentage sign. So if I type percentage and if I type SQL, it will change the language of this cell to SQL. And let's say if I create a new cell and the default language would be the Python one. Okay, so multiple languages we can use in the same notebook, but default language of the notebook will create when we create the cell will be selected. Okay, let me go through one thing. Just give me a moment. So, okay, so we are going to talk about table today. So how we can basically create a table or query a table. Okay, so just give me a moment. I'll just bring in right. Okay, if we need to create a table, we can create it using the SQL as well. So here the table is basically the resource which is here. So let's say in the default, default schema, you have one table created. We can create another table as well. Okay, so let's go to our notebook. In notebook, we can say by default, it is anyways going to use the same schema, but we can mention use. So this is like SQL command, catalog, and then we can mention the name of catalog here. So it should be, I believe, what was the name? DBWS. DBWS. Okay. So this will use the catalog. So we can change the catalog, which catalogs. Catalog is like database. The same way it is like, we have databases and we use in SQL the same command to basically choose the database or use database name, and then it start using that database to query and work with. Okay, and next command is like, for example, if we would like to create a table, so we will have to tell about the creation of table. Maybe we can create in next cell as well, or the same one as well we can create. So create table, and then we can say if not exist, it's gonna have, or maybe it will take in the next, just why it is having red, could not find create. All right, so no problem, it should work, I think. Or in case if my SQL warehouse is not working, it may have issue. So finally my cluster is working, means compute power is working. Now I need to start my SQL warehouse. This could be the reason, because this is stopped right now and it will not work with the SQL commands. Create table, and I would say if not exists, Then I would say default dot. Basically, I'm using this one and it is having a default schema. And I would say, let's say department or something like this. So name of table. And then like same in SQL, we do the brackets and we provide the name of column. So let's say if we have name department code is integer, we would like to keep an department name, for example, as string, we would like to keep. So something like some columns we can create in the table while we are creating the table. So location string. Okay. Now, for example, let's try this. If there is any error, it will give us the automatic compute resource connect success. Okay, so it has connected with our cluster, which is the default cluster. Here we can change the name, check the name is already here. And it is providing an error. And what the error is, syntax error at near create. Semicolon maybe. Assistant quick fix on. So we can accept this. And basically these two statements are separated by the semicolon. So now it is running. Right now the command is under execution. Okay, so this was successful, means your table is created. So with the name of department, we can verify this. We can go to our resources here or catalog. Under catalog, we can see the tables. So I think we will have to refresh from here. And now you can see your table is created with the given columns. And AI suggestion is coming in. So these are like columns created, and you can provide the comment and text from here. So anything, for example, you want to mention here, so it's there. All right. Is a acid layer or for the table. So now it is showing the notification to start it. So here you can see that all the tables which are being maintained on Databricks are going to become delta table, which is like additional layer on the storage. So when we have CSV files or anything we are querying, it can have the acid property, which is like with the structured data we do have. Okay, so next, let's say if we would like to add some rows here or something, or insert some rows, we can do that as well, like we do in the SQL. So let's say if we run this command in here, we can say that we want to change the language to SQL, and we can run an insert into command. So insert into. And for example, we can provide that, okay, because our schema, we want to default schema, and now we can have the table and values. We can put the values, and this is like, so it executed by, mistake. We hit enter here. So hit enter, and we will have bracket here. And we'll provide, let's say the first column was, I think, the integer, and then string, and then string. So integer, let's say we put 10, for example, and then in the quotation mark, we can put, let's say, department name, which is the finance, for example. And then separating from comma, we can say location, let's say anything like Mumbai. So it will add one row of this data. So this is how we can add the data. Another same one we can add, maybe we can copy this. And let's say if we putting here 11 and we are saying, okay, it's about sales. And if we're putting it here, let's say Chennai. So something like this, we can add rows into the table. Okay, so if we execute this, should work. And the requirement to run the SQL queries which we are, running here is, so it has, affected 2 rows and inserted 2 rows. So we should have, in compute, we should have our compute running and our SQL warehouse should be running. So these both, if these both are running, it means it will allow you to, fire these commands, okay, on the notebook. Otherwise, it will give you some kind of errors where you will have to work on. Okay, so this is how we will be able to, create a table, insert these, some data into it. Okay, and let's say if we would like to drop also, we can drop this, table. So this is like, we can work with the SQL commands. I hope you guys are familiar with SQL, or would you like to explore more on the SQL commands? I'm not sure about that background, so if you can maybe. But yeah, all right. I'll cover with the commands which are like relevant to the workspace, so it will make more sense for you. So this is how basically we can create a table, and like even like we inserted the this one, so we can select the data as well from here. So let's say in next cell, if I say there is select command, or I will have to change the language first, because my default language I kept is the Python. But if in case if you are working, maybe you will select your language from here once and it will always keep. But I'm just giving you the example where how you can switch between the languages in the same node. Okay, so let's say if we would like to select the data from here, so it's so sometime it doesn't work because maybe you may have different schema on the default one, so you may have issue as well. Okay, so we are able to fetch the records which we are having. So how basically we'll provide fully qualified name is that first of all we put the catalog name here. So DB, what was the name? DBWS9, and we'll hit the tape command, and then whatever the schema we are using, so we are using default here, and then the department. So this is like fully the address of the table is going to have, and basically this will fetch the same result. Okay, all right, so let me create one more, maybe another notebook. So let's go here and let's go to workspace. Now you can see I have some notebooks created. I can create another one. And let's say if I'm putting here the SQL as my language. So it will automatically be turning when I create the cell, it will have the SQL language selected. Okay, so this is my first cell. And for example, if we would like to query any table which is already there. So for example, let's go to our schema. Here we can see we have some tables in default schema. Same way, we have another catalog created, but we don't have any data here. So we just understood how we can create the catalog. And if we go to shared one, we have some sample data as well. So I believe we have some data. Yeah. So here in this schema TPCH, we have some sample data. So you can see customer, maybe line item, nation, order. So these are like tables as we have in the database. We do have the tables. Same way these are arranged. The shared schema is basically shared between all the members who are using the Databricks account. So it will be visible to everyone. But the data or the, the schemas or catalogs which are mentioned here are, personal to the user who is logged in the account. Okay. So these are not the shared one. These are like shared one. Okay. Now let's go and query one of these tables. So I think we'll go with the customer, maybe tpch and samples. So samples dot tpch dot customer. So let's go to this notebook and we'll keep the name this exact same, no issues. So let's say if we want to query this, select star from what was the schema name? Sorry, what was the catalog? So samples, right? So I'll go to samples. Okay, samples dot, then we have tpch, I think. tpch, and then it should, why I'm not bringing tpch. So we are samples, tpch, and customer we should have. So customer, let's fire it. So it should give us the result. Now you can see it is connected to a resource. So maybe we can mention it here. So it will not, giving this pop-up here. Now you can see it fetch all the records in this table. I think how many records, I'm not sure. 10,000 rows plus. It was able to fetch in 9.95 seconds. Okay. So it's very quick, to fetch this number of data in only 9 seconds. Because we are using, minimum power, which is available in the compute. So that is only we are using the resource, which is maybe around, I think 14 GB of RAM and 4 cores of CPU. Okay. And how many number of notebooks are running on this. So it will show you here the configuration that how many notebooks, are using this cluster basically. Okay, so you can limit this, maybe limit it by 100, for example. So there is limit command. You can just put the number. So it will fetch the, maybe, in some cases you may have, let's say 1 million rows or something like this. In that case, it's not good idea to, bring all the, data all together at once. Maybe you can, prototype it with some. So here you can see it took almost 2.88 seconds and it was able to bring this many of rows. Okay, now let's say, for example, if we would like to, group it or some functions we would like to use. So SQL commands will work with this, which generally we are using like select statement and all those. So it will be easily working with this. So let me see what command we can trigger here. So I think I have. Just give me a moment. I'll find out some syntax. Okay, so here, for example, we are bringing all the columns. We may pass some name of columns. So here we have these names written like CNAME, address, or maybe I'll just bring in 10 rows. So it will show you all. Okay, so here you can see we are getting these columns. These are the columns like comment, marketing segment, okay, and actual, balance, something like this, phone number, national key, address, CNAME. So these are the columns we are getting from here. Okay, so what we can do is maybe we can club it together by CNAME, for example. So let's say we want to bring in CNAME, C_name. This is one of the column. And then we want to bring in the, for example, national key, C, it came and it went. Okay, national key. And I hope CNAME is the correct one. So, okay. Next is, for example, we want to bring in the account balance or marketing segment, for example. Let's bring in the marketing segment. So C_marketing segment. So we are bringing different columns from here. And one more column, maybe we can bring in like CACCT balance. So account balance, it should be CACCT balance. Okay. So like we can select some columns and bring in or fetch it in this query. So same we do in the SQL, nothing different from the SQL. The exact same commands and almost same, identical. Now let's say if we would like to group them together, if we would like to visualize in group or something, or perform some count operation or something. So we should be able to do this. If we let's say if we go here and type count, so this is like count function. So we want to count the number of customers here, and let's say we will group it by for example market segment or something like this. And then let's say if we want to perform sum of account balance. Okay, so we are counting, we are summing it up, and we have 2, so we'll remove 1 from here. So at least we can group it by this one. So group by, and see, I think it will work before this. So group by, and then we'll say C market segment. And then the limit will limit it to 10 rows, or maybe we can make it 100, or even we can remove it. So little bit to make faster, maybe we can limit, because 10,000 rows are huge here. So I'll just limit it to 100, and we can fire it. So it should give us the result. So this will do this one. So then we can maybe, give them the alias or column name. So as, for example, I want it written as customer name. So I think it will take in the bracket. No, it won't take in the bracket, like transact SQL I am familiar with. So it will take with the underscore. Okay. So we can format a little bit. Let's say if we want to have market segment written as MKT segment. So we can write it like this, and is total balance, something like this. Now we can run this query. So it will give us the formatted names here. Okay, so this is how it's going to, format. And also we can use like some commands like distinct, where clause, and all those things, having clause, and all those things. So we may use this query in, to fetch the data and present in different ways. Okay, so this is like SQL query. And let's say now if we would like to see something on top of this. So right now it is like data which we can, so you will say that, okay, this anyways we can do the same, like querying data in the SQL database. So why do we need here? Right. So here we can basically add these to the charts. So how we can add the chart to this one. So I'll just make it simplified one again, or maybe we can go to another, but yeah, it's better to simplify this. All right, so what I'll do, I'll minimize this and I'll open another one. So that would be easy. Select star from the customer name, right? So it was where it was. Okay, so right, it was in the sample, so I'll just take it from here. Okay, so we'll fire the full query, but we'll limit it to 100. Limit to 100. Okay, now what we can do here is you see there is little plus sign here. So here we are, able to view this table, and here we can add some visualization. So if I go to visualization, it will give me visualization editor. And here I will see that we can select some columns. So let's say on x-axis, I would use, for example, market segment. So we have these market segments. So it's creating graph for us, or chart, you can say. And then I can add the Y column where maybe I can, create, for example, let's say, with the amount I would like to play around. So where is our amount? Account balance. So account balance, and we would like to sum this up. So in Y, it will have like market segment and summed it up, So this is like values we are getting here. Okay, if we would like to, let's say, group it by something. So let's say if we want to group it by national key, so it will group it by these national keys, or we can relate it to the another table, and we can bring in the names from there. So this is how we can do. So it's really very easy to work with, visualization. You may choose, let's say, line chart, for example. Maybe you can choose like pie chart. So it will give you that how much market or sum of the, or the percentage of this all, so market segment is there. So this is how you can create your visualization. You can save your visualization here. So what will happen, that you have table open here one end, and another end you have a visualization open. So, and you can rename it, let's say, market share or something. Okay, so something like this, you can give the name, and another plus you can add another visualization. Okay, so let's say you want to add it by country or something. So let's say if I go here and say market segment, and this time I would like to count the customers. So customer keys, I don't want to sum them up, I want to count them. So like this, I can count all the customer, or I can count the distinct one. Okay, so it will count the distinct customers. And so I can keep the bar chart. Maybe I can change it to heat map or something like this I can do. So I can change the scattered one. Okay, so any chart I can use which I believe is good to show my data in correct way. So I can choose some of these charts. So bar will show like this. I think bar is okay for this. So these are different visualizations we can add. I am limiting here with this data, otherwise it will give all the names here. Maybe, so this is like, we can give the name here, that clients, CLIENT, clients by, what do you call, market share, MS. So like you can, add visualizations and it will bring in some meaning. So in one notebook, you can have, one cell. In one cell, you can have a query, and in query, you can fetch the data and create your visualizations. So here, this is the advantage that you can, have visualizations in the query, and also you can associate multiple visualizations in the same notebook, same cell. And each time you can run this and it will give you the chart or updated chart. Whenever you run, whatever the data is fetching, let's say in schema, if your table is updated, so it will automatically be fetching the updated information. Okay, so this is about chart, and let's see one more thing I just wanted to share with you. I think creation we have seen. Yeah, if you have any question, any doubt, so far we have covered. So anything you would like to ask, maybe we can, take it while because continuously we are going. So maybe some of you are not, familiar with SQL or so any queries, any question. So this is how we can basically create or notebook. And feel free to ask the question anytime while I'm going through. Yeah.
Kamal, one question.
Yes,
So,
please.
so in this case, right, what you are giving one example on one table,
Yeah.
so we can execute, like we can join with 10 tables or 15 tables. We can write a query that
Yeah.
on that result we can do these charts and everything, the
Exactly.
visualization. Oh,
Exactly.
got it.
Yeah.
Yeah, but I have a question on deployment, but I'll ask later, not now.
Yeah.
How,
So
how
as
we are
we
doing, because
Mhm. Yes, continue, please.
how we are going to deploy and all these things, because usually, right, we used to develop usual in
Mhm.
on-prem, right, we
Mhm.
develop the report in dev environment, and then
Mhm.
then that will be migrated to prod. But now
Mhm.
what you are showing here, like we can
Mhm.
then and there execute the query and see the results on
Right.
the notebook itself.
Mhm.
So like
Yeah.
how the deployment and all will
Right.
happen.
See, so basically, this is like playground where you can, play around with the notebook. So when we talk about here in the workspace that we have workspace, so let's say you are, experimenting with this and you don't want your maybe colleagues to see, while you are, just it's like a development one, right? So one way is that what you can do is you can create in the workspace your own folder. So let's say here we created the client, right? So same one you can create your development, notebooks you can keep in one place, one folder, and it's like shared with everyone. Okay. Another way is that let's say your colleagues are also working on some notebooks and they are also, let's say someone is working on marketing data, someone is working on maybe operational data or something like this. So you can work on your workspace. So when you are on home, basically these notebooks are not being shared. So this is like my experimental notebooks. And once this notebook, I think it's let's say it's ready for evaluation, or it's ready for production, I can simply drag and drop into this. So from here I will simply go here and drag and drop in whatever, wherever I want in to share, and it will go there. Okay. So let's say if I just say okay, let it bring it here, so now it is available in that particular folder. So I
Got it.
think I Okay. So basically these are like files we are working in, in our directory. So nothing much. And uh, these notebooks you can, share with anyone on these folders. Okay. And you can create multiple folders. So you see notebook appears here. And while you are working, because everyone is working, it's like pilot testing you are doing. So you will be working on your own place, means your this is home is only visible to you. Only this workspace is visible to others except the users one. User one is the workspace which is visible to that person who is, that logged in. So I logged in from my account, so it is visible to me. The another user who is working on maybe the same stuff or different stuff, so his notebooks are here. So this is how you can share all this or work with this. So let me go back here. Okay. So this is like simplistic, very simple way. I just wanted to explain you about the chart and all those things. That's why it's like a very easy one. And once you have, let's say, a little bit more complex scenario, yes, you can have multiple tables. So we'll go through that as well. We'll do the joins and we'll, create some visualization around them. So little bit more complex, scenario we'll be creating. Okay, now I just want to explore one more thing here. So I think we were working on one data set or first table we were working on, and we left it in the last session, I remember. So I'll just go there. Yeah, so loading and transforming the data using Apache Spark we were working on, and I think we didn't complete this fully. So we understood about creating DataFrames, so we'll continue from there. So that example we'll just finish today. So at least we'll have more understanding. So I think I'll create one. Let's see. If I go to users, I can, I have my home folder, and in home folder, I can create, let's say, one more notebooks. And here I'll keep the default language to Python because we will be using the Apache Spark. Okay, so I'll simply just make some space. So I'll copy this to save some time. So we can simply put here, like we can create variable and put it here. So like name of catalog, like SQL statement. The one thing is that SQL statement is like one statement you can work with. Like variables and all those things are a little bit tedious to maintain. But in Python, this is we can maintain this. And last time I think we bring in this data, so we'll check if this data is available with us. So let's go to our catalog. And I think we were working with the catalog which was here. So this is our default catalog. So if you are not mentioning the catalog name, it is going here. I think which one? Yeah. So we have one volume created here. And volume is like location to keep your CSV files or bring in your CSV files. So we have some CSV file here you can see in this volume. I'll simply, maybe I can keep it. So this data we were able to bring online. So again, we'll go through this, and I think we just bring in the data, but we didn't work with the data. And your SQL, this you have to keep eye, so it keeps stopping sometime. If you are not using it maybe for 10 minutes or so, it's going to stop. So I think I will have to increase the time. Okay, this one looks like working. Okay, this one is working. I'm not sure about this. Let's see. Yeah, so this looks like has stopped or stopping. What's the starting? Okay. So let's see. Sometime it will give you the false information as well. So I mean, on production, you will have more resource, but when you are doing the lay with the personal resources, you may struggle with this because this is very small one, tiny one. So it's going to take a little time. All right, so we'll continue with this, and we have catalog name, and then we'll provide the volume name, schema name, where we want to keep, and we want to bring our data from here. Okay, so this is like open data which is available on this CSV file on over the internet. We can bring in the data from outside, and then we'll create a table with the table name. and that is going to be into this volume. Okay, and you can see that schema and these variables we are basically calling here and putting it here. Okay, so let's see in the catalog we have one rows I think we have bring in last time, but again we'll do because maybe it was for very fast for you guys. So we have DBWS_9, the DBWS_9. This is our catalog name. Okay, from here we can see. And then schema, I think we can keep it default. We'll check it, DEFAULT. And the volume name was volume 1. And this is our download URL, so we don't have to touch it. And the file name is rows.csv. And then the table which we would like to create out of it is going to be, let's say, rows 1.csv. Okay. Or I think the table name is going to be in different. Let me double check here. Yeah, it should not be. So I'll just simply mention it table 2, for example. And then this is going to be the path of this. Okay. And then the catalog, schema, and path of table, path of volume. Okay. So let's run this and see what happens. So if we have error also, it's okay. So see, my computer resource is stopped. So it may take time. That's the problem here. Maybe I will have to increase the time here for computer resource to stop. Otherwise, it will keep stopping. And our computer resource, I think, let's go to computer resource while it's starting. We can simply click on this. So I keep here 10 minutes. So I think I will increase it to 30 minutes. But since it's starting, it will not allow me to change. So whenever, my computer resource is, being not used for 30 minutes, it will wait for 30 minutes and then go for shutdown. So I think last query we fired and it took, it almost, we spent maybe 10 minutes or more. So it stopped. So here you will need to increase the time. Okay. Okay, finally it looks like it started and I should be able to, still I am not able to, or I will have to go here and edit basically. Okay, so I'll make it maybe 20 minutes should be reasonable, or 30 minutes. It's better to keep 30 minutes to be safe side. Sometime we are, so if I confirm, I will have to start. So I will stop it. No need to change right now. Whenever I'm available, I'll change it. So, okay, so let's trigger it and it is triggered. So let's see what has happened here. So we should have something in the volume 1 and we should have in the default schema something. So like these both are the path, and we'll go to our catalog and we'll refresh it. So if we go to volume 1, or I think I'll have to reload maybe. So it will reload my schema, volume, everything. And looks like it didn't come. Okay. So let's see. Wow. Still, it didn't come here because, yeah, we didn't fire the actually command. We just fire the command and declare the variable, and it has given the path. but we didn't actually perform any task on this, or we didn't actually created this, right? So next is like we define the variable here, but we didn't say that, okay, we want to do something with this. Here next is what we'll do is we'll copy and paste the, this code. So I'll take this code and I'll say, okay, in next cell, you do one thing. So we'll say, okay, we have some command in DBFS basically, which is called dbutils file system and copy. So we are saying that to copy this stuff into this. So we have declared the variables and we have the path of volume. We have the file name as well. Okay. So we want, let's say, if I make this file, for example, this one, if I change this better, because we have rows .csv already. So that's why I'm changing it here. And then I will fire this one. So it will have updated variables. Okay. So what I'm saying is from this download URL, you put a file or copy this. So this is like source. When we are performing the copy command here, this is like source we are saying before the comma, and this is like destination. Okay, so this is formatting of the string with the along with the variable. So to bring in the variable here, you have to have double quote and the curly braces, and here you can use this quotation. So it will use this variable from this this cell and put it here. So like this, it will create a file name. So let's run now. Actual, it will copy this. So it will use the compute power which we are using here. Okay, so true means basically it was able to create the file. Now we can check it here. So if I maybe refresh data frame, okay, I'll go here, default one. And if I go to volume one, see, now I am able to view that I was able to bring in the data from that one, and that is the table name. Oh, I have given is the rows one.csv because I have already bring in one, so I could delete it, but it's okay. I could change the name. So this is how we'll bring. And now what we can do is we have bring in the data in CSV file. Now we can play around with this data, means we can use the data frame from the Apache Spark, PySpark we can say, and we can use this data. So before that, like what we are doing is that we can create a data frame itself from the blank one. So the blank one also we can use. So this one I will just keep it aside. And what I will do is I will copy one more cell here, or bring in one more cell and paste some code. So what I'm trying to do here is that I'm preparing an array of data. So this is like JSON, you can say. In JSON or the Python, basically, not JSON, sorry. It's a similar, thing. So the Python is also having the same thing. So yeah, we are creating a array of data, and so it's like one row having 2021 test, these like columns, and we are defining the columns here in Python, that okay, we want to create one year, first name, country, sex, and count. Okay, and here what we are doing is whatever the data frame name we would like to keep, we are keeping the name here. So df1, we are keeping the name of data frame. It's not like fixed one. You can put any abc, xyz, whatever you like. You can put the name, and then you can say that spark dot create data frame. So this command will basically create a frame of data. So data frame is basically frame of data or set of data, you can say. So this is what it's going to create, and what you want to bring in. So first parameter is the data, what exact the data you would like to bring in. What is going to be the schema of this? So we are defining the schema, that year column is going to be integer, first name is going to be string, country is going to be string, and like others string and int. So this is what we are defining here, that this is going to be the schema of our data frame. Okay. And then there is one command called display and df. So if we are going without display, it's going to give us, you know, very basic one. So what I will do is I will change it here, maybe hit enter, and I will say df1. Okay, so it's going to give us the data frame 1, but it will be the row. I think I think it should work. Let's try it. If it is, I'm not sure, because df1 show work in that way. So I'll just comment it out, maybe just to test. Okay, so let's run this, and we can run it multiple times. So here it will show the result like this way, that what, you know, structure you have here, but it will not fetch in or bring in the data. So when I type this df1, it will bring me this data frame information. Okay, so let's remove this, and now what I will do is I will just try it. So yeah. Okay, so let's say if display command, before display I just wanted to test another one, so let's bring in here. Okay, so df1 show command, we'll see how, you know, it shows. And I think I'll put here. Okay, why it's giving the error? Let's see. Let's try, in case it will at least give some meaningful error. So sometime false alarm also it's giving. So now it will show you the structure of data, as well as you know, very basic primitive way of displaying it. So it's not formatted properly. We cannot use like a space and like this. So this is very basic one, df1 dot show. Okay. Next, another command is, if we wrap this up around display. So just enter. So this command will show us nicely the data frame which we have taken. So let's say if I run this, it will show me the data in nice formatted way. Okay, so this is the you know, very common command, display data frame. Okay, this is like a method. All right, next is how we can load the data. So what we have done here is that we created a data set or data, and we put that data into a data frame. Okay, by using the create data frame command. Now we would like to see that how we can load the data from existing file. So basically we have file here, rows1.csv, and we would like to bring create a data frame out of it. This is what we are trying to do here. So let's say, for example, we want to do this. So I'll just minimize this cell. Okay, and I'll click on plus code. So another cell I'm going to add. And definitely I showed you that you can put the title, what you are doing in this cell, what you are doing in this cell. So you can keep putting the titles, so you can keep track of this, you know, whatever you're doing. Okay, so for that, what we'll do is we can simply, I have some code, so I will paste it here. Okay, so this time I'm saying that, okay, data frame underscore CSV. So create a data frame with this name and spark.read CSV. I'm saying that, okay, you read this CSV file from this path, which we have already put in the first, you know, cell. So the same variable we can use, and from this path, you use this, and it will have a header basically, and it will use the same schema which is being used in the CSV file with the separator comma, and then you display this data frame in the CSV, or this, you know, data frame with the display command you show. So you run this. Okay, so it will fetch all the data which are available in that CSV. I think there is huge amount of data, looks like 10,000 plus rows. See, so this many or the data is taken into the data frame. Data frame is like memory, data into the memory, and as we know that Spark run in memory processing, so it's taking into the memory and processing it. All right, so any command or anything we are running on top of this is going to be in memory, this stuff. All right, so we can, for example, print the schema from here also. So let's see how we can print it. So I can minimize this cell and I can go and create one more cell. Okay, empty cell. So I can keep creating the cell. Maybe it will go 10 pages. It's okay. So this is how basically the advantage of this, that we can have multiple cells, each cell is doing something. So basically we are segregating or commands, or we are organizing the commands related to a particular data set or data frame or something like this. So we may have multiple notebooks. Each notebook is performing some sort of task, something related to some particular data, and we can keep all this organized in a folder structure. So next command we are going to talk that we have now two data frames. One is we created using the CSV file, right? And the second one we created using the data frame or creating the data frame ourselves. Okay. So we do have two commands here, and I'll just trigger it. So it will show me the schema of each one. And like here we have, different namings, except this column, all looks good. Okay. So what we can do is we can combine this data frame together. Okay. So how we can combine? We have one command, which is, let's say, create a new cell. So here in this next cell, we are going to combine this data or data frames, and I'll put this command here. So data frame is equal to going to be data frame 1 union with the CSV. Okay. And then we can display this data. Okay. So let's see if we can run this. So number of rows and all those things we have together now in this data frame. So dfs underscore CSV we have combined with the df1. So these both were different data frames, and these both are combined together. So column by column it is combined. So order of the column has to be the same, so it will combine properly. Okay. So this is all about the data frame we have and how we can use the data frame, how we can use the data frame maybe with the visualization, or even data which we are bringing in, we can have visualization added. So and then visualization make it powerful, because visualization we can use in the dashboard as well. So it is a huge advantage working with the Databricks. The data is from different sources we can combine, we can work them together. Maybe we will look into more data sources, then it will make more sense to you guys, because right now we are working with the CSV file, and this looks very primitive or small sort of data. But when we are working with the multiple type of sources, and then if we are dealing with the huge amount of data, in that case it will make more sense. But yes, to pilot test you will have to work with the small set of data, because in development you will have a minimum resource or whatever minimum resources available with the organization. They will not allocate you the huge amount of resources on non-production environment. They will just give you the basic one. So maybe if you are working with 100 or 50 rows, it's more than enough. Okay. Yeah, that's it about this data frame and this topic today. And maybe we'll discuss more detail about these things in next session. So at least you should be aware of the compute, catalog, and workspace. These three things are very important. Right. So when we so far we have having these classes. So in these classes, we are trying to use the compute, that how we have configured the compute, how we have, used this catalog part. So how the catalogs are, organized, at least we can make this sense. So catalog is using the SQL warehouse, so catalog is running using this. Compute is having two sections, mainly the SQL warehouse and the compute power. These both are working together. So compute is like computer which is running in the background for us. SQL is like SQL commands you can, run with this warehouse. And yeah, catalog is like organization of your data and, schemas and all those things. You may have multiple catalog. Catalog is, providing you the feature to separate your data from, maybe you have each catalog created for different client. So let's say if your company is dealing with the 10 clients, you can create the catalog for them and, bring in their data into their relevant catalog. So at least you can configure the, relevant permissions. So you may have multiple analysts working on, huge set of, clients, and you are using maybe the same environment, and, you can separate it by the catalog and the permissions. So you can separate your data from, each other. Here also in this shared one, maybe you can use, shared data, which is commonly available with each other, and, you can use in that way. So I hope it's making more and more sense, because it should be at least clear about the notebook, key playground for us, which is combining compute power, SQL, everything together. All right, thank you, and see you tomorrow. Yesterday we created this notebook, and what we have done is that we defined some variables here. Maybe it is a little bit small, so I can make it big. Yeah, so we created these variables where we pass the catalog, schema, volume, and we downloaded this stuff from here, and we put into this CSV file in the volume. Then we just declare these variables in this cell, and here we copied this file. So the file which is available over the internet, we copied into our file system using the dbutils fscp command. So this will copied the file from over from the internet to our volume. Next, what we did, we created a data frame, and this is not related to these two cells, because this data frame we created independently, means having some test data. Okay, so this data we have created like manually. We created columns, we define the data, what data we are creating here, and then we put all these things into the data frame. So using the create data frame command, we created the manual data frame, and then we displayed it. Okay, so this is the one. Next, what we did is we read the CSV file and created a data frame. So this data frame, which is defined here, is df1, and another data frame which we have created is df underscore CSV. Okay, and this data frame we created using the spark.read.csv command, and we pass the path of the file which we have created using this command cp. So the same path we have passed here. Okay, and this data frame is created with the header, and the schema we have used from the file itself with the comma separated file, and then we displayed the data and it showed the data. So it fetched almost 10,000 rows from here. Okay, now next what we did is we printed this schema. Okay, so we printed the schema for the database data frame which we have created from CSV. So df underscore CSV print schema command prints the schema and shows that what is what. So you can see the year, column is there, and that is a integer and nullable. First name column is there, county column is there, sex column is there, and count column is there. So these are the column, and these are the, nullable is equal to true. In DF1, we created these columns manually. Only the difference you can notice here is that the first name here is first and space name, and in the second one, data frame, we have a different name here, first underscore name. So next, what we supposed to do before we combine it, we supposed to have done one more cell where we could make these columns both same. So first name and first name, we could make it same. So we'll start from here. Okay, so let me see. Okay, so what we are planning to do here is that we want the column name same before we union or mix this both the data frame together. Meanwhile, we do this or write on this cell. What I will do is I will start the compute resource. So we will save some time on here. So I'll start it. Okay, and we go back to our notebook. And we'll say, okay, we want to change the name of the column in the first one, which is the df underscore csv. So for example, if we go here and type df underscore csv and is equal to, we want df underscore csv only, but we want with column. Actually, it should give us, the IntelliSense means it should automatically be giving us the suggestion, but sometime it doesn't. So, or it takes time to, give the suggestion. So this is the command that with the data frame, we want with the column renamed. One column we want to rename. So which column we want to rename? We can mention the column here. So let's say the column name right now is the first space name, and we want to rename this column to first underscore name. Why we are renaming it? So the second one, it will match with the second one, and then we can merge it so it will not have any problem with the columns. Okay, so let's run it. Or before we run, I think we will have to run this because our cluster is not started. So we'll have to see, let's the cluster start first, and then we can run. So it will not run successfully if I run this cell. I'll show you right now. Let the cluster first get up. Let's go in here and see what's happening. The bad thing here is that it doesn't show any progress, that how much time remaining to get it up. We have no way to, we just have to wait only till it gets up. So it should give us some sort of progress or estimation, but it doesn't. If we would have, multiple clusters, then it will show us all the cluster and we can create the resource as well from here. And basically, this is the place where we are attaching this notebook with these clusters. So let's say if we have multiple cluster, we can choose which cluster we want to run this notebook on. So yeah, now finally it is up, so we can use this. And now I will show here, let's see. So we'll fire this, cell. So it should work, but it will maybe it will throw a error. So I just want to show that. Okay, so last execution failed here. The reason is because df underscore csv is not defined. The reason is that we haven't run any of this cell right now after sorry, starting this cluster. So if it doesn't know that what is what means what these variables are, so the system is not aware of these variables which are declared in the cell one, because it is not it's not run so far on this cluster after it's getting up. So we'll have to run these all things before we execute this. Okay, so what we can do here, we can go simply here and say run all above. So it will run all the cells which are above this cell. So let's run everything above this. Yeah, so it's running, waiting sign is there everywhere. So this ran, this finished, this right now it is here, this ran, this here, now it is running. Yeah, data frame created. Okay, this ran, and now we are available. So all the cells above this, successfully ran. So now we can run the this cell and it should work. So now we can say that, okay, in this data frame, rename this column because this is in memory right now. So we can say, okay, run this. Okay, so it has given us that what is the structure now. It's going to have the first underscore name because we renamed this column with this one. Okay, so now we can see this here. Okay, now we have union statement, and we can say that, okay, data frame is equal to data frame 1 union df csv. So we want to combine these both of the files or data frames together into data frame. So we are basically creating a third data frame out of these two data frames. So we are combining these two together and creating the third one. So let's say if we have two different sources, and maybe in this case we may have multiple union as well. So we can fetch the data from multiple sources and we can union them together. We can maybe format little bit of their columns and their data types, etc., and we can union them together and make a large data frame. So this is how we can combine them together. All right, so what I will do is we have combined this one. I think we already ran this. So this data frame is now yesterday, but we missed this step, so we covered this one. So we can say we are renaming columns. Okay, now we have combined this data and the output will be a combined output of these both. So we have only one row because we manually created it, but still it will be there. Okay, so this is now we have done this. Now let's see what else we can do. So on this data frame, now we have data frame. And let's say if we would like to filter. So in SQL statement we can have where statement or something like this. So let's say if we want to work with this data frame now, and we want to filter it using some method. So let's see. So we can say, okay, data frame df, and then there is these are some of the commands available. So we can say filter, see if there is a filter command. Okay, and then in df we want to filter, and what you want to filter. So df filter, and then what we can say that df and square bracket, we can say that we want to filter it by some column. So let's see what we can filter upon. So we have like count folder column, county for column, and this column. So let's see if we can filter it by count. So what we'll do is we'll go here and type count. Okay, and in count we have these numbers. So from these numbers maybe we can so this is like a column. So data frame and square bracket and count we are providing. So we are referring here the column name. And let's say because this is integer column, so we can say, okay, filter it by 50 or something. So greater than 50 we want to see in this data frame. But now if we just type like this, it will give us the row format, and we want to display it nicely. So we'll say, okay, display, and then bracket, and then we can wrap this whole entire statement into the display one. Okay, and then we can run this. Let's see. So it has given us the result with the count, which is having more than 50. So if let's say if I make it 500, I think I will have little bit more refined. Or there is no one 500, maybe 100. So see, more than 100 only we are getting. So like this we can filter it. I'll just minimize this one to create the space. Okay, so like this you can filter with the one of the column. Okay. All right. So this is how we will use the filter, but there is another method also available. So what we call this method is use of filter method. Okay, there is another method which is called the where method. Just okay. So next method is the similar one, but is a little bit different. So we can say data frame. We are same like the above we are referring here. And if we type where clause, okay. So where clause we can put, and it will work similar to the filter df, and then we can pass the column name. So the same query we'll use like count, and let's say greater than 100. Okay, so it will work in the same way, and then we can wrap it around display. So the same command is, it will give us the same with this maybe equal sign, less than sign, or any other column like string comparison, all those things we can perform. So that is possible with this. So it is able to fetch all this data. So let's say if we want to filter it for let's say one county. So let's say county is equal to Kings if we provide here. So just to test with this COUNTY, I think county, and this is a string, so we can put equal to sign, and let's say in quotation mark we can say kings, something like this. So we want to filter it by this one, so you'll see only the records which are having county is equal to kings. Okay, so like this filter will work, or the where clause will work. So this is like use of where method. Okay, so we use both the method and have seen that how we can filter it. Now what else we can do with the data frame which we have here? So we can, let's say right now we are getting all the columns here, all the columns available here. Maybe we have, in some data frame we may have many columns which we don't want to fetch altogether. So we want to select some columns. In that case we can we should be able to select the columns which we are looking for. So let's see how we will do this. Here we'll add another cell and we'll say, okay, we want to select some columns. To select the columns, we can simply say data frame, and there is a command called select. Okay, and in this command we can pass the column names which we are looking for. So what are the names we do have here? Let's go. So we have year, first name, county, sex, and count. So we can fetch this column. So let's say if we just want to bring in the first name, first underscore name. So sometime IntelliSense works, so that's good. Then let's say we just want to see the count. Okay, so count. Okay, and county. So count. All right, so we should be able to see these columns. So I will just make it nice just by having display. So display is always being used basically, and we can see all the result which are having only these two columns. Okay. Now let's see if we want to order this result which is coming in, maybe by text or by, numeric number. So we should be able to order it as well. So uh, what we can do here, because this is like display, display bracket. So before that, what I can do is I can put dot, and there is command called order by. Okay. So order by, I can mention how you would like to order by this result. So I'll say, okay, make it descending, and descending by count. So I can say count. So basically what it will do, that it will fetch these two columns and then it will order it by descending. Okay. And the column it will use to descend is the count. Okay, so let's see. It's firstly, I think it's giving firstly, but let's see. And we'll just run this. What problem has occurred? So dot order by is okay, and then we have DESC, and then we have bracket, then 3. So name DESC is not there, so I think maybe here DESC descending. Let's remove this and try again. So at least this should work perfectly. It just makes sense. Okay. So this one, up to this point, it is working perfectly. Then we say order by and two brackets, right? All right. So we'll say here DESC. DSC should not be there. DSC only it was. Let me give a try, and maybe the column name was correct or not. Count. But it's giving the error here only. I'm not sure why. Order by DSC. Okay, and this is fine. This is 3 bracket. Let's try it. Try. This DSC it is not accepting. Okay. Right. Yeah. So basically the error is because this DESC or descending in the order by requires an import. Okay. So that's why it's not taking. So before that we used the order by, we have to have some sort of import. So from PySpark, because this is the PySpark function, and SQL.SQL, and this function we didn't import, that's why it's giving error. Import, we want to import DESC. Yes. So this is the reason, that's why it is not identifying this. So hopefully now it should resolve this issue. Yes. So this is a PySpark SQL function which we had to import, and once we imported it, it is working and it's not giving any error. So now it has sorted or result in this format. So descending order, ascending order, all those things will work. Okay. So like this, you can order it by and select particular column. Next is if we want to, let's say, because we have this data and we don't want to have all the data selected, we want to select some subset of data, means we just want to create a data frame out of this data frame. So what we did earlier is that we combined 2 data frame, so it was like union, and we created new data frame out of these 2 union or 2 data frames, right? So now what if we want to create another data frame out of this data frame, which will be filtered one? So let's try this. We'll just go here and go to code and write into this cell. So here we did is the order by method. We used the order by and we ordered the data. And also we used here is select method, select and order by method. So I will just type select and order by method we have used here in this cell. Next, what we'll do is we will create a subset of data frame. So subset of data frame. Okay, so we are creating here subset of the data frame which we have already there. All right, so let's give the name, let's say subset of DF data frame, and whatever name we wish to, we can give here basically df dot filter. And what we can do here is we are using the filter one which we have earlier used. Same way we can filter the data, and we can use multiple filter basically here. So let's try with the one. So data frame, we want to filter with the column which is year column. I think this is the first column. Let me see, year column. So yeah, I think it's better to wrap in double quotes. Sometime it can give error. So year column, and we want to filter it by year column. So I'll just verify here. Not here. Basically, we haven't used year here. Like here we can see. So Y capital YEAR. Okay, so we will use this column to filter this. Okay, and what will be the filter here? We want to filter it by, so year only we want to include, which is the year 2009, for example. So this will create a sub data frame. So we have this larger set of data frame where we may be getting 10,000 records, and we want to filter and work with the subset of this data frame. So we can filter it. So let's say we just run this. and it has created the data frame with the all these fields. Okay, so if we want to see, we can just create another and say okay, display, and we can say subset df. So in this command it will show us the result. So it will create the data frame and it will show us the result where all the year column is 2009. So still we have very long number of data. So we are getting 6,312 rows. So it was above more than 10,000 basically. So 6,000 rows are having year 2009 only. Okay, so this is how we can filter it. Again, what else we can do is we can have here is we can use multiple level of filter. So what I will do is I will wrap this around one more bracket. So then I will put the condition end, and I will use another bracket. Okay, so I think I have done it correctly or not. Yes. So we have two bracket here because one is this condition, and with ampersand we are adding another condition here. So another condition, let's say we want another filter on different column. So this time we want a filter count column, and in count column we want to filter it by because it's an integer, so maybe we can say we want to filter it by 100 or maybe 150 or something. So whatever this number we want to filter. So we are applying two filters here and creating a subset of data. So now we have 36 rows now. Okay. Same way we can add more conditions. So we are trimming down these data, which may be a huge data, and like same way like we do in the let's say in SQL Server transact query, but only here the way to query is different. It's not a SQL statements. So same way we can add another condition, and we can further drill it down. So let's say if you just want female records. So here let's say we can say sex is equal to, because this is a string, so is equal to, and we can say I think how the data is going to be. See, M and F. So I will just trim it down to F. Okay. So now my result should be further trimmed down, and I should have only, so we got only 7 rows out of it. This is how we basically trimming down or filtering out the data which we have available in the data frame. Okay, next is what else we can do with this is maybe so now we can combine. So here we have use one statement where we have used in this one I think we have used select. So next what I can do is I can maybe select particular columns in the next statement. So here we use the filter one. So df dot filter, and I can add another condition on top of this. So I can say, okay, you filter it down by this one. So data frame is filtered down by multiple conditions. Now, without writing another statement, I can add another statement here. So I can say, okay, I just want to select on top of these. I just want to select a few columns only. Let's say I just want to see their first name, for example, first underscore name. And I just want to see their county, for example. Okay. So I just want to add these two columns. Okay. Or I just want to see these two columns. And I can just run. So it will not give all the columns and their first name and county only available. So what I did here, I use the filter statement. Okay. And on top of this filter statement, I connected it with the dot and said, I want to select these particular columns. Okay. So this is how I can, and on top of this, maybe I can, add more. So let's say we have here county, and let's say with the comma, I can add count. Count column was there, I think. Yeah. So let's see if it is working perfectly. So now it is returning 3 columns. And on top of that, I just want to add another condition, which is like order by. Okay. So order by, and I will say order it by descending. And you can see that in previous cell, we imported something like this import descending. That's why it is available here. We don't have to import it again and again in next cell. So descend it by count, for example. Okay, so how many conditions? We first filtered this data with multiple conditions, basically in the data frame. And then we selected specific columns. Then we are ordering it by, so 3 conditions we basically put together. And then now we are showing it here. So if I run this, now you can see that my data is ordered by descending count, filtered by gender, okay, here, and also, yeah, first name, county, and count is returned. So all the conditions are meeting here. Even if I just don't want this display here, I can use it directly as well. So I can wrap it around display. So even if I am not writing this, I can write display here, and without a subset of data frame, I can use this. All right, so subset of data frame we understood here. What next we can do is, now let's say if we want to save the data frame. So we let's say this data frame or any data frame, we want to save it to a table. Okay. So if you remember, we haven't used a variable in the first cell, this table 2. Okay. So we don't have, we didn't use this variable. We created this variable here, but we didn't use it so far. Okay. So if I go to the catalog here, and if I go to, because we are using default catalog for storing the table. So we can see we have department, organization table. In volume, we have some files here. Okay. So these are some of the files in volume, but we want to place, so whatever output we have used in data frame, we would like to store it here in a table format. So we can later on, maybe we can include with some other, other maybe Python files or something, and we can work with that. So that's the idea here. What we'll do is that now we'll create a table out of this data frame. And if we go here, you can see that we have given the table name, which is the table 2. So it should create a table with this name. Okay. So let's go down. And now let's add one more line of code here. So here we are trying to create a table, and so for that, create table from data frame. Okay. So we are going to create a table, and we will say, okay, data frame. So we have data frame which we have combined together, and then we have one command called write, and we are going to write this command with the mode to overwrite it. So if we have existing table, it will overwrite. Okay. And then we are saying save is table, and then we can pass the name of table, by which name we would like to save this table as. So to have variables called, like we have seen earlier as well, I think. to have these variables called, we will have to put like f and double quote and the path in bracket. Okay, so this is how we can call these variables. So if we see the variable here, we have path of the table and table name. So path of the table is going to be catalog and then schema. So these two variables are combined. Catalog.schema is the path of table and the name of table is table name. So we will be using these two variables. Go down. And here we'll say, okay, we want to say, so we'll start the string with f and double quote, we'll put a variable. So variable is going to be in the curly braces and we will say path of the table and we want it connected with the dot, having another bracket and table name. So both the variables we are calling here. So path of the table will have the schema name on the catalog name and table name. Okay, so this is how we will be creating it. So let's see if we can create this table. We'll just run this. So it should be writing our table on the schema. Yes, so it successfully written the table. Let's see these all the details. Let's verify it on the catalog itself. So it will, what we'll do is we'll refresh it from here. Now you can see we have the table 2 created, which was the name of table. Okay, so from the data frame, we are able to create a table which is having, all this data available. So this we will have to, if for SQL we want to see, then warehouse cluster we will have to start. Okay, so this is how we can create the table out of data frame. Now let's see what else we can do here. Okay, for example, we don't want to create a table out of it and we want to save it somewhere with the, as a JSON file or JSON data. Temporary, we want to store as a JSON data or something like this. Then maybe how we can do is, save data frame as JSON. So we can use it later on or something like this. So we'll look into it, how we can do this. So data frame, let's say we have write command here and we can write with the format. I think we should have df.write. Let me double check formats. The weird thing is sometimes it doesn't, give us correct IntelliSense. So here we can define the format. We want to write the data, but with which format? So we can say, okay, we want to write it by JSON format. We want to save as a JSON format. And what mode? So mode is going to be that we want to overwrite if it is already there. Overwrite. And we can write and then we can save this into temporary storage. So it is going to be temporary and we can say whatever the name, JSON and data. Okay, so this will be saved into the JSON data file and this will be the JSON format basically. So it will convert it for us as a JSON format. So let's start this one. Okay, so it ran successfully, looks good here. If any error is thrown, then we could have suspected. So let's read from this if it has saved into this JSON format, we should be able to read it from here. So let's go and read from JSON, what do you call JSON file. Okay, so we are going to read from this JSON file where we have saved. So we can say, okay, Spark read command is there, and read with the format, which is the JSON format basically. So same like you can see from data frame, we are writing it, but this is the Spark command which is going to read the data in this format. Okay, so JSON, and then we can say, okay, dot JSON, and then we can put this path, so TMP and JSON underscore data. Okay, so yeah, so to fetch the result in nice format, we should use display command. Okay, looks good. Should not throw any error. So I'll start with this. Yes, and the data which we have saved here in JSON file, we are able to fetch it from there. Okay, so this is how we'll be saving the data if we wish to save in JSON format or any format for that matter, and we can read from that file. Okay. All right, so next thing is that, let's say if we want to use some expression or mm, like some SQL related commands we want to run or transform this data a little bit or change the way this data is. So how we can use it. So there is one expression or one what do you call function is there, which with the data frame which we can use. So we'll use, basically we'll be using a select expression function in data frame. So how we can use and how it will be helping us to display the data, or how what formation it's doing. So we'll understand about this. So we'll call data frame, and with the data frame we'll say select expression. Yeah, this function we are going to use, and this function basically will take the columns, and if we want to do something with the column, we can do. So let's say we have a column. If we see and go the data here, data frame, right? Yeah, we already fetch it here. So data is same basically. So we have these columns here, right? So county column, we can format, or count column is also there. So let's go down. Sorry. So let's use the count column. Is we are not doing any formatting on this column. And let's say if we want to format this county column, which county column we are getting, like first letter is capital and others are small letters. So if we want to change it to uh, upper case, so we can use upper and county, okay, on this county column, and we can show as maybe like county with uppercase or something. Okay, something like this, whatever the name, like it's the alias we can use, okay, of this column. So on this column, basically we are performing this SQL command. Upper is a SQL command which we can use, and this SQL command will be performed on this one. So select expression allow you to perform some sort of SQL command on your column, and that column can be represented as alias. So let's perform this, how it works. Yeah, to show this, like it has showed that it was able to bring in the count column, which is the int, and county upper is string, but we are not able to see the data. So to see the data, we have to use the display command, display, display command. Now you can see that we should be able to fetch this data transformed. So see, all are in uppercase. Okay. And this is like count column without any alteration. So we are able to fetch this with this select expression statement over the data frame. So this is how we can, change this data in, different format or whatever, function we want to run or SQL function we want to run without using SQL. Basically, we are, using here DataFrame, and in DataFrame we are performing some SQL, tweaking, and we are using the Python language here, right? Okay. Next is, let's say there is one more, function which is available. So we'll look into it quickly. And yeah, one more function is called expression or express, something like this. So how we will be using it? Data frame, let's say, and we can use we have already seen the select. So let's say if we are using count column and we are using, let's say, county column. Okay, county column. So it will be returning these two columns from our data. But let's say if we want to change it with the different function. So we have seen here select expression. Okay. Here we were able to transform the column. But let's say if we want to use another PySpark function, which is the express function basically. So in that case, we can to use the express function, we will have to import it. So from PySpark .sql, this is SQL function, okay, functions, and we'll import expr, this function. Okay, so we are going to import this one and we will use with this county column. So basically here we are using this in the quotation. If you notice here, we are not importing anything and we are using the upper, in this double quote. But in this expression function, which is the PySpark function, we are going to use it outside because this is PySpark function. So we can say XPR, okay, and under the bracket, we can say, okay, I just format it better. Okay, so we are basically creating another column. I'll just, yeah. All right, so we are going to use XPR, okay, and we are going to put lower, okay, county. Okay, so this time we are, formatting is with the different, function. Okay, doing the same job but with the different function. That's it. How many quote, how many bracket? 3 it should be. Let's see if we are correct. So one bracket is here, second is here, and yeah, so it should be. Let me see if I am doing any mistake here. Yeah, it should be 2 only. One is when we. Okay, so here what we are doing is with the express function, we are lowering the county, because in county we have first capital letter and all the remaining letters are lowercase. But if we want to lower down all the letters, in that case we can use this function with this import. Okay, now we can show this data frame into display command. So let's say display, and we can wrap around this and let's run this. So now you can see the result is, in lowered case, all the result which is coming in the lowered case. So this is about the expression function. Okay, in some cases, we may require to run, for example, a SQL statement in the PySpark. So here, let's say we are, in this function, if we want to run, instead of going to import and, going to call this, or, changing this little bit, if we want to run with the entire SQL statement, how we'll do this? So we can go to next cell, and so this was about select express. This was about expr function. Okay, and this we are going to go with the SQL in this one. So in that case, we can say Spark dot SQL is there. So we can use this SQL, and simply we can use the statement. Okay, so SQL statement we can use with. Okay, and what is going to be the SQL statement? Basically, like we can pass it like a string. So F double quote, and like we can say select star from, and we can use the variables here. So we have table path, which is like catalog name, and or like we can directly pass the name like default and catalog, or manual also we can do. So DBFS dot default, for example, dot what was that, tables 2. Okay, so like this I can put, and it should work. So let's test it, but before that, the result we have to display nicely. So we'll use display is always there. Basically they should merge this command permanently. They should make it available. So here if I see that, now I can see that my data is being fetched using the Spark SQL command, and this is the simple SQL statement. Okay, but now if I want to pass here let's say variables, and that is also possible, because this is already wrapped into the variable, and I just need to put into the bracket. So we have two variable with the dot, and I think we should be able to use this. So one was like path table, and second was table name. No, not this one, table name. Okay, so these both the variable we are using, and it should do the same job like which we have done manually. So we are just calling these variables. Just start this, and it should be able to fetch all the records. So yes, it worked, and it is able to fetch these records using this one. Okay, this is how we can use the SQL statement. So let's say if I want to, show some column only, let's say first name, comma, county only, then also this will work perfectly. Okay, so whatever we can do in SQL statement, we will be able to do this using. All right, so this is all about the data frame and the Spark statements, how we can, use these, how we can manipulate the data, how we can save or read or create a JSON file, so mostly we have covered, so many things here with this one. All right, so thank you, everyone. In today's session, we are going to learn about repository, means how we can save the notebooks to repository. So how we can have the version control in the Databricks. I hope my screen is visible. I'm not sure. Yes, it looks like. Okay. Okay, so we'll understand how we can have notebooks having on the Git repository, how we can save the notebooks on the Git repository, so our other members can use that, or maybe update the repositories or the notebooks which we are using in Databricks. Okay. So if we go to the workspace here, a little bit make it big. So we can see here repository or legacy one, and the same thing I think you will find here in workspace as well, repos. So these both are basically the same thing. It will be removed from here and placed here. That's it. Nothing much changed. So in this repo, basically in the workspace, we are going to keep all our notebooks. So notebooks we can keep in repos. Let's say it may be the GitHub, or it may be GitLab or Bitbucket, or any version control system. We can put our repos or our notebooks into it, and our colleagues can update. They can fetch from there in their workspace, and they can work with these repos or notebooks, and we can collaborate with each other. So we can maintain different versions of the notebook, and we can work together as if it is like for example, we work with the code, or the coder especially, they use the GitHub, etc. So same way we can also use it. So now let's see how we can set it up. So there is a lot of documentation, but we'll just navigate through quickly. So set up Databricks Git folder. Here we will configure the user settings. Let's see. So basically we use the personal access token. This token can be generated from our Git provider. So let's say if it is GitHub or GitLab or anything, we can produce a personal access token, and then Databricks can use this. So assume this one as a key to access our GitHub account. So we can use the personal access token from Databricks, and once it is generated, it is added into Databricks account. Databricks will be able to access the GitHub account. One more way is like you can go to the username password approach as well. So that is also possible. So most recommended, or recommended way is to use the personal access token. It's more secure. You do not require each time going with the password. Maybe you can change the password, but your token will remain available or accessible to the Databricks. Either you change your password, it will not impact. So that's more a recommended way. And how we will configure or access or the configure with the GitHub. So here these are the steps. We'll go to the account name. Top right screen means in the Databricks basically, and then we'll go to settings. There we'll find the linked account tab, and there we are going to configure it, or we can change it. So we can provide either Git username and password. Let's say if we want to integrate with the username, password, or email, that also possible. Or if we want to use it with the personal access token, that is also possible. So here we'll just provide the name or email, and here we'll provide the personal access token. All right, so it's very simple way. It's not a very complicated one. It's easy to configure. So I'll simply take you there. Let's see if anything important for us. Yeah, these are some of the security feature in Git folders we can configure. So like encrypt Git credential, allowed list, access control, audit logging. So these are some of the feature we can, have on this one. Even we can restrict the usage to URLs in allowed list. So let's say if we just want to configure with the Azure DevOps, we can do this, or maybe if we wish to configure with the visualstudio.com, so we can, provide this. So this will be basically the setting we have to change from here. So like this is the allowed list here, permissions we can configure from here, and allowed repo export also we can, output also we can configure from here. So these are some of the configuration related information. And we'll simply jump to the, I think, to the article or to the, Databricks itself. So we can configure. It's easy process relatively. So before that, I will go to my GitHub basically, github.com. And on the github.com, so this is my GitHub account, which is, having this one. If I go to settings here, if I go to developer settings, here I would see personal access tokens. So I can produce a personal access token from here. Basically, I can connect with or I can give any other software the access to my GitHub account. Okay, so I'll go with the token classic way. If you want granular control on the repository, then this is in the, like beta version. So you can also do this. Means if you want to give access to some of the repos and some you do not, then you can use this one. So we'll go with the classic one. Here we can generate a new token basically. So simply we have to click on the generate new token and generate new token with the classic one. And then it is going to ask you the authentication of your account. So most of the, GitHub accounts are configured with the multi-factor authentication. So in my case also it is having authentication application. So I am opening the authenticator or Microsoft Authenticator on my mobile device and going to GitHub, and it will send a code. So I'm just putting that one, 593. Yes, code is verified. So now I can create a personal access token, PAT, and I can give some of the permissions. For example, repos related, workflow related, admin related. So these are the permissions which are basically the GitHub permissions. So we can provide these permissions. I think with us, we just need the repo related permission. These are more than enough. We can fully access, private repositories and work with them. So if we tick this, these all are selected. Here the expiration, you can choose that how many days you want this token be available. So after this number of days, this token will be revoked, means you will have to reconfigure it for your Databricks. So we can keep any number of days here anyways. And this many days, this will remain connected with the Databricks. So I can say, let's say Databricks connection or whatever name I want to give to this personal access token, or Databricks PAT also I can say. PAT, better. And yeah, so finally we'll say generate token. So we are creating a token inside of our GitHub account, and this token will remain visible for now only. Means once I close this window, it will not be visible. So I should copy it. Now what I will do is I'll go to my Databricks basically. I'll go to repos. And let me see if I'm doing right. This one. Yeah, I think I will have to look into documentation. There was something to change, I think. and you will also get an email which I got from the GitHub. So yeah, I think we should go to development in our settings and see this one here as well. Repo control access or repo optional settings. I don't want to go to the optional part. Looks like the same documentation. Yeah, this is basically the document which will provide you GitLab. So you can connect with any of these here in this documentation. This is mentioned clearly. So let's go back. Azure Databricks. Here you have different GitHub is there, Enterprise Edition also there, and link your GitHub account with the Databricks. In Azure Databricks, link your GitHub account on the user settings. So this is where we will have to go. In upper right corner, any page, right click your username and then setting, then linked account. Okay, and then you can link your account with the username password. So you will select the provider and then the username password, or you can choose the personal access token and then simply you have to link. So not much complicated, it's easier. Then it will be connected with your GitHub. Okay. Okay, so application, we are not looking to install any application because it's better to work with the remote one. So when we go to, basically this is our account, go to settings and linked account, I think, yeah. Yes, looks like here. So linked accounts will have to go, and then here we can do the Git integration. Okay, and the Git integration, so I'll make it little bit, yeah. So I'll choose which provider I want to link with. So I have these many options. These are like version control systems. So I'll choose here GitHub, and you will see that it has two options. Either I can go with the username and password. If I go like this, it will ask me to authorize with my logged in account. So it knows that I logged in with my GitHub, and this is my account information. This is already fetching the username, and then I can authorize the Databricks to use with this username and password. But much better way in the production environment is that we should not authorize it with the username, because username are bound to change, and your access may be revoked or something. But if you have personal access token, it will not be impacted by the username or permission related username. So I'll quickly cancel it. Let's go back. I think I can close it from here. Not authorized. Okay, and I'll choose the personal access token because we have already created the personal access token. We already copied it from our here. So we copied this one already. We'll go to our Databricks and we'll put into the token this string. So this is our token, and username or email we can provide. So my username is Kamal Purbia 77. So I can link my GitHub account with my Databricks by just providing this information, and it will remain connected for 30 days. So if I save it, okay, so this is now connected. Okay, credential update. So let's go to our workspace now. I think this is what the only setting we require, and then we can go to our workspace, repos, and we can create our repository. So let's say if we create our repository, you can now create Git folder outside the repo folder, and so this is like message earlier And they used to have the legacy one, and now they have a little bit better one. So this is what the information it's providing. Here we can create a folder, for example, let's say folder 1 or git folder 1, for example, git. So it's going to be a container only. Inside we will be able to create a git repo. Okay, so under repos, we can see we have one folder created. And if we click on this, we have, a git folder and repos. In the repo home folder, so you can, create your repo here. So we can simply clone it from our existing repo, which we are already connected with. So at once we can connect with multiple repos. So we are connected with GitHub, and we are going to provide the URL of our repository. So right now we do not have any repository related to this. So what we'll do is we'll simply go to home and create a new repository in GitHub. Okay, so let me go here, click on new, and I'll create a new repository, which is going to be a private repository and going to have name, let's say Databricks repo -1, something like this. We'll just put a name, and we are going to put a readme file because we have nothing on this repo. So we'll just put a readme file and create this repository. Okay, so our repository is created with the branch name main. Okay, so one branch is there, and we have now the code button here. So from here, we can take this repository link. So we can clone this basically. So this is the link of my repository, which is privately available. So we are authenticated in Databricks using the personal access token. So it should allow us to access this repository. This will not be publicly accessed because this is not available on, over the internet without the access token. Okay. So now this is the URL here. What we'll do is we'll go here and we are going to add a repo. So in here, git repository URL, we are going to put this URL. Okay, provider is this one, and repo name already it picked from here. Okay, so repo name is going to be the same. We'll simply create this repository. Okay, so as you see that we are inside the repo now. So workspace, repos, git folder 1, and inside the git folder 1 is the repo 1. Okay, so this is having a readme file, and this is like created or something. So what else I can do is I can, create a notebook and put inside the repo. I can simply go here, create a notebook. And I can say this is like control F. So I will say git repo -1 note book -1, something like this. So just to identify this notebook, that this notebook belongs to this and in the main branch. So I'll say, okay, this is going to be my cell 1, cell 1, for example. Just the dummy code, I'm just putting some cells here, cell 2 or code and cell 3. Show hash is used to comment it out, just 3. Okay, so I just created some cells here, and this is my notebook here. Okay, so this is inside. So once I go to my repo here, and if I refresh this one, okay, so this is not still, being fetched here. So let's go back and we can see or cell here or repo. So if I go to Workspace, repo folder, and this is my repository. So when I open this, I should be able to, let me open this. So this is my, all this information kept here. Let me see, there was an option to basically save on the GitHub. This is what I am looking for. So I can click on main basically. Yeah, so it's little bit, change here. So when I go to the branch, this is I am on the main branch. So if I do have multiple branch, I need to click on the branch, and I can see that the git repo one notebook, -1 py is added. So this is Python file basically. So py is added here, and this file is still not reflecting on the GitHub, right? The GitHub only we have README file. So if I'm on my repo one, which is the private, this log denotes the private one. So I can see only I do have README file, but not the other one. Once I go to my Databricks account, I can see that the changes are there, but still these are not, pushed. So these are not basically committed. So you can see here, these changes are added, but not committed to GitHub. Okay, so we need to commit this change to GitHub, and this is already selected for us. So I'll say, okay, in commit message, I will say added notebook 1. Okay, and I will commit and push. So commit and push will basically commit this file and then push it to the GitHub. Okay, so this is pushed to GitHub now, successfully committed and pushed these changes. So if I go to GitHub now, and if I refresh this page, now I can see that I have 2 files here. So the commit message which I put here, like edit notebook 1, and it was done now. So it is added here. So let's say my another data engineer or developer is having access to this notebook or this Git repo, then maybe he or she can open that notebook in Databricks environment, connecting with using the personal access token. So the person or developer can work with this notebook. So let's say if the person is opening this notebook, you can see that we have written cell 1, cell 2, cell 3. So when the person is opening this notebook in the Databricks environment, it will look the same way. But since I have opened this in the GitHub one, so it is little bit looking raw format. Okay, so what I can do is, so let's say if I am editing this, and the same method, if I do, let's say, for example, if I put some changes here, so cell 1, this is cell 1, for example, I'm writing just comment just to explain that how it will, work back and forth. This is cell 2. And this is going to be, this is cell 3. Okay, so I'm just putting some comment just to make it more the similar to the notebook update using the Databricks. And let's put it here, and maybe we can add one more cell just to try. or reflect that if developer is working and making some changes. So let's say cell 4. Okay, so developer made some changes on whatever platform the developer is using and committing the changes. So once you commit the change, you just have to pass some message. So commit the changes. So these updates should be reflecting there now. So let's just refresh it in case. And now we can see we have notebook 1 and it should be updated. Still not updated. The reason is that we didn't fetch these updates to our Databricks environment. So what we can do is we can click on the main branch and you would see here nothing basically. So you will see here only one written, means there is change or commit on the GitHub side, and that change is ready to pull because this is committed already. So this should be we should be able to pull this change from there. So that's why it is showing 1. So once we pull, proceed with pulling. Yes, do it, confirm. So once I close this, I am able to see the changes in the notebook because this is now the updated in our environment as well. Second thing is like you can have multiple branches here. So let's say this is the one branch we do have. We may have multiple branch and the same way it will work. So multiple branches we can create and we can add it here. So this is what I think from here also we can, yeah. So we have main branch here and we can create the branch from here. So let's say if we create another branch, let's say branch 1. Okay, so we have branch 1 here. Now if I close, I can see in my notebook, I do have branch 1. I do have, I think I should be able to switch the branch from here. Yeah. So I have main branch and I have branch 1. Basically, I can switch from here. Okay, so branches basically will help you to maintain, let's say if you are working on a solution and you have so many notebooks, and let's say so the main branch basically represent that you have core branch, which is like production branch, you can say, and your branches, or maybe you can create a branch for developers. So let's say if you have 2 or 3 developers working together, they can have their own branch. They can do the experimentations on their own branch, and if they find that that is ready to merge with the main branch, they can do this merging, and they can update the main branch after testing their feature branch. So whatever branch, let's say branch 1, branch 2 is there, they can work with these branches and update this accordingly. Okay, so this is about little bit about branching. You can keep creating the branch for multiple people, and you can work with this branch. So if you see in the branch 1, we have whatever update we were working with available in the branch 1 as well. So branch is like up to whatever point we were having on the main branch. So in the main branch, we were having updates up to this point. And if I add another code cell, for example, and it's going to be cell for branch 1, for example, this cell is added on branch 1. So this should be available with the branch 1 and it should not be impacting the branch or main branch. Okay, so that's what the idea here. So this cell is added here when I change the branch basically. Yeah, and another thing, this branch is not yet committed. So when it show here, it means that this is modified, but this is not committed yet. So I can say, okay, commit changes to branch 1. And I can commit and push. So this branch will be available on my GitHub as well. So if I go to my GitHub here, let me refresh it because it will not reflect otherwise. So I can see now that I have branch 1 available. So when I shift to branch 1, I can see that cell for branch 1 is added here. When I shift to main branch, I can see that up to cell 4 only I do have this. So these different versions are being maintained here. Basically, we are maintaining different versions. So let's say if on branch 1 we have developer working, so developer can keep changing, his or her file, and still it will not be impacting our main branch. So once everything looks good on the branch 1, we can merge this code into main branch. So that's what the branching concept here on GitHub or any basically version control system. All right, so yeah, now this is how the branching and all those things will work. This is how the integration will work here, and we can maintain our notebook, we can run the notebook. So concept is same, only that this code is going to be residing on the GitHub, so everyone can collaborate. So let's say if these notebooks are in our personal, means the home workspace, it is accessible by us only, not others. So we can keep working with our notebooks in our relative branch, and then once everything is okay, we can merge this code to the main branch using the GitHub. So like this, we can maintain version control on our our notebooks. Maybe we can refine our notebook. Maybe if we are working with the long pipelines and all those things, we can maintain our code like this. So this is about this part. And the same way it will work with the other repo solutions, or the version control systems. So you can simply link the account from here, and it will work with the whatever you link with. Okay, there are other ways also, like Bitbucket, Azure DevOps also you can integrate with. So the concept is same, that you can have personal access token, and you can connect with the personal access token, and you can keep your connection active. So once all these things are done, let's say you don't want to continue with this connection, you can simply delete this connection, and it will be disconnected from your account. Okay, so this is how we will maintain this. All right, so I'll simply, maybe I'll remove this. I don't need this here. So let's say if I go here and I move it to trash, I can simply remove this from here. I can go to here and settings, linked accounts, and I can delete this connection. So now this is disconnected and again available to be connected with any other repo we want to. Okay, like this, we can work with this. Okay, next topic is Databricks file system. So this was about repo and Git repo, or in Workspace, how we can work with the repos. Okay, so this is repo. This is how it's the same way, like we are keeping the notebooks here, but only repo will help you with the collaborating with the other another users. Okay, so this is how you can connect with this. All right, let me see another topic, which is the Databricks file system. Meanwhile, if you have any question, I'll take, no problem, with the Git and GitHub related. Okay, so what is Databricks file system? I'll see about this briefly. So Databricks, basically, I can show you what we have right now here. So if we go to catalog here, so all or file access, etc. are being maintained here. So everything like catalog, schema, everything is being maintained here. But there is another file system available, or the main or the legacy file system of Databricks is also available. These are like newer one which you require SQL warehouse, and this works with that. So like high meta store or samples, and this catalogs are available on this new system. But we have one more system which is called Databricks file system. So let's understand about this, and then we'll include. So yeah. So basically we have two folders here, or two type of accessibility available in this platform. So it is divided into two part. Databricks file system, so DBFS for short it is called, DBFS root and DBFS mounts. Okay. So what is Databricks file system? The term Databricks file system comes from Databricks file system, and which describe the distributed file system used by Azure Databricks to interact with the cloud-based storage. So this file system basically used to interact with the cloud-based storage. We can have any cloud-based storage account, and we can bring that account and work with the file system. The underlying technology associated with Databricks file system is still part of Azure Databricks platform. For example, DBFS colon this one. So this is like symbol to access this one is optional scheme when interacting with Unity catalog volume. Okay. Past and current warning caveats are about only apply to DBS root and mounts. So this is little bit, I mean, legacy system, but still is being used heavily. So this is like some of the warning and caveats are there. How does DBFS work with the Unity catalog? So Databricks recommend using Unity catalog to manage access to all data. Unity catalog aid the concept of external location, storage credential, and volumes to help organize, provide least privilege access. So basically the DBFS also work with the, Unity catalog. Unity catalog is nothing but a governing system for access management. Okay. What is DBFS root? We'll understand about this. DBFS root is a storage location provisioned during workspace creation in the cloud account. So this is like root location for DBFS, and it's going to be created when we are creating the account. Okay. So we can enable and disable. How we can do this, we will simply look into it. Right, so there is nothing much. And the second thing, so this is the DBFS root, first concept. The second concept is the mounting object storage. So if we are having any storage account, we can mount it along with the DBFS as well. Okay. But the DBFS mount is deprecated now, and we can use the Unity catalog volumes. So we have seen about the volumes, if you have seen it here. So now new way to maintain volumes or mounting is that we can use the volumes here and put the physical files in the volume. Okay, so like we have put some physical files earlier in the volumes. So this is new recommended way, but there is mounting also being used. So in DBFS we can mount the volumes. Okay, and let's go back. Okay. So we can compare this. So this is not much to understand here. That's it about this article. Let me see if anything missing. Okay, so let's enable this first and see how it works. To have a DBFS enabled, right now, if we go to our account, we don't see anything related to DBFS in our catalog. So we will have to enable this so we can see our DBFS. So for that, what we can do is you have to go to your user profile and go to settings. Under settings, you will see workspace admin category. So here on this section, we will have to go. Under that, we'll go to advanced. And here we should be having, where it was. This is about pet, access control. Okay, storage, purge, enable. Yes, this we can enable from here. Databricks file system or DBFS file browser, enable or disable DBFS file browser. Then only we should be able to view this. So before I, what I will do is I will open the catalog in new tab. Okay, so this is our catalog here. If you see, we have data sharing, we have external data, and we have aid data. So these three buttons are there. And I am on, advanced tab in user settings. And if I enable, what will happen? So see here, once I enable DBFS file browser enable, you must refresh the page for change to take effect. Okay. So once I go back here and I refresh the page, you see three button. I should be having fourth button. I am waiting for fourth button, but it's not coming. Let's see what has happened. Is it save button there? I'm not sure. Okay, let me go here. From here, let's say. Yes. So after few refresh, it is displaying here browse DBFS. So by doing by just going there and updating this one, now we can see that we are able to enable this one. So Databricks file system browser is basically enabled, and if we click on that, we should be able to see some of the files or whatever we have stored in here. So this was not enabled earlier, so we were not able to see this Databricks file system. After having it enabled, now we are able to see the folder structure like file store. In the file store, we have, like, for example, folder 1 created, and under the folder 1 we have one file. So same like we are keeping the files in volume, we can keep the files in Databricks file system as well. Okay, so same method, but this is like different just for Databricks file system, and we can use some file utilities to work with this. Okay, so what we can do with this file system, let's see. So let me just open some of the notebook. Maybe I can show you with the notebook. So let's go to Workspace, and we'll simply create a new notebook, let's say. And I'll provide this that we are going to work with the file system or DBFS notebook S2 or something. Okay, so I think we will have to start the cluster now. So at least we can work with this file system. Okay, I think I'll have to go to another tab, open the compute and start my compute. It may take a while. It may take maybe 2 or 3 minutes to start the compute. And then we'll connect with this cluster here. So once it is started, we will be able to connect with this. So we have something called DB utils. And in DB utils, I think we should be able to fetch the help. Let's see. But it will be running after it starts, looks like, yeah. So Databricks is having a utility called DB utils. And it's having so many commands in it. So we can, meanwhile it is starting, maybe we can go through this. So list available utilities, what we can do is dbutils.help, and it will show us what utilities are available with this command. Okay, and we can use with the Python, we can use with the Scala, we can use, yeah, these two only we can use. So list available command for a utility. So let's say we have one command which is called fs, or it stands for file system, and we can go for the help and look into what are the commands available with this. This is how, so there is some commands available, so we can pass the command name. So under fs, we have a command called cp, which is used for copying the data. So we can go to the help and see this one. So we'll just try this out. And then we have, data related, dbutils.data and related, information. We can go to dbutils.data.help and see what helps are available. Again, in data, we have summarize one. So we can see the help related to summarize one as well. So like there are so many commands available into it, and we can maybe use this command and, use in the notebooks. So this is what we are trying to do here. Let's see what has happened with our cluster. Still not woke up. So once this cluster is running, our command will trigger immediately. Meanwhile, let's explore some more commands. These are DB utils file system related commands. So these are like commands in it. So cp is one command, head is another command, ls, make directory, mount, mounts, mv, put, refresh mount, remove, unmount. So these are the commands related to fs. So if we go for db utils and then .fs, these are the commands available into it. Okay, so these are the list of commands which are available. So copy basically will do the copy. I think maybe I'm not sure if I can open this in new tab, information separately available, or maybe it will refer to the same document basically. Yeah, it looks like the same document. Yeah, it is the same document here. But it's like that, it's referring to that section where, we are getting FS related commands. It is a little bit more detailed. Okay. So like cp command or fs .cp command, basically dbutils.fs, then copy command basis. This will copy a file or directory, possibly across the file system. And to display the help, we can go for this and see the help related to this command. So in this example, it is showed that we have data.csv. We want it copied from volume, main default volume to a new data CSV, this location change. So it will just act as a copy command, and we can just simply type this command here, cp, provide the source volume address and destination volume address, and it will copy this file and it will throw out the true. So when it is done, it will true. If it fails to copy, then it will return the false. Okay, let's see if our waiting period is over. Yeah, looks like our waiting period is over. Cluster running. So here you can see that by dbutils help or dbutils.help and bracket. So you can see these commands are available. This module provides various utilities for user to interact with the rest of Databricks, and these are like utilities which are available, or like data is there, FS is there, jobs is there, library is there, meta is there, a notebook related command, preview, secrets, widgets. So most commonly used is FS basically, which is the file system related command, which we will be practicing on, we'll looking into. So if I go and I type, let's say in new cell, if I type dbutils dot, I'll say fs dot help and then bracket. So now I'm asking for the help because from dbutils.help I was able to see that these commands are available. In that one command which we have available is fs. So under fs, I just want the help and see what else available in the this command. So I'll be able to see that I have dbutils.fs, and it provides like a utility for working with the file systems, and I can access the file system like this. These are some of the examples. Then I can use this command for mounting the storage. We'll look into it practically, so don't worry. And then we have fs util, which is like copy one, head is there, ls is there, mv is there, put is there, and rm is there. So these are like file system related utilities available in fs. So if I want to understand about cp, for example, so I can just use this one, this command, dbutils.fs. So I'll go for new one, dbutils.fs dot cp and dot help. I think it should work, or maybe dot help, and it will work like this, cp. Let's try if it works. Yeah, it should work. So it will give you the information about this command, that what you can do with this. Basically, you can copy the files from one to another. So here the example you can see, you type cp and then whatever address of your source folder or file, you can copy it to destination folder or file. Okay, so this is how you can use this command. Now we have another command, which is the ls command. Let me just make it small if I can. I can collapse this all, and now I can try is dbutils dot ls dot help. Fs will come, right? It's under the file system basically. Yes, it suggested me automatically, so that's great feature. Okay, under the file system, we want to understand about ls command, right? So ls should be here, this list or directory command. So if I go and type ls here, it should give me the information related to ls command. Okay, now here you can see that we have, so basically this command is like, Unix command, which, help us to list the directory of content of a directory. So let's say, yeah, if I say display and then ls, display is basically the command to display it nicely. So ls and give the path of the folder. So it will give me the result of ls command. So let's say, for example, if I want to see db utils, then if I say fs ls, and if I give the path which is like slash, yeah, so I should be able to see the folders or files which are available in root folder. So if I wrap it around display, yeah, so it will show me in tabular format. So these are like path DBFS. So I am having a path which is called file store inside any, so this is like my root folder. So if I go to my catalog, go to DBFS. So if I go back here, this is the file store. Okay. Inside the file store, I have folder one. So inside the folder one, I should have something. Yeah, one file is there. Okay. So how the path is being, mentioned here, the DBFS and the file store. So I can simply go for file store here and see what inside of it. Okay. So on root folder, this is showing me like this. And I think if I take this one, copy this, and if I put it here, it should be reaching me out in the file store one. So let's see. So I can see I have folder and tables inside my file store. Okay. So this is how I can access from, this file store. All right. So this is about the, DBFS. And yeah, that's it for today. So let's start today's session. And we'll start with our portal.azure.com. We'll go to our Databricks, launch Workspace. We'll start our compute first, so at least we can start working with the, queries. So we'll start our compute. Confirm. In another tab, I'll open Workspace. So basically today we are going to talk about, the DBFS where we left yesterday. So I'll just quickly go to the reference here. And I'll go to one more page. So basically in Databricks file system, we have directories here and we have some root directories. So we'll look into it, what exactly we do have. So we basically work with the file store, and we have another directory which are basically hidden directories. So one is like datasets, Databricks dash datasets. It is having some sample data in it. So this directory contains the sample data. Then we do have hive dot warehouse, so that we can see in our file or schemas as well. Then we have file store, which is visible in the Databricks file system. Then we have, this is like temporary, where it will store the results which we query the data, and initialization directory. So these are the directories which we have. Okay, mainly we will be working with the file store. So I can basically, we can go here, and this is our compute. I will open one more, it's catalog. Okay, so if we go to catalog here, in catalog we have schemas, we have default schema, table, volume, all those things. And if we go on the top, we can see here the DBFS, browse DBFS, Databricks file system. We in yesterday's session, we understood how we can enable this. By default, this option is not available. So we can go to the settings from here, and we can enable the browse DBFS, browser. So once we go here, some error coming here, looks like. Okay, why this issue? Okay, it was like temporary warning. So we have file store. So this is what we are talking here, that we have file store, and in that file store we can create structures. Then second, we have about mount. Also, we can mount some external storage. We will look into it as well. And we can have some temp, JSON data, etc. we can keep here. I should have cluster attached, but it is an existing computer resource. Okay. That resource is also working, so it should not be creating any problem. So if I go to my computer resource, this one is working. SQL warehouse is also working. So both the computer resources are working. All right. So it is basically false warning, looks like. Should not create any trouble. So this is how our structure of DBFS is in place. So yeah, now it is giving me option. All right. So basically, our DBFS, when we are querying it, or maybe we are, fetching the data. So this will be using our compute resource, and that time it was starting. That's why it was giving the warning. From here, in the file store, we can, create folder. We can put some files into it. So we can copy some, data, or, any CSV file. We can simply basically upload our data to the folder we wish to, and we can, drag and drop, or, put the files. So let's see if I do have any CSV files. star.csv. I have, for example, people 1000. So I can simply upload this and it will keep that file available. So this is how we have the structure here. Now from the notebook also we should be able to upload these files or create the folder. So we'll look into these commands one by one. Okay, so let's go to our notebook. So this we were on the catalog basically. So now we are going to notebook. We will create a notebook. So I have this structure I created in the shared folder. That means everyone or other people, if I do have another member who are working with the workspace, it will be visible to them as well. Okay. So I created one DBFS folder. In DBS folder, I created some notebook for my reference. So we can create a new notebook and replicate the same stuff. Okay, so I'll just open this in maybe a new tab. And we'll create a notebook here. So simply we go to create and click on notebook, and I'll give the name like DBFS notebook 2 maybe. DBFS notebook 2. Okay, so our notebook is ready. This is our like browser here or workspace where we can view the notebooks and all those things. Here we can view the content of the file and catalog and assistance. So let's see what we have in that notebook and then we can replicate. So I will give you the reference as well. I'll just open this in another window. Let me just arrange it a little bit. Okay, so we have so many commands available in DB utils. We'll go through these and understand about this. So let's quickly go here. And the first command we can have about the DBFS or DB utils is file system. So DB utils. I think I should be able to get it automatically, but yeah. Okay. So now it should give me IntelliSense as well. So DB utils or DB utils dot file system. And if I say list command or ls command, it should give me that what the folder structure is. So it will give that how many volumes are there, but this is not the nice format. So for that, I can go and wrap around the display command, display. And now it should give me the tabular format. So here I can see I have file store. So this is one of the location. Another is mount. So mount is having some data in it and we can mount some storage account, etc. We will look into it. And we have other, for example, other, locations which are available with this file system. So these all locations are accessible using this file system. Mainly, we are using the file store to store the files or CSV, JSON file, any file we would like to keep in DBFS. So it will store it there. And volume is also available. So if we go to a catalog, we can see the volume as well. So here we can see the volumes. By ls command, that how our file system is arranged. Let's go next and say, okay, DB utils. And for example, if we want to utils and then fs, then ls, let's say if we want to see about the file store, because we have the path here. So we can say, let's go to file store. So we'll take this name, basically, that is more than enough. And we can navigate through this and see that what we have. So again, it will give us that how many folders are there. So folder 2 is there, folder 1 is there, tables are there. So this we have seen anyways from here. And go to browse DBFS in catalog, and you can see folder 1 is there, folder 2 is there, and tables. So this is how we can explore or open these folders in the notebook, okay, by using DB utils utility. Okay, and let's say if we want to further open the same one with the more in depth, so we can go and maybe we can copy this same thing, and we can say, okay, I want to go to folder 1, for example. So you can go to folder 1 and see the content of folder 1, and it will show what is available in the folder 1. Okay, if you want to show it in tabular format, display is the best command we have. And we can see this in the tabular format. Okay, so we have basically 2 files into it, and these are the CSV files. Okay. All right, so this is about the ls command. So we can, keep exploring, or, if we have the file structure, we want to call it from using this command, we can do this. Next command is copy command. So let's say, for example, we want to copy this file to the folder 2, for example. Then we should be able to do this using this command. So I'll just comment it out, and we'll say, okay, db utils fs, then cp, and then we'll provide the source from where this file will be copied. So for example, if we want to copy this file, so I'll put in double quote this one. This is going to be our source, and we'll remove this part. So we just refer
Kamal, one
file store.
question.
Hello, yes, please.
Kamal, one question. Like if you go back to that folder 1, folder 2, right? There we can see the files, right? How many CSV files are there? So why
Exactly.
we are using this display here? What is the use of this display? We can
The
go directly there and see the files, right? In the folder 1, folder 2.
Exactly. Yes. We
Okay,
can
why?
see, basically, if we want to notebook to, explore this or list this in the notebook, we can use DB utils and copy these, move these, arrange this. So sometimes we are working with the notebooks, we don't want to, or we want to, explore this thing using the command. So these are the commands which we can use to copy, make directory, move, remove. So manage all these things using the command line. So this is like utility, you can assume. And having this utility, basically that do the same thing. So like if we have CLI command line interface, where we can use this command line interface and manage our folder. Exact same thing, nothing is specific. So it's exact same thing, nothing more or less, but using the
So
dbutil command. Yes.
got it. So you are saying like in Windows, we can go to,
Mhm.
I can go to C drive and I can see the file. Or I
Exact.
can go from command prompt and I go to C drive and see the file with the help of commands. So that is the same thing you are saying. Is that right? Like manually also I can go to C drive, I can double click and I'll go to C drive and I can see the
Can
file. Okay,
you?
what are the files?
Sorry.
You are saying like there are two ways. Like one way
Right.
is like we can go from GUI and we can see the file, how many files are there in each and every folder. There is
Right.
another way from command prompt also, with the help of DB utilities, we can see how many folders are there and in each folder how many files are there.
Correct.
Okay,
Correct.
got it. Thank you.
Welcome. All right. So we are basically copying this one. So that's why we are seeing here graphically as well that we have folder 1 and we have people CSV. And let's say if we want to move it to folder 2 or copy it to folder 2, and we want to rename this as well. So we can simply do it by using here as well. I think there is move command or move you can do, copy path, rename, delete, all these you can do. Second option is that if we want to, because mostly we are working with the, DB utils. So once we are used to with this, we can, simply do it as well from here. So let's say if I refer this one, copy from here, and this is going to be my destination path. Okay, so we have, I think this is going to be case sensitive. So I am just putting folder 2. I noticed that this folder 2 is having capital F. So otherwise it will create a new folder. So let's say people 1000 CSV, I just want to rename to 100 CSV or something like. So this is going to be my source, and that is going to be my destination. Okay. So this is how I can copy it from one place to another, or move it from one place to another also I can do. So let's try this one, and it will return the true, means it has happened. So let's verify here. I think we will have to reload it. Go to DBFS, and if we go to folder 2, now we can see that we have renamed the file. We have copied that file from folder 1 as well. So it is available here and available here as well. Okay, so this is one of the command. Another command is like we have head command, where we can, see some content of it. So I'll simply go there again into Databricks here in notebook. So next is, for example, head command. So db utils dot fs dot help, help, and head command I want to understand about. So head will basically return some characters from a file, right? So it will return up to the first max bytes of the given file. So it will give a string output. So let's say if we do have a text file or some file available, we can simply use the head command and get the output from that file. Okay, so it's rarely being used, so it's just for information. Next is make directory, which we may use. So I'll just simply comment it out. db utils fs make dir, make dirs. This command is used to create a directory. Okay, so we can create a directory using this command. Let me see if I have. Yeah, so basically, let's say we have, so if we go here, we have the catalog, we can simply create a new folder. So same way we can create the directory as well. So create folder, it will do. So I'll just simply demonstrate it by creating the folder here. So let's say I create file store, and I just need to give the folder name. So folder 3. So it will create a directory. It should be working fine. Yes, so it returns true. It means the directory is created. Let me reload. So folder 3 is created. Same way, if we want to create a directory in our volume, that is also possible. So we have volume here. Okay. In volume, so we have one volume, volume 1. Let's say we want to create a folder inside of it. Okay, that is also we can do using this command. So if I go to detail here, I can just give me a moment. So I think I can directly see from here. So volume, and this is the location of my volume. Okay, so this location I can copy, and I can say that in the volume 1 I want to create a directory. So simply I can go to notebook, and I can same way I can use this command to create the directory inside of the volume. So Control Z, DB utils, FS, make directories, and I can pass that address. So in volume 1 I want to create folder 2. I think folder 1 was already there. So let's do this. And it should create, so it has returned the true, means it has created a folder inside of this. So if I go here and refresh from here, I have folder 2 available. So I can arrange the folders like here as well in this volume. So these are different locations here. So one location with the DBFS, Databricks file system. So we may have question that why we have these two different locations. So basically this location reside in our Azure account. This location is Databricks its own location. So it doesn't reside on the Azure. It reside in the Databricks file system itself, or Databricks itself, basically. So these are different, or two different locations. Okay, but managed with the same interface. Okay. Next is move command also will work the same way. So move, I think we can maybe skip, or it is the same like this copy command. So move command also exact same, that you have, source and you have destination, but this time it will move the entire file from one place to another. So mv, basically the command is like, can just copy and show you. So command is same, only fs.mv is there. That's it. The rest of the things are same, exact same. Okay, so we can skip this, but it's going to work the same way. Next command, let's see what we have left with. Yeah, one more command is there which we can use is to remove this. So I'll just simply copy paste from here. So this command basically rm fs.rm. We can remove either a folder or file or anything we want to remove, maybe from volume, maybe from DBFS. So we can remove these things. So let's say I think we created folder 3. So we should be able to remove this just to test. Okay, it was quick, looks like. If we go here, and if we explore DBFS, we don't see the folder 3 now. So it is removed, and it will be removed along with the file content if there is file content. Okay. Next one is, let's say there is a quick maybe command to create a file. Okay. So let me little bit arrange this. Remove. Okay. Okay. One more command we can talk about is okay. So here, let's say put command is there. So for example, we have volume folder 1, and we want to create a text file into it. So I will select the folder 2, for example, and I'll say hello text, and we can write the content inside of this text. And the true will basically make sure that if you have existing file, it will remove it for you. Okay. So it will create a file in this location. So location is volumes, then schema, catalog. volume name, folder, and then the file name. So we can simply trigger this, and it will create a volume basically inside here in the default schema in volumes in volume 1. There we should have folder 2, and inside the folder 2 we can see that it has created a text file. Okay, if we do have content and we want programmatically, so basically the command utility why we should be using is, let's say if we want to save the output in a text file in the cell. Let's say if we are working on the cell and we have data frame, and in data frame we have some output we want to save into text file. So this is one of the requirement. So in that case, what we can do is we can use these commands, because uh, a manual way we can work with, but programmatically if you want to generate an output here or create some file and move it somewhere, so we can use these commands, okay, in the cell itself. All right, so this was about this. Next is, yeah, so now we'll talk about mounting the storage account. So let's say, for example, if we have storage account, and in the storage account we have some files, and we want to process, let's say maybe we have a bunch of CSV files, or we may have a source, so in Azure, and we want to we don't want to bring in these files into Databricks file system. We want to work with this file. All right, so the scenario would be simply graphically, if I can show you, let me just get another here. Give me a moment. So I can add, okay. Minimize screen. Okay. So basically, let's say we have Azure account, right? Azure account is there, and Azure account is having storage service. We are having in this storage, we called a container in Azure language, TAINER. Or if you know about AWS, they call it S3 bucket, right? So this is the same thing. So in Azure case, we have storage account. In storage account, we have containers. In container is basically folder, you can assume. Okay. So let's say we have some system which is producing the files or log files here. So in this container, we are going to keep a bunch of CSV file, maybe JSON file, whatever the file. So let's say if we are putting up here, or any system we have integration with, and that system is producing CSV files and putting the files here. So maybe daily log or something, So day 1, day 2, day 3, we are putting it here. So in Databricks, we have, and we don't want to fetch or unnecessarily create the copies of this file. What we can do is we can mount this storage account, or basically mount is like, just create a pointer in Databricks. And whenever we want this file to be read by, Databricks notebook, we can simply, refer to these files and read from here and produce the result. Okay. So let's say if we are creating, aggregation, where we are just want to count the records, maybe we want to sum up something. So we will be doing the processing using the Databricks, cluster. But our storage will be used from here only. So we are not, fetching all the result to, maybe let's say if we have 1 million rows in each file. Okay. So we don't want to bring, millions of rows into Databricks and, make it heavy. We just want to mount it from here read it there and process, and whatever the outcome we can, represent in a dashboard or graphs or something like this. So we can use this. All right. So this scenario we will understand. So we'll understand about the mount here, how we can mount it. All right. So I'll just close this. Let's see. All right. So we have mount command. I'll simply open another one. And I'll say db utils and fs help about mount. First, I'll talk about mounts. There are two commands, mount and mounts. So we'll talk about mounts. So it will display the information about what is mounted with the DBFS. So Databricks file system, it will give us the list basically. So let's understand, or let's just list down with the mounts. So fs dot mounts, and it should give us the list of existing mount. How many? Maybe we have 3, 4, different accounts, or, which are mounted. So here, these are the mount. I will just format it. Display. And it is going to give us the result in tabular format. So these all are the mounts you can assume. So these are some of the Databricks root, and these are reserved one. And others are like result one is there, Unity catalog, which is having volumes, data sets. These are like sample data. Result we already talked about. Volume is, this is reserved. These two are reserved, DBFS reserved one. So these are some of the mount. So when we create our own mount, it will be reflecting here. To create the mount, we should have, so I basically just comment it out. And if I say, okay, db utils, fs, and then mount, or before that, I'll just take the help, and mount. So command we will write here. So it will give us the information about mount with the example. So we can mount like S3 bucket with the security key and all those things. So this is the information it will provide us. Okay. So now let's see, before we mount, we should have a storage account. So we'll quickly create a storage account. I'll go to my Azure, go to home, and I will select my resource group. So basically I have some resource group which are related to Databricks. Resource group is nothing but a container. It's like logical container which is going to keep your resources. So I have created two resource groups here. I'll make it a little bit zoomed for you. So here I have Databricks and Databricks managed. So Databricks related the resources I am keeping it here. And I have another resource group which is empty. Nothing should be there right now. So I'll create a storage account here, and then we will mount this storage account to our Databricks environment. So assume this is like maybe not my Azure account, maybe your Azure account or someone else Azure account. We can have multiple Azure account or storage account basically in the Azure from maybe third party or whatever the source we have. We can bring into our Databricks. Maybe we can, fetch this data from there without loading the data into the Databricks, and we can work with this. We can create DataFrame, and we can manipulate this. So here I will create a storage account. I'll click on plus create button, and I would say, okay, create a storage account. I'll go with the Microsoft provided because there are so many third-party services. You don't have to get confused. You simply have to select with the, Microsoft provided storage account. We'll click on create. and we'll provide the unique name of the storage account because it should be globally unique name. So I'll just use this name and the region where we would like to host this storage account. So we'll choose the closest one in the area where you are located. So you should choose this region where you can you want their data to be loaded quickly or fetched quickly. So I'm using this area. Primary, we will just keep it empty. We will go with the standard because we are testing, and I'll go with the locally redundant storage. Means it is not going to have multiple copies of this data. It's going to have in one data center, it will maintain 3 copies. So if GRS we are going, then it will have replication with the different zones. We don't want this complexity here. We just, for simplicity, we are going with the LRS. Next, we'll keep all the options. These are like security related options, which are by default configured. So we'll not touch them. We'll simply go next. And data protection, if we want this storage account, if it is in the production, in that case, we want soft delete option enabled. Means whenever we delete the data, it will keep somewhere like in the recycle bin, you can assume. And after 7 days, it will remove actually. So you can restore it back. But since we are just, having this demo, so we'll remove these 3 options. We don't want any data retained because we will be deleting afterwards this demo. So it's few, maybe half an hour only. Then this is like encryption related information, that how you would like to keep this storage account encrypted. So we will keep it Microsoft managed. So Microsoft will manage the encryption part. We don't have to do anything. And blob is basically, you can see the files are called blob in Azure basically. So it's the same word. Next, any tag you would like to provide, and next. And finally, it will give you the, whatever the options we have chosen, it will show you here that what we have chosen. So you can review, and finally you can hit on create and it will start creating. So now actually the storage account is being created. It may take maybe a minute or two to get it deployed. Okay, so deployment is complete. What we can do is we can go to home. And if we see in the recent one, we can see our storage account. But the second way is we can go to resource groups where we created and click on resource group, and you can see your storage account. Okay, and this is your location which you have chosen. So if I click on the storage account itself, it will show me the detail about this storage account, if it is active or not active, etc. And when I go to data storage, I can see the containers here. Okay, so if I click on containers, I can add a container. Container is basically folder. Okay. Click on container, provide the name of container, container1, for example, and we can create a container. So this is like folder inside the storage account. So let's assume that in this folder, if our system, let's say we have any system, maybe IoT devices or anything which is producing the files, CSV file on maybe hourly basis or something like this. So that files is landing here, and every hour the file is created inside this container. And we are, let's say, having a analytics solution where we are reading the files from this container. So as we are adding the file here, we are keep reading the files from here whenever new file is landed, and we are maybe creating a data frame or producing some graphical results or analyzing this data, or putting into ML or somewhere we are using this data. So we can use the data from here without taking the data from here. So we can simply upload some file just to test. So I can just put some file here. Maybe I can put CSV only, I think will be better. So I'll just search CSV, star.csv. I think I was having customer 10,000, people 1,000. So anything we can put, let's say we put people 1,000. So this CSV file is landed here now inside this container. So what I'll do is I'll go to the overview here, and I'll show you one thing here, which is the security related, that each storage account is having its access keys. Access keys is like key at the home we have with the lock. So you can open this or access this storage account having any of these keys. So we have key 1 and key 2. We can, give this key to someone, and that person will be authorized to access this storage account and the files in it. So these are like key to access the storage account. Okay, so let's go back to our notebook, and let's see how we can mount this storage account to our Databricks. Okay, so we have mount command, and what we need to do here is we need to provide the location. There are a lot of details, but yeah, we will just follow the process. So dbutils.fs.mount command will run, and once we have mount command, we need to provide source. Okay, then we will separate. So in source, we'll put the source in double quote. Then we have to provide a mount point. Mount point. Okay, so the problem here is my cluster is terminated. So let's restart because we didn't use this for a while, so it stopped. I think I made it 30 minutes, but maybe we created a storage account, so we passed 30 minutes or something, so it stopped. So let it start, no problem. Meanwhile, we'll work with this. All right, so a mount point, and in mount point, we'll provide that what the name we are going to give for the mount point. Third parameter we'll pass is extra config or configs, I think configs. So here we'll provide this key which we have. So there is certain format for this. So we'll follow this format. So we'll put it into curly braces. Okay. So these three things we have to provide. In the source, we'll have to provide the source of our container where we are keeping the file. So it's going to be a string. I'll just copy it from a file which I already have. So it will be quick. So in source, basically what we are doing is we are providing our container name. So I think our container name is container1, and our storage account name .blob.core.windows.net. So sorry, how we got this address, we have to check. So basically here, if we go to any file, let's go to here, data storage container. in container, if I go to this file, for example, each file get an address. So let me open this in notebook or in notepad, not notebook, notepad. So if you see the address is like, this is my storage account name. And this is like static address blob.core.windows.net. And this is the container name. Okay. And then the file name. So this is like global address of this file. Whoever having this storage account key can read this file. Okay. So in Databricks, we need to provide this location in this format. So first we have to pass the container 8 storage account name. This is the static one. So this will read the file. Next is mount point. What the name you would like to give to this mount? So mount is starting with the MNT or mount, something like this. We can start with this, and then we can provide the name of our mount. So we can say okay, this is my private storage, for example. So it should have this name reference in the Databricks, inside the Databricks. And then in the extra config, there is a format. So that format we have to put is a string. So we can pass or, token or short of what you call access key. So I will just paste it here. So to make it easy. So we have basically Azure account key. And this is the first key from blob core Windows net and then dot format. Sorry. Then storage account name in bracket. So basically we are saying that this key we want, this is the key we want, okay? And this is the value of key. So this is the key address basically. This is the address of key separated by colon is, key value pair. And this is the value of our key. So value, how we got the value? If we go to our storage account, we go to security and networking. Here we find our access keys. We show the key, we copy it to clipboard, and that value has to be placed here. Okay, so that value we are putting it here. So we are saying that, okay, this is the configuration to reach out to this storage account. And this mount should work now. I think we didn't miss anything. It looks okay. So let's run this now. Our cluster is also running. So it returned true, means this is mounted. Okay. Now what we can do is maybe we can open another cell and we can say dbutils.fs.mount or mounts basically. And I will display, put into display. So if I see, I have one location, which is the mount and private storage. And this is the location it's going to. Okay. So this is how I can create a mount and use it. Next command is how we can basically update the mount. So let's say if our key is changed in future, for example, we need to update this. So the same command is there, update mount. So we'll simply write the exact same command and we'll say here update mount. That's it. All the other things would remain same. So this is how we will update the mount. Okay, next command is this was about update mount and create mount. And next command is that how we can unmount it. So unmounting is also very easy. I will simply keep it there, no problem. I'll use this cell to unmount it. DB utils, and we'll say before that I unmount it, I'll show you there. So at least in the catalog, you can make sense that how it will look like. So if we go to catalog, DBFS, you can see the mounts here. So I think it's not loaded. DBFS, go back, and you go to mount, and you can see you have one mount. So you can have multiple mounts, So in now it is reading the file which is available inside your Azure storage account. From there, we can see, and what we can do is we can copy the path from here. I can now refer this file anywhere in my notebook, and I can read from that file. So let me see if I will open another cell, and just give me a moment. So I should be able to read this file. Just hold on. df is equal to dot csv will use, and we'll put the path here. Okay, so now we should be able to read this file from this mount. Okay, so we are referring this file, and I will put the next command as well, display and df. So we are putting this, reading this file from this mount. So we are not fetching anything to our Databricks. We are just reading from there. What issue? Path must be absolute one, I think. Okay. So this data is being fetched from that file and put into this data frame, and we are able to view this data frame. Okay, so we are reading from our storage account. So next is how we can unmount it, right? So DBFS. Okay, DB utils basically, not DBFS. Just give me a moment. Okay, and we will say fs dot unmount, and then we'll provide the mount name. So our mount name was this one. MNT, yeah, this is the mount point basically. Copy this. And this is how we can unmount. Okay, so this is unmounted. Now, if we go for mounts, means if we look for the mounts here, we should not be able to view these mounts. So now we are not able to view this. This is remote. Okay, so this is mounting, unmounting, we can use without bringing the data into the Databricks, and we can, query from here. Now in here, I want to go with the reference here. So most of these things we have covered here. So you can practice it from this document. Basically, I'll provide this document, and you can see the utilities. So we have help command. We can use, basically we are using, mostly we are using the Python one, but you can use Scala and other thing also. It will do the same way. So we knew about the fs command and help, how we can take the help from here. Then about the help, if any specific command we want to see the help about, we can see the help from here, and we have to type the command name. So let's say in fs, if we go and we go for help, and we will see all these command, and we can put one by one command and see the help. In specifically in production environment, we don't have time to go to the documentation and see, so we can see from here itself. This is deprecated, basically data utilities, so we are not going with this. Okay, so this is deprecated now. Next is, okay, so yeah, this one already we have seen. System utility fs we have covered. So we covered all these commands. Basically, you can see this command, all of this command from here. Okay, so all these commands are showed here. cp is there, head is there. Okay, so head will basically give you the number of characters. So I think we skip this one, because it will just give you the number of characters from that particular file. So if I just want 25 characters as a output, I can just get 25 characters. So let's say year, first name, country, AC. So these are like 25 characters only returned. ls command we have covered. So it will list all the files in this volume, let's say. Next, we covered make directory command we have covered. So if we programmatically wish to create the directory, then we can use this command in the cell, and it will create the directory for us. Next is the mount command we have covered. So how we can mount a storage account, maybe if it is a AWS, GCP, or Azure, we can mount any of the storage and read from there. So it's like read only. Also, we'll understand tomorrow that how we can, use this token in encrypted way. So how many ways we have available to use this token. So mounts also we have covered. Okay. Move command is same, is just a brother of copy command. So it will move the file from one place to another. Put command is just to write a file. So any text file or any output programmatically, if we want to write, we can use this command from dbutils. Okay. Refresh mount command is basically if we have, let's say, if we want to run this command before we fetch the information from the storage, we can use this, because sometime we have number of files increasing on a minute by minute basis, some cases. So we can refresh it, refresh basically the mount, and if anything is stuck in the cache, we can refresh. So forces all machines in the cluster to refresh their mount cache. So when we are running the cluster, because from the mount, we are getting this information to our cluster, and from cluster, we are querying it. So it will refresh the cache of cluster. Next is remove, or it can remove. Basically, it is used to delete the folder or files. And then we understood about the unmount command, which is used to remove the mount, basically, which we have pressed. update mount is also same, where you can update the token or maybe the path. So you can keep the same mount, but maybe you can change the container in the storage account, etc. You can do. And then these are related to jobs, but when we cover the job, maybe we'll go through this. So this we will just skip for now. Yeah, this is what we have mostly. A notebook command is also there, but these are only two commands to run the notebook basically. So basically we can run one notebook from another notebook with having this command. This is really very easy command. Let's say we have one child notebook and we have one master notebook. From master notebook, we can run a child notebook. The scenario would be, let's say we have a scenario where, for example, we have one master notebook. And we have, let's say, child 1, child 2, or child 3 notebooks, something like this. But the prerequisite is before we produce this result. So let's say if we want to create output from this, but the prerequisite that we should have, commands written here should be triggered. So we have some dependency on this notebook. So what we can do is in cell 1, we can say, okay, fire this notebook, fire this notebook, fire this notebook. And let's say these notebooks are updating some tables for us. Okay, so let's say this is updating table 1, table 2, table 3. So this is like mini process happening here. Okay, so some queries are, firing, updating these tables. And in master notebook, we are combining these tables together and producing some output. So we depend on this manipulation of this. Maybe this is one layer where we are, querying this data and, analyzing or, formatting this, transforming this data in these tables. And then we are reading from these tables and producing the output. So this could be the scenario. Tomorrow we will look into it and understand more. So this is all about DB utils and the commands. Only few commands we left with. Tomorrow we'll cover this remaining one, maybe first 15 minutes or so, and then we'll continue with our next topic. Okay, thank you everyone. We'll authenticate to our Azure portal. Go to Databricks. So we'll open our Databricks workspace. Okay, so we are on Azure portal and we have just opened the Databricks workspace. Now today we are going to talk about command line interface of the Databricks. So I'll just open document CLI. Yeah, so maybe I can take this document here. So it's a command line utility. We can install it on a local computer and we can use it to basically, access some of the, some functionalities from Databricks. So CLI, it's you can install on maybe Windows, Linux, or whatever operating system you're using on this. And there is installation procedure as well. So you just right click and open it in new tab. And this is the detail about the command line utility. So we'll open it here and see that how we can install and update the Databricks CLI. So if we see in this article, we have installation about macOS. So on Linux and macOS, we can install using this methodology. So here, if we go, we can see the detail about this. And if we go with the Windows, we can install with Wingate, Chocolatey, Windows Subsystem, WSL. So there are several ways to install it. So this is the installation procedure or commands, terminal commands related to macOS and Linux. We'll skip this part. We'll go with Windows and with Wingate installation with the Windows. So we can search for Databricks in those commands. So I'll simply open a command prompt. So let me open it side by side better. Okay, so right hand side, I have command prompt and left hand side, the documentation. So I can maybe make it a little bit small. Okay. So in those prompt, we can search for, if we have Wingate installed, Wingate search and Databricks. By doing this, we will be able to search if what is the latest version of Databricks is available to install. So it will show that this version is available. And then we can simply type Wingate and then install Databricks dot Databricks CLI, and you hit enter and it will start the installation. But in my case, I have already installed this one, so I don't have to do this exercise again. It is already installed. So how we can check that we have Databricks CLI installed on the system? For that, you can simply type Databricks -v and it will show you the version which is installed here. And as we have seen the Databricks latest version, this is 0.232.1, and the same latest version is installed in our computer right now. Okay, another command, maybe you can just type Databricks space version and it will give you the same result. So instead of -v, you can type version. So it will give the same result. These are the installation method with the different, let's say, Chocolatey, you can install with the Chocolatey. So Choco install the same way you can install this and check. With the curl installation on Linux, macOS and Windows, also you can perform this one. So these are, various other methods, but it will do the same job basically. And these are some of the zip file which can be downloaded and installed. So briefly, Databricks CLI is helpful to perform certain tasks. So we'll look into it and let's see what else we have here along. So we understood about the installation, and now we'll talk about authentication part on the Databricks CLI. So now we have installed the tool, but we haven't connected it with our account right now. So we'll see we can connect with our account here. So if we go to authentication for the Databricks CLI, let's see. So here, if you see the first line says that Azure Databricks personal access token authentication you can go with, and with that you can authenticate to Azure Databricks account. So let's see. There are a lot of information. You don't have to go into these detail. You just need to understand that how you can authenticate on your account. So Azure Databricks Personal Access Token Authentication. Azure Databricks Personal Access Token Authentication uses Azure Databricks Personal Access Token to authenticate the target Azure Databricks entity, such as Azure Databricks user account. Okay. So let's see, I think there should be method here. So here the steps are to create a personal access token, because we are going to authenticate with the personal access token. So it has to be created in Databricks account. For that, we'll go to Azure Databricks Workspace and then click on Databricks username in the top bar. And we'll go to Settings tab. And from that drop down, we'll go to Developer. Under Developer, we'll go to Access Tokens. And then we'll click on Manage. Then after that, we'll create or generate a new token. And this is optional. You can put some comment and lifetime for 90 days. So default 90 days, this token will be able to communicate with your Databricks account using CLI. Okay, now you will press generate and it will generate the token, and then you can copy this token to a secure location because it will be visible once only. Just give me a moment. Okay, so let's go to our Databricks. And as the procedure, we should go here to our account, click on settings. Under settings, we'll go to developer. Under developer, we'll go to access tokens here. Under access token, we'll click on manage. And we can generate the token from here. Okay, so we'll click on generate new token. We'll provide the comment. This is like optional, why you want this token to be generated. So we are going to connect with the CLI or command line interface. What the duration you want for this token. So we can use, if we want it 90 days maximum, we can use it, and we click on generate. So here it will provide you the warning that make sure you copy this token because it will not be visible next time. So you will have to, if you lose this token, you will not be able to paste in your command line interface, and you will not be able to establish this connection. So that's why sometime you can maybe, keep this on secure location. So you copy this, and next step, we'll see what else we can do here. So yeah, to configure and use Azure Databricks personal access token authentication, do the following. So it will give us the procedure. Now we'll go to our command line interface and run following command. So we'll say that, okay, Databricks and space configure, and then we can configure or follow the instruction. So let's open our command line interface. I'll make it side by side view. So we'll go here and we'll say, okay, Databricks configure, and then it will ask for the URL of our account. So the workspace URL you have to provide. So that we can find from here. Basically, if we go to our account and maximize it for better view, and if I copy this URL up to my domain name, so Azure Databricks.net, and if I copy this, so I'll press Control C, I'll make it aside, and I'll go to the command prompt here, edit, paste. So why why it has copied so many things. It looks like something went wrong. Or it has copied multiple times, looks like. Okay, so Databricks host, we'll try to paste it again. Yeah. So HTTPS up to Databricks and we'll hit enter. Okay. Next question it will ask is provide the access token, personal access token. So we have created a personal access token and kept it open. So I'll copy it again. I'll keep it aside and maximize this. So I can paste it, my personal access token. I'll simply right click, edit and paste. So it will paste the personal access token. And I should be able to connect with my Databricks now. So this is like configured that you provided the secret key from your Databricks account, and this CLI is now connected with your Databricks account. So how we can verify? Let's go and see what are the commands. So we'll go under authentication page, and there should be something called profile, I think. This profile to make sure that you are connected. So I'll just go to next tab. So simplest way is that we can go to Databricks, auth, environment, host, and URL. And this should provide this result here. So I'll copy this command, minimize this, maximize this, and paste it here. So basically we want a workspace URL here. Okay, so after host, we will provide the workspace URL, and our workspace URL is if we go here, that should be our workspace URL. So we'll just keep it here. Copy, Control C, minimize this, and we'll say, okay, this is our workspace URL. So hit enter, and we are getting all this information. It means it has identified that we are connected with our personal access token to this host, and this is our token number, this is like URL, etc. So we are successfully configured with our workspace. Now let's see what else we have here. Okay. All right, so this is how it will give that what URL, what token value you have, etc. Also, you can get the profile information by using Databricks, auth, and profile command as well. So if we put it side by side, maybe better view, I think I can drag and drop here. So I'll clear this screen and I would say Databricks, auth, profiles. So it will list down that how many profiles are configured. Why this is there? Because you may have multiple Databricks account and you may have multiple profile associated with each account. So it will say if yes means you are connected, no means you are not connected with this account, or if there is any problem with the connection. All right, so you can test it by having some command as well. So these are some of the command maybe you can try with the Databricks. So I think I have some command. Let me see. So for example, what else you can do here is just to verify that we are connected with our account and to make sure. However, this is already saying, but some of the command maybe we can use like Databricks cluster list, for example, clusters list. So it should provide us how many clusters we have already created. So compute power. Let's say, for example, if we want to access the file system, so Databricks, and then you can say file system, for example, ls. It will take some argument, it looks like. So what I can do is ls, and I can say DBFS, Databricks file system. And now it provides me my files which are, or folder structure which is available with the DBFS. Okay, so you can see I have file store, volumes, and all those things. And if I would like to, like ls command we run in the, dbutils, so same way we can also use here and explore this. So let's repeat this command with the file store. So I just put this folder name and it should list me the folder of this one. So I have folder 2, folder 1, and tables inside. Let's say if I wish to go into the folder 2 using this one, I can go from here as well. Okay, so whatever CSV files I have, so I can, work with this as well. But this is not the real use here. Actually, we are using this CLI. So we which can explain this. Just give me a moment. So secret management in the basically what is the secret? Let me explain you before we begin with this. The secret is something which we want to keep confidential and don't want to reveal to our developers. So let's say if we are a Databricks administrator and we are dealing with the Databricks account and we don't want to reveal the passwords to our developer, but we want them to use with their, notebooks, so they can use it with the key, and they will refer the key there and it will automatically be providing the password for that key. So by making sure that we can have a key there, and that key we can create and keep in the secret management. So it's like key value pair we can create using this. So for this, first we have to have a secret scope. Scope you can assume as a container. Okay. So when we talk about scope, basically scope is a container to manage that secret. Okay. So we can use CLI. I'll just open this in new tab. I think we should have command, otherwise I should have another. So basically these are the functions we can perform using the CLI. This is basically theoretical part here. Looks like create an Azure keyword, configure Azure keyword. Okay, create this one. This one will follow afterwards. First, we will see how we can manage a secret in Databricks. So first option we will look into create a Databricks backed secret scope. So secrets, we have two ways to manage it. Basically, if we are using Databricks platform to manage the secret, then we can use the secret in Databricks itself. We don't have to use any other service. But some cases, some companies have policy to manage the secrets in a secure place, which is called Azure Key Vault. That also can be used to manage your secrets, and you can bring these secrets to your Databricks account. So why we are learning about secrets is that whenever we are connecting with the database or third-party database or client database or any production database or anything, we don't want that secret to be revealed to our developer who is working on that, and we don't want to have access to this secret or like clear text password. So here we can store these secrets either on Databricks platform, or we can store these secrets on the Azure platform, and we can, whenever in our notebooks we need the secret to be fetched, we can bring it from there. So let's create one and see how we can create it. So by CLI command, that's why we configured install CLI command, so we can create a scope. So secret scope is the it's like container. You can assume it as a folder of keeping the secrets. We can have multiple secrets inside of this scope. Okay, so create a scope using Databricks CLI. So simply we'll go to our CLI. I'll just keep it aside and I'll keep it here. So side by side, we'll go clear screen and just scroll down to the place. Okay, I think this is the right place. I'll just make it little bit small. Okay, create Databricks backed secret here. So okay, my command prompt is looking weird here. So actually these are both are overlapping, looks like. Okay, anyways, I think it's visible to you guys. So what we'll do is we'll type this command or copy this command from here and paste it here. Basically what it's saying is Databricks space secrets space create dash scope and provide the name of scope. So let's say if I provide the name of this scope, that Databricks secret scope 1. So this is just name to identify this scope, where or just you can assume as a folder name. So I'll create this one, and I think we should be able to list it down as well. So what we'll say is that, okay, Databricks secrets list scopes. So it will list down what are the scopes available. So here we have DB secret scope 1, which is the Databricks scope, and we have a previous one as well, which is the scope 1, which is the Azure Key Vault scope. So we'll learn about this as well. So this scope, now I can keep my secret inside of this scope. So let's say if I do have multiple clients and I want to keep their secret in separate scope so I don't get confused. Let's say I have database connection for client 1, somewhere stored here. So inside the this scope, I can maybe I can provide the scope name as a client name, and then I can manage the whatever secrets. Let's say I'm working with the multiple databases or storage accounts, etc. I can keep all the security stuff in this secret scope. Okay, so that's what the idea behind this. Next is and this feature is available in premium account only. So when you are working in the production, this feature you will see, but you will not see in the free account, or your community edition also you will not see this account. And next is I think we'll create, okay, so we created a secret, we listed down, and then we can delete this secret as well. So in the in between of this, what we can do is we can create a secret inside of our account as well. So I'll show you. Let me just correlate this. So listing down we have understood. So we have listed it down. What next we can do is we can create a secret inside of this secret. So how we can do this? I think it has provided the documentation as well. I'll just look into it, or I can provide. So if I open this in new tab, it should show me that how we can create a secret. So under secret, we have created the scope. Now we are talking about the secret inside of this. So we can create a secret, but this is the first one with the Azure Key Vault, I think. The second one should be with the, let me see. Yeah, this is the Databricks secret access list. Documentation is little bit not arranged as expected. Okay, yeah, here it's list secret. Yeah, so create a secret in Databricks backed scope. So because we have created the scope in Databricks, so we will first learn about this, that how we can create a secret inside of our Databricks account. So what we can do is we can simply type the Databricks space secrets, put secret, and maybe we can put the JSON, or maybe we can simply put the secret name. All right, so key name we can provide basically. So let's say I put Databricks secrets, put secret, put dash secret, SECRET. Okay, so that space, then the key name. So let's say this is the secret key 1. So this key will be created inside of our scope, right? So secret scope name we will have to provide. So before that, we will have to provide the scope name. So that is the DB secret scope 1 and then the secret key. Okay, so this is the format by which we can create a secret key. I'll hit enter, and then it will ask that please provide the value of your secret. So let's say I want to save a password. So I just put 1 2 3 4 5, anything, just to so that value is stored in by using. So when I am on the notebook, or I am using any programming stuff, I can call this secret key, and that will put it the value in instead of this key. So that's what the idea behind this. And then I can list it down as well. So Databricks, it should be secrets, and the list secrets, and I can list it for a scope basically. So DB SECRET secret scope 1. So I am listing down all the secret created inside of this scope. So it will give me the list of keys and encryption value. So here it's providing that how many keys we have created inside, or how many secrets we have inside this scope. Okay. Now next is we can also delete this secret, and we can use some commands. So before we delete, what we'll do is we'll just start our cluster here, go to my Databricks here, and we'll go to home. I will open a compute in next tab. I will start my cluster here. While it is starting, we can, yeah, maybe we can talk about this one as well. Secret scope in Azure Key Vault. So in Azure Key Vault, we have one service. So we, meanwhile, it is starting. Maybe we can talk about this as well. So that is called the Key Vault service in the Azure. Okay. So what we'll do is we'll go to our Azure account, and we'll go to home inside of our Azure account. And if we search for keyword service, so what we can do here is we can go to search box on the top and type key vault. So this service is provided by Microsoft to keep the secrets. So I can create a new keyword service, instance of keyword basically. I can choose the subscription. If I have multiple subscription, I can choose the subscription, and then I can choose the resource group where I want to keep the secret or the keyword service. And then I should provide a unique name for this keyword service. So keyword KP2 or something I can provide, which should be uniquely available, with the Microsoft domain. So this will create, make it accessible over the internet as well. Then I need to choose which region I want to, host it. So since we are working from Indian subcontinent, so we can use somewhere data center available in India. So I'll use India here. So India, we have 3 data center. I'll choose the West India. And then the pricing tier, if you are in the production, maybe you can go for premium. Otherwise, standard is more than enough. Here we have one feature called soft delete. So whenever you delete any secret, it will not be deleting immediately. It will keep it for 90 days. So we can make it, less number of days, but it will accept between 7 to 90 days. So we'll make it minimum. We have no option to disable or, this one. So we'll, at least it will keep 7 days. Purge protection also disabled this one. We can enable if we want it, retain that deleted vault also. So we don't need this. We are just going for demo right now. So then in access configuration, by default, it is having recommendation that you should have role-based access control. And this is the recommended one. You can have vault access policy as well. So I think Azure Databricks will work with the vault access policy. We can just switch it to there. And yeah, these options are, for Azure basically. Okay. So you can, communicate with Azure access policies. We have access policy for this one. So here, for this user, we have this policy where it can get, list, update, create. So all these tasks this user can create. And we can create another access policy as well. And we can provide whatever permission we want to provide. And then we can select the principal. So let's say get, list, key management, secret management. So this is like key management. We'll go with the secret management here. Basically 3 things we can manage here. We can manage the key, we can manage the secret, and we can manage the certificate. So we are talking here about the secret. So we'll focus on that, and we select everything related to this. Go next. Here we need to provide the principal or basically Databricks related, account. So Databricks. I should be able to get Databricks resource provider. I should be able to configure this one, and next. Okay, this is optional. And I should be able to create this. So now this application should be able to access this, and I should, from my account, should be able to access this as well. Next, enable public access. We will keep it open, so we can use it from internet as well. Next, So we are creating a keyword here with this, configuration. We'll hit create and it should create our keyword. So maybe few minutes it will create. Meanwhile, we'll see our cluster is started or no. So our cluster has started. So meanwhile, we'll check what is happening with our account or what we can use in the workspace. So what I'll do is I'll go to my workspace. I'll simply create a notebook, maybe in the user folder. I'll create a new notebook. Provide the name of this demo 06 November. Okay, so we have created this notebook, and what we want to check is that if we are able to see or scope or secret scope, which we have already created on Databricks. So there is something called DB utils secrets basically. And if I go for help, you should be able to list down the help items. It's already associated with this one, but this one new notebook, so it just asks which cluster you want to associate with. So here we can see we have these commands available: get bytes, list scopes. So these are some of the commands. Maybe you can try on this. I'll just comment it out, or maybe I'll go for next cell and I'll say, okay, I just want to list down the scopes. So DB utils and secrets, and then I'll say list scopes. Should have bracket, I think, yeah. And basically it will list down that how many scope we have. Okay, so this is not displaying nicely, so I can wrap it around display command. So I can view this in tabular format. So now I have two secrets, scope created, scope 1 and DB secret scope. So this one we have managed with the Databricks account. Okay, so that's what basically it's doing. So we last time we search it from here and we listed down by using Databricks secret command. Same thing which we are able to do in using the DB utils as well. Okay, so we can list down our secrets or secret scope as well. So let's say what we have in the DB secret scope 1. So if we want to see that, maybe I can open this one and I can say, okay, I want to list down. So DB utils, I would say secrets, and then maybe I can go for help and see. So I have some commands available like list scopes and all those things. So I can simply, go for list. And it will take scope as the parameter. So I'll provide the name of scope here, which is the DB secret scope 1. And I'll search that one. So it will list me down that how many secrets, how many keys are stored there. So same list secret command in this one. So this is how we can basically list down our scopes and secrets. Okay. So let's say if I want to refer this to my database string, I can simply, if it is having database string, I'll just put this one, and this one will provide me in the value of this key. Okay. All right, so let's see what has happened on our Azure. So our key vault is now ready. It is deployed. So what we can do is we can go to home. If I go to home, I go to my key vault, which the key vault is created. And I can see that I should be able to save some secrets here. So like we were doing on the command prompt on the Databricks backed secrets, the same secrets we can create and store into the key vault services as well. So this is Azure service. It is going to cost us separately, and we can generate or import the secrets. So let's say if I'm creating a secret, let's say I will say secret 2, for example, and I'll provide some password here, which I don't want to reveal. So I can put the secret value, and this is the key, basically secret 2, and I'll hit create. So now you can see that it has created a secret inside of this key vault. But this is not available in the Databricks because we haven't established any connection with this key vault service so far, right? So to establish this, let's see how we can. I think we'll go to secret scope. So in this documentation, we will see how we can configure this one. So Azure key vault backed scope to reference secrets stored in this one. So how we can refer or secrets which are stored in Azure key vault. Okay, so we'll go to key vault and how we can do this. So it will explain us. Databricks backed secret scope stored backed by encrypted database on. Okay, must be unique. So these are like condition that secret scope name, how it should be, and what are the criteria it should meet. So 128 characters, should not exceed this one. It must be unique in the workspace. You cannot have like two scope having same name, etc. So like the permissions related to secret. Now we'll understand how we can create a Azure keyword based secret scope in the Databricks. So we should be using Databricks CLI, looks like. Okay, requirement is this, that you must have a keyword contributor or owner role on the Azure keyword instance that you want to use on the use to bake the secret scope. So these role-based access control, you should have this role assigned to you. To configure your Azure Key Vault instance with the Azure Databricks, what you will do is you will go to Azure portal, find and select the Azure Key Vault instance, access configuration, settings, set permission model to Vault access policy. This we have already done because we went to our security, or when we created our key vault service, we have already configured the vault access policy and provided the access. Let's see if anything we missed. So here it is saying that under networking, you can go for settings. If you don't want it publicly accessible, then you can go to networking under settings, and under settings, you can go to firewall, virtual network, and allow access from public access from virtual network and IP address. So here you can allow to your trusted Microsoft services only. Okay. So basically what it is talking about, I can simply go here, and if I search here network, and if I choose this option, right now it is available anyone to open. If I want to access, or I want to limit the access to the keyword service, to only some of the services. So I can choose some virtual network, maybe I can configure the firewall, I can provide the exception to some trusted Microsoft service. So it will not be stopped by the firewall. Okay, so I can apply this. It should be working. So I simply have to hit apply, and now it will be available to trusted Microsoft services only. Okay. Let's go. I think, yeah. So this is where we were. So this is what it was talking about. Then what we can do is create an Azure keyword-based secret scope. So how we can create, so far Azure keyword is separately running. It is not integrated with our Databricks account. So Databricks is separate account, Azure is separate account, but these both are not connected. Means your keyword secret doesn't know, Databricks doesn't know about this keyword service. So to integrate this, what we can do is we can go to this URL. Okay, so we'll have to, basically this URL doesn't exist, so we'll have to manually create this. So URL is that you have HTTPS and then Databricks and the instance of your Databricks. So basically your Databricks URL, this one is talking about this one, this URL. And then you have to push or put hash secrets and create scopes. So this is actually weird way to create or link with the Azure keyword. They could have better way. I don't know. They kept it like this. So you replace with this and little bit it doesn't work sometime as well. So if and further, if you are not using the scope in this format, it will not work. So if S is not capital, it will not work. And it doesn't work with the same browser as well. So sometime you have to open with the private or incognito mode as well. So let's try it. So what it's saying that you should have your instance. So I'll simply go here and let me open the new one. So I'll simply open this one here. And if you see in the notebook, maybe I'll copy this and I'll show you. Notebook, Notepad. So in Notepad, if I copy this URL, this is my account information, Azure Databricks. This is my unique number for my account. And this is like a static one, Azure Databricks.net. And then this question mark, and this is my workspace. Okay, so you can have multiple workspace. Like if you notice, I have workspace here, and I created earlier one workspace which is not deleted. So it is also there. So you can have multiple workspaces. So this is my workspace. So this number represent that workspace. So if I go to another one, it will have another number basically. So this number represent this one. Now, if I basically what it's saying that after this I should put hash and what was that document? Let's go back. I think, yeah. So I should put this word after this. So copy this as it is. And after hash, I should have this one. So if I target this URL, it should open. So I'll open in new tab. Let's try one. Hit enter. So this will have this URL like this. When I hit enter, it should open that page. Let's see if it opens. So what is happening here is that automatically it's just making it, small letter, and the S should be capital letter. So it is not working on this step. So what I will do is, because I faced this problem earlier as well. So what you need to do is you need to open this in private mode. once you open this in private mode, you paste your URL, and now you make sure that your S is capital, and you hit enter. So it will ask you to authenticate, you sign in. My sign in is little weird, so I will simply go to my Azure account. I'll go to enter ID. Enter ID. And I'll look for my username. So this is my username. I click on that. And I should use my principal name. So I'll copy this. I'll go back to my another window, which is this one for authentication, and paste it here. Hit next. And then I should provide my password. And then it will have the authentication request on my authenticator application. On my mobile, I need to put this number. So very highly secure stuff. And then I can stay signed in. So if I make it a little bit large. So now if you see, I'm able to open this window. But because of this S was not getting, capital one in this one, so I was not able to open it in the regular one, like Edge. I had to open it in private mode. Then it is, opening this one. So it was just showing me blank. If you have noticed it, I think where I tried here, somewhere I tried. So yeah, I think maybe I have closed it. Yeah. So this was showing me the blank screen, right? But in private mode, now it is, I am able to open this window. So this is what I was trying to open. Okay, now what I will do is I will just give this name of this scope. So I'll provide the name of scope here. So I'll say, okay, this is going to be Azure, Azure Key Vault Scope. Okay, Azure Key Vault Scope. And I should, if I use that everyone can use this, so I will choose all workspace user. So all the user on this account will be able to use these secrets from this keyword. Then I need to provide the DNS name of my keyword, which is like fully qualified name. So what I'll do is I'll go back here to my Azure account, go to home, go to the keyword, and this URL I need to provide. So I'll copy this, go back to here, and put it here. Okay, so DNS name I have provided. Now I need to provide the resource ID of my keyword. So resource ID is like unique identification for my keyword. So I'll simply search for properties here. So instead of going here, I'll simply search here properties. And I should be able to open the properties tab here. And if I go for resource ID, I can see the resource ID here. So I need to copy this resource ID, go back to the window and paste it here. So this is my resource ID of this one. So I will maximize this for better view. Now I can hit create, and it should create a secret scope which is related to our keyword. So I'm like setting up the connection between keyword and Azure Databricks workspace. So the secret scope name, this one has been added. Manage secrets in scope, Azure keyword, we manage principal. Okay. So now I should be able to call these, in my Databricks. So I'll minimize this. So incognito we have finished working. Now if I go for list of the scope, so I think, yeah, again it got terminated. This is really weird. Let me restart it. We started actually our cluster, but our cluster got terminated because I'll just go to compute and I'll start. Maybe it will take a minute or two. So now whatever we are, like why we are learning about secrets. So in next session, we are going to discuss about connecting with the databases, connecting with the, let's say storage account, which we have already seen. So whatever account or databases, external sources we are going to connect. In professional life, you are going to manage in the secret, or maybe you're, someone who is going to be administrator is going to provide you this information in the key vault, or maybe in the, Databricks manage scopes. So you should be familiar with this before you proceed. So you need to include this secret or using the DB utils in your account. So in your notebook, you will be using these secrets to fetch the information, connect with the, whatever sources you have. You may have multiple sources you are dealing with. So you should be familiar with these secrets. So we followed this process. All right. So we have followed. So created this one and get. So both of this we have understood. So this was like creating a key vault. We created the key vault. We connected the key vault with our, Databricks account. And then the first one was we have done Databricks based secret scope, created a secret, listed that secret. Also, we can delete this as well. So just by pressing Databricks space secrets, delete a scope, you can delete entire scope as well. Let's see where our compute is. Now it's still starting. Meanwhile, we'll get ready to perform here. So we'll hit this command to list down our scopes. So we should be able to view our scope here from the key vault one. So right now it's showing 2 right now. So it should show us 3 later on. Yes, now finally restarted. I'll run this command. So now you can see that our scope is created and listed here. So if I go and if I put this here in next cell, I should be able to list the keys. So now we created a secret 2 inside of our Azure key vault. It is going there and reading that key. So now it has successfully, integrated with our Databricks account, and we are able to fetch the keys. So let's say if I am creating another one as well, let's say, let's quickly create one more. Key vault, go to objects, secrets. Okay, so basically what has happened here, see, it doesn't allow me to access this key vault now. So what has happened? Because we restricted in networking, with the limited accessibility. Under networking, we limited it and we didn't provide our own IP here. So my own IP is restricted. So if I go to what is myip.com, I should be able to see my public IP address. I copy this. I go to keyword and provide this one here and apply this. So it should give, it should add this IP into the exception. So yeah, now if I go to my keyword, I'll stop the search, go to secrets. Now I'm able to open this because my IP is in exception now. So I think we created secret 2. Now we'll create a secret 3 and provide whatever, number, and also we can set the activation and expiration date. This feature also available. And now I should have secret 3 in that one as well. So if I run this, now you can see I am able to fetch the secret 3 and secret 2. So I will be able to, whatever number of keys in this one, it will act as a scope in Databricks Azure Databricks, right? So I can see it from here, as well as I can create my own in Databricks itself. So both the platform I can use to manage my secrets. Either one, maybe some companies have policy to manage on Azure, so they will follow with the Azure keyword. Others, they do not have the policy, so they can simply manage on the Databricks platform itself. Security point of view, why people manage or why companies manage their secrets on Azure keyword is because they want to manage their permissions, and they don't want the permissions with the data analyst or data engineers, because data engineer and data analyst, if they are having the access to the all the security stuff of their client, it may be they feel like it is risky, so they give this access to or they give the permissions to manage Azure administrator people, so they manage the secrets, and they give the access to Databricks people, so they can fetch it and use in their code. So that's what the objective, to keep managing the secrets separately from the Databricks platform. That's it for today. All right, thank you everyone. So today's topic, we are going to discuss about connecting to SQL Server, means external data source. Okay. We have gone through this document earlier as well, so I'll quickly walk you through this. That this is called Lakehouse Federation, means when we are connecting with the database system or external database system which we don't want to load into the Databricks, then we can call it or we can query it directly in that database. So let me zoom it a little bit further. So this is called Lakehouse Federation, means the data we are not fetching in, rather we are just creating a catalog which is called foreign catalog. So we are creating a connection for that, and we are creating a foreign catalog. Lakehouse Federation is a query federation platform for Azure Databricks. So query federation describes a collection of features that enable user and systems to run queries against multiple data sources without needing to migrate all data to a unified system. So we are not bringing in the data to our unified system. We are just fetching or running the queries directly on the database management system. That means that we are not using or resource or cluster resource in that case. All right, so we have already discussed about this and went through this document earlier. but now we will create one and see. So here you can see we can use this federation concept for maybe just to prepare ad hoc reporting, proof of concept or exploratory phase in new ETL pipeline, etc., supporting workload during the incremental migration. So these are the some of the reason which we may use this approach. And what is the use case for federation is that you don't want to ingest the data into Azure Databricks, then you can use this. Second is you don't want to query to take advantage of compute of external system, means the query will be running on the external system, so that's an advantage. It will not be costing us. You want to take the advantage of Unity catalog interface and data governance, including the fine-grained access control, so we can manage the access control as well. So what we require to have a federation setup, or how we can connect basically with the external database system. So one thing, we will have to create a connection, and it's going to be a securable object in Unity catalog. Okay, so we can connect with the external database system. And second thing, we require a foreign catalog. So we'll create these two things, and we should be able to connect with the external system. And these are supported data sources with which we can connect using a connection and foreign catalog. So either MySQL, PostgreSQL, Amazon Redshift. So these are the database systems we can connect with. So connection requirement, we should have a workspace enabled for a Unity catalog, and compute requirement is that we should have a cluster running. So this is like runtime, which should be 13.3 LTS or above. Okay, if it is below that, it will not be running. Or so this is minimum compute requirement we should have, and these are the permission that at least you should have these permissions configured. So as we are the account owner, so we shall have all the permissions available anyways with us. So now what we'll do is we'll create a connection. And to create a connection, we'll go to Catalog Explorer and we'll create a connection. So before we proceed with creating a connection and foreign catalog, at least we should have a database system so with which we can connect. For that, what we'll do is we'll go to Azure. In Azure, we'll go to Home. I'll go to resource groups. So basically, we are going to create a database. We don't have any database created right now. So we'll go to a resource group, whatever resource group you have available, you can go to that and click on plus create button. Here you will type SQL Server. And check the Azure services only. So it will show you the services which are offered by Microsoft. And the easiest or smallest service in SQL is Azure SQL Service. So I'll pick this one because others are, specialized services or little bit expensive services. So either we go for SQL database or managed instance. These are little bit expensive. The minimum viable or just for the lab or demo purpose is SQL or Azure SQL. We click on create button. And now you can see that all these options are available here as well. So SQL database, SQL managed instance, or SQL virtual machine. So basically SQL virtual machine is the virtual machines it will create, and it will have the SQL server installed over it. In this option, we will have managed instance, means you will have SQL server running, but you will not be managing the virtual machine for that. And the first option, which is the minimum possible one, that it will just create an instance or one instance of database. So you just get one database in it. and we'll click on create. So in first basic tab, it will ask some details about the project. So here the first question is, what is the database you are creating for? Means what exactly the database you want, the name of database you want. So generally we take a simple name, so database 1 for example, and what the name of your server you want. So you need to create a server. Server is like container where this database will be running. So we'll provide a server name, which is, fully qualified domain name. So we will, it will have a .database.windows.net at the end, and it should be, unique name over the internet. So I'm just putting Kamal DB server and then .database.windows.net. So if it is available, it will tick mark. Let's say, for example, if it is not available, so let's say, for example, this is already in use by someone, so it is not available, so it will not allow you to create this server name. So it should be unique. So kamaldb.database, so this also is available, so we'll go with this. And then we have to choose the location where we would like to host our database. So this is the region. We would like to keep our database system close to our cluster running. So a cluster is basically based in South India. So we'll choose India and we'll pick the South India, Asia Pacific. So this database will be created on this data center basically. Click OK. So this is the server detail. And here you can see next question it is asking. So in server detail, we have filled this, and now in authentication method, it is asking, would you like to authenticate using the Entra ID, username and password, or would you like to use the user SQL or SQL authentication? Means you would like to choose, if you choose, let's say, Entra ID 1, it means that your Entra ID user will be able to log in, and there will not be user created on the database itself. The second option, if we choose, then we will have choice to create username and password on the database itself, and our Entra ID user will not be able to log in into this database system. So if we go with the middle approach that use both SQL and Microsoft Entra authentication, so most of the databases you will find in either in the production or with the client having both the options. So as your requirement is one of the username and password you can use to authenticate into the database system. So this middle approach is combination of both basically. So since it is the combination of both, it will ask that whom you want in your Entra ID to be the admin of this database system. So one admin is from SQL end, one admin is from the Entra ID end. We'll create or we'll set one. We'll click on users. And we have some users, so we can pick the user and make that user admin of this database. Select. So we pick the Entra admin, or this is going to be the user from Entra ID, is going to be the admin for this database. And then next question is the server admin login. So whom you want to login, or what the username you want to login from the SQL server. So we have DB admin. We can use this username. Basically, we can create any username and then the password. So password should have this requirement meeting. So what are the requirement? Let's see. Azure password, it should have special character. So all the requirements should be meeting here. So we have to repeat this same. So both are matching now. So this username and password created, and we will click OK, and it will start creating this. Now we are still on the basic tab here. Here it will show you. So I'll close this pop-up. Here it will show you, storage cost, GB a month, how much cost it will have. So it will give us the estimate here. So okay, I want to use SQL Elastic Pool. So if you want to extend this scaling point of view, then you can go for yes, because we are going for development approach. We are not going to create this database for the production one. So we don't want any price specific or heavy what do you call the performance related options. So we chose here environment for development. Then here the compute and storage, we can go for minimum one. I think there should be, this is providing 32 GB of storage. We don't have this much of requirement. So I'll configure the database. And this is going to be most budget friendly, and we will go. So we have two options, basically vCore based purchasing model, the second DTU based purchasing model. So if we go for this basic, for less demanding one, it should be costing us very less. So here maximum data size in GB is going to be 2 GB maximum. So I can make it even 1 GB or something, because we'll start with some sample data. So I just kept it 1 GB is more than enough for us. And then we have the backup, redundancy. So we will go with the local redundant backup storage. We don't want it geographically replicated. So this is expensive one basically, and we're going with the cheapest one. Next. So now we are on, we finished the basic tab, questions. Now we are on the networking tab here. In networking, we can provide what connectivity we want with this database, right? So either if we are going with the no access, means no one will be able to connect with this database. If we go with the private access, so whatever the IPs we will provide are going to be able to connect with this database. For this demonstration, we'll keep it public. So from anywhere we can connect with this database. Will remain open. Connection policy, here we will use the default one. We don't want to create a proxy or redirect through some hosting database or something. So we'll keep it default one. Encryption, by default it will use the TLS 1.2. If you have a specific requirement to choose one of these, then you can change it as well. Click next. And in security tab, now these are like some additional service. If you want to have Defender for SQL, you can go with this. So we'll just not now. If you start with the trial, then later on it is going to cost you from next month. So we are going to keep it not now. These are some additional services if you would like to configure. So since we are just going for basic demonstration, we don't need all these services like auditing purpose. Here, the additional setting, we have data source. So if let's say if you have a backup in of any previous database with you, you can use the backup. If you want the fresh database without, means empty database without any table structure or anything, you can go with the none. And if you want a sample data, because sometime you just want to experiment with some data, so you can create a database with the sample data as well. So here since we don't have any backup, we'll go with the sample data, and it will create a adventure works LT database here. So it will, keep some sort of, sample tables created for us. And then database collation, it will use this one. So this is like language related stuff where you can use this collation. Since we are using the sample one, so it is disabled for us. Click next. Now, if you want any tag to be associated with this database, you can keep it with this database. Otherwise, you can keep it empty as well. And finally, we'll click on review and create. In review and create, it will show you that how much estimation of this database to cost us. So it is going to cost us $423 or sorry, Indian rupees in a month. And this is the just estimate. It can maybe go high or low depending on the queries and data which we are going to transfer. And whatever we filled in the tabs, it's going to show us that. So if we find anything incorrectly filled, we may change it. So all these settings, and we'll say okay, click on create. It will start the deployment of database. It may take 1 or 2 minutes just to create the database. It has created a policy, SQL Server. Now it is creating the database. Our database is created, deployment complete. So if we go to home and if we click on resource groups, we go to our resource group where we created the database. We can see that we have one database created, and that database will be running inside of this SQL Server. So since it is a platform as service, means this is logical SQL Server. It is not the actual physical one. So we can act, or we can use this one as a SQL Server for us. But this is not the like virtual machine or something like that. So this is just a service for us. You click on Databricks, and what we'll do is we'll just follow the instruction. So now we'll go to our Catalog Explorer, and in Catalog Explorer, we'll go with the Azure Databricks Workspace and click on Catalog. And on top of that, we'll see Add button, and we'll add a connection. We can go to external data and do the same thing. So this is alternate method. Then in connection type, we are going to choose our SQL Server, and then connection properties, we are going to provide the host information and all those things. Then we can test the connection, that if connection is working then we can click on create. So let's see how we can do this. Alternatively, if we don't want to follow this process, we have the option to create this connection using SQL as well. So this is the alternative option. Here we can connect it using create command in SQL in the basically the notebook, and we can say create connection, and then we can provide the name of connection, type of connection, whatever the database we are going to connect with, and then in the options we can provide the name of host, port where it is going to connect, name of user by which we are going to authenticate, and the name or basically the password which we are going to provide. So alternatively, if these secrets or these confidential information, if we are not going to have publicly available, or these are managed with the secret one, which yesterday we understood that how we have secrets, then we can use this SQL command. So here we can create a connection. So here what we can do is we can store this stuff in the secret, and from secret we can fetch it. So we need to provide the name of scope or scope name from the secret or secret scope name. Either it is on the Azure Key Vault, or maybe it is on the Databricks. So we'll provide the name of or scope name, and then the key name. Okay, so this will replace with this secret, or so this string is going to be replaced with the actual value of this key. And the same way we can have the secret for password as well. Okay, so we can so this is like not going to show as a string, but here it is like open. So this is like anyone can read and maybe look into. So if we have multiple people working, it's better to keep the password and username in secret. Okay, and in this case we don't have to be worried, because we will be copying it, or basically we are just filling up the form, so we can, it's like it is not revealed. So let's go to Databricks, and then we'll go to, I think, catalog. I'll make it a little bit large. So here you will see a plus sign. Here you can go and you can add a connection. Okay. In connection, we have to provide whatever the name of connection we want. So let's say I will say SQL connection, or I'll just make it DB connection, SQL connection, SQL DB connection, action -1. So we can provide or distinguish this connection if we have multiple connections. In that case, it's better to have a connection name, properly written, so we can see that what database is going to connect. Then we need to choose which database we are going to connect. So we are going to connect with the SQL Server. So we are just choosing this one. Then authentication type. So is it going to be with the OAuth, or is it going to be with the username and password? So we will simply choose username and password here. If we are choosing the username and password, then it's going to ask for the host name. So host name is like full server name of the host. So how we'll get the host name? I will go back to Azure. We'll click on our resource group and we'll go to the SQL Server. You click on the SQL Server, and if we click on show networking, I think not here, looks like. All right, so we'll go back and we'll click on our database. And this is the server name or host name, you can say. So I'll copy this, and this is going to be my host name where I will be connecting to. So I'll go to Databricks again and put the host name here. Okay, and it should be without HTTPS and prefix. So we'll simply type this name. And this is the default port, unless if you have changed the port while you creating database, you can change it accordingly. Otherwise, you can keep it same. Then the username of your instance. So basically when we created the database, we provided the admin name, which is the DB admin, and we'll provide the password. And if we wish to write any comment, we can write, and we can simply test from here. So before creation, it's better to test. So if any error or anything, to test this one, we will have to start the SQL warehouse. So let's start it from here itself. It may take maybe 2 minutes or 2 to start. Meanwhile, we can open another tab, maybe ADB. So it's still starting. Okay, while it is starting, it may take time. So what we'll do is we'll go to our database, and in database, I'll show you one thing. There is a query editor. In query editor, we can see what sample data we have meanwhile. So what we'll do is we'll just type the username and type our password. We click OK, and we are not able to connect here. So basically what it's saying is that my IP address, which is my local IP address, is not in the allowed list. So I can add this my IP in allowed list by using this link. So I can click OK, and it will update the firewall, and I can click OK. So now I should be able to log into this system. So here, query editor, I am able to log in. And if I expand this from here, this is the sample data or table structure created. So it's really good for experimenting. If you don't want to create these tables manually, you have data available in these tables and you can easily query it as well. So let's say select star from customer, for example, and you can run this query on database itself. So this is like, you can see all the results. Same way, product. It's written twice, so you can fetch the data here or test the data here as well. Meanwhile, let's see if it has started. Okay, so SQL Server is started. Let's test it. Connection established, basically. Okay, and there is a warning associated with this. Let's see if it works. So we'll click on create. Close this pop-up, and our connection is created. Right. So once the connection is created, we will see here that we have one option available, create catalog. We can click on create catalog, and in next step we can provide the name of catalog here. So let's say catalog 1. If we provide, this is going to be a foreign catalog because this is external connection. This catalog is going to use this connection. So here, since we are clicking from the connection interface, it is pre-filled for us, and we can choose the database 1, I think, or database name was database 1, if I'm sure. We are on server, looks like. You go here. I think we provided, yeah, let's see in the connection. This is the server. This is the catalog. DBMS password. This is the server address. I think it should be, if I'm not wrong, it should be database 1. I'm not sure about this, but let's try with this. Let's test this connection. Test. So connection got some issue and cannot establish this connection because check connection information, port, username, database option, if you be correct. All right, it looks like that we are using here SQL warehouse, which is not going to work with this. So what we can do here is that we can start our compute as well. So I'll right click on compute and go to compute. And I'll start the compute from here. So meanwhile, what we'll do is we'll go here and see if our database is correct. Database is Azure user. By mistake, I think we created database like this. So our database name should be Azure user in this case. Right. Okay, we'll try with this. So if we go here, we can edit our connection from here. And here, because this is server information, we already tested this connection. So again, we can test maybe DB admin and Azure AZURE. And we can test it again. Let's see if it is working with this or cluster is not started. We can choose both. So connection established means server, we are able to connect with the server. But next step, we need to, create a catalog. And let's just provide this one. And here Azure user will provide Azure user. Okay, so catalog created. And we can configure catalog. Now in configuration, we can see that all the workspace, we want everyone to have access to this database. We can, tick this and go next. Owner of this, the permissions, if we want to, grant more permission to other users, we can do this from here. And if we want to provide any tags to this database, then we can provide this and we can click on save. Sorry. Okay, so basically it requires 13.1. So this is like warning. What we can do here is either we can choose this or we can choose the cluster so that warning will go away. So our cluster is still starting. We should be able to see this table structure under catalog 1. Once I think it starts, then it will show the details here. To run the SQL statements, we should have SQL warehouse started, and our cluster is like compute resource where it is going to run. Let's see if It is populating. Yes, our cluster has started. And now I think it is trying to load the information from our SQL Server database in Azure. It got some error. Let's see. SQL Excel cannot connect. Requested the login client with IP address. This is not allowed. So it looks like firewall is stopping us to connect with this server. So we can provide maybe this IP address in the safe one. Let's go to fire security. Let's see if anything is stopping here. Not here. We go to resource group, click on server. Let's go to networking. And here you can see the rules are configured. So we can stick here, allow Azure service and resources to access this server. So this should allow our Databricks account to, connect with this service. Now we'll go back to our catalog here. And again, we'll try this. Oh, yes. So this time we are able to connect. Okay, so you can see we have a schema. So there are so many, schemas, but we are talking about the user schema, which is the sales IT. Here we have some, tables created, and these tables we are successfully able to open in our Databricks account. So this is the federation. We can see even the data from here. Okay, so we are able to fetch the data, all this. We can configure the permissions related to, we can grant the permission to our Databricks user, etc. All right, so next thing is that we are, successfully connected with this database, and we are able to, bring into our Databricks system. Next, what we can do is, so let's go through. We have followed this whole procedure, done this. Okay, now these are limitation and all those things. So we don't want to go here. Let's see what we have here. Okay, so next stuff is that run federated queries on Microsoft SQL Server. So how we can run some queries on this, we'll see. We have already done this part. This is already done. And this is like data mapping. So when we, run this, so we have a SQL Server data type. So these are the data type which are mapped with this Spark data type if we wish to, query it. So these are the data type we have. Okay, let's see. And now what we can do is we can go to SQL Server reference and we can, retrieve some data. So let's go to DML statement. All right, so I think not the DML one. We'll go for retrieval and select statement. So we can use our select statement in query and we can bring in the data. So quickly we will jump to our notebook. So this is our, catalog. I'll go or open the notebook in Workspace. I'll go to shared one. And I think I have already created one in SQL. So in SQL folder, I have created one notebook. I will close this just to make more space. So what we can do here is we can use the catalog. So what the name we have provided to our catalog is going to be catalog 1, right? Here. So we can say we want to use catalog 1. And this is going to be our schema. So we want to use this schema and we want to use this catalog. And we will just hit start and it should return us okay. So it returned us okay because it would have returned something else. So it means now these are like set that we will be using this catalog and this schema. Why we are putting this statement? So we don't have to write fully qualified name. Otherwise, what will happen that in next query, we'll have to write like if I want to fetch something, then I will have to write first catalog name. So it will be catalog 1 dot sales IT, something like this. And then so now since I have used this statement, I don't have to write this stuff. I can simply write the table name. So I have one table, which is the sales order header. I can click on this and it should be running and fetching the record from there. So I am able to fetch this record in this. Okay. Same way, I have, maybe I can comment it out. So I can comment it out about dash dash. And I can activate this statement, which is the select star from customer table. We have customer table and we can use the limit to, limit our results. So let's say if I want to bring in the 10 records only. So it will bring in the records, like 10 records only we got. Okay. So like I can fetch this one. Okay, I'll minimize this. This is like about the select statement. We can run the select statement. Maybe we can use the column names as well instead of star and all those things. Then about the join, we'll just expand this. So let's say if we want to join two tables together. So we have already, used these two tables here in the select statement. In next cell, what we have done is we said, okay, select the first name from the customer table and the count of sales order IDs from the second table, and then from customer inner join with this one on customer dot customer ID and sales order header dot customer ID, and group it by first name and having count more than. So basically what we are saying is we want to group by the first name. So whatever the first name in the first table, we are going to count the orders which are being placed, and in having close, we are counting the order only which are having the value more than 1. So if I run this query, I'll get only one record because only one customer has placed order twice, so 2. If I make it, let's say for example 1, and if I run the query again, so what has happened? Failed table existing check LT customer somewhere. Why failed? We just ran the query. Both the warehouse and both are running. Should not have failed. Let's see. Okay, failed unclassified. Okay, let's see if I make it less than 2. So maybe your query has some issue. Yes, this time it is working. Maybe equal sign was having issue, looks like. So is it going to take double equal sign? Yes. So it was equal and 1 is supposed to have be. So now it is returning with the only 1 records or 1 order only placed. So this is how we can do the inner join and fetch the record using SQL statement. Okay, next cell what we did is we used the SQL statement this time, but with the smaller footprint here. So you can see here we have like inner join clause, and since we have column name same, so customer column name or customer ID and sales order ID are the same naming. So we can do this by having a using clause. So what the using clause? We can say select star from sales order header, join with the customer, okay, using customer ID. So both the tables should have the same column, and if with this statement it will return everything which we want to return from any table. Okay, so like this we can return all the columns from both the table. Okay, so this is like using clause. And then what we can do is we have some more commands available. So if we want to show the table in a schema, we can have show tables from sales IT. So this is the schema name, and these are the tables which are in the schema. So by having this command, we can return all the tables available in this one, and it will show if it is the temporary table or permanent one. Okay, so next one is show views, and by this command you can if you have any view created in this schema, it will return the same way like table we have. And then what we can do is we can refresh the table as well. So let's say this SQL database is having continuous updates, and sometimes what happens that we have these entries or the customer information which is fetched. So we can clear that cache in Apache Spark, and we can ask it to fill it with the new or updated information. So this is the refresh table. So these are some of the SQL commands. I'll give you the command reference. I think I was having there. Yeah, this is SQL Server command reference, SQL language reference. And here you can see a lot of reference available. So if I go here, I think there was a place where data types, principles, lot of information available. So these are like alter command we have. These are the alter commands. These are creatable. If we want to create table, volume, anything we want to create, we have these commands. A lot many commands, and these are like list commands. So we can get the list of any, let's say, file or anything. Insert into command will insert the record. Get command will get the information. Load command will load. Having clause, like we have, group clause we have discussed. Values, we can get the values from order by clause, we can order it by. So like we are on select command right now. So this is like select command. We can use distinct keyword as well with the select. Star clause will bring, all this. Where clause will, we can search it or sort of filter it. I think where clause, maybe we can try in the same one. Okay. So what we can do is, let's say if I want to fetch the data from some other table, for example, let's say we have, let's say we want to see what tables we have. So we have order detail, let's say product table, right? So sales IT product, we can go for select star from product, and we'll just hit the play button here. It will bring in all the products, and by the where clause we can limit the output of this. So let's say where let's say how many records there are a lot many looks like. So at the end it should show us that how many 295 records. So let's say I want to bring in the products with the having product ID greater than 900, for example. So like this, I can limit the output. Okay, so I have only the product returned with the product ID having 901 or 900. So same way I can limit the output of columns as well in this. So let's say if I want to limit I just want to see the name and color, for example. So I can say name and comma color, and it will bring in only these two columns as output. Okay, so like this I can have this manipulation here. Refresh table we have seen. Okay, where clause we have seen. Order by will basically order it by. So maybe we can descend or ascend the order, means the output which is coming in, we can either say ASC, means ascending order, or descending order. And also we can have like a nulls sort, direction, or nulls first, nulls last also we can do. So for example, let's go here and we can say, okay, order by, and we can say order it by product ID DESC, descending. So I think we are not returning this column, but yeah, I think I did some mistake here. Let me just put product ID. Product ID. And it will return this, with the product ID. Okay, so this is how we can order it, group it, filter it, limit it. So there are several commands available. You can, slowly practice some of these, but you don't have to go to all the command and, understand. So like show command we were talking about. So in show command, we have like, you can show catalog, columns, connections. The show command is, extensive. You can show anything basically. So you can see in the notebook itself that how the structure, how many, and how the schema is, and all those things. So these command you can practice, and these are the only command with the SQL Server. So today we understood about creating a database, SQL database, having a sample, figuring out what the problem we may face when we are creating a database and putting the data into, and maybe connection related issues, how we have to provide the connection to the Azure, Databricks. So Databricks can, query with database. So connection, catalog, querying the catalog, all those things. So this is how we can, connect with any of the database and use it with the notebook and trigger the SQL queries, and these queries are basically running on the SQL server itself, because these are not using your cluster power from your here Databricks, because Databricks cluster is just providing or facilitating the fetching the results, not querying it. Query actually happening on the DBMS itself. So whatever it could be, any database system, and the same resources we can use to query or bring in the data, just triggering this one. Okay. Other than that, like we understood about joins as well, we have two more joins. So left join and right join also we can use here. So left join will bring in the data from all the data from left hand side of the table, and so left table we will get all the data. If we are doing right join, means we will get all the records from the right one. Okay, so these are like some of the join we have. I think it should be in the reference as well. Where was join? I didn't see it. It's supposed to have, yeah, joins are also there. So you can see we have joins here, and we have inner join, left join, right join, full join from both, and cross join. So these all joins are available. You can read about these. You can test it with your this thing. So each commands are really written nicely here. Everything is available, and as your job role requires you to create complex queries in future, so you can use these commands, and you can use your notebook, and you can practice this. So lot many commands here available, and this is about connecting or querying the database. So now how we will clean up our stuff. So first we have to delete. So what I will do is notebook I will let it be there, but then what I need to do is I need to stop the compute. I have SQL Server stop. Compute I can stop. So just cleaning it up. And in catalog, I can go and remove this from here. So I can delete the catalog. It will delete the catalog from here. So connection, now we need to remove the connection. For that, we'll go to add connection. And we'll click on connections from here. And then we can click on the connection, existing connection basically. And I think we should have delete from here. So this, triple dot, we can delete this one. So we deleted the connection, we deleted the catalog which we created. And now we can delete our database. So we can go to a resource group, we'll select database and database server. We can go to this triple dot and we can delete this as well. So we are deleting SQL Server and deleting our database. Click delete, and this is also gone. This is how we'll clean up, or if we are just testing, so we can clean up everything. So we stopped our what do you call compute power. We are before we closing the session, we should stop this, so it will not cost us. This is also stop. This is also stop, and that's it, I think. And we removed connection, we removed the catalog, we removed the database. Yes, so this is gone from here. Now you don't have any resource in this resource group. So starting our Databricks. Okay, Databricks is there. Now what we'll do is we'll start our compute. and we'll keep running our SQL warehouse as well. While this is starting, we'll go and open our notebooks. So today's topic is we are going to learn about the pipeline. Okay, we will start with the basic pipeline, and then we'll look into a pipeline which is having, little bit advancement. So maybe we will be dealing with the two pipelines. I'll start with the basic one. I should be able to merge it with this window. Okay. All right. So let's see how we can build a pipeline out of these notebooks. Okay, run your first ETL workload on Azure Databricks. So here, these are the steps given. Like we have to have cluster. So we have already cluster in place. We just need to create a notebook and then configure Autoloader to ingest data into Delta Lake. So basically, Autoloader is a feature which is helping us to load the data into Delta Lake. All right. So then we can process and interact with the data. Maybe later on, or along with this, we can schedule this job or notebook on regular basis as well. So we'll go through one example while our compute, I think, still starting. Meanwhile, we'll go to, okay, I'll keep one tab open for compute. So at least 3 tabs we have to keep it open. One for catalog, one for compute, and one for our notebooks. So we have here catalog, where we can see all the catalogs, and one we can see compute, and one we can see with the notebooks. So I'll go to Workspace, click on my shared one, and start with the basic ETL pipeline. So I have already created one folder. This is the folder, basic ETL pipeline, and I'll create a new notebook. I'll provide different name, maybe basic ETL notebook 1, something like this, just to identify this. We may have multiple notebook. I think we have a notebook earlier, so I'm just providing different name from this one. Okay. Now let's go to our documentation part. So run your first ETL workload on Azure Databricks. So how we can use production ready tool in Azure Databricks to develop and deploy extract, transform, and load, or ETL pipeline for data orchestration. So we'll go with the requirement. Requirements are like you should be logged into here and you should have appropriate permission. So, and then we have to have cluster. So we already started our cluster. So cluster is starting. So compute. Next requirement is that create notebooks. We already created a notebook. And then what we need to do is we need to configure Autoloader to ingest data into Delta Lake. Now, this is new term Autoloader. So let's understand about this. We'll right click here and open this document. So let's understand what is the autoloader. Autoloader incrementally and efficiently process new data files as they arrive in cloud storage. So let's say if we have any storage account or any volume, any location of the data where let's say we are getting the log files. So mostly autoloader is being used with the log files where we can load the data as log file arrives. Okay, it could be log file, it could be images, it could be any file, any sort of data, binary or CSV, JSON. So any sort of data we can load it incrementally. So this feature is called autoloader basically. And how it works. So a little bit about autoloader. Autoloader incrementally and efficiently process new data files as they arrive in cloud storage. So we have already understood that how we can create cloud storage and like blob storage, container, etc. If we are mapping a container, in that container, if we are getting a file, that file incrementally will be added to maybe data frame or data table. We can add this file to and we can fetch with the help of autoloader. It provides a structure streaming source called cloud files. So this is the identifier for autoloader. If cloud file is used, it means autoloader is in place. Okay, so these are supported sources which we can use with the autoloader. Okay, it can load from Amazon, it can load from Azure Data Lake storage, or even blob storage. So these both are the source from Azure. If we have data lake storage, we will have this initial. So ABFSS is used. If we are having Azure blob storage, so we will be referring or creating a link. I think we have created earlier with our blob storage as well. So we'll be using this. If we are using Google Cloud, then we will be using this initial, and here we will be using S3 colon. Okay, so if we are using the Databricks file system, DBFS, which we have seen, then we will be using this initial here. And autoloader can ingest JSON file, CSV, XML, Parquet, Avro, ORC, and text. So and even the binary file. So these are the file formats which are supported by the autoloader. Now, how autoloader works? So it basically maintains a checkpoint. So what will happen that if file 1 is there, so log file 1 is created, there is another file is added into the storage, then it will maintain the checkpoint that last time it visited that storage account, it was having one file only. Next time it visits, it has another file. So it will keep adding this. Okay. So it will maintain this key value pair in a sort of database, rocks DB, and this will maintain the checkpoint location. We'll see how practically it does. So no worries here. In case of failure, autoloader can resume from where it left. So advantage here is that when we are using autoloader knows by the help of checkpoint that where it was last working, and let's say due to compute resource or any reason, if there is a failure, it will resume from there. Okay. So incremental ingestion using autoloader in the Delta live table. So this will be incrementally adding this. I think yeah, that's more than enough for us to just understand. And then now we will run our basic pipeline first. So I'll go here. It was just explanation for the autoloader. So in this pipeline, anyways, we are using autoloader here. Okay. Now Databricks recommend use Delta Lake. So basically, we create a table in Azure Databricks, and it is called Delta Lake layer. So it becomes Delta table. So Delta table is stored in Delta Lake. So Delta Lake, like we have understood in the theory part, that Delta Lake is additional layer in Lakehouse. Okay, Lakehouse concept is introduced by the Databricks. So it is the combination of data warehouse and data lake. So these two are combined in the Lakehouse. Okay. So it will support the ACID transaction and all those things. So these are some of the feature. Now we'll understand that how we can configure Autoloader to ingest data to Delta Lake table, copy and paste this. So we have this code given and we can copy this code. So what this code, explaining us. First of all, it is importing. So we are using Python based code here, and we are importing these functions. So these are PySpark functions. So from PySpark.sql functions, we are importing column and we are importing current time stamp. Okay. Then we are defining the variable used in the code below. So first we are using the file path, file_path, the variable, and this is pointing to Databricks dataset. This is the location of our sample data in Databricks. Okay, so Databricks hyphen data sets is the location of different kind of variety of sample data in Databricks. So under that you have structured streaming category, and under that you have events folder. So in this Databricks has provided some event related data which we can use for testing. Now this variable is optional basically. So basically here we are creating a username variable, and that we are creating using the spark.sql command. And in SQL we are running this SQL command and finding out the username. Okay, so username is a variable, the current user who is little small. So if you go here, yeah, connection is unstable. Okay, so this command is basically creating the table name from the username and adding it this text. So let me make it little bit again. And basically I'll just try to scroll here. Yeah. So here we have current user, and then we are adding this hyphen here, and we are taking the first part of it. Okay, so this we are creating username, and then username we are using from here to create the table dynamically. This is optional step. This is not necessary. If we want manual also, we can just provide anything, any string like username ABC, or even we are not using the username, we can create the table name. It's not mandatory step. Then what we are doing here is we are putting a checkpoint path. So where our file or where our autoloader will keep its checkpoint. So we are just providing a location. In DBFS, we are providing temporary location and the username. So username, we have created this one. We are going to provide it here, and then dash checkpoint and ETL quick start. So this is like location we are providing. Next, what we are doing is we clear out the data from previous demo execution. So let's say if we have earlier run this query, and we are having this, so we can clean it up before we recreate it. So here we are running a SQL command with the Spark, and we are saying that, okay, drop table if exists. So basically, literally, this is a SQL statement, okay, with the table name, because table name we are dynamically creating from here. Then we are using DBFS, FS, and remove command. Okay, so that will remove the checkpoint path. So let's say if we have already created this checkpoint, then checkpoint will tell to autoloader that we are on certain point. So we want to reset it. So we are resetting it by this one, by removing this checkpoint path, and it is going to be recursive. So it will remove all the files in this checkpoint path. Okay. Next, what we are doing is we configure autoloader to ingest JSON data to the Delta table. So basically, the loading is happening here. So we are running a Spark command, which is called read stream. And this is what the autoloader identifies. So read stream is a command, but if it is without autoloader, it is going to simply read the stream. But with the autoloader functionality, it is the identification of autoloader that cloud files is being used in the bracket as a format. Then in options, you can choose what file format you are going to read, what is going to be your checkpoint path. Okay. So where you are going to load this, or what is the file path. Okay. And then star statement, if you see select star. So all the columns we want to fetch. Then we want to add some additional column here. So we are, using this library from here, import column, and we are adding additional column. So we are adding one more column after so it's like reconstruction of the table or data source. So we are using everything from the data source, and we are adding additional column here. So it's going to be a file path alias, source file. And then we are going to add one more thing, which is the current timestamp. So these two columns we are adding. So like of the source file from where we are picking this. So this will give us additional help that from which file we are reading this data. And then we'll write the string. So this is the checkpoint location it will mark, and then it will write to this table, which the table name is there. Okay. So it will trigger on available now. So whatever available we have the data information, it will trigger on that. So this, let's copy this and go to our notebook. Control V. Okay, I think we have to take Python as a notebook language. So I'll remove SQL from here. I'll close this for time being. Okay. So we put all this code. This code is written in Python. So we selected Python language, default language for this notebook. And I hope our cluster is running, and why it is getting down. See, this is time consuming. I think the timer we will have to work. Yeah. I don't know. We spent 10 minutes just talking about this. So it is stopped. So anyways, so this now, meanwhile, it is starting. What we'll do is we'll go to this location and see what we have. So I'll take you to another tab, which is the catalog. I hope it doesn't stop again. And I'll go to warehouse is stopping. Okay, for timing, let it stop, no problem. Then here we'll go to browse Databricks file system. And we can see all the, information from here, or see if I think Databricks also stopped. So my God. Let me restart this one as well. So if you are not using for, I think this, yeah, this is stopped. Okay, so let's go back here. And what we want to do here is we want to check the path, but it depends on the cluster. So let it restart, or I'll just reload in case. Okay, our cluster is running. Databricks cluster confirm. Okay, so this is our Databricks file system, and we can see the location, or what was the location we can see. So it says that this should be our path, right? But we cannot view the sum of the folder, like a data set folder, we cannot view from there. So by command utility, we can definitely be able to view this. Okay, and then the table name, this table name should be in the default schema. So where it will be created? It will be created here basically. If I go to default schema, and I will have the table like this, but this is not the one table. We don't have that table, so it will be created here in the default workspace. Okay. So let's see what else we have. Yeah, checkpoint location. So we will have a temp location, and then we will have username and this. So it will also, we can see the checkpoint location in DBFS. Let me see. Okay, catalog explorer, and I'll go to DBFS. We are not having temp created, so we will be able to see once we have temp created. Right now we don't have temp one. I think we deleted it, looks like. Otherwise we should have a big button here. So we'll see how it goes. Okay, so let's trigger this, and what else we have other than that? Yeah, so this is in Scala, the same one. The same code is in Scala, will look like this. And then we can process and interact with the data. So let's first run this one. I'll go and run this cell. So it should create a table for us. Okay, so stream initializing. So Spark jobs running, and these are like number of jobs. Okay, so this has successfully run. So now it is giving us time and ID. Let's see if it has run. Then it should have created a table with the ETL quick start in behind. So let's see if we go to our schema here, and I need to refresh this. Where it is? It should be in default, looks like. Yes, this is our table. Okay, so this table is created basically. Okay. Because my username is little long, so it took and replaced the numbers and all those things with this and the underscore, and it created. But it was not mandatory step. We could have avoided this step, or could have written the table name manually as well. Okay, so we created the table. Now let's see what has happened with the checkpoint stuff. So I will go back to Catalog Explorer, go to Databricks file system, and now I can see a temp folder here. And inside the temp folder, I can see checkpoint stuff. So it took my username and that long string stuff, created a checkpoint, and in that it created a ETL quick start, and it is having all this data. So it will keep track of our schema, commits, sources, and all those things. So This is like the location where it is going to maintain its checkpoint. Okay. Okay. So this is entire, this has run successfully. Now let's see how we can read this data. So I'll go back to and go to step to process and interact with the data here. So simply we have to take this data which from the table, because table is created and table variable we have created in the notebook. So the table name variable we just need to pass and say that Spark read table and read the table data. So I'll copy this stuff and put it there in next cell. So it will be creating a data frame. Then we can read the data frame. Okay, so data frame is created. It will inform that this is like you have, all schema stuff. So you can see from here. I'll just minimize this. And next step is that after you read, so in Scala, if you are using, this is the way, if Python, we are using, this is the way. So next is where we can simply use the display command and we can view the data from here. So I'll copy this and put another cell and say that, okay, display and data frame. So I can read from this data frame. Okay, so this data is being loaded from there. Okay, so this is how we can read the data. And if we just want to see, not to read the data, we just want to see the schema only, then also we can see the schema from here. df dot print schema, I think, yeah. By using this function, we can, understand the schema. So by default, actually, it will, return everything in string. If you see everything is being written, then you can convert it later on with the functions and, column types, data types you can change. So this is how data frame will return. So the autoloader, basically, this is how the autoloader work, and autoloader work with the checkpoint. So you have to have a location. Maybe you can have external location, or you can have, DBFS location for the checkpoint. Okay. So this was about autoloader. Now we will understand about, a little bit larger example. So what I will do is, okay, let it be there, no problem. I think I can go from here itself. So we will understand about example which is having end-to-end pipeline. So build an end-to-end data pipeline in Databricks. So how we can build an end-to-end pipeline where we can have multiple layers, right? So here we were not having a lot of transformation, but in this pipeline, we'll understand that how we can transform the data. So here we'll ingest the raw data, and then we'll prepare the raw data, and then we will query and transform the data. Okay. And then we can run this pipeline. Okay. So we'll go with this example and understand that how we can do this exercise. All right, so let's go, and I think I have created a folder, so I'll take it there quickly. Workspace, and shared one. I should have created end-to-end data pipeline. So I have already created these notebooks, but what we can do is we can, create another copy of this, so that will be more practical for you guys. So I'll keep creating the copy of this using this documentation. All right. So first step is that prepare the data. So let's go. What is a data pipeline? And this you can, so data pipeline is like, implement steps required to move data to source system. And then we can transform data based on the requirements. And then we can store the data to target system. So this is like entire ETL process. Okay. The data pipeline includes all the process necessary to turn raw data into prepared data, and then user can consume it. Okay, so that's what the idea behind this. So entire ETL process workflow. So we will be creating workflow out of it as well. So first we will create a ETL pipeline, then we'll create a workflow as well. Okay. Data is ingested from source system, then written in staging area, and then transformed based on this one. So we can ensure that data quality, deduplicate records, or anything is not messy, and we have clean data available in the output. And there is a model as well which can explain this. I think that image will be very helpful. Bronze, silver, and gold layer. Data lake or Databricks. I think I'll go for images. Yeah, I think this is the example. But this is not the actual example. I have seen that image somewhere. So basically, we have three, layer we will be creating in this data pipeline, where we will have three set of layer. So you can understand maybe from this one, but this is very small really to make sense. Let me see if I can get somewhere. Yeah, this is the one. Yes. So we will be ingesting the raw data in the bronze layer. This is generally called a bronze layer. Then we will be filtering, cleaning, aggregation, etc. We'll be doing. So that will become silver layer. And then we will have business ready, or ready data for maybe dashboard, maybe Power BI, maybe external system. So that will be a gold layer. So this is the concept when we are going with the ETL process in Databricks. So these three layers can be on top of the Delta Lake. Okay, this is what it explains. No worries. Anyways, we are going practically, so should not be having any confusion. I'll just close this stuff. Okay, so we are going for this. So basically, this is what we are doing here. So 3 steps. Data pipeline steps. So here we have steps work. So we have we'll explore the raw data set. And then we'll in notebook we'll ingest the raw source data and write to raw data to a target table. This will be our bronze layer, where we are just ingesting the data into target table. Then we'll create a Databricks notebook to transform this. So basically we will be doing these 3 exercise on 3 different notebooks. So first notebook, we will do the ingestion of data. Second notebook, we will be transforming this data and write the transform data to target table. So that will be a silver layer. Then we'll create a Databricks notebook to query and transform data and automate this entire process. So this is like we will query and this transform data into the gold layer. Okay. And then we'll automate this entire pipeline. So this is what we are going to do in this entire exercise. Okay, so we should be logged into Azure Databricks, then fine. So basically, example is given here for this exercise is a million song dataset. So we have so many, songs or their, metadata available in some format. So first is we should have cluster running. So let's see, we have cluster running, then explore the source data. Then ingest the raw data. So we'll go to ingest raw data part, and we'll create a notebook which ingests song data. Okay, something like this. We'll give name. I think we have already created one. So we have ingest song data. Okay. And maybe we can use the same one. Why to create another one? Just explanation I will anyways provide you here. So this is our notebook, and first we are going to ingest the raw data, right? So let's go here, and we are just going to use this code into first cell. And what we are doing here is we are importing this stuff, or data types. These are like data types which are available in PySpark. So double type, integer type, string type. So all these data type we are just importing. Then we are defining the variable used in the code. So the same like file path we are just defining here. So in file path you can see Databricks, data sets, and songs, and data 001. So this folder we are just bringing in the data from. So this is again Databricks dataset folder or sample data available in Databricks. Then we are going and providing the table name. So here it has given us the string which we can provide whatever the table name we wish to. Then it is providing the checkpoint path. So we can create our checkpoint path in temp location with whatever name we want to that checkpoint. And then we are creating a schema. Okay. So this is the schema because we want the same schema which is available in the source data. Okay, so we are creating like artist ID, string type, okay, artist, and I think latitude, longitude, I think location. So these are like metadata related to that song. So these metadata, we are just creating the structure or schema, and then we are reading the data using the autoloader. Cloud files return means autoloader we are using. Then we are creating, or we are fetching into the schema which we have created. And the data files which are available, or the files which are available, which we are going to ingest using the autoloader, is the CSV format. Okay, and this is like a change we are doing here, /t to sep here, just change one. And then we are using the file path and writing the stream with this checkpoint location. Okay, and then finally we will be writing to the table. Okay, so this is what our first cell we have already taken here. Ingest the raw data, that's it. Okay, so this exact code we have written here, and I think I have, yeah, so I have provided here the table name, or change the table name to row song data. Okay, and this rest of the things are exactly same. Okay, so we'll quickly run this, start and attach. Cluster is stopping again and again. I am not sure. Let me see what is the setting here. Last time we did 30 minutes, I remember, but I'm wondering it is stopping earlier than that. Oh, 10 minutes only, that's the problem. 30 minutes I'll do. I cannot change it. 30. Since it is starting, maybe it is not allowing me to edit. If I terminate, I can edit maybe. Once it will start, because it's waiting, as soon as it start, it will trigger this run. Meanwhile, we'll see what else we have. So basically what we are doing here is we are bringing into a table, which is the row song data here. Okay, so we replace with the table name, and then the checkpoint, it is going to maintain the checkpoint in this location. So we have given this location. The next step would be, while it is running, we will just understand next step as well. We'll prepare the raw data. So this is going to be our silver layer, right? So to prepare the raw data for analysis, the following steps to transform. What we are transforming here, let's see. So we'll be using SQL language here. and we'll say create or replace the table, and we'll provide the table name. Okay, and we'll provide the artist ID, name, duration, release, tempo. So these are the information which we are going to store it here. And then so this is what we are defining the table. Okay, so we are basically creating a table or replacing a table if there is a table, existing table with the same name, and we are creating these columns into this. Okay, and then we are saying that insert into this table. So this is insert into SQL statement. So we are saying that insert into this table, and from where to insert, select this. So we are running a query to our row song table, which we have recently created. So we are picking the data from there, or specific columns from this table, and putting into our silver layer, right? So we are just fetching whatever we need. So we are basically in raw data, we are getting all the data. Then whatever data we need to process or queries, or to use in Power BI or wherever, we are just fetching the data. So we are manipulating it little bit here, and this is what we are doing using the SQL statement. Now let's see if it has started. Yeah, so it has run successfully 20 seconds ago. So this entire process happened. Now we should have rows song data table created. So we'll quickly verify. We'll go to our catalog. I'll close this. And since we are using the default one, so I'll just go here and refresh this one. Go to default catalog, and you can see our row song data is created. So we fetch the data from this location. So this all data came. I think there are maybe 100,000 or million row data there, but here it's just giving a preview, so it will fetch maybe 100 data or something. So this is, and this, I think it will show here the schema as well. No, not here. Yeah, here it will show all the columns and all the schema you can see from here as well. Okay, and all the tables are delta table. So this is like delta, whatever table it fetches into the system, it put the delta table. So this is like type of table which is faster for query. So now let's go to next step. We have ingested our data from the source. Now what we need to do, let's go next step and put this. So we'll say, okay, prepare the raw data. I'll just copy this title and put in next cell. So basically not in next cell. So we will be creating another, a file. So if I go here, I have another file, which is the, prepare song data, right? So first one we already created. Second one we are talking about now. So second one is basically we are preparing our song data. So we have SQL statement, and notebook type is also SQL, so we don't have to change the language, and we can simply run this. It should be ingesting or giving us the result that how many data or how much data are inserted. So number of row affected, number of row inserted. So 31,389 rows were impacted by this. And we can see this now. We should have one more table here. So let's go here and refresh. Now you can see we took the data from here. We put into prepared song data. Whatever the column we created, it will be available here. As the sample data also we can see from here. Okay, so now next thing is next step, let's see what is the next step. So we prepared the data, we ran this query. All right, so we have created this one. Now query the and transform data. So query the transform data. So last step, we are just querying this and group by or whatever aggregation we want to do, we will be able to do from here. So let's say here, which artist released the most song each year. Okay. So here we are running a select statement with the artist name from the silver data. We are counting the artist name, that how many artist name there, and is number of songs. Okay. So this will be represented a number of song, and then year from prepared song data table. Okay. Where year is greater than 0. Okay. And then group by artist name and then year. So there are two group by, and we will order it by number of songs, descending order, and year then descending. So this is how we want our data formatted. Okay, so I'll just go to next step here. And third one we have created is the analyze song data. So this is the third notebook. We have ingested in data into first notebook. Second second notebook, we prepared the song data, and now we are going to analyze. So I'll just close this, and we return this one. So here I have already created some what do you call visuals. So we can interpret it here, but let me fetch it. So in table format, we'll get this one. And then we can create our visuals here, like we can simply add plus, or we can click on the plus and we can add or create a chart. So I'll just quickly show you how we can create one. So you can simply go to plus sign and click on visualization. And we can pick here the column which we want to visualize. So let's say if I want to create a bar chart or pie chart or whatever, I can put in the X column what I am looking for. So let's say in X column, I want, let's say year. So it will be year. And then in Y column, I want, let's say, number of songs and the sum of number of song, let's say, or count of number of song, whatever feature you want to use, you can use like this. Okay, so this data will create the chart accordingly, and then you can, I think, format as well or change the color and all those things as well from here. So it will be like this. Data labels also you can format. So if you want to show the data label, you can show in this bar like this, automatic data label. And label order, so little bit of tweaking with the X and Y axis you can do from here. Okay, so this is how I created this chart here, the pie one and another one like this. Okay, so we just need to change the chart type, and it will change the chart type as well. So when we create the visualization, let's say I want to create a pie chart. So I will select pie here and then X and Y column. So let's say year, for example, and Y column, I want, let's say, number of song, or number of song, for example. So it will create, and then I can save. So this is how I created this two chart. I'll just quickly, and next what we can do here is we can, add this chart. So number of, I mean, with the one data, so one output, let's say we have one output here. With one output, we are able to create multiple charts, So let me just, okay. So with one output, we are able to create whatever number of visuals here. So if we are able to bring all these visuals together, because this is not practical to see and go one by one visual and, compare and all those. So we may have multiple queries running on the same notebook, or maybe multiple notebook, and then we can, visualize these data or charts. So another way is that what we can do is we can, put this chart into a dashboard as well. Okay. So if we put this chart into dashboard, then it will be, one place where we can see all this. So how we can do this? We can simply click on this arrow and we can add to a dashboard. Okay. We can create a dashboard and we can add to an existing dashboard as well. So when we create or add to a dashboard, it will ask or give us two options. We can create a new dashboard with this name, or we can use the existing dashboard where we want to put this, show this data. Okay, so I'll create a new one and I'll choose whatever visuals I do have here. Okay, and I can, easily add to my dashboard and click on create. Warehouse stuff looks like. So it won't take much time. SQL is Excel, very small one. Meanwhile, it is starting. We will go and see what else we have. So we are able to do this fine. Next is how we can create a Azure Databricks job to run the pipeline. Okay, because these are three separate notebooks. It will not be practical to go each notebook and run cell by cell, and so we want some automation here. So what we can do is we can go to workflows and then we can create a new job from there. Okay, so if we go to workflow tab, we can go to new and create a job. And in that job, we can include this, workflow, or we can give a name of the task, song workflow, task name. And then here we can provide ingest song data. So let's do this one. Let's see. I think we were on here. So should have started. Okay, no problem. Let it take time. Meanwhile, we'll discuss this. So these are the steps to create the pipeline, entire pipeline with the multiple jobs. So first job, we are doing a task name. We are, giving a task name and we are going to ingest song data here. Then it is going to be a notebook. So we'll provide the type of that, task notebook. And then we'll provide the source, means which notebook we want to point, and then we'll confirm. And if we need to create a cluster or something, we will do. Otherwise, it is not needed. Then we'll add another task where we will say prepare song data, and the task name is going to be this, and we'll pick the second notebook here, and we'll provide the workspace and all those things. Then next task we'll create to analyze the song data, and then again we'll provide the information which is needed, and we'll create to run this. Run now button will be there, so we can run this with all these three notebook in sequence. So this is like sort of automation for the job, and then we can schedule it, this job, so it will be automatically happening for us. So once we write the notebook, we write the code, we put into the workflow, and we schedule it. So it's like fully automated solution. Okay, so we can trigger it or schedule it, and then we can, see that notebook is running one by one. So let's see what has happened, or stuff is still not started. Microsoft also, now have started towards this, and I think they have launched one product called Microsoft Fabric. So that is also going to do the same job in future. So we have now notebook created, and that is in draft mode, means we can review, maybe we can change. So I'll just reload this page. It looks a little bit weird. Okay, so here basically we can, arrange, let's say we have multiple, data or chart, etc. We can maybe, make this chart small or big depending on our, space utilization. I think we can easily move that also from one place to another. So let's say if we have multiple, notebooks, we are getting the data. So we can nicely create this, dashboard. So if I click on dashboard, I think I have created earlier one as well. So this is like one we have created. And once this, dashboard is published, it will be visible for everyone. So you can publish it and you can keep it in draft mode. So once it is published, you can give access to other users to see this. Maybe you may have, management or someone who is a stakeholder who wants to read out this data. So we can create the dashboard, and each time the pipeline will run and the dashboard will remain up to date. Okay, so this information will update it automatically. All right, so we'll go to our pipeline and we'll follow these steps to create this one, right? So we'll go to, I think we have completed this part, and we'll create a job now. And for that, we'll go to workflows. So let's go to workflow here. Workflows. Okay, I have already created this one, but what I will do is maybe I'll keep it and I'll create another one. So create a job. We'll go to create a job. And here we'll see interface where we can provide the task name, right? So if we go to our example, here we are providing the first task name. Songs workflow will, this is going to be the title of that entire workflow. So that is going to be here. I will provide it too because I have another with the same name. Then I will say what is going to be the first task name. So I'll provide the task name, ingest song data. Okay. It is on mobile editing. Okay, fine. And then what type of job it's going to be. So type will select our notebook. Maybe it is SQL or some other files. So we can select the notebook here. And from where we will bringing in this notebook. So I'll make it a little bit small. So type is going to be notebook, source is going to be workspace, and path of the notebook. So we'll select our notebook from shared, and we'll going to be end-to-end pipeline, and we'll say ingest song data. So this is our source. And job cluster, we are going to use our cluster, and then we'll create this task. I'll restart in case if it is stopped. Okay, meanwhile it will remain a start. Okay, so we created first task. Now the second, so these only parameter we have to pass. That's it. Name, type, source, path, and cluster name. That's it. And then we can add another task. Another notebook we are going to add. Simple to create the workflow. And then again, we are going to pass the name and all those things. So ingest data we have done. Prepare song data. The second task we are going to create. We'll say, okay, second task. This is the second task. Notebook, workspace, and then the name of notebook. So we'll go to our end-to-end data pipeline, and prepare song data is going to be our notebook. And then the cluster name is already picked, look like. So this is going to be our cluster where it will be running, and then create task. Second stuff done. Then the third one will pick. So again, add task, give the name of task. Go to here and add task, notebook. This is the task. Analyze song data. So this is going to be in the sequence. Once it is succeeded, next one will start, working. So these three tasks we have created in queue. I'll simply just make it more space. Fit to view. Okay. So now I have 3 steps. First, this notebook will run. Then once this is successful, it will run. Then this is successful, this will run. Like this, one by one, it will run. Okay. So I can say run now and it will start running. Okay. Before that, let me just do one thing. Let me go to workspace on another tab, and if I can run it from beginning would be great. So what I will do is I'll go here, and I have one notebook created, which is the clean notebook basically. And that notebook is going to remove or checkpoint. So we can start this entire process. So I will remove this checkpoint. And I'm going to remove this temporary location entirely. So okay, both of these command worked. So now what next I'm going to do is I'm going to go to my catalog explorer and going to go here, tables. I have first table row song data. I don't want AI. I'll remove this. I will simply delete this table. So it will recreate for me. So basically, I just want to run it with the pipeline. That's why I'm removing these all. So I'll remove another table, which is prepare song data. Yeah, that's it. So these two tables I have to remove. Right. So now I should be able to run this entire pipeline. So where I was here. So this is our pipeline and we can run it. So I will click on this run now. So this is triggered. So runs. This pipeline will run and entirely. I think I should run different parameter. I can go to jobs. And this is running here. I can see the detail. So if I go here, I can see in the graphical way that the first ingestion of data is going on. I can make more space, make it fit to view. So yeah. So first, not right now. Now it was successful. So second notebook started running. Now this is also successful. So third notebook started running. So all our notebook run successfully, all green. We can see here in the timeline as well. So first notebook took little bit longer. Second notebook took little bit lesser, and third notebook look. So this is like time we can analyze. We may improve our queries all those things we can do around. So that's it for today. This is about the pipeline. All right, thank you. Okay, launching our Workspace, Databricks, and we're almost there. We'll go to compute and start our compute resource first. I think this is the one. While it is starting, we'll talk about PySpark functions. Make it large. Okay, we already have looked into these functions, but these are aggregated one. So we'll quickly go through this. So for uploading the data, we have these functions. We'll see how we can upload the data or import the data types. So you can see we can import by PySpark. These are the types we can import. The SQL types, import star. And these are like we can import the function from PySpark. Then we have, we can, import like integer type, string type, individual data types as well. Okay, so the next key thing is here that how we can create a data frame, which we have already looked into, but various ways to, combine these together. So we'll look into this. So here, if we see in this example, the data frame children is created using this function, which is the spark.create data frame. So manually, if we don't want to use any, source and we want to create our own data frame, this is the way. So two parameters will go into this. First one is data, means you can put your records here. So this is the first row, like name is there and then the age, for example, and then the second record. So these are row, or we can call it tuple in Python. So we can create the records like this. So there are three set of rows here. First set, comma separated in bracket, second set, and the third set. So again, this is array is, ending here, the data array. And the second parameter we are getting here is the schema, means we are basically telling that what is going to be the header of these rows. So name, the first record is name, second record is age. So these are like header or, title of this. So we can quickly copy it. Maybe your compute should have started, not yet. So I'll open another tab. And let's create one notebook here. Border name, you can give the name. Can close this. So I'll paste this information here. Let's see if, yes, this is green now. So it has started. So if we simply run this, it should display this one. So it will create a data frame and it will display here as well. So it's waiting right now. So this is how it will create the frame. So this is the data frame which we have created, and by display command we have shown it. Another way is if we want to show it, we can show it df children and dot show. So these are two ways to display the data frame. Okay, so this is like very normal way, and that is having little bit of spacing and all those things. Okay, so let's move ahead. So this is what we can do here, and this is the explanation that how we can, use this with the fields. Okay, here you can see that we are importing here struct type, struct field, string type, and integer type. Okay, and what we are doing here is we are, providing the type of schema. Means here in the previous one, we simply pass the schema without mentioning any type, right? But if we want to mention with the type here, so we can say struct type, and the field, each individual field is having its own type. So what we are doing here in struct field, we are passing the name. So name is like column name, and then the type of the name. Okay, and I think this is for null. So this is 3 parameters we are passing here. Okay, so if we let's copy this and try it here. So if I replace this code, or maybe I can take another code, can just minimize this cell, and the second cell I can bring another. So basically this data frame is different than this data frame. Okay, if we run this, okay, so it has the same record, but if I run it with the different command, which is df children with the schema, and if I say print schema, it will show me the data type as well. If I do the same with the previous one here, let's say if I say print schema, so here it is having the long in age, but here we have integer because we have defined it. So this is how we can change the data type or have the data type when we are creating the schema. All right, so this is one example. Create a data frame from table in Unity catalog. This is the first way that entirely we are creating this data frame using our own records, basically manual way to create this. Next, we are looking into that how we can create a data frame from table in Unity catalog. So there should be a table inside of Unity catalog, and then we can refer to this table. So we have one sample table called samples, TPCH and customer. So if I go and look where exactly it is, so I will go to compute and open in new tab my catalog. So I should be able to view here, yeah, in the samples one. Okay, so this is what we are TPCH and something customer, I think. Yeah, so this is the schema and the table inside. Okay, so let's go back to our notepad here, or basically, yeah, here. So we are referring to this one, samples, TPCH and customer, and then we are showing this here. So let's copy this and put in our cell. So this time we are creating a data frame df underscore customer. We are saying that we are creating a data frame from existing table, and we are referring to the catalog, schema, and table name. So it's working. It's fetching the data from this table, and it has created a data frame. All right. So next, see how we can create a data frame from a uploaded file. Now, next way is that when we are creating a data frame from uploaded file, we maybe may have the file in Databricks file system, or maybe in the volume or somewhere, so we can refer to that path. So here you see volume file path, and then option is having header, true, infer, schema, and volume file path. So any path we can give. So let's copy this, and we'll just minimize this and open new code or new cell basically. So we can supply the path here from our catalog. So, or basically from volume, I think. So I can go back to catalog, and I can see if I do have any volume here. I was having volume in default, I think, yeah. Volume and volume 1. So this is the address of my volume. I copy this and put it here. And inside volume 1, I can refer to my table. So let's say if I refer to this one, I can simply copy this and paste it here. Okay, so now I can create a data frame out of it. And this is the CSV file, so format is mentioned correctly, and this address should be correct. Let's try this. So you can see that we are able to fetch the records from this file or CSV file using the spark.read command. Next is, let's go. So create a data frame from a JSON response. So let's say if we have a URL, and we are using here sample URL with the limit of 100 records. So from this URL, or we would like to read a URL and a JSON provided in the URL and create a data frame. So that is also possible. Same way like the CSV, we can do that. So we can go here, and I'll just minimize the previous one. Import requests. So we are basically making the request to URL. So we are importing this library, and this is the public URL. So we are fetching 100 records from here, and in the response we are getting request get URL, and then we are going to create a data frame with the create data frame command, and we are putting this response here with the results. Okay, so let's click here. So something is not correct here. Unable to infer the type of field products. So looks like that. Okay, so we can try it here. Let's see what is going on here. Results. And this one is basically having another set of records here. So that's what creating problem, because it is also having array inside this JSON. So it's nested one. So this is creating problem. Right, no problem. We'll look into another example. Maybe if we can find a sample JSON table. sample JSON table URL. Like I believe this one should be okay. To-dos. Let's try does take. Integer slice not str. I think we are not reaching to the JSON file like we were doing in previous one. So we should have, I think, yeah, this one 100 posts there. Yeah, this is the correct one. Let's go back. Yeah, this time here we should not have results. Yes, so we are able to fetch all the records from this URL. So there it was having results, but here we have direct records. So we are fetching these records directly as an array. So it's starting with the array, and these are like, attributes having this record. So from curly braces to curly braces, we have, a record. And these you can call attributes like user ID, title, body. So these are attributes. Okay, so this is how we can fetch from this one. Let's see what is next we have. Okay, so if we wish to display one record only, we can, just put the record name with the select command. So if we are putting with the dot select command, means the data frame name dot select and then data frame, and in square bracket we can provide the column name. So we may try this command. For example, from this response, maybe we have body, for example, or let's see what else we have. So we have title. And if we just want to print the title or show the title only, then what we can do is here we have display command. We can say, okay, dot. And here we can provide simply title from here. No, it's a little bit, I think, format wrong. So here we have to provide, dot select, and then inside the bracket, we have to provide this one. So I'll go and we'll say dot select, and inside we have to provide df underscore drugs, and then another bracket here. One bracket less looks like. Okay, should be working. Yes, so we are getting one column only this time. If we want to get another one, also we can get or separate it by comma, and we can get another column as well. So let me, before that, what I can do is I can say df drugs, I think, and then I can say print schema. So at least we can understand what's going on here. And we can see that how many columns we have. We have body, ID, user ID, etc. So we can get DF drugs, and we can get another column as well. So for example, ID. Yeah. So like this, we can formulate or create this one. Next, let's go. What else we have? So like this, we can do create a data from a file. Also, we have some sample files in this location. So we can create a data frame out of it also. And this is the one. So let's say CSV file. So it's the same way, only location we are changing. So this time we are getting the sample data from a Databricks file system. So that's the only difference here. So we are getting this one. This is available. I think we can just hit it and easily run it. I'll just minimize this. So you can see that from this sample data set, we should have this file available there, and we should be able to fetch the records. Yes, so this is bringing all the records from this specific file from that location. Okay, so it's the same method basically, it's nothing different. Only location is changed. Okay, now we will understand how we can transform the data with data frames, right? So let's go. We have these many functions. So we have column operations. We'll quickly go through these by select column. So if we select the data frame and dot we put the select, we can have columns. So we can select these, and we can print this, or we can create another data from out of this. So this all we can do. You can also refer column using expr. So we have to import in that case this function expr. And what we can do is we can mention or fetch this column out of this one, and then we can print from this function or data frame. Next, you can also use select expr, which will accept the SQL expression. So here, if we would like to, combine the SQL and Python together, so basically Spark and SQL. So here we can run or type our SQL command. So let's say, for example, round function he has put here, and alias. So these things we can run into the PySpark itself. So maybe we can quickly, I think we have customer one created, so I'll try this. So first one is having the column, and with the help of import column, we can create this column. So I'll copy this, put it here quickly, and we just hit. I think we have DF customer created earlier. So children is there. Yeah. So this we have created. I'll just minimize others. So DF customer. So this cell we have already run. Okay. From here, we will be fetching some columns. So we'll go here and we'll be fetching this. Let's see if these columns are available in this data frame. So we are getting this one. So if I, let's say if I create another data from out of it, I can do this. So let's say DF one or something, I can give the name to this one. So this result is being fetched into this, and then I can say display and DF1. So I'm getting these two columns inside of this DF1. So we can derive one data frame from another. So we are having this column function we used, and we derived this result into another data frame. So this is like transformation task we can conduct using this. Next one here, we can use a expr or import the function expr. And instead of column, we can use the expr as well, and it will do the same job. Next, SQL query statement we can do. So let's say we want to round the CACCT balance or account balance, and rounded we want to create one column. So these two column we want to fetch, so we can do that and run this one as well. So I'll just minimize this. And now if I want, I can do it like this. Dot show also I can use at the end. So like chaining I can do, and here we can see the result immediately. Instead of creating another data frame out of it, I can simply say dot show at the end and it will work. Okay, so this, let's go here and it will show like this. Okay, next is to select columns using string literal, do the following. So we can directly also use this with the select command. So we can provide the column name in string and it will do the same job. All right, and also we can do with the df customer, means we can refer to dataset and provide the name of the column in square bracket and it will do the same job with the select statement. So there are plenty of ways, like here you can use this, so it will bring the same. But sometime we may have, we may have to create a new column or with the existing result. So how we'll do this? So there is a with column method. We can use this with column method and we can use it with the data frame. And we are creating this column with this name, balance flag, for example. And then we are providing that this column is going to be a column which is going to return that if this is greater than 1000 or no. Means basically this is going to be a binary column, means 0 or 1 it should return that if this condition is true or false. Okay, so we'll simply try. Let's see if we have these records. I'll just minimize this. Okay, so here we are getting another column like boolean, so it is returning yes or no wherever it's finding the value greater than the 1000. If it is finding, it is returning true, and wherever it is finding less than or equal to 1000, it's returning false. So no need to print, or if we want to print, we can simply say dot show in back and it should do the job. So it will return all this. But if we want to show it nicely, we will have to wrap it around display and it will work. All right, so sometime I think we have, in past we have done this, but again, I'll show you. So you can rename a column. So here you will use with column renamed and you will provide the existing name of column and you replace the name with the new one. So it will rename the column in case. All right, so alias also you can use. I think, yeah. For aggregation, we can use alias. So here we'll import average, for example, average function from PySpark, and we are having, let's say, this, and we are putting here dot group by, means we are grouping it by this column, and then we are doing or performing aggregation on this, and that under the aggregation we are providing that we are going to do the average of this column on this column, and we are providing the name of this column to this one. Okay, and then we are going to display. So let's quickly run this. Okay, so if we run this, so you can see we have average account balance like this, and we have the market segment. So it's grouped by market segment. So it's providing market segment, and then the aggregation type is going to be average. We can have mean, max, or so many aggregation are available. So we can use this, and as alias we are providing this one. So name just we are changing from here, we are just changing to this one. Okay, so this is about this one. Let's see next. And then we can cast the column type as well. So here, if we import the column function, so we can cast it with this. So let's say if we have customer key, we can cast it to string type as well. And then we can cast maybe, or we can print it. In some cases, we may have to remove some column. So that also doable using the drop command. So we'll use the DataFrame name, and then we'll say, okay, drop this column. So this is how we can drop this column. So these are some of the common, column related commands. Now row operations we also have available. So we'll quickly go through this. We can filter the rows we have seen in previous also. We can remove the duplicate row. We can handle the null values. We can append the row, sort, and filter row. So let's see. To filter the row, we'll import the column here, and then we'll use dot filter command. So we'll provide because when we are importing the column, we can provide the column, and in a small bracket, we can provide the column name. And filtration, maybe we can use equal, or greater than, less than. So some of the comparison commands we can use from here, and we can filter the column, and the result will be shown accordingly. If we want to filter on multiple conditions, then we can use the logical operators like ampersand and this pipe sign. So this will provide these conditions, and or. So we can see here, for example, we have provided one filter on the column, and with the national key is equal to 20, for example. And this is the first condition we are putting inside the filter dot filter. We are having one column where we are putting the C underscore national key column value is equal to 20, and ampersand is the end operator. So another column value actual balance is going to be greater than 1000. So there are two conditions here. So it will return the records with having these both the conditions. Next is, for example, if you are putting the pipe sign in the between, means either this condition or this condition meets, then it is going to return all these rows. So and so end condition is basically going to check both the condition it should meet. So this as well, this one, both the conditions has to be there, true. And in this case, any one condition has to be true. Again, we have duplicate rows. Also, we can remove the duplicate. So we can say that we have data frame and it is having duplicate rows. So it will only pick the distinct one. Also, we can handle the null values. So if we say, okay, data frame and then .na and drop. So wherever it will find the null values, it will drop that row. Okay, and the same way it is basically to drop any null value, use either of the following examples. So we can use this, or if instead you want to only the filter out rows that contain all null values, use following. So if all the values are null, then it's going to drop this one. You can apply this subset of columns by specifying this. So for example, if we want to drop with the subset of these two columns only, then also we can use in this format with the comma, and we can provide the subset that we want to see the null values here and drop. So it will not drop other rows which are having other null values. To fill the missing values, also we can use the fill command, and we can fill the missing value. So wherever we have a value or null value, we can provide the 0 or something like this. So we can replace on that subset. To replace the string with other values, we can use this one. So here we can provide the empty and unknown. So we can do this. Append rows. So if let's say if we want to add a row, so data frame appended rows is going to be equal to data frame that one customer, and we can use the union command here. So we are basically adding the two data frame together and creating a new one. Okay, so let's say if it is having one or two row, it will be appended to this data frame. So with the help of .union command. All right, so yeah, one more sort is also there, or order by command also we can use. So with the help of order by, we can arrange the columns or result in by using the sort or order by. So order by also we can use, and then we have to provide the column and name of column, and definitely ascending and descending also we can use in the back. So here it has used descending, we can use the ASC also, ascending, and we can sort it or order by, both will work. Okay, also there is one command which is called dot limit. So when we have data frame, we can limit the record, because each time, let's say there are thousands of record, we don't want to fetch each time. So we can limit the result to maybe 10 or 20. Next one is the join command. So inner join, left join, and outer join. I think we have seen when we created the pipeline. So inner join will join with the both one, and left join will have all the rows from left side, and outer join will have the all the rows from both the data frame, regardless of match or no match. Okay. So yeah, I think this is again taking from customer and orders, and you can see here. So I think we can maybe replicate this one easily. We are having this record, so inner join. So we are getting from customer, and they are having their order. So one customer may have multiple order, and we are joining both the tables, and we are creating new data frame out of it, these two data frames, and we are saying that join. So we are saying that on order, data frame order dot join, and inside the join we are providing another data frame name, which is the df underscore customer, and with the comma we are saying on and df order, and in square bracket we are providing the name of column, and is equal to the name of column of the df underscore customer one. So both, wherever these both columns are equal, is going to have inner join. So inner, left, right, whatever we can write here. So this is what the format it here, and it will return the result from both the tables. I think it's fetching lot many records, looks like. Ah, 6,900. So we could have used here, I think here we could have used, for example, limit dot limit, and then we can limit it to 10 record or something. Yeah, so only 10 records fetched. Okay, so next one is, let's say this is about join here. Yeah. Further, we can have, multiple conditions here. So basically, to join on multiple conditions, use Boolean operator. So we can connect it by an ampersand or pipe sign, and we can put another condition. Let's say if these returns should have, or these rows or should have two conditions. So we are adding here customer key, and then data frame order should have total price, and this should be larger than this. So join as well as where condition, you can say, we are just putting it together. Then how we can aggregate the data. So let's see, we have these functions like group by, and with the group by we can use this. Here we have group by, and aggregation methods like average we have seen earlier, sum, max, min. So these are some of the common function which we can use for aggregation. And this generally will work with the group by. So first we'll put the group by, and then the column name dot aggregation, and then we'll put the aggregation function, and after that we'll provide the data frame column name. So here if we see, yeah, this is the same. What is the difference here? Group by 2 columns, so multiple group by also supported. So here you can see it is group by, and then it is comma separated in the same group by. So there are 2 group bys and then aggregation function. So also to count the rows, we simply have to type count after the data frame name, and it will work. Then this concept, the chaining calls, basically we can change this command behind, as you have seen that we have multiple commands running one after another. So this is called chaining. All right, so data frame chained, for example. So here you see data frame order is having a filter command here. Then it is chained again with the dot, and it is having group by. Then again it is chained with the aggregation. Then it is chained by alias. Then it is sorted, so again chained by this. So these all commands are clubbed together by these dots. So this is what we call chaining of the commands. And display, definitely we have seen so far that display is having this one, so we can. And further at the end, what we can do is we can save this data which we are fetching. And if we say data frame and then dot write and then dot save as table, means we can save whatever data we have brought into to our catalog dot schema dot table. So I think we have performed this activity as well. Okay, and also we can write our data frame as CSV. So for example, if we want to write, so we can provide which path or where we would like to write as a CSV, and then we can provide dot write dot format, and we can mention the format either JSON or CSV. And if the file is already there, then it will overwrite, and then it will write to the path. All right, so these all are the PySpark functions and commonly used for transforming the data. So we have covered all these. Next, we are going to talk about integration with the Azure Data Factory. Okay, so Azure Data Factory, how we can integrate, or basically what we can do by the integration is that we can run these notebooks into the Azure Data Factory as well. So let me, I think I have right document for this. Just get me the document. Okay. So this is about the data factory, how we can run with the data factory. So let's say if we are using the data factory and we would like to run the notebook inside the data factory. In that case, how we can do that. So it will explain. So what we'll do, we will create a data factory, and inside data factory, we can create a pipeline that uses the Databricks notebook activity, and then we can trigger the pipeline and run. So in this example, it is showed how we can do this. So if we create a data factory, we can simply go to our Azure portal and we can create our data factory. So let me go to Azure portal. I am inside of my resource group, and I can click on create, and I can type the name data factory. So it will provide the service, or you can just tick this one. So it will provide the Microsoft one only, not the third-party one. And we'll click on create. And then we'll have to provide the data factory name. So I'll say Azure Data Factory one something. The instance name we have to provide. I think it's already taken. So it should be globally unique. Let me just take another, yeah, this should be available. Okay. And then we have to provide the region where we would like to create this instance. So I'll use South India. And then version, definitely it's having V2, only one version available. Earlier it was having V1 as well. So if we wish to, we can configure the Git as well, but if we don't want, then we can just tick this one. Networking, we will keep the public endpoint open, so it is publicly accessible. And encryption, if we wish to have customer-based encryption, then only, and tags are optional. So this is how we'll create a data factory. And while it is creating, I'll show you that how it is having. So Azure price calculator. If I go for Azure data factory, yeah. So in estimation, you can see it will cost me almost 0 monthly. But as I, tweak in with the options here, it will, let's say if I go for SQL Server integration, it will start costing me huge. So with the data pipeline, it's going to cost me 0. So pipeline, maybe you can test, but as you have different, services like execution and all those things, it will start costing you. So orchestration, execution, data flow, data factory operations. So as you use this, functions from the data factory, it is going to cost you. All right, so let's go here. I think our data factory is created. So here we are looking into that how we can run our notebook. So I'll just look the integration part. So we have created data factory from here. We select that the resource group, and we select that the region, and we created our data factory. And now inside the data factory, what we have to do to run our notebook. So we just have to go to Data Factory Studio, same like we have Databricks one. So when we go to Azure, we can go to a resource group where we created the data factory. We'll see our data factory here, and we click on the data factory, and there should be, yeah, it keeps changing. So quick start gallery training, yeah, launch studio. So we'll just launch the studio. It will start the Azure Data Factory Studio. So this is a like low code version of Databricks only, but it is provided by Microsoft. It is not having, it's just having GUI, and you can create the pipeline. It's comparatively easy. So here, basically what we can do here is, let me see, we can create, yeah, we can create a pipeline from here. We can create a pipeline. And by having pipeline, we should be able to have Databricks notebook from here. Okay, so let me see how it is explained here. So we'll go here, create a linked service. So we'll have to create a linked service using this icon. Okay, then we can use our pipeline. So we should not be going directly here. I'll go home, and we'll go to manage. We'll click a new. So we are creating a linked service. Click new, and we can link with our Azure Databricks. So I think I'll just type it better, Data bricks. In the compute, I will have to go. So this logo should come, not the other one. So that was Delta Lake. So this logo should come, and click on that. So here it will ask some questions. So let's see. First, we will have to provide the name of this link. Then runtime, it will automatically pick, no issues with that. And then Azure subscription also, it will pick automatically. So you can see my subscription is already picked because this is running on the subscription itself. Then Databricks space, workspace also it can, choose from. And if I am creating a new job cluster, then maybe it will not ask anything. But if I am going for existing, cluster, then it will ask the authentication type, or So here I can use the token to connect with my workspace. Okay. So here, if you see how I'll get the token, so I should go to my Databricks account. So let me go here. So up to here, we are on correct path, linked service. We clicked on new. We selected the compute. We selected our Azure Databricks. We continued. And we select the cluster. Databricks URL, okay, authentication type. So we'll go for access token, and we'll find the token. So I'll take you there. I'll go to, for token, we'll have to go to basically our account, user account. Click on settings. And then under user, you will go to developer. And here we will get the access tokens. So we'll click on manage. And here, like we have done, one we have created to connect with the CLI. So to connect with our Azure Data Factory, it'll generate new token. It'll provide the name, ADF connector or ADF enough, and we'll generate it. So this, it will show only once. We have to copy it. So we'll not close this. We'll go to our data factory, and we'll provide this token number here. Okay. Second method is we can provide the Azure keyword secret key as well. So that will be longer video if we want to, go with that. So we'll have to create Azure keyword like we have created earlier, then created key, and then from there also we can provide the reference. All right, so we can choose existing cluster because we have provided our token. So we can choose existing cluster and we can create. So this is like linked with our Databricks account. Now, what is the use of having this link? So let's say if we are creating any pipeline now, I think to create a pipeline where it is new, I think go pipeline. When we are creating a pipeline, we can go to our Databricks and it will recognize, or we can choose or notebook and drag and drop. So here it's really easy to create pipeline because this is graphical interface. We don't have to work with the command here. So you can run now. What the advantage here that we can run our Databricks notebook on Databricks using data factory basically. So inside the data factory, we will be able to run our Azure Databricks notebook. Okay, so that's the advantage here. And then we can, configure from here and all those things. So this is like, which Databricks service you are going to use. We can test the connection, which notebook we are going to use. So we can pick the notebook from here. Now it will show our Databricks stuff here. So whatever notebook we would like to run, we can simply run it from here. So like prepare song data or something, we can simply, so whatever pipeline we are creating inside of this, we can run our notebook as well. And we can define the trigger and all those. So this is about the data factory. All right, so I think we just have to look into the integration part. So cover this. Yeah, so we have covered this. So we can create the pipeline like this, and we can bring in our notebook from here. We can provide the name and etc. This. All right, so this is the integration with Data Factory. I'll simply go there. I'll close this studio. So close this, leave. I'll go to here, select this. And should be able to delete. Delete. Okay, one more tool which we can connect with our Azure Databricks is called Synapse. That is like I can Azure Synapse. So Azure Synapse Analytics is the tool. So let's see what it is. Is an enterprise analytics or analytics service that accelerate the time to ingest across. So it's like SQL warehouse or warehouse, data warehouse. And I think, yeah, we can use as a data warehouse only. I think there is some more information. So with this also we can, connect the same way we have connected with the data factory. Okay. So same way we can do this one, we can connect with this one. And it is like data warehouse. And deeply, okay. ETL process also we can do. So we can store our data. It is working with the, maybe we can, read and write the data to Synapse, and it is like warehouse. Okay. One more thing I just want to, one thing I want to cover is UDFs or user defined functions. Before that, I think I have a built-in one also. Let me just find out. Yeah, one more tool which we can connect with the Databricks is called Power BI. That one also we can connect with this one. So Power BI, I think I have seen my cluster is terminated, looks like. Let me go to compute. With the Power BI, we have to have a licensing or online. Basically, there are Power BI online. So which also we can connect and publish to our Power BI online. Or basically dashboard and all those things we can do. And we can publish. So this is the way we can integrate with the Power BI as well. And we can publish our Azure Databricks tables to Power BI dataset. So that let's quickly let it start, and then we can go to our tables. And I think it should come here. So a cluster runs, then only that option will be appearing here to connect with the Power BI. So we'll be just waiting for that. Meanwhile, while it is starting, maybe we can explore other things here. I have SQL related. Yeah, one thing I just want to show you guys is SQL statement. So Databricks or Azure Databricks built-in functions, I think. Yeah. If you go for built-in functions in Databricks, you will find there are thousands of functions which are built-in one. SQL, SQL one. So if you go on top, you will see SQL here. So these are built-in functions related to SQL one. And these are like operators. You can see, ampersand and star not equal to, so not one between. So these are like so many of the functions like exist. If something you want to check exist, not exist, like I like, in, distinct, false, is null, true, like. So if you go continue, you have so many different options available. Okay. So if I just open, I think there is alphabetical also should be there. Just quickly go through alphabetical list of the function. So here you can see like these are like categorized, absolute, echoes, so aid months. So these all functions you will find, and there are several because these are SQL functions. So if you understand from the definition also, it's easy to understand. And you can further go to that function and read about it, right? Format, lengths, and all those things. So several functions available in it's very long list. Upper, for example, like this is a string function. We can change it. Then numerical scalar functions. So several, numerical functions also available here. See, so many. Okay. Then aggregation functions. So basically, this is no need to, remember all together, because this is really good resource. Everything is available. When you want to search something, you will definitely be finding it. So when on, on hands-on or practical environment we are working, we can easily, find it, like mean, mode, everything we can find it. And even ChatGPT, Gemini, these also can help. So these are like ranking Windows function, analytics Windows function, array function. So several categories, map functions, date, time, stamp, interval. These are built-in functions which are, available here. Now, in case if we want to create our own function also, that is possible in basically PySpark. So we'll look into it, see. So I'll just quickly, I think my compute should have started by now. Yeah, started. I created, I remember. So I'll simply remove this stuff. We have to refresh this. So this token I created while testing ADF. So I'll simply remove this unnecessary cluttering. Okay. So I'll go to Workspace. And in Workspace, we should have somewhere functions. And we should have custom functions. So we'll understand how we can do that. So a simple example. So it will give you the idea how we can create a custom function. So we are creating here, let me just make it a little bit more space. So we are creating a data frame here named data. And then we are putting the schema. We are having 4 fields and 2 rows only here, right? And then we are create data frame command we are using. We are passing the data and schema. And then we are showing this. So it will show something like this, that we are fetching all this record. And then here what we are doing is we are creating a functions. Okay. So there are 2 ways we can simply, refer it UDF. Okay. So this also possible. We can simply on the top of function where we defining the function, we can provide the name of function and we can pass the parameters like .NET sort of thing, or any programming language, we pass the parameters. So same way we'll be passing the, like say here we have salary and bonus, so we are just passing S and B to parameters, and we are saying we want total pay. So function name is total pay, and as a return of the function we are saying that we will be adding S and B together. So S plus B, simple function just to understand the function. Then here what we are doing is we are registering this function. So we are importing the UDF from PySpark functions, and we are putting it to integer type. Okay, and we are saying that we want this function registered as total payment, and it's going to be user defined function UDF lambda, and we are going to provide these 2 parameters colon, we are going to include this one total pay, and then the parameter, and the output is going to be integer type. So that's how we are defining this one. Okay, so this if we don't want to define this one, so basically we can avoid this, all these lines. How we can avoid? Because if we enable this one, it will only already be registering it. So we just need to remember this one. But this was the long method. So if I just remove this one, it will also be the same. The result would be same. Okay. So this is just for the explanation. That's why I'm just keeping both there. Okay, both the methods available. Now call the function. How we will be able to call this function? So when we are having data frame, so we are saying okay, data frame with column. So we have one more column. So basically what we are saying that we want this data frame outcome with a additional column, and that column will be created from total payment function, and that is the user defined function we have created here. And that column will be taking data frame dot salary, means salary column, and data frame dot bonus, so 2 parameters S and B, and then we are saying dot show, so it will show the result. So if you see that it's fetching all the columns plus additional column. Okay, and that column name is coming from here. Okay, this is one method. Second, we can say that DataFrame dot select statement and return everything from the DataFrame, and then comma, and then we can say total pay. Okay, so basically we are calling this function without registration. Okay, so we are saying directly approaching here, not going through the total payment. We are saying directly call this one. So we can directly call that one total pay, and then we are passing this one. And we are saying that once this column you are creating, we are chaining this one with dot alias, and we'll say to pay and dot show. So to pay will be the column name. So you see here we are getting the name to pay, and here we were getting the name total pay call. Okay, as we are passing the name here. Okay, so that's the difference here. Then what we can do, so let's say if I want to run the SQL queries on this, on top of this. So definitely I cannot write these SQL queries. So on the data frame, in that case, I will have to create a temp view out of it. So by using DataFrame dot create or replace temp view, and then providing the name of temp view, I'll be able to have a temporary view created out of this data frame, and then I can run the SQL queries on top of this. So I can maybe if my default language is Python, for example, then I can use the %SQL, or maybe I can just simply go here and change to SQL. It will do the same job, and then I can put the whatever SQL statement I want to run on the data frame, because I have now created a temporary view out of it. Okay, so that's how I will be doing this. Let's say if we want to register or this function, or we want to call this function in the SQL, that is also possible. So in that case, we can say, spark.udef and then register. And then we are providing here name of function, which is going to be total pay SQL function. And we are referring to our definition of the function. And we are saying that return type is going to be integer. Okay, so this is how we can register PySpark function in the SQL. And once the function is registered, we can use that function in SQL statement. So total pay SQL, and I can pass these two parameters, and I can alias it is total pay from EMB. So this is how I can use this one, and it will also work in the SQL statement. Okay, so this is how we can combine the function with the SQL as well once we register with this. So yeah, this is all about PySpark function or custom function, which we can say user defined functions. Okay, yeah, that's it for today. Take care. Bye bye.